Ever wondered how Amazon seems to know exactly what you want to buy? Or how Instagram and YouTube always seem to suggest videos that keep you glued to your screen? And what about Spotify, effortlessly crafting playlists that match your vibe? With a base salary ranging from 5 to 10 lakhs per annum and an increasing demand in IT sector, data analytics has become one of the most critical aspects for shaping the future. If this wasn't enough already, according to a report by Forbes, the data analytics market is set for an explosive growth. We are talking about growing from 5 trillion Indian rupees in 2023 to over 47 trillion rupees in 2033, meaning analysts are going to thrive and not be replaced by AI anytime soon. Welcome to the Data Analytics Full Course by Intellipaat. This free course has been designed according to the latest market trends of 2024 and is delivered to you by the top industry experts from leading companies like Google, Meta and Microsoft, sealed shut with the most frequently asked interview questions. If you stick to the end of this video, I can assure you without any doubt that you will have enough knowledge to be able to extract meaningful values out of any dataset like true data analyst. Now let's look into the topics that will be covered throughout this video. We'll start by understanding basic topics like what is data analytics, need of data analytics, who are data analysts, followed by data structures like pandas along with topics like what is EDA and why EDA in Python. Then we'll move on to NumPy, where we will learn about multiple EDA operations that you will perform with both NumPy and Pandas. Stepping forward, we'll also discuss about data visualization using the popular Python libraries. After that, we will discuss inferential statistics for data analytics. Finally, towards the end, we will wrap up this session with one industry-grade data analytics project, which you can directly add over your resume to get recognized by the recruiters. After that, we would be also taking you through the most commonly asked data analytics interview questions. If you go through this course properly, we are sure that you can get entry-level data analytics job. So make sure to stick till the end of this video.
We've all heard this term somewhere. It pretty much rings a bell that every time we think about it, right? So analytics with respect to data. Well, what are we trying to analyze is what we need to know here, right? So the formal definition of how it goes, it's basically extracting meaningful information from raw data. It's as simple as that. So we have data, right? So consider anything to be data. If that is not useful to you at that point, it is considered as data. But then if you perform some operation on this data and make sure that it is useful for your organization, this is when the data becomes information. And this information is what is usable for you, right? So the process of pretty much converting raw data into information by performing certain analysis on it can be termed as data analytics, guys. I mean, this is just a very rough definition of what goes in the industry. To give you a better insight of what that means, basically it is the pursuit of extracting meaning from raw data using specialized computer systems, guys. And then these systems, they transform, they organize, and they model the data. End of it is to basically draw the conclusions from all of the data. So you'll have, again, as I've mentioned with the raw example, our goal here is to basically draw conclusions, to identify patterns, to make use of this raw information in a better way. I mean, sure, data can just be used in its raw form, but then not with every case, right? And to give you an example, so think of the data, probably you understand. So let's say you're looking at a huge data set which contains thousands of values. Those are just numbers, right? So having these numbers, sure, as a data analyst, you will understand what you're doing. But then let's say you need to explain it to a person who doesn't know what data analytics is, or you need to explain it to someone, probably your peer or someone above you as well. Let's say you have a business meeting where you have to explain this. Giving the numbers will not really be that great, right? It will not make a very good presentation. So converting all of these numerical data, making it into graphs, making it in a way where everyone understands the data, and showing out graphically whatever insights that you can generate from the data, that can be considered as data analytics as well, guys. Again, today basically the field of data analytics is ever so growing rapidly. And why is it growing so rapidly? Well, because the market demand for it is that much. So we have pretty much every startup companies these days have a requirement for big data as well. So big data to dumb down the definition, it pretty much means a huge amount of data that cannot be handled by just one machine. If you're stretching out your data across multiple nodes, you have data coming in from various sources. Then you need a method to handle all of this big data that's coming in, to process the data and then to perform analysis on it, guys. So this has been in demand in the market for a while, and for the last couple of years, data analytics has been in the boom, and then it's providing a very straight answer to all of the questions being raised about how all these can be handled, guys. And of course, we're going to need the people who have the skills which is needed, skills which are needed to manipulate all the data queries, to translate all these numbers into graphs, and to make insightful analysis on it, right? So that's what is the main key role of a data analytic person. What is the need for data analytics if we have to break it down into 3 steps, guys? So again, we already know that it is on the rise, right? So I can pretty much go about to step out into the open and then tell you that it is not soon that it will be an integral part of an organization. It is already an integral part of every organization there is, guys. So the first important need is, again, we already know that it is a top priority for all of these organizations, ranging from the small organizations all the way to the big guys. And then this is needed to make very good decision making. Well, with respect to you being confused to, let's say, take a decision for you, then looking at this analytics will make your decision making skills and decision taking skills a little bit easier, and it'll be more validable as well, guys. And it'll be more validated as well, guys. And the second thing is to will require new revenue, right? So let's say you have the data which pretty much only a couple of people can make sense of understand. Let's say your market is very niche. In that case, sure, you'll be still making revenue, still be making money on it. But then at the end of the day, if you have to reach out to a broader audience, you need to make sure your data is understood by this broader audience, right? So that forms the second very important need for data analytics, guys. And the third one is to obviously decrease these operation costs for every organization. So this can be a very demanding task if you have to convert raw data into information, process the data, and make out very good visualizations out of it as well. But then if you have the workforce for it, then sure, you can do it. But if not, again, since it's probably a manual task, and until a couple of years ago, it surely was a manual task. And these days, you can implement machine learning and data analytics to pretty much automate itself and make your job easier as well. It speeds up your work. It keeps you very efficient in such a way where your data is being visualized, processed very effectively. So again, time is money when it comes to big organizations, right? So on that note, pretty much it helps decrease all of the operation costs with respect to, either waiting in the data pipeline, or waiting to process, waiting to publish, waiting to do some analytics, waiting for visualization. All of these waits, you need not consider them anymore, because they will pretty much be reduced to null, guys. On that note, you might be wondering, who are data analysts, right? Data analysts are the people who sit at the end of the chain. I'll just explain the chain in the next slide. So these guys form a very good workforce for the company, where they basically deliver the values by taking in all the data that data scientist might give it to them, a data engineer might give it to them, and then he uses this person, data analyst, uses all of these to answer a couple of questions and then communicate all of the results back. And all these results that he just gives back is basically used to take very good business decisions, guys. It might include analytics of past trends, it may be prediction of what the future looks like, and so much more. And then the common tasks done by data analysts are data cleaning, performing analytics, and then creating visualizations. Well, data cleaning, to come about it, is basically simple, guys. So again, data is raw information, right? To make sense out of it, to pick out information that we only require, and to make sure that, again, efficiency is the game here. If you're pretty much processing data that we pretty much will not require, then it's just a waste of time and resource. So cleaning the data, making sure that your data is just perfect enough for processing, that's a very important first step, guys. So this is the spearhead of a data analyst's role. And then the second one is, obviously, as soon as your data is clean, you need to perform some very good analytics on it and create very good visualizations, guys. So these four designations you see on the screen right now is basically the designations a data analyst is also known by. So the first is a business analyst. So data analyst is also a business analyst. He or she can be an operations analyst, a business intelligence analyst, and a database analyst as well, guys. So coming to the tasks that they pretty much do, the first important task that we already spoke about was cleaning and organizing raw unstructured data, right? So this is again a very overlooked concept in today's world, unless you get your hands dirty with the data itself. When you start to go about doing that, you will realize that cleaning and organizing the raw data is extremely important, because at the end of it, your data might be unstructured, your data might be semi-structured, or it might be a structured data. This will not matter if the data you're processing is of no use at the end, guys. So cleaning and organizing raw data is very important. And then the second thing is the analysis of all of the hidden trends found in the data. So making sense of something, again, maybe predictions in the future, or looking at past trends, generating this sort of an information which you cannot figure out upfront just by looking at the data. This is pretty much the umbrella under which the hidden trends function of a data analyst's work. So you'll be looking at a data, you'll find something very interesting. So let's say you find a trend in your data where pretty much you can access a new side of the market with respect to your sales in the next 5 years, 10 years. And then you were not told this, but then your data was telling you this. So you making sense of the data in which this trend was found, which was not upfront, then this is again a very important skill of a data analyst as well, guys. And the third important thing is pretty much the big picture view using descriptive statistics. At the end of it, sure, we know what the past trends of the company are, we know how the company is going on now. But then if you need to just summarize all of this and say even add some predictions for the next 5-10 years, getting this big picture view of what's happened, what's happening now, and what will happen in the future, not just using very simple statistics, but using descriptive statistics where we'll be picking up each aspect of what's going on and then perform analytics on it and find out what's going on. If we are right at this place, if we are wrong at this place, how can this be improved? How can this concept be checked? How can we reach the clients better, and so much more. So getting this big picture view is again a very important task a data analyst goes about doing, guys. And the fourth one is probably the most important thing a data analyst does, is pretty much the creation of dashboards and visualizations, guys. So as I already told you in the introduction part of the video, where we're starting out with raw information, again a lot of numbers, but if you have to show these numbers at a business meeting, numbers are numbers, some people like them, but a majority of the people who they might not understand the numbers. So making these numbers as your input, creating very good visualizations, giving them a user interface, and giving your customers, your peers, your superiors, your business meeting members, giving them a very good user experience with all of this data, again at the end of it will add up to very good business methodologies, and then it will help you take better business driven decisions again. And again, the same goes for presentations of results to your clients and your internals as well, guys. So coming to the chain of how the data moves around in a firm, I have three important things that I just want to walk you through, guys, in a quick gist. As the first person who is the spearhead of the data for an organization. By spearhead, I mean he's the first one who look at the data, or he'll be responsible for bringing in all of the data from various sources, guys. So data coming in from the various sources, right? So think about all the data you can get from Twitter, or if you're performing any sentiment analysis, think of all the data that can come from all of the big data sources. You can have data coming from your various nodes from Hadoop, so much more. You can have your data coming from your own network, away from your network, and so much more, guys. So the data engineer is a spearhead who handles bringing in the data and making it understandable by the organization, guys. And then as soon as the data engineer finishes his part with the data moves on to the data scientist. The data scientist, he's responsible for working on all of these raw data, converting it into valid information. But then we already told this for the data analyst as well. Well, the data scientist pretty much uses machine learning algorithms. He uses deep learning. He uses, let's say, binary classifications, naive bias. He makes use of so many concepts here our data analyst might not know. And he uses a lot of machine learning and deep learning, as I've already mentioned, to convert this raw data into valid information. And 99% of the time, the information which is being converted into are numbers, guys. So after the data scientist pretty much goes about doing his magic onto the data, and then we have the data analyst who steps in. This person, again, as we've already been mentioning, he is responsible for the prediction of what happens in the future, that is finding out trends, and then the presentation of all these informations to your peers, to your clients, to your superiors, and so much more. This is the basic gist of how data moves around. So the data is first seen by the data engineer, he does his job, comes to the data scientist, the data scientist works his magic via all these fancy algorithms and whatnot, and then pushes the data to the data analyst. The data analyst performs predictions, sees trends, visualizes the data, makes it presentable for everyone to understand, and then eventually goes about analyzing the data, guys. So on that note, we can come check out the type of data analytics that can be done in today's business, guys. There are a couple of types of data analytics, and I'll be walking you through the same. So the first type of data analytics you can go about doing is the descriptive analytics. With respect to descriptive analytics, again, the quick one phrase answer to what descriptive analytics is basically picking out data from a source, summarizing your data, making sure your data can be understood by everyone, that is picking out very good insights from your data, from all the past events, doing some predictive analytics on that as well, and then keeping it ready so your data is descriptive at the end of the day. And a question which goes by to understand the descriptive analytics is what happened in my business. So the answer to this question, what happened in my business, is given to by the descriptive analytics, guys. So most of the time, the data which is generated by descriptive analytics is very comprehensive, it is extremely accurate, and the visualizations are very effective as well. So here's a very simple scenario that you guys can consider. So consider a scenario where an e-learning website decides to focus on a trending course according to the analytics of the search volume of the course content, which pretty much the users go on searching, and all of the revenue generated by the course in the past few months as well. So there are certain technologies, again, we live in a world full of trends, right? So let's say data science is in the boom right now. So pretty much any e-learning company, or any company for that matter, they're going to find these trends. They're going to know that, hey, data science is sitting in the top tier and we need to do something about it. If they have students in data science, then most of these companies are aimed at making the students' life better, right? So even as a firm here in Intellipaat, that's exactly what we do as well. We get this amazing insight from all of our learners for any particular course, and we use all of those insights, all of the feedback that we get, and what's trending in the market, what's latest in the market, and we use all of these to perform analytics, and then pretty much all of these helps us to put out a better course as well, guys. So at the end of it, you can already see how the descriptive analysis is already helping our business, right? And then the next type of data analytics we can check out is the diagnostic analytics, guys. So we already checked out what is happening to my business with respect to descriptive analytics. With respect to diagnostic analytics, you will check out of why this particular thing is happening to my business, guys. To simplify it, again, it basically gives you the ability to drill down to the root cause of why something is behaving just like how it should, guys. So drilling down the data to identify certain set of problems which are present in your data or in the trends that the data shows is a very vital part of diagnostic analytics, guys. And then it basically helps in answering the question for us about why the issue has occurred, So it just takes one look towards the data, towards the analytic result of the data, to understand what the cause behind a problem, if one should exist, as guys. So again, to give you a very simple scenario of how diagnostic analytics would work, let's say consider a company where the sales went down for a month. So let's say they weren't doing as good as the previous months. So to diagnose this particular problem, you will let's say consider the situation where the number of employees were quitting their job and they weren't bringing in a lot of sales. So this could pretty much, this number of people quitting the company could directly impact the sales that they brought into the company. So the sales went down this month because they did not have the company right. They did not have the sales right. So finding out why this is happening and hunting for that root cause, which is basically a treasure hunt with your data, where you go on finding something and taking insights from your data. Finding out that why part of it is extremely important, where you'll be finding out what's happening to the data and why it's behaving this way, guys. So this again is a very vital part of diagnostic analytics. And coming to the third type of data analytics, it is predictive data analytics, guys. And as the name suggests, the quick question you'll be asking is what will happen in the future based on the past trends, guys. So finding out, hunting out, historical patterns that are being used to basically predict all these specific outcomes using, let's say, machine learning algorithms, using deep learning, and using so many more concepts to predict something in the future based on the data we have now is again a very important niche of data analytics, guys. So predicting the future trends and the possibilities in the market based on the current trends, self-explanatory. And then it helps in optimizing all of the business plans for the future because now your business has a direction to head to, right? So you're predicting certain aspects in the future and you know which path leads to better business strategies, right? And this will give you an edge over all of the other businesses as well. To give you a very nice example, think of the Netflix recommendation systems, guys. So this will basically use statistical modeling to analyze all the content that it's being watched by the audience across the world. So let's say there are a couple of TV shows which are very famous in India, but then there might be a couple of TV shows which is trending in the United States and let's say Australia, United Kingdom, so much more. Making sure that the right users in the right geographical area get to know the right recommendations are extremely important for Netflix as a business, right? So this again, predictive analytics will just do them good there, guys. Again, it will provide us with the prediction of all of the upcoming content and the shows that must be watched by all the different class of audience as well. So let's say someone sitting in the United States is very interested in watching an Indian trending television series as well. So knowing Netflix, finding out that this person exists and to recommend an Indian TV show for this person sitting in the United States to watch. Again, this is another very good business opportunity for Netflix. And then if they go about nailing their recommendation system for everyone, it just makes them a better business model. And then it just makes a better user environment for the users to go about watching videos there, guys. So the next type of data analytics is prescriptive data analytics. So as soon as we think of a prescription, again, we think of a doctor, we think of something, a medical appointment or something, right? Here it's again something similar. The question which will be asked here is what should be done? So applying advanced analytical algorithms to ensure that you make very good recommendations, you make sure you're punching out very good strategies that help the business and so much more is a very vital part of prescriptive analytics, guys. So it basically involves breaking down all of this complex information into a very simple set of steps. And these steps are like the prescription we handed out when we visit the doctor, right? And these are the prescriptions which are precautious as well, let's say. They're the precautions basically used to remove any of the future problems that might occur. And it will also help in performing predictive analysis. This will basically help to predict outcome. And eventually that will help us optimizing business as well, guys. So this again demands the use of artificial intelligence and big data. And then the data analyst person will always be in touch with the data engineer as well and the data scientist as well because he's going to need all the help he can get with respect to artificial intelligence from the data scientist and help with respect to big data from the data engineer as well, right? So all these three guys working in correlation make up a business and I've already told you that. So again, to give you a common scenario of how this would happen, consider the prescriptive data analytics that Google Map goes about doing, right? So every day we are commuting from our office to our homes, or let's say we're going on a vacation and then we need to get out of the city as quick as possible. So Google Maps has a wonderful API where they map out the best possible route considering live traffic conditions, weather conditions, road closures, and so much more. It considers your distance, traffic constraints, and again, as I already told you, it even considers if it's raining, if you're walking, what's the best route that you can take to walk, what's the best route to take if you're in a car. And now they've come up with the bike route as well. So if you're in a moped or a bike, you can take a different route compared to the person who'd commute with the car, and so much more. So knowing this kind of a prediction into the future and giving you this sort of a prescription to ensure you don't run into any problems along the way is a very important part of prescriptive data analytics, guys. So on that note, let's quickly check out what the life cycle of data analytics is like. So the data analytics lifestyle, it basically defines the analytics process, our goal, and all of the best practices which goes on from the discovery of the data or the project till the completion of this project, guys. So there are a couple of steps involved in this life cycle process, and the first one is business understanding. At the end of it, again, understanding the purpose and all of the requirements that come from your business, and understanding it from the business viewpoint is very important and vital for the functioning of a business, right? This also consists of a very good introductory plan. It consists of a decision plan. It consists of a formal to-do list, let's say, for the business to go on to achieving the target. So the first important thing about the life cycle is the understanding of what's going on around you, and the second one is the data understanding, guys. With respect to data understanding, again, this mainly involves the process where we're collecting the data and we're processing the data in a way which leads to analytics. And then after the analysis of the data is done, we need to pick up some insights that we can go about using from the data. So extracting all of these meaningful insights from the data, again, is a very vital step in the life cycle of data analytics through data understanding, guys. The third part of it is data preparation. So data preparation is the let's say converting the data from an unstructured form to a structured form, and this involves constructing, let's say, a data set as well. And then this data set will be provided and fed into a model, and then this model will be used by a machine learning algorithm to train, to understand, to see what's going on, to perform predictions, and then it will be given to the data analyst to be visualized using Tableau or any other business intelligence tools, and so much more. So data preparation, again, is a very important phase where the data is actually being transformed, and even at the stage the cleansing of the data is pretty much performed as well, guys. And then comes modeling. Our goal. This step is very important because it involves the selection of various modeling techniques. Applying all of these modeling techniques, making sure the parameters are right, and all of the readings here are right to ensure that your data being converted into the information, raw data being converted into the information, is of the optimal, let's say, it's of the optimal tolerance that can be used for your business usage. And then as soon as your modeling part of it is done, as soon as the techniques are applied and all the parameters are marked, then comes evaluation, guys. So evaluation is a very important phase where, again, the model which is being built, it will be built very rigorously, tested very rigorously based on what you've built in the initial stages, and then so many tests will be performed on this data as well. So evaluating something that you've generated, performing various tests on it, is extremely important. Most of the time this is overlooked, but then these days everyone knows the value of evaluating your data, guys. So this again involves reviewing all of the steps that are again needed to carry out to construct this particular model and to perform tests on it is very important. And with evaluation, that's exactly what we do, guys. So the next life cycle concept I want to tell you guys is deployment. Deployment is the last step in the data analytics life cycle, because deploying is when you're sending out your model into the world for, let's say, by the world I mean, let's say, for your team, for your peers, or let's say even for your client and customers as well. So making your data go from just you seeing it all the way till spreading the data and perform it, spreading the data to your clients, to your peers, or anyone else. If you can perform more tests on these as well. So after deployment, you can have after deployment tests. If something is wrong, again, you can go back to modeling, perform more evaluation, perform more deployment as well. So the thing you need to know here is that deployment pretty much goes about to be the final phase of the data analytics lifestyle, guys. Our goal. And on that note, we can check out very quickly what are the roles of analytics in various industries around us, guys. Again, data analytics has an amazing insight and impact when it comes to telecom industry, because again, if you've been observing, all the prices of or let's say the calls, the messages, or the internet packs these days have been coming down and down. And there was a time when they were being exorbitantly high as well. So again, the telecom industry realized that if you keep the prices very high to make more profits, then eventually your customers will not come. They will not buy the internet packs. So to keep this in mind, probably they decided, let's say we're having a bad impact right now, so let's drop down our prices to see if it works. And it is, I guess. And this has helped the telecom industry in bringing better business. And for us as users, it has helped us just make it a bit economical and efficient on our side with respect to money as well. And then the retail banking industry, data analytics has a huge impact in the retail banking industry as well, to know what their customer wants. Because again, with like telecom industry as well, they have a huge amount of customers to play with, right? So they need to understand the view of each customer, the requirement of each customers, and then to find out if all of the customers are actually in the common chain of what's being supplied by the bank, or if the customers are against something that's being sent by the bank. So our goal, that again is a very important thing that you need to check here as well. And then with respect to the e-commerce industry as well, to perform again some analytics in the e-commerce industry, it might be ad recommendations, or there are very big sales which are run by some of the big names in the industry such as Amazon, Flipkart, Myntra, and so much more. So these guys will have to perform extremely heavy analytics on the data that they see, based on the products that they sell, and based on the places, based on the city in which the product sells, or if the people are unhappy with the price. Again, performing analytics has just changed the e-commerce industry, if you may, guys. And last most important industry where data analytics has touched is the healthcare industry. This has had the most impact with respect to analytics in the healthcare industry, with respect to so many things. Mainly it is with respect to finding out what medication is required by what countries, what amount of medication is working for what population, and so much more, guys. I can probably talk about just the roles of analytics in these industries for days together, and we can still be going on and have a very good discussion of how important analytics has become these days. Again, with respect to insurance as well, what geographical location requires insurance, what the audience are, and so much more. So again, as I've said, we can go on talking about this, but then to keep it to the scope of this tutorial, we can just quickly brief through each of these guys. So with respect to the healthcare industry, this is the formal way of going about analytics. The first one is to again analyze all of these disease patterns, analyze all of the disease outbreak that pretty much goes out. We had a disease outbreak a couple of years back, which is Ebola, and so much more. We had H1N1 and so much more, right? To keep a track of all of these outbreaks, this basically again improves the surveillance with respect to health, and then this gives out good responses to the emergency sectors as well, guys. And then development of better targeted preventive techniques, obviously, and then with the development of vaccines, making sure your vaccines again reach your customers, and all of these where you need to reach your customers, or let's say in this case the patients are very important, guys. So identifying the consumers again in this is the greatest risk of business. So identifying certain customers or patients who are at the greatest risk is again, because they might be developing some adverse health outcomes, and then developing welfare programs to keep a track of their health, to track their health on a daily basis, even a weekly basis, monthly basis, to perform analytics on all of the aspects and the parameters that you're tracking with respect to the patients. Again, that is a very important thing. And lastly, to ensure that they can reduce readmissions, because they might know what the cause of an adverse effect is. And if there are 10 patients with very similar symptoms, then you can perform analysis and you can at least filter out and find out that all of these 10 patients might have this one common symptom associated with them, and this might be the cause of that. So mapping that for every patient is again very important, guys. So coming to the telecom industry, again, telecom industry pretty much goes about using predictive analysis to gain all of the insights that they need to make better decisions, to make faster decisions, and to make more effective decisions. Again, as I was talking about the internet pack example, again, this was very key in that. And then by learning more and more about the customers daily, and the preferences and the needs, these telecom companies can be more successful in this extremely highly competitive industry as well. It's good for them with respect to business, and it is good for us as customers by bringing down the prices again. So it is used for analytical customer relationship management, it is used for fraud reduction, it is used for bad debt reduction, it's used for price optimization, call center optimization, and so much more. So now that you're looking at data analytics in this way, you realize that data analytics eventually has a big play, or has a big say when it comes to any of these business models, right? So again, coming to banking, as I've already mentioned, analytics is making banks become very smart day by day, guys. So it is managing all of the plethora of challenges that the bank faces, and then again, while pretty much going about doing some basic reporting all the way till descriptive analytics. And this is all a must for every single bank, right? Even performing, let's say, advanced prescriptive analytics or so much more. And all these are starting at this age. Banks have started to realize that this will again help you generate very good insights, and this will result in extremely good business impact, and it will help the banks as well. On that note, we need to check out how data analytics is helping in the banking industry as well, right? So it is used to acquire and retain customers. It is used to detect fraud, which is again extremely important with respect to banking. It is used to improve risk control, find new sources of growth for the bank, and to optimize all of the product and generate their portfolio models as well. So as soon as we check out the banking sector again with the e-commerce industry, right? So this is a market which is exploding for the last couple of years. I can say even the decade, right? eBay came up, Flipkart came up, Amazon is again taking over everything, Myntra, Nykaa. Guys, there are so many e-commerce portals today, and to make sure we perform very good analytics on these e-commerce industries is very vital. So how is data analytics used? Again, it is used to improve user experiences. It is used to enhance customer engagement, customize offers and promotions, maintain effective supply chain management, optimize pricing models, minimize the risk of frauds, provide them very good advertisements that pretty much help them pick up products, good recommendation systems where they'll pick up another product after the first product, guys, and so much more. If you've just bought an iPhone, again, you'll pretty much be recommended with a couple of cases that the people have bought as soon as they bought another iPhone. So you might be that person, you might like the case and you might pick it up. At the end of it, you have the case to protect your phone. The business just created more money out of it, right? So again, at the analytics, the role of analytics in e-commerce industry is extremely vital. Let's say the people in the e-commerce industry have known this for a while, guys. So coming to the analytics in the insurance industry, again, here as well, guys, this is basically used to enhance your customer engagement, acquire new customers, retain the existing customers, make sure the customers don't leave, prevent the frauds, at the end of it, reduce the frauds, prioritize all the claims that need. You'll have medical insurance, you'll have again health insurances, you'll have life insurance, you have so much more that you need to take, and all of these directly impact the user, right? So making sure you take the feedback from the user, work on it, and then create some analytics out of it is again very vital, guys. So on that note, we can quickly come to our case study, which I was talking about, and this case study is a very famous one. It's basically the house price case study, and here all we'll be doing is predicting house prices, guys. So we'll have a certain set of data which we will use to predict the prices of the houses. So basically, how can we predict the price of a house? There are so many things that you will need to know, right? You'll be looking at the locality in which the house is present. You'll be looking at the amenities. You'll be looking at the number of bedrooms, the living space, the number of floors in your house, or the number of cars that can fit in your garage, the size of the garage, the quality of the construction of the house, if it has a swimming pool or not, if it has a spa or not. I mean, so many things. If we have to list down this particular use case, then it will be extremely tough because each one of us has our own judgment of how we can validate a house, right? Because house is something that's very personal to us. Again, the materials of what was used to go to build the house, the style of the house which is built in, the number of if the house has an elevator, how convenient is the house for disabled people, guys, so much more. So basically, we'll be performing exploratory analysis on this, guys. So exploratory data analysis, again, is used to find a hidden trend in your data by performing analysis on it. And then at the end of it, the trends will be shown as numbers. But since we already know visualization, we're going to be pretty much using these numbers to visualize all of the data for us. And we'll be doing it step by step. So we'll be finding correlation between the data as well. So again, correlation is basically to check how one variable is linked and how the changing of one variable directly changes the other variable as well. So how these two variables are pretty much hung up together, how changing one variable changes the other can be known using correlation as well, guys. So a couple of steps that pretty much is generally followed in the case of performing exploratory analysis. First, we'll be visualizing all of our data, finding the missing values, and we'll be looking for correlations, guys. And then after this is done, we'll be cleaning the data to check if any issues are fixed, or if we'll be checking out if the data that we have is pretty much being used fully or not. And then we'll go about building a model which is used to visualize our result. It will give us the diagnostic, it will give us the residual diagnostic, ROC curves, charts, graphs, tabs, tables, and so much more. Guys, I do not want to basically overwhelm you with the use case. So to keep this use case very simple, we'll just perform exploratory data analysis at this stage to find out correlations between the data. And as soon as we go about progressing with respect to our data set and to work with, you will understand how beautiful data analytics is, guys. So let me quickly jump into Google Colab, which is basically a Jupyter notebook hosted on the Google Cloud. And here we can go about performing our data analytics on the use case that I just walked you through. So we're going to need a couple of files to run our use case. We'll actually need one file, which is our training dataset file. Let me just quickly add the file to our Google Colab, and then we can go about proceeding performing our analytics, guys. So this will just take a second to upload the file. Give me a second. We just actually need one file from out here, but then it doesn't harm to upload it and keep it in your runtime. But then you just check the message, right? So pretty much all of your files are recycled as soon as the runtime is pretty much changed. So the first step for our use case is to load all of the necessary files and the libraries that we require, guys. So the first, again, we'll be using Pandas to handle all of our data. We'll be using Seaborn and Matplotlib to perform plotting operations on all of this data, to perform visualizations on all of these data. And the style that we'll be using is pretty much called as the BMH method. And with respect to the BMH, again, BMH is nothing but the Bayesian method for hackers. And this is just a type of a graph visualization method, which gives us graphs which look nicer, and then it helps us to perform analysis better on linear data sets, guys. So the second thing we'll be doing is, again, loading all of the necessary files. One of the important files we need is the training data set, which is this. And here you have the ID of the houses, you have the subclass of where the houses is present, you have the zone in which the house is present, what is the area of the frontage that you have, what is the area lot of your house, what is the street, what is the alley, again, lot shape, lot contour, what is the year the house was built in, what it was remodeled in, what is the size of the roof, again, so many conditions out here. What is the foundation made of? How is the quality of the basement, condition of the basement, the exposure to the basement, again, finishing type of the basement. Guys, just look at how expansive this data set is. This is, again, a data set which is extremely popular among us analysts, where we pretty much like to work on this because it consists of everything and you can perform so much on the single data set and so much more, guys. So on that note, let's quickly find out the information of all the variables that are present. Again, since I was just working with the housing as heating, how is the quality control of the heating? Does that centralize air conditioning? How is the condition of the electricals? What is the square footing of the first floor, square footing of the second floor? What is the low quality finish that's and how many square feet of that do we have? What's the living space area? How many full bathrooms do we have? How many half bathrooms do we have? Kitchen quality. Guys, this will go on, right? So all these data is what we need to check out. Again, if you see here, all of these are the values that are present which will help us map something. But then Ali, again, doesn't have many values. You can check out here itself, right? So Ali, it's NaN is basically not a number. So there are not many, Ali or details which we can make analysis out of. So we will not require Ali. Again, coming down, not much of fireplace quality as well. We do not have pool quality control at all. Miscellaneous features are very less. Again, even fencing is very less. So the average is somewhere around 1400, right? So to make sure that are cleaning up our data, very important part of it is to basically how we go about doing it again. We'll just remove all of these data which are less than 30%. So less than 30% of, again, 1460, and then we can have at least 70% of the data to give us some accurate results, right? So as I already checked, alley ID, not every house has an ID, so that's removed. Not every house is mapped to an alley. Pool quality control is not there. Fence is not there. Miscellaneous features are very less. So we have dropped all of these columns and we'll not be using these to perform our analytics, guys. And so again, to describe what goes on to do a distribution, I hope you guys know this concept about normal distribution, and with respect to all of the details that we can get out of it when we perform the math operation, guys. So basically we can count the total number of data that's present with respect to all the individual data. What is the mean sale price of the data? What is the standard deviation? Let's say the mean of the normal distribution is right at the center somewhere here, guys. So the mean is somewhere around 18,000, right? I'm sorry, this is 180,000. If you just keep tracing from the center point down, this is somewhere where 180,000 exists. guys. So again, what is standard? Standard deviation is basically the deviation from the mean. So there are house values which deviate from this mean as well. Again, 25% deviations, 50% deviations, 75% deviations. And then what is the maximum sale price of the house as well? So all of these can be found out from this particular graph, guys. And if you can already observe, and even if you're not exposed to a normal distribution, this starts out as a very steep curve, but then it ends out with respect to a lot of data here as well, right? It goes on until 800,000. So basically, probably from 5,000 or let's say even 400,000 all the way till 800,000, we call these as outliers. These are called outliers because these are very far away from our normal distribution, and then these actually might not be useful for us with respect to our mean or whatever, and these will impact a lot when we are performing analytics with respect to the mean or the standard deviation or anything for that matter. So we will have to actually remove them and not consider them to basically perform very accurate analysis, guys. So on that note, we can pretty much go on to finding the type of the data set and the type of the data that we'll only consider, because in this particular case, since we're playing with numbers, it has to be the numeric data type, right? Again, as you can check out, we have integer numbers, we have floating numbers, and so much more. So let's pretty much go on to print what it looks like after we have dropped the values where we're not using id, we're not using alley, we're not using so much more, right? So these are all the numerical values that we'll be using to pretty much consider. Again, year built is a numerical value, 2003 is a date, a year, overall condition, overall quality, all these can be rated from a particular scale, right? So again, a square footing is a particular number as well. So the second floor of this particular house has 854 square feet, so much more. So on that particular note, as soon as we check out all of these numbers are present, we can start performing an analysis, guys. So before that, again, we need to just plot all of these to just check what it will look like on graphs, because seeing numbers are one thing, seeing graphs on the other hand are something else, right? So pretty much we'll be developing histograms and we can be checking out, guys. So let me just scroll down a little. Yeah, perfect. So with respect to first floor square footing, the mean is somewhere around here, right? So it's around, let's say 500 square foot, 1000 square foot. And again, look at second floor square footing, look at the bedroom average, basement finishing qualities, garages, the number of cars that you can park in the garage, and look at the value here too. So the majority of the houses here have two spaces to park your cars. The year that the garage was built in. Again, the ground floor living area, how many half bathrooms? So you can see one half bathrooms. Again, at this point of time, you have certain values at 0 as well. Well, sure, we can consider values of 0 if it's very important. But then since we're talking about sale price, what is present is more important than what is absent, right? We need to have something descriptive for our analytics methods to work. So in that case, we'll have something called as the golden features list. And this variable will basically contains all of the features that will be associating with respect to why our sales price is as high as it is, guys. So this variable called as the golden features list will have all of the features, guys. So basically we're creating a variable where we're finding out the correlation, and then we can already check out the top 10 correlated values which are strongly correlated. By correlated, again, let's say let me give you a quick impact. Basically, we have described this in the descending order, as you can already check out. So the first thing here is overall quality. Again, to transcribe this into literal terms, overall quality of the house, whatever the rating that was given in our data set, is mattering the most of how the houses is being priced. Again, the living area of it, the number of garages you can park is having almost 64% impact of with respect to why the price is like that. Garage area is having a 62% impact. The basement square footing has a 61% impact. And then the year it was remodeled and changes made is having a 50% impact of why the house price, the sales price is like that, guys. So looking at a couple of linear relationships, you can pretty much find out that a lot of values are zeros that I just walked you through a couple of seconds. And look at that. With respect to our, again, the ground floor living area, we have a very little number of zeros. With respect to the sales price, again, check out the basement surface area again. With respect to the total basement surface area, again, even here as well. So look at all these tiny dots which are sticking up to 0 with respect to sales price. So these have no impact for our sales price because they're not giving us any valid linear data. Look at this again with 0. Oh, it is raised up to a lot, about $600,000, right? So all these are not adding any meaning to our data. So if x is equal to 0, again, this might indicate that that house does not have that feature at all. So if this is 0, this house does, a lot of houses do not have pools here. So pool area is 0. So in that particular case, we need to remove all of of these zeros so that we can go on to finding more correlated values that we can actually use to go about working with it. Guys, again, here's all of the correlated values that we found as soon as we ran this command. Basically, we are sorting it again in the descending order to find out what helps most. And you can see that it's almost 80% of the total quality of the house, which matters when you're buying because of the price of the house, and people are actually preferring this. Living area, second floor surface area has a 67% chances of affecting the price, and so much more. And check out what the golden features list looks like with respect to all of the strongly correlated values we just found. Again, you're remodeled, you're built, so much more. So total surface area, again, number of full bathrooms, the first floor surface area, the garage area, total basement square footing, the number of cars you can park, the square footing of the second floor, the living area, and the overall quality, again, in this particular order from the least to the highest, is exactly what we're trying to find out with respect to exploratory data analysis, guys. So just looking at the data set, you could never figure out why the list price of a house was so much. And once we break it down into simple terms like this, we can find out that there is an 80% impact from the overall quality of the house, which the user is checking out to just consider the house or not. If the quality is very less, he will not pick up the house. If the quality is higher, then sure, he will pick up the house. So 80% of the reason why the price is set like that is a very important aspect of why the house price casing study is important, guys. Again, this has been a very important, very nice data set to work with, and you will get a lot of analytics that can be done using this particular data set as well, guys. Next up, I want to discuss the skills of a data analyst with you guys. So a data analyst is a person who pretty much works with and creates a lot of beautiful visuals, guys. So to do this, you need to understand the basics of mathematics, because if you have to have knowledge of statistics, mathematics is the foundation to go. And after you understand the foundation, you will build a step-by-step growth, a career path for yourself, where learning becomes the most important thing, because again, having the knowledge of statistics will help you play with a lot of numbers at the same time. And keeping the math part aside for a second, you need understanding of languages such as Python and R programming language as well. Guys, at this point of time, my goal here is to not overwhelm you. If you do not know statistics, if you do not know Python or R or any of these technologies mentioned on your screen, well, fear not. Make sure to stick with me till the end of the video, and I will guide you on a fast track path to become a professional data analyst, guys. And then the next point we have is data wrangling. Data wrangling again is to have an idea to play around with data, throw the data which is not needed, keep the important ones to know that you can work with. Because if you're working with inefficient data, your visualizations will be really bad. It's like, again, if I bring back the food example, adding a little less salt or adding too much salt is bad as well. And to give you a more clarity of data wrangling, let's say you're preparing noodles, but then if you just put the noodles in, fine, it's working. It's working because you're just making use of the part you'll eat. But what if you throw the entire packet of noodles along with the packet, right? It doesn't make sense if you try to boil the packet as well. Here is where data wrangling makes so much sense in the world of data cleansing and pretty much data processing, guys. So you need to understand your data before you do this. And then coming to a little bit of big data concepts, you will require a little bit of knowledge about Spark, a couple of components and tools of Spark. One of it is Pig, and another one is Hive as well, guys. Well, to break it down a little bit simpler for you guys, let us talk about each skills. The first thing I want to talk about is the analytical skills, because data analysts will work with large amounts of data at every point of time. So what is this large amount of data? It can include a lot of facts, it can be a lot of numbers, it can be a lot of figures, and so much more, guys. This if it is structured data. If it is unstructured data, they can work with images, they can work with audio, video, and much more at the same time. So basically what they'll do is, they need to go through this particular data, they need to understand the data and analyze it to pretty much find some sort of conclusion. So that is a very important skill to have. And then coming to the communication skills, well, again, as I told you at the start of this presentation itself, a data analyst will have to present his or her findings to a non-technical person. So having the communication skill where you can convey all of this really well is extremely important, because at the end of the day, you'll be translating your data, which could be meaningless to someone because they cannot understand it at this point of time, into understandable documents, very good looking dashboards, or again very nice looking reports at the same time, guys. Because again, having a good communication skills will ensure that you can convert a complex idea into something which is easily understood by a lot of people. And this brings us to the skills, next skill set, which is pretty much very important, and this is one among the important skills to have, which is critical thinking skills. Because at the end of the day, again, you'll be looking at thousands of numbers, right? So you need to know where to look, you need to know what to look, what your numbers can do for you, where are the trends, how can you get to those trends, what is your process benchmarking, how can you get to the goal that you set, and so much more, guys. And why is all of this done? Well, all of this is done to make sure that you can have a conclusion to look up to, right? So to simplify it, again, to give you an example, let's say you go shopping for all the food that you have to pretty much cook at your house. So you're going to need vegetables, you're going to need seasonings, you're going to need so many things to cook with it. You're going to need oil for some dishes. So you will plan, right? So most of us pretty much go out once a month or twice a month to bring out all the groceries and store it. So if that's the case, then you need to understand how much of groceries you need every single month, how much you're consuming, right? So you have to set a goal saying, what, this is the amount of vegetables that I'm going to need for this month, and then you're going to plan it and pick it up weekly, daily, or whatever your schedule is. So how do you set that duration of when you should go pick your vegetables? That is exactly why you need to formulate conclusions to understand how you can go from nowhere to there, guys. And then coming to the most important communication skill is that it'll again work together with the critical thinking skill, which will basically enhance the output of you guys. And then the most important thing I want you guys to contemplate about and think about is that data analysis is an art, guys, because you'll be working with numbers, you'll be working with graphs, visualizations, and everything can look its best, it's most beautiful if you know how to create it, right? So contemplate on that for a second, guys. Again, if you have any questions about data analysts, again, guys, I want you guys to head to the comment section.
So Pandas is an open source Python library which is used for manipulating one-dimensional and two-dimensional data. And the name Pandas is derived from panel data, which is a common term for multi-dimensional data sets encountered in statistics and econometrics. Now let's look at the types of data structures in Pandas. So we've got one-dimensional and multi-dimensional data. So if you're working on a one-dimensional data set, it is known as a series object. And the two-dimensional data object is known as the Pandas data frame. And if you're working on higher than two-dimensional data, Pandas would create a panel data for you. So let's properly understand what exactly is a series object. Well, a series object in Pandas is a one-dimensional labeled array which is capable of holding mixed data types like integer, string, floating point number, and so on. Now let's understand about data frame. So a data frame is a two-dimensional labeled data structure with columns which contain data of different types. So here we see that we have a two-dimensional data frame where the first and the third columns are of string type and the second column is numerical in nature. So now that we've understood what exactly is Pandas and we've also understood the different types of data structures in Pandas, let's go to Jupyter and start working with Pandas. So I'll start off by importing the Pandas data frame. So I'll type in import Pandas as PD. So this PD which you see, this is just the alias. So I am importing Pandas with the alias PD. So we have successfully imported this Pandas data frame. Now I'll go ahead and create a series object from a list. So let's see, I will name the list as data and I will give in these values. So the values inside these lists are 1, 2, 3, and 4. Now to create a series object from a list, all you have to do is use this pd.series function. I'll use pd.series and inside this, I will pass in this list and I will store this in S1. Now let me print this out. Right, so we have successfully created our series object from this list. So we've got these four numbers and these are the index values. So what you see over here is the indexing starts from 0. So 0, 1, 2, and 3, these are the index values and these are the actual values. Now let's see how can we change the index of this series object. So I'll just copy this over here, paste it over here again. So we have got the index attribute over here. Inside this, what I'll do is I will give in different set of values. Now let's say I want the index values to be A, B, C, and D. So I'll just pass in these values for the index parameter over here, and I'll store it back to S1. Now let me print S1 over here. So we have successfully created a series object where the index values are A, B, C, and D. Now if we want, we can actually extract these individual elements with these index values. So let's say I want to extract the value which is present at the index value C. I'll type in S1, I'll put in parenthesis, and inside this, I'll put in C, right? So I've successfully extracted this value. Similarly, let's say if I wanted to extract the element which is present at index A. So I'll type in A over here, right? Now let's say if I want to extract the first two elements. So if I want to extract the first two elements, I'll just put in a colon over here. I'll put in 2. Right? So I've extracted the first two elements. Similarly, if I want to extract the last two elements, I'll put in a colon, and over here on the left side of the colon, I'll put in -2. So this is how we can extract the last two elements from the series object, right? So we have created a series object out of a list. Now let's go ahead and create a series object out of a dictionary. So let me create my dictionary over here. I'll name this as D1. I'll put in curly braces over here. Now I'll create my dictionary. So I'll just start off by assigning the key value pairs. So A, 1, B, it is 2, after that for C, it is 3, and after that for D, it is 4, right? So I have successfully created my dictionary over here. Let me also print this out. Right, so these are the key value pairs. Now, again, to create a series object out of this, I will type pd.series, and inside this, I will pass in the dictionary, which is D1, and I will store this in S2. Now let me print out S2. So this is my series object over here, right? So all of the keys have been assigned as the index, and all of the values are the actual values in the series object, right? So A becomes the index value over here, B is the index, C is the index, D is the index, and the value corresponding to this key becomes the value in the series object as well. Now let's say if I want to resequence the index values over here. Let's see how can we do it. So I will copy this and I will paste it over here. Now again, I will use the index parameter. And inside this, let's say instead of A, B, C, D, I want the sequence to be D, C, B, A. So that is what I'll give over here. D, C, B, and A. Now let me run this and let me just print out S2 over here, right? So we have reversed the sequence of these indices. So initially it was A, B, C, and D. Now I have reversed it and now it is D, C, B, A. Right? So this is how we can create a series object out of a data frame and also change the sequence of these indices. All right. So we have work with series. Now let's go ahead and see how to create a data frame out of a list. So I'll just write a comment over here. Creating data frame from a list. Right. So let me again go ahead and create my list. Data equals 1, 2, 3, and 4. Right. So I have created my list. Now I'd have to go ahead and create the data frame. And to create the data frame, this would be the syntax. So I'll type in pd.data frame. So over here, you have to keep in mind that D is capital and F is capital. Right? And inside this, I will just pass in this list. And I will store this in df. Now let me print this out. Right? So we have successfully created a data frame out of this list. Now let's also go ahead and create a data frame out of a dictionary. So I will type in fruit over here. So the name of the dictionary is fruit. And over here, I will write the key to be equal to fruits. And the values for this key are, we've got all of these fruits. We've got apple, we've got mango. After that, we've got banana, And finally, we've got guava.
Our goal.
So this was the first key value pair. After that, I'll give in the second key value pair, which would be the count of the fruits. So I'll type in count.
Our goal.
And over here, I will just set in the count.
Our
So
goal.
let's say there are 10 apples, 20 mangoes, 40 bananas, and 30 guavas. Right, so we have created a dictionary.
Our
Now
goal.
let me print this out. Now let me also go ahead and create a data frame out of this. So you already know we'd have to type in pd.dataframe, and inside this, I will pass in fruit. And I will store this in, let's say, fruit underscore df.
Our goal.
Now let me print this out, fruit underscore df, right? So what happened over here is these two keys have turned into the column names. So fruit has become the column name over here, count has become the column name over here, and these values come into the rows, right? So fruits we have over here, and apple, mango, banana, and guava are the row values. Again, count becomes the column name, and these values over here come over here, right? So this is how we can create a data frame out of a dictionary. Right, so now that we've understood the basics of series and data frame, let's go ahead and see how to import a data frame and do some sort of data manipulation on top of it. So I have this customer churn data frame with me. Let me go ahead and import it. So to import a data frame, I'll type pd.readcsv.
Our
Now
goal.
inside this, I will just give in the name of the file. So the name of the file is customer churn.csv, and I will store this in a new object and name that object to be customer churn. Now let me go ahead and print the first 5 columns of it.
Our goal
will be customer churn dot head. Right, so this is our customer churn data frame, and it comprises of all of these columns. So we've got customer ID, gender, senior citizen, partner, and so on.
Our goal.
So this is a special function in Pandas which gives you the first 5 rows, right? So 1, 2, 3, 4, 5. Or similarly, let's say if you want to have a glance at the first 10 rows, you just given the value 10 over here, and you can glance at the first 10 rows of this customer churn data frame.
Our goal.
An analogous function to head is the tail function, which would give you the last few rows. So I'll type in tail over here.
Our
Now
goal.
I'll click on run. So this over here gives you the last 5 rows from this customer churn data frame. Similarly, if you want to have a glance at the last 10 rows, you will just put in the value 10. Right? So these are the last 10 rows present in the customer churn data frame. Right. Now let's see how can we extract specific rows and columns from a pandas data frame. So for this, we've got log and ilog functions. So let's actually start working with the ilog function.
Our
So
goal.
let's say I want to extract only the rows from row number 5 to row number 15, and only the columns from column number 2 to column number 4. Let's see how can we do it. Right, so I'll start off by giving the name of the data frame, which is customer churn. After that, I will use the function ilog, and I'll put in a comma over here. Right, so whatever is present on the left side of the comma, that denotes all of the rows, and whatever is present on the right side of the comma, that denotes all of the columns. So let's say if I want to extract all of the rows from 5 to 15. So I'll put in 5, I'll put in a colon, and I'll type in 15. Right, so I'll be extracting all of the rows starting from row number 5 to row number 15.
Our goal.
Similarly, if I want all of the columns starting from column number 2 to column number 5, this is how it will go.
Our
Right.
goal.
So let's actually have a glance at this. So this 2 to 5 over here. So since we already know that in Python, indexing starts from 0. So 0, 1, 2. So this would be our column number 2, which is senior citizen. So 2, 3, and 4, senior citizen, partner, and dependents. Right? So we have extracted column number 2, column number 3, and column number 4. And we have extracted the rows starting from row number 5 to row number 14. Right, so this is how we can extract specific rows and columns from a data frame. Now let's go ahead and see how can we perform some sort of data manipulation.
Our
So let's
goal.
say from this entire data frame, I want only those records where the gender of the customer is female, right? So for this, what we'll do is I'll just start off by typing the name of the data frame, which is customer churn. And then inside the parenthesis, I will give in the name of the column, which is gender. After that, I'll use the double equal to operator and then given the condition, which is the gender of the customer needs to be equal to female, right? Now, I'll click on run and let's see what do we get. So you get a bunch of true and false labels. Now, this bunch of true and false labels basically means that over here at record number 0, it is actually true. That is, the gender of the customer is female. So false over here indicates that gender of the customer is not female. Here again, it is false. Here again, it is false. So again, at record number 4, it is true. That is, the gender of the customer is female. Now, what I'll do is, I will cut this.
Our goal.
I will paste it back inside this, right? So what is happening over here is, from this customer churn data frame, I will extract only those records where this condition is true, right? And I will store this in, let's say, female customer. All right, I'll click on run. Now let me print out the head of this. Female underscore customer dot head. Right. So we have successfully extracted a subset from the original data frame where the gender of the customer is only female. Now, similarly, let's say if you want to do some sort of complicated operation than this. So let's say you want to extract only those records where tenure of the customer is greater than 50 and the internet service of the customer is equal to fiber optic. All right, so now let's start off with the first condition. So I'll give in the name of the data frame, which is customer churn. And inside the parenthesis, I will give in the name of the column, which is tenure. So the tenure of the customer needs to be greater than 50. All right, so I'll cut this and put this inside braces. I'll put the AND operator and give in the second condition. So the second condition is the internet service of the customer needs to be equal to DSL. I'll type in internet service and this needs to be equal to DSL. Again, I'll put this condition inside quotes over here. All right, so we've got these two conditions. And finally, I'll put those two conditions inside the data frame. So what is happening is, from this entire customer churn data frame, we'll be extracting only those records where these two conditions are satisfied. And I will store this in, let's say, C underscore tenure underscore internet. Now let me print out the head of this. So it'll be C underscore tenure underscore internet dot head. So let me have a glance at the tenure. So over here, if you see, the tenure of the customer is greater than 50 for all of these values. So 62, 58, 72, 70, and so on. Now, similarly, if I have a glance at the internet service column, then you'll see that all of these values are DSL. Right, so this is how we can perform data manipulation operations on top of the Pandas data frame. All right, so we are done with the practical.
What is the primary purpose of data analytics? Our first option is to collect raw data. Second is to analyze data for decision making. Third option is to store data securely. And our fourth option is to design databases. So whatever option you guys feel is the most suitable one for the primary purpose of data analytics, kindly drop down your answers in the comment.
So, exploratory data analysis, or EDA for short, is the process of performing initial investigations on data so as to discover patterns, abnormalities, or anomalies in assumptions with the help of summary statistics and graphical representation. Basically, when we have some data on which we want to perform data science and statistical analysis and machine learning modeling, we first need to make sure that we understand what the data represents, shape of the data, what are the different kinds of things that are available in our data, different data types available in our data. If we could visualize our data and understand relationships between individual columns or individual features in our data, that's really good. And all of it and more, such as visualization and all, is done in a step called exploratory data analysis. So that's what EDA is all about. Now, EDA allows us to get a better understanding of our data and make important observations on it. In order to understand this, let's understand with an example. If you have a data set which you have no understanding of, you don't understand what the data it contains is, what do the columns represent, how do the columns relate to each other and which columns are important for the particular task that you are trying to solve. In cases like this, it is very difficult to understand how you are going to solve the problem, how you're going to build the model, how you're going to perform statistical analysis, so on and so forth. So in this sections, what happens is we would like to perform exploratory data analysis in order to get a better understanding of our data. This also helps us understand whether or not the data that we have needs some sort of boost. So, for instance, if we have some data set that's highly biased on one result, for example, we are trying to predict whether or not a particular internship is going to convert into a job. Let's say we have a data set that we want to figure out whether or not we can create a predictive model in which we can feed in some data about an intern and figure out whether or not we should give them a job. Although it's a very specific use case, if all we have is data where people did not get converted into full-time employees, our data set is completely biased. And this is something that we could miss if we don't take time to analyze our data using exploratory data analysis. So if that is the problem, then we would have to get more data so that we can balance out both the probabilities and then teach our model about these things so it has better understanding of what features lead to what results. So now we come to why EDA. Why would you want to perform exploratory data analysis? We've understood what it is, but why exactly would you want to do it? Well, exploratory data analysis is one of the most crucial steps in data science. It allows us to achieve certain insights and statistical measures that is essential for the data scientist. A good understanding of exploratory data analysis process allows us to make some important observations and early decisions that could help us reduce or that could help us not take steps that are not needed. So as we discussed in the previous example, if our data set is biased, then performing modeling and using multiple algorithms and trying to figure out the accuracy of each model is not going to be a good idea. Mainly because the data set we have is not good. If you don't have a good data set or don't have a data set that's representative of the reality in the current world, then your model is not going to be good. It's not going to perform really well. So exploratory data analysis helps us perform as few steps as possible in order to get the best result. This is why exploratory data analysis is so crucial a step in our data science process. So it performs certain steps to define and refine our important features and variable selection. So it could be that you have a data set that contains 25 different columns, but for what you are trying to predict, only 3 or 4 columns are going to be enough. They explain most of the things or most of the variation in the data or in the column that you're trying to predict. So you only need to use 4 variables. Now, which 4 of those should you use? And if indeed are the 4 variables or are the 5 variables that explain it better? For that, exploratory data analysis is important. It allows us to select features that are going to be useful for us. In case we don't use the correct features, we end up with a model that's highly bloated, contains data that's irrelevant, requires users to fill in data that's relevant, and could lead to incorrect or highly improbable results. So we need to be very careful when we're trying to take model columns or columns on which we are trying to model our data on to make the prediction. Now, why would you want to perform exploratory data analysis with Python? There are many other languages out there, including R. You can even perform exploratory data analysis in JavaScript and Java and C++. So why should you use Python? Well, exploratory data analysis using Python is very easy. First of all, Python is probably one of the easiest languages to get started with. This is why Python is so popular in data science community, because many people who perform data science operations or machine learning operations on a particular data set are people who come from the academic world. They don't have much understanding of what programs are, what variables are, what classes are. They only need to write code to get the things that they want to get done better. This is where Python comes into play. It fills the gap. So since Python is so easier to use, and another advantage that Python provides is that it has a number of libraries that allows us to perform tasks related to exploratory data analysis. In case we are performing these tasks ourselves, it's very, very important for us to make sure that the libraries we are using are trusted and used by multiple people, because if it's a library that someone has created, our confidence in it is going to be really low. For example, if it's a library to perform data visualizations, but it's a library that not a lot of people have used, then you cannot be sure that the library is going to give you accurate visualizations. And it's always going to be a bit problematic. In Python, however, there are libraries that have been used by millions of developers and academic people. What they do is they just understand the basics and then they import the data and visualize it and perform the task that they need to perform right at the step. And that's really important for our dataset. So this is why Python is such a good candidate for exploratory data analysis, mainly because it's easy to understand, easy to read, it's got a really clear syntax, as well as because it's got so much good tools and libraries around exploratory data analysis and data science in general. It's just a really good experience for developers or people who are getting started with exploratory data analysis or data science, or even professionals. Now, Python has libraries to perform all kinds of tasks relating to exploratory data analysis, such as visualizations analysis, etc. Visualize the data, there are libraries available, not just one library, but multiple. Depending on the features that you're trying to use, you can import either one of the libraries that are available. The libraries for data analysis, libraries for numerical manipulation. There are libraries for many other different kinds of tasks, such as creating neural networks, defining the structure of a neural network, visualizing neural networks, so on and so forth. So this is why Python is so popular. Now, some of the most popular libraries to perform EDA are NumPy, Pandas, and Matplotlib. Now, since I'm assuming that many of you are beginners and you have no understanding of what these libraries are, we will cover what these libraries do in a later point in the presentation. Also, again, if you wish to learn more about these libraries and more about data science and exploratory data analysis and Python in general, stick with us till the end of the presentation and we'll help you guide you to some of the resources that can help you out there.
Just a quick info, guys. Intellipaat offers data analytics course in collaboration with IIT and PowerTech. Through this course, you will master Power BI, data modeling, data mining, and much more from the IIT Madras faculty and industry expert. With this course, we have already helped thousands of professionals in successful career transition. You can check out the testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your careers to a new height. So visit the course page link given in the description and take the first step towards the career in the field of data analytics.
Now let's take a look at some of the advantages that exploratory data analysis provides us. So it provides us with several benefits. First advantage is that it allows us to spot missing data. Using exploratory data analysis, we can easily find null and missing values. So in case we have a data set in which certain columns have null values or certain columns have certain proportion of the data is missing, we can remove the data, we can fill the data. Although removing the data and filling the data is not part of exploratory data analysis, spotting the missing data is definitely a part of exploratory data analysis, and it allows us to do the same. It allows us to find the underlying structure of data. So on the surface, what we can see is the number of columns, the columns that we have, and the data that we have in them. Underneath the row and columns and the tabular structure of our data, if indeed it is tabular, what we can do is we can understand what the underlying structure is. Underlying structure means what are the different data types that a particular column holds. Are they in the correct format to be processed? What is the range of data that is contained in a particular column? Do columns relate or correlate with each other in the data set? And if so, is it helpful or harmful for the task that I'm trying to perform? So on and so forth. Then there's variable importance. Exploratory data analysis helps us to figure out which variables in our dataset are the most important ones. So in that case, it helps us understand which variables have the highest influence on the thing that we're trying to predict or on the column that we're trying to predict. That way, we can just drop the rest of the columns and only use the ones that have influence on our columns above a particular threshold. And finally, data visualization. Now, we can sit and talk about data a lot, but one of the issues that exploratory data analysis solves is that when we show these statistical measurements to people, first, especially people who are not statistically literate, it's going to be really difficult for them to understand. mainly because they have to firstly scan through the data, then understand which data has higher value, which data has lower value, and then understand the implication of each of them. It's much easier to visualize this data and understand the characteristic of the data that we possess. In this scenario, exploratory data analysis is really, really helpful. It allows us to perform visualizations and explain our data in a better capacity, even to people who may not be that familiar with the data that we have, as well as the statistical analysis that we are performing. Now let's take a look at the libraries that we had discussed earlier and what in exploratory data analysis. I would just like to mention that these are the three libraries that I have picked. These are the most one or at least some of the most common libraries that are being used. Not necessarily the case that these are the only libraries that will be used, or also not necessarily the case that these are the libraries that are going to help you in a particular problem. It could be that there are better alternatives available, and to understand about the alternatives, you need to firstly look at all the options that are available. So I recommend before starting any exploratory data analysis process, take a look at the tasks that you want to perform, take a look at the libraries that are available. These libraries are the most popular ones and for good reason. So these should help you out, especially if you're a beginner. But as you become more and more advanced and more into the exploratory data analysis and data science community, you understand that there are better tools available for the one particular task that you're trying to perform, and it's better to use those tools. All right. So the first one is NumPy. NumPy, or many people call it NumPy as well. It is a numerical manipulation library. In Python, we can perform numerical manipulation using raw Python itself, but it contains a lot of the information that are not relevant for our purposes. Since Python is an object-oriented programming language, which it's fine if you don't understand what that is. But in case you do understand, it stores a lot of information that's not relevant. So when we try to perform complex mathematical operations, those properties about the object orientedness of the particular variable come into play, and they negatively affect the or negatively impact what negatively impact the performance. So in situations like this, NumPy is quite useful. It firstly just keeps all the relevant data. Secondly, it has a lot of functions that allow us to perform these numerical manipulation. Inbuilt functions for calculating the sine wave, the cosine waves, for fast Fourier transform is also available, and many different kinds of numerical manipulations that are difficult to implement by hand are already implemented in NumPy. So you don't have to worry about implementing these things. You just have to worry about using them when the need be. Then there's Pandas. If you have done data science with Python for any period of time, Pandas is a library that you must have come across. Pandas is great for data analysis, data summarization, and many other tasks relating to data. It allows us to load data in our Python program using something called data frames. Data frames is a special object or a special way of representing data in Pandas, and it affords us a lot of benefits. It allows us to perform a lot of complicated tasks on our data, such as joining two data frames, filtering a data frame, manipulating data, dropping data, and a lot of different kinds of tasks that by hand are going to be very difficult. So it's a layer of abstraction over these complicated tasks, so you can perform them yourself, and it's very efficient as well. Then we come to Matplotlib. It is a visualization tool or a visualization library, allows us to create charts and graphs and allows us to perform a lot of visualization. Many different visualization libraries such as Seaborn use Matplotlib underneath the hood. So in case you wish to become a data scientist and want to perform exploratory data analysis by visualizing the data, Matplotlib is a library that you might need. You can also use other libraries, but Matplotlib is probably the best one to start with because it's very easy. It exposes you to some of the fundamental concepts that you need to understand when you are dealing with in Iron Python visualization or graphs or charts. They can help you out with that. All right, so we have reached the demo section. Now for the demo, I have already written the code so that I don't write the code and you have to then follow along and look at the errors that I make. I'll explain the code to you now. I told you that you only need to import the libraries that you need. In the current scenario, I didn't need to use any numerical manipulations because the data is already manipulated for me. Then I can use this. I'm using Pandas. Seaborn for interactive visualizations, and also Matplotlib. These are two different visualization libraries. Seaborn is great for creating summarizations of our data sets, and Matplotlib is great for visualizing individual columns. This bit of code here is telling the Jupyter notebooks. Let me just zoom in on it because it may be possible that you guys aren't able to see this. Now, in Matplotlib, it's possible to use it with multiple backends. In this scenario, we're using it with Jupyter Notebook. We're just trying to tell Matplotlib that whatever visualizations that you produce, make sure that they are optimized to be rendered inside the Jupyter Notebook. Now, many people say it's not necessary to do this step. It was necessary previously, but now it's not. But I like to keep it in just in case. Then I am importing a data set. And to give you some context, this is a data set that I have downloaded from Kaggle. You can download it yourself. I would recommend that you do it afterwards, and you can play with it as well. This data set and many other data sets are available on Kaggle for you to perform exploratory data analysis with. You can do it on Kaggle as well. And when you're doing it, you can, using that exploratory data analysis notebook that you have created, you can share it with people. Kaggle is a great platform for that. So you can use it for that. And now we take a look at the first 5 columns, first 5 rows of the data. Now, as you can see, the shape of the data is 5 rows in 81 columns. Now, 81 columns is probably a lot. As you can see that even our Pandas library is refusing to show all of this because it knows that it's not possible for us to show everything. So we have this. Now, we take a look at the information of the data. This tells us about the data set that we have and gives us information about each column, right? So we have 1460 non-null columns, non-null data points with of type int 64 in the ID column. And you can take a look at everything. Here, as you can see, in the Ali column, we only have 91 data sets. That means that majority of the data is null. We'll deal with that in a moment. As you can see, the data is quite disparate. Sometimes it's 1460, sometimes it has 1452 data points. So we are dealing with a data set in which we can have null values quite a lot. So the pool QC has only 7 values that are not null, others are all null. And as you can see, the data set is quite disparate as well. Some are objects, which are basically string or some other data set other than numerical data set. Some are integers and some are float. Float are basically real numbers. These are numbers with decimal points. So currency could be considered float, and real numbers are considered integers. So your mobile number could be considered an integer because it's not going to have a decimal point in that. Right. So I don't want you to get bogged down into the specifics of the code. What I'm trying to tell you is how we're going to do this. So here what we're doing is we are taking all the columns in which our data is greater than or equal to 30%. So any column that contains less than 30% data, which is it has 1460 columns, but only 30 or less percent of the values are present in that, and we're going to drop it. So any column that contains less than 30% of the data, we're not going to consider it at all because it could have negative implications. So we do that. Now what we do is we also delete the ID column from our data set, mainly because ID is just something that is generated by the database in which it was stored, or maybe not by the dataset, but by the people who collected this data. It's not really important for us. It's important for storing the data, but for analysis of the data, ID is just a number that was randomly assigned to a person. It has no significant value. Now we will print the list of columns that were dropped. As you can see, Ali, QC, friends, and miscellaneous features are the columns that are dropped. ID is the one that we have dropped manually, even though it contained a lot of data. Now we try to do 2 things here. First thing, we take a look at the sale price, which is a column that we are very interested in because that's the column that we're trying to model our scientific process across. So we describe the data, which is we count the number of columns. As you can see, it contains every bit of data that is available. The mean is 1,80,921 point some value. Standard deviation, minimum value, 25th percentile, 50th percentile, which is here, then 75th percentile or the 3rd quartile, and the maximum value in the column. This is, by the way, this is something that Pandas is doing for us. We didn't have to write functions to loop over the data and figure out the min, max, 25th percentile and all of that. So it tells us the name of the column, sale price, data type is float, and now what we do is we try to visualize it. So as you can see, the majority of our data lies in this region.
What?
Yeah.
What?
So here and here. This is what is known as a histogram or distribution plot. Since Seaborn allows us to do it pretty easily, we do it. Don't worry about the code. Stick with us till the end of the presentation and we'll show you how you can learn to write the code. Right now, we're trying to understand the process of exploratory data analysis. So as you can see, even though we have a maximum value of 77,55,000, majority of our values are lying between somewhere around these values. Right. Now we take a look at the different data types available in our data set. We have integer, we have O, which stands for object. Object basically means that this is something that's not a number. And we have float. This 64 is basically how many bits are used to represent the data. This means that the data could be of high size. You can, by the way, change this all yourself. So here what we do is we say, okay, give me all the numerical data that we have. This is done mainly because we want to be sure that we are only dealing in numerical data. Dealing with data that is not numeric, firstly we'll have to convert the data into numerical formats and so on and so forth. So we're trying to firstly estimate the task ahead of us. We take the numerical data that contains float 64 and int 64, basically not selecting the object data types. We take a look at the head. As you can see, it has 37 columns, which is a massive drop from what we had earlier. Earlier we had 81 columns, out of which we dropped, I think, 4 or 5 because they had a lot of null values. This one is by far something that we have done only to understand what the data is about. Now we take a look at the distribution of our data using histograms. What we do is we basically create a histogram for all the columns. So again, we didn't have to do it ourselves. These are all 31 columns with histograms, and you can take a look at the data. As you can see, it contains a lot of data. Some columns contain a lot of data that's centered around a particular data point. Others are very separate, such as this one. This only contains values that are 0, so that's fine. And you can take a look at the data and analyze it. We're not going to analyze it right now. This is just for you to understand how to generate these visualizations. Then we take a look at correlations. Correlation basically is a number that allows us to understand how how much of our data is how much influence does one column has on a particular column. And we remove the last column because the last row is basically sales, or the last column. Sorry, I'll just remove the comment. So the last column is sales, so we don't have to worry about that. From here, we basically just take all the columns with correlation greater than 0.5. We call them golden feature list. Any column that has a higher value than 0.5 on correlation means it has good correlation for our data. We're taking the absolute value, which means we don't care whether it's negative or positive. Correlation ranges from -1 to +1. -1 means if the data in this column decreases, data in the other column which is negatively correlated with it will increase. Positive correlation means data in this column increases. Data in other column which is positively correlated with this increase. So we take that and we sort it in ascending values. Now after doing this, we take a look at the correlations. So these are the correlations. The highest correlation we have is overall quality and GR live area. It's around 80 to 70%. Now what we can do is we take a look at all the numerical columns and we generate for the first 5 months for all fifth values. What we're trying to do is we're trying to create visualizations to understand how a particular column relates to first 5 columns. So for instance, sales price relating to MS subclass, MS lot range, lot area, and so on. And as you can see, we're doing it for everything, and we're doing it 5 plots at a time. Now that we have done that, here is a bit of a code that's going to be a little difficult to understand. So I'm not going to try and explain it to you. But basically here, what we're trying to do is we're trying to create individual data frames or individual feature data frame as I've named it. Create some temporary data frames based on particular sections, such as we take the column name and the sales price, And then using that data frame, we check whether or not the column's value is not equal to 0, and we create or we add it to the data frame. Then we create an all correlations matrix, and then we try to print it. Now we come to the interesting part. So these are all the 11 strongly correlated values that we have, right? For this one, since we had 81 columns, and now we have reduced it down to only 11 columns that have really high influence on our sales price column. Now to visualize it, what we have done is we have created one thing called heat map. Let me just zoom in so that you guys can see. I think it will be a little too much. Yeah. And also you can manipulate the size of this plot by when you're writing code. I'm not going to do it right now. But as you can see that some columns have correlation of 0.4, some have, and this is negative, by the way. As you can see, these are color coded. So any column with light color such as blue or purple are negative. Any columns with light the color such as yellow or green are positive. As you can see, we have 0.83% of correlation with GR 11 area and fireplaces. And so this allows us to understand what are the particular columns that are highly correlated with each other. Allows us to understand whether or not a column has influence on not just one column but multiple columns, and how does that affect our purposes.
So our second quiz question is, what does EDA stand for? Option 1, exploratory data analysis. Option 2, efficient data aggregation. Option 3 is external data application. And our fourth option is extended data analytics. So again, I want you guys to drop down your answers because this is very easy. This is like the most basic question. So I want all of you guys to give the right answers in the chat.
We have a fancy thing called package in Python. Okay, so those packages are available for free in the market. It has a lot of built-in functions and built-in things that will help you guys to write many codes easily, okay, without going for the detailed algorithm and all. So in that way, these packages are really helpful. So NumPy, what it does, it is used for mathematical and logical operations on the arrays. Okay, and it provides feature for multi-dimensional arrays also. So again, when we tell arrays, Python doesn't have any array. It is built on list only. So basically, when we go through NumPy, when we go for indexing, slicing, and all those kind of stuff, it will only be the list. Everything will be based on the lists. So that's how it goes. Okay, so NumPy can support 1D, 2D, both of the kinds of arrays. Okay, and I think you might be using this Anaconda version of Python, so that will be coming along with Pandas and NumPy version pre-installed. Okay, NumPy will be pre-installed in the Python versions. Okay, Anaconda Python. Okay, now when you use a package, right, what we do, we import the package. Okay, we import the package with something like the syntax is, it can be any package. Okay, alias can be anything. So what is the syntax? Syntax is import, then there will be package name, then there will be as keyword just to assign an alias. Otherwise you would need to type the entire thing throughout the program, and then we will have alias name of np. Okay, so that's what it was. Okay, so now when I say NumPy array, it can convert anything, any Python data structure to arrays. Okay, so that's how it works. Okay, so if I show you like this, what, it is taking time now. So see, it has converted both these things. So the first one is a Python list, second one is a Python tuple, right? So when we pass that argument, that tuple or a list to a NumPy array function, it converts them all to a NumPy array. Okay, so that is what this returns. Okay, and whatever we provided, as you see, the outputs are starting and ending with square brackets, right? So that means it is already converted to a list. Now we can perform various functions in NumPy. Yes, so once we have NumPy array created, it can be editable. Okay, because it's a list now, it's not anymore a tuple, so that's why it is editable. Okay, and NumPy doesn't come by default with Python. If we want to use it, we need to install it. So let's say you are not using Anaconda and you are using this kind of a Python user interface, then what you need to do, you need to install it using command prompt. Okay, pip install, sorry, we are letting it again and again, pip install NumPy. So it will find it and it will install NumPy. Okay, I don't have this pip version set, so that's why it is not working, but it should install it. Okay, so that's how it works. That's how we can use NumPy in this kind of functions also. Okay, now we can have 2D arrays in Python also, like 2D arrays in NumPy also. So how we write it? We write it like this. So we just need to pass 2D arrays. So 2D array means two lists, right? We can pass two lists. So it will be concatenating it to what 2D array. What okay, so it will be changing it to 2D array. So that is how we write it in NumPy. That is how we create arrays in Python. So that's how we do it. So now next will be where it is, and where it is advantageous other than using a basic Python list or Python like that, Python list or Python tuple, right? So by NumPy you are changing, yes, so we are changing data type from mutable to non-mutable. It's the other one, right? Next is ND array object. Okay, so in NumPy, as I have shown you, 2D arrays, right? It can go up to n and then can have any number. So in the real world, if you ask me, we don't use more than two max to max 3D arrays, but yes, it can go up to that. Okay, so like that it works. So next is like why we use NumPy arrays. So in NumPy, this ND arrays will have all the items of same type. Okay, so it can't be one of them is int and one of them is string list. All of them has to be int arrays. Okay, like that. So items can be accessed using zero-based index. As you know, Python arrays, Python lists also starts from zero indexing, right? So here also it remains the same property. It has zero index. So if we go for NumPy array, then if we want to see the first row, it will be like this. So it will give you the first row and this will give you the second row, right? Similarly for columns, if you want to see first, if you want to see the first column, you need to do this, right? Sorry. So you need to do this. So you will see the entire values. If you need to see only the first column, then you need to do it like this, like that it works, right? So that's how it will be working. Now for 2D arrays, I will be coming. Okay, I am working on 2D arrays. Sorry, I forgot. So that's how it works. Okay, so we will be coming to that in a few minutes. So 2D arrays, I will show you. So for others, what was the names? A and B, right? 2D arrays, I will be showing you. Not an issue. So for arrays, if you see 1D array, it will give you A0, that will be 1, A1 will be 2, like that. And if you do 1 to 2, then it will be printing only single element, because the right hand side index is always left. Okay, right hand side index, it is not up to, it goes up to that. It is not including the right hand side index. So that's why it has two elements. Now if we do this, then it will print all. If we do this, that also will mean the same and it will print the same. It is pretty basic, pretty much like the lists that we have in Python. Okay. Now NumPy arrays are beneficial because it takes up the same size of block in the memory for all the objects that it stores. Okay. This part we will see a comparison in the later half of the section, and then we can understand like where it is beneficial rather than storing it in a classical list than NumPy array. Okay. Now next is, if you go into check the individual, yes, right, so it will be begin colon n minus 1, that is how. So right hand side will always be excluded, like that. Okay, next is NumPy array initialization, right? So how do we initialize NumPy array? As we have already seen, right, how do we do that, but still this is how you do it. Okay, so initialize means what we want to do is, we don't want to place any list in there. Okay, but what we want to do, we want to have some by default values. Okay, default arrays we want to take it up. Okay, so let's see how we do it. Okay, first one is, we will, if you guys are familiar with the terms like masking and all, that is for image processing, and for data processing we will do that. A lot of times we will do that. Okay, so a lot of time we will be using this zero based or one based indexes. Okay, so for creating a zero based arrays, right, what we need to do, we need to have some sort of like some shape of zero arrays. Okay, so that's how you do it. Okay, that's how you do it in NumPy. So what you do, you write np.zeros, then you specify the dimension of the array. Okay, 3 by 4 means it will have like 3 rows and 4 columns. So first one is of, so you can think it like this, it will be np.zeros, then row, comma, column. Okay, that's how a tuple you need to pass it to. Okay, that's this kind of tuple you need to pass it to the Python arrays. Okay, so that's how it works in Python, I mean in NumPy. So that's how you print zero arrays in NumPy. Okay, next is if you want something with an interval, right? So how you do, you write like this, np.array, within bracket we pass what so it will print you another new array. So what we are doing, we are in here what we are doing by array, what yeah, so in this what we are doing, we are, yeah, right, it's arrange, so it's a range actually. Okay, so what we are doing, we are passing 3 variables. First one is the starting number, second one is the ending number, and last one is the line is the interval that we want to print. So from 10 to 25 we are having 5, we want lists to be 5 separated, right? So first one and second one difference will be 5, like that. So that's how we have, so we have 3 numbers, right? 10, 15, 20, and always remember the right hand will be excluded, so 25 won't be taken up. So till 20 we will go. Okay, till 20 we will print it out. Okay, so that's how this kind of arrays are getting printed out in NumPy. Next thing is this arrange is done, right? Now let's say we want we want to spread some points over a straight line. Okay, so how do we do it? We want to I mean what I mean is, if you think of a 2D plane, right, like x and y plane, if you think of, and we want to spread some points along that line. Okay, so what we will do then, like we want some points between range A and range B. Okay, so here we are giving intervals, right? So we need to calculate the interval, we need to calculate the point difference and all, then we need to provide it here. So that's how it works, right? But we don't want it, we want it otherwise. Okay, we want it to spread along a line like this. So between 5 and 10 we want 6 numbers. It is almost same as NumPy, but it has a bit difference. So how it is differing, I will show you. Okay, next is this linspace. Okay, what linspace and arrange, right? So arrange, what it does, it takes in 3 numbers, so start number, end number, and so what we do in arrange, we have 3 numbers as a parameter. We take end number, start number, end number, and the interval, and we print out the values based on the intervals. So from start number till the end number, we print out the values based on the intervals. Okay, but in linspace, what we take 3 parameters again, and what we have in there, we have start number, end number, and then we take in number of points in there. Okay, number of points in there. So if we give you a start number and end number, then if we split it into 10 points, then we will get 10 points between the start number and end number. So that is the difference between linspace and arrange. And all these functions we will be using heavily when we go for data science. Okay, because these things we will need, and we will see how do we do that. Okay, now next is how do we do array with the same number. Okay, next is how to create an array with the same number. So this is same for same uses, like that, like for zeros, right? Formats for carving out some masks, like that. Okay, so if you use this keyword, what then if you pass some values, so come on, what if you pass some values, then it will give you that number of the dimension it will take care, and it will give you that kind of an array. So row, then column, and then it will be taking up, so np dot full, it will take up first the tuple of row numbers, column numbers, and it will take up the number to fill that array with. Okay, number to fill, like that. This thing works, this full function works. It can be anything. Okay, it will give you a array full of that kind of numbers of any dimension. Okay, any dimension can be given. Okay, any real world numbers can be given, any integer number can be provided as a dimension. Okay, so that's how this full function will work. Okay, next is to randomize an array. Again, for that masking only. So
What
we do,
what
let's say we want a 3x4 matrix to be randomized.
what
So it will give you some here and there numbers of random numbers. So that will be and those will be structured in a matrix form. Okay, the dimension you pass, and that way it will be organized. So random is this thing. Okay, now we go to how do we access this NumPy arrays. Okay, now let's say we are creating two arrays. How do we access it? Okay, how do we see what's wrong with the array and what not? Let's say I am creating a 2D array. Okay, now if I do print there, so that's how this shape function works. Okay, that's how we can access a shape of an array. So shape function will return a couple of its row number and column number. Okay, so a dot shape returns tuple row num column like that. Okay, so it will be returning like this. Okay, now the next thing is what is the use of the shape function. Okay, so this is a tuple, but we can change the values of the tuples. So this will change it. Okay, we can access the shape function of it and we can change the values. Okay, even now we can access like a no, come on, we can access this. Yeah, so we can access it like this. Okay, come on, I have not given print. What is happening? Okay, so we can access individual elements of the shape tuple that is being returned like this. Okay, like we use like we access normal tuples. Okay, so we can what we can do with this a dot shape, we can get the tuple, tuple of row number and column number as an output. We can change the shape of the matrix with this shape function, and we can access individual arrays. Let's say you want to see how many rows are there in a data set, right? You can use it. You would want to loop through all the data sets, all the rows of your data set using a for loop. You don't want to go for map and all. So that's when you use a dot shape. And for print a, that's how you use. Okay, for print a, what you do, you just for shape 0, that means you are accessing individual elements of a tuple, right? So 0 will be giving you the number of rows and 1 will be giving you the number of columns, like that. Okay, one thing, so you guys are acquainted with you guys know about lambda functions, right? It was covered.
Yes, sir, correct. But just want to go back to zero index. Zero index, it will return the number of row, correct?
Right.
If you give comma and another zero, then it will give you the number of column. Is it okay?
It's got
No.
one. Shape is always gives only the columns and rows here. The 0 will give the rows and 1 will give the columns.
Column. So that is a tuple basic, right?
Can you please do that?
So tuple, how it works, number of elements in tuple, we will have a 1D array, right? So 1D arrays can't be having two indexes, right?
Okay.
So
Okay,
that
got
will be 0, 1 like that. So it is an 1D tuple or 1D array, whatever you call it. Okay. So that's
Okay,
how it
thank you.
works. Okay. Now we can have several more examples of this shape function, but I am not going into the detail. But you need to remember one thing: you need to match the number of elements in the tuple. Like we have 6 elements, right? If I want to split it to 3, it won't work because the size of the array is to total of 6, right? So we need to have it multiple of 6 only. That's how we can break. That's how we can reshape. Okay. That's what is about this shape function. Okay. Next is how to get total number of columns. Okay. So again, I am having 10 functions and I want to see the size of it. So it will give you 24. As you can see, there are 24 elements in the array. Okay. So that's how this size function works. And this is another syntax of np.arrange. So here what it takes some number of values. Number of points needed. Will place the numbers between 0 till that number. Okay, so that's how another syntax of arrange works. Okay, so for size function, it will give you the total number of elements in an array. Okay, so that is what size function works for. Okay, next is dimension of array. It is more or less same like this. It is more or less the same thing like that. Like a shape function, so I will put it right in there, but the only difference, it can be modified. Okay, so where were we? We were with this ndim, right? So how it will work? Ndim will return you the, it is not, I mean, it is a bit different from shape. Shape returns you the exact shape of the array, like the number of rows and number of columns, right? But ndim will return you the number of dimensions of the array. Okay, so if you see the ndim, then what we have 2 as a return, right? That means it a total of 2 dimensions, 3 and 2 dimensions, right? So that's what ndim returns. Okay, ndim will return you the number of dimensions of the array. Okay, so that you need to remember. Okay, so that is what you need to remember. So ndim returns you the number of dimensions. Okay, it is not shape, but it is a dimension. Okay, now d type is the array data type that we have already. Okay, next is d type. Okay, d type is to give you the type of each elements in the array. Okay, in the NumPy array, it will give you type of all the elements, and NumPy arrays cannot be heterogeneous, it has to be homogeneous always. So NumPy arrays will return you, I mean the return you homogeneous arrays. So when you do a d type function on an array, it will return you the number of dimensions of the array, I mean sorry, the data type of each of the elements in the array. Okay, so here we have 24 int numbers, right? So that's why we have int 32 as a return type. Okay, so that's how it works. Okay, so that is what is about this d type function.
Our third quiz question is, which Python library is commonly used for EDF? So our first option is NumPy, second Matplotlib, third is Pandas, and our fourth option is all of the above. Again, this is a very easy question, and I expect a lot of right answers in the comment.
Next is, how do we use it for maths calculations? Okay, so any doubts till this part, till this d type? Now if I show you something more, say okay, next is as I have treated now array with like float numbers. So you see the arrays are, the d type is printed as float 64. Okay, so you have you got an array of, I mean the d type as float 64. Okay, so that's how this d type function works. Okay, so and NumPy, as the name suggests, it is used for linear algebra. Okay, so NumPy is used for number mathematics or linear algebra. So you won't be really having string arrays in NumPy. Okay, so you won't be having it. That is not provisioned. So NumPy is only used for linear algebraic operations, and for that we need integers and floats, right? Nothing more than that. Okay, next is NumPy maths. Okay, we can do summation, division, multiplication, and all those kind of here and there stuff with this NumPy. Okay, now how do we do it? Okay, let's get started with a single array. So this is how NumPy summation function works, and it can add up to different things. Okay. Okay, so sum will return you or sum of all the elements, or it can return you sum of two arrays. Okay, sum can do anything, anyone. So sorry. So sum can return you either sum of all elements in a Python array, or it can return you the sum of elements of two matrices. So matrix multiplication, matrix addition, all this logic will be implemented in there. So now what it will do, it will take up two lists, it will add up all the elements, and it will return you the output. Okay, so 5, 10, 2, 3, that means 10, 5, 15, and 2, 3, 5, so 20, right? And for subtract, it will take two arrays and it will subtract the results and it will throw it up to you. Okay, so that's how this subtract, and numpy.sum function is used for summing up and finding difference between two matrices. np.sum has a few flavors in it. Okay, so it can do a few things, so we will discuss that. So let's say we have seen how it takes in two lists and it sums you up the result and it will show it up to you. Now if you specify an access parameter, then it will do the sum based on the rows or based on the columns. Okay, we print out A and B for you. What yeah. So see, A and B are 5, 10, 2, 3, right? If we do a sum of sum with x is 0, that means it will do you a column wise sum. So that means 5 to 7, 10 to 13. Okay. And if you go for a row wise sum, then it will be x is equals 1. So it will return you 15 and 5, right? So that's how this will work. Okay, and the row wise sum, that's how it will work. Okay, so that's what is the so that's how this functions work. Yeah, that's how this NumPy array sum function works. Okay, so that's how you can get the Give me a second. Yeah. Okay, fine. So this is not how it works, right?
Remove the square brackets and keep only the circular brackets.
Sorry? No, not like that. It won't take it. So x is 1, 5, 2, 7, 10, 3, 13. Yeah, got it. Okay. So two confusions were there. First of all, we like it. Like x is 1, why it is not taking up? Okay, let me check for some example in the PPT. Doing some casual mistakes. Yeah, that's what I have written, right? So 0, 0, 0, 1, 0, 5. So it should be 0 plus 1, 5 plus 0, that is 1 and 5. So it's fine, right? 0, 1, 0, 5, so 1, 5. Yeah, correct. 0, 0, 1, 5, 6. Okay, let me copy this exact example, but it does. Not sum with x is 1 having some problem. Just give me a few minutes, I will do that. Now it is working fine. 0. Yeah, now it's fine. So now if I replace it with A, I replace with B. If we remove this, as those are already list, how it works. Yeah, now it is looking good. Again. Okay, I will be getting back to you on this. So for now, let's move ahead with the other functions. Okay, so having some kind of a problem, I will check that in the break and I will explain that after the break. So not sure why it is happening, but it shouldn't be happening it like that. Okay, let me go ahead. So sum I will discuss it later. For subtract, we already have discussed. For this division also, it will work in the same way. Okay, what is it with sum? Sure. Okay, now if we pass two parameters to the divide function, it will divide row wise or column wise as you define with this axis, right? So okay, so divide won't work axis wise. It will just take in two parameters and it will just divide you the numbers. Okay, row wise it will divide you the numbers. So 5 and 2 will be divided like whatever happens in the matrix operations, right? In mathematics, the same thing will be applied here. So in matrix operations, what we do, we just divide the first element by the first element of the next array, second element by the second element of the next array, right? So that is how it works. So that is how this division will work here. Okay. Similarly, we can see the multiplication being worked on the same thing, how we did in matrix multiplication in our class 12 maths. So it will be same thing. So 5 into 2, 10 by 3, so 1030. Like that it will work. Okay. So these are a basic few functions that will be needed for our data science courses. And this EXPA, it will give you e to the power a. SQRT, it is for square root. NP.sign is for sign value of each of the elements. NP.cos for cos value. Log for log values. Okay. So these are not really used in data science related things. Let's say I will show you quickly all these examples just to have your basic knowledge about this NumPy. I am showing that to you. So these are not really needed for being a data scientist. So you can just check these values. Okay. Next is the element wise comparison. So we have so that's how element wise comparison does. So it will compare each and every element of the array with another one, and it will return you a list of true falses. Okay, so that's how it will work. Okay, so that's how it will work. It will give you an output of true false. If you change something this to true, then the second element of the output will also be changed to true. Okay, now along with this np.equal, there comes another function where we check the entire array. Okay, if all the elements of the array are same or not. So that one is called so it will give you a single value. Okay, true or false. So it will check the arrays that is passed to it. It will compare those on a broader level, that is on a array level, and it will give you only single output of false or true or false based on the comparison results. Okay, so that's how it is. That's how it works. Okay, next is aggregate function on this on a single array. Aggregate functions always work on a single array, right? So that's what we are gonna see next. Now, if we have already seen this sum function, right? Yeah. So these are a few aggregate functions of the what we can apply to a NumPy array. Okay, come on. Why are we forgetting this? If you write it or not doesn't matter. When you do np.sum, it will automatically be converted to an array. So you can skip it safely. But again, okay. So np.sum a will give you sum of all the elements. Minimum will give you minimum. Max will give you the maximum element. Mean will be the mean of the elements. Okay. So mean means the middle element of the arrays. Okay. Then standard deviation is how the elements differ from the mean. So that's what is standard deviation. Okay, so that is what is about standard deviation. I will try to connect my pad and will show you the formula once. Same thing will happen. Okay, so it will give you sum of all the elements, minimum of all the elements, max of all, min of all, like that. This correlation coefficient is a machine learning term. We will go into it later. I will tell you what is it. So it's not. Let's not worry about it. So accept this, have all these things clear. So that's how it will work. Okay, so that's how mean, median, and standard deviation you can take into account. Okay, now what is mean, what is median, I will stack it for the next class for SciPy, because then we will be discussing all this statistical things at one go, and I will give you a brief about all this. Okay, so if you have forgotten this, not an worry, we will be discussing in the next class. So that's fine. Mean, median, mode, and all this thing. So not sure, I am not having my tab with me, so I will have it and I will show you the formulas and all this small stuff. And also what you can do, you can once go through all this basic things. Okay, that's just the basic stats, not needed in entire detail. You can go through the basics, so it will help you understanding what I am covering in the next class. Okay, so that's how it will work. So okay, so this must be clear now. So with that assumption, we will go ahead with to some new topics. Okay, so that is like broadcasting. Okay, what is broadcasting? If we have taken two arrays of different dimensions in here, what would have happened? Let's say we are keeping till this part. What is this error? Axis 1 is not coming through. Okay. Yeah, axis won't work for this kind of cases. Yeah. Okay. So let's say we have this kind of an array to work with. So the first array, if you see, the first array is of 3 by 3. right? So 1, 2, 3 and 4, 5, 6. It is in 3 by 3 array, right? The second array, if you see carefully, we have passed 4, 5, 6, only 3, 4, 5, only 3 numbers. It's 2 by 3. And the next one, if you see, that one is a 1 by 3 array, right? 3, 4, 5, only 3 numbers are in there. So it is an 1 by 3, right? So now when you add it, if you notice it carefully, you will see the second row of the array is also getting added with the same number 3, 4, 5, right? So that's why it is coming 4, 3, 7, 5, 4, 9, 6, 5, 11. Okay, so how this is happening? This is the concept of array broadcasting in NumPy. Okay, so if you see in this diagram, what is happening, this array is getting expanded to match with the exact dimension of this array, of the first array. Okay, so this was an array of 1 by 3, but when it stretches down, it becomes an array of 4 by 3, right? So it matches the dimension of the first array, then only this array addition is possible, right? So this is the concept of broadcasting. Okay, this is the concept of broadcasting. Now, one thing to notice, this broadcasting won't only work for array additions. Okay, it will work for all kind of operations between two arrays in NumPy. Okay, so as you have just seen, this thing all works for this subtraction also, right? So subtraction is also supported. I mean, this broadcasting is also done for the subtraction scenarios also. Okay, this is the concept of array broadcasting. So what it does, the NumPy array gets inflated to match with the dimension of the first array, so that the operation that we are supposed to do is possible, is feasible. Okay, so this is what the concept of array broadcasting is. Okay, now indexing and slicing in Python. This, as you have already went through, I will go through this a bit quickly. So let's just see how you do it. So index in Python list refers to a integer position, right? It can either start from minus or it can start from plus. So minus, when we go for, so Python, when positive indexing is done, then the index goes from smaller number to higher number, and then prints accordingly, right? So let's say for this Monty Python, we are going from 6 to 10. So that will take from P till H, right? Because 10 will be excluded. But when we go for -1, and then we go from the larger number to smaller number, because as you know, for negative, everything goes opposite, and the bigger the number is, it is smaller, right? So -12 and -7, it will go from -12 till -8, because right hand will always be excluded. So that's how it will be printing the entire Monty string. Okay, so that is what indexing works in Python list. Okay, now when we do a 6:10, that means that is from 6 till 10, like that indexing is done. Okay, next is slicing. Okay, so A0, if you see this matrix 1, 2, 3, 4, 5, 6 and 7, 8, 9, if you go for A0, then it will print all the elements of the first row. And so that's how first row will be 0th index and first column will be 0 index. Okay, if you go then within brackets :1, that will also return you the same thing. Okay, let me show you. That means we are just taking what 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 we return the first element of, I mean, the first row of the matrix. Okay, when we return A:1, what does that mean? Okay, so :1 is for the so what we want all the rows. Okay, so in 2D arrays, how the indexing works, if you know, so then it will be a comma separated one. So first part will entirely work for rows, second part will entirely work from columns. Okay, so if we write :1, that means for the row part, give me all till the second row. So that is the first row, right? So that's what it is returning, 1, 2, 3. But that list is within a list because we are taking it as a list only. We are slicing it, so it will return a list. Okay, and list of lists. And the first one of A0, we are just simply accessing the first row of the 3D array, 2D array, and that's why we are getting 1, 2, 3 as a list. Okay, so that's how this slicing works for arrays. Now let's go back to the PPT and let's see how what all things we can do. So A:1 extract till row equals 0. That means it is the first row that is being printed, right? Now for the second part, if you remember the indexing and slicing thing, what so the first one will account for the row and second one will account for the columns, right? So if we do :1, that means give me all columns till 1. So that is the first column. So that will give you only 1. Okay. Now if we do 1 column, that means give me all from the first column till last. Okay. So that's where we get this 1 column will return you 2, 3. Okay. Now if you remove :1, that means you want all rows and you want columns from 2 onwards. Okay, so that's why it gives you 2, 3, 5, 6, 8, 9. Okay, so that's how indexing and slicing works for NumPy array. Okay, that's how it works. Okay, so we will have a few examples. Let's do it. So okay, so so let me explain. This 2 colon means we are wanting the third row of the matrix. Okay, from the third row onwards. So third row is the last row, so only 1 row will get printed out, and we are giving :3. So that means it will go up to the third element of the column, right? So it will give you the entire column. So that's why :3 returns you 7, 8, 9. Okay, next thing is array manipulation. Okay, array manipulation is to stacking array. Okay, so what is the difference between array manipulation and the sum and other operations that we have seen? So in that case, what we are doing, we are performing some operations on 2 arrays and we are outputting a third array. Here also we will almost do the same thing but a bit differently. Okay, we won't add or subtract those. We will keep the originality of the arrays and we will output something and something. Okay, so what okay, the first function is concat. Okay, so this is horizontal concatenation. Okay, so the arrays will be concatenated horizontally, and one is out of bound. It shouldn't be. Okay, we don't have any columns in here, right? So that's why column wise is not possible. But if we had 2D arrays, it will be possible. That's what I will create for you. It will be easier for you to understand. Yeah, so this is like column wise stacking, right? So this 1, 2, 3 in here and this 3, 4, 5 in here got concatenated together, formed a new row. This 4, 5, 6 and 5, 6, 7 formed a new row. Okay, if we go for 0, it will be like this. Okay, so this is just column wise. So that this is row wise. That means the rows of the first matrix and the rows of the second matrix will be concatenated to another matrix. Okay, let me print this matrices for you. It will be easier. So see, the first matrix is 1, 2, 3. Second one is 4, 5, 6. When we do row-wise concatenation, right? We just concat the rows at the bottom of the matrix. So 1, 2, 3, 4, 5, 6, 3, 4, 5, 5, 6, 7. Okay. Now, if we go for column-wise addition, column-wise concatenation, then what it will do, it will concat the columns on its own. Okay. It will concat the columns on its own. Okay, so then it will give you a new row output. Okay, so that's how. So what it does, this 1, 2, 3, 3, 4, 5 gets stacked in because this is column wise now. So that will be column wise now. So 1, 2, 3 and 3, 4, 5 will be stacked in together. 4, 5, 6, 5, 6, 7 will be stacked in together. Okay, so that's how the array output will look like. So the columns will be concatenated to a row. Okay, so that's how this concatenation works. Okay, that's how the concatenation works. Okay, so this is what is about this concatenation property. Okay, next is VStack and HStack for NumPy arrays. Okay, so what is VStack and what is HStack? As the name suggests, VStack is vertical stacking. Okay. Okay, and H stack is horizontal stacking. Stacking means the same thing as concatenation with a bit with just a small difference. Okay, that we will discuss now. So before going into VStack, what I will do, I will show you a stack example. Okay, there is another function called stack in NumPy. Okay, so I will show that first. Okay, before going into this normal thing, this H stack and V stack operations. Okay, so what it will do for these two arrays only, I will consider. So what say I am stacking A and B with X is 0. So I am stacking A and B on X is 0. Okay. So it is not a list I should pass. It should be a tuple in here. Was what 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 yeah. So this is how the stacking looks like. Okay, this is stacking horizontally. Okay, and if I go to axis 1, this is stacking vertically. Okay, let me print out two separate ones. Might be the quick change I haven't noticed. It should change. It will be 1 2 3 4 5 6 like that. No, yeah, that's the intended output I was looking for. So for horizontal stacking, for x is equals 0. So for again, let me try with 1D array once. 1 second. What 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 yeah, now it is coming fine. Yeah, so that is what is about horizontal stacking and vertical stacking. Okay, so in horizontal stacking, we stack two arrays row wise. Okay, we stack two arrays row wise, and in vertical stacking, what we have, we stack two arrays based on columns. Okay, two arrays based on columns. So as you see, in the row equals 0, the output is 1 2 3 and 3 4 columns. So the two 1D arrays have gotten into a sequence. Row wise they have concatenated, but when it is going for column wise, then for 1D arrays it has concatenated the columns into its rows. Okay, it has concatenated its column into its rows. Okay, so this shouldn't be printing. First of all, this shouldn't be printing like this. Why it is printing? So that's how this stacking works. So again, this for 2D, why this problem I am not really sure. I'm typing the exact syntaxes, but still it is not working. Okay, so for stack, we need to have 1D arrays. If we need to have more than 1D arrays to be concatenated together, then for that we have concat function. Okay. This stack function will only take in 1D arrays into account, and it will stack those accordingly. Okay, so that is what is about stacking. Okay, now if we go into this is what is about stacking. So stacking will take only 1D array into account, but if we need multiple dimension arrays, we need to go for like 2D arrays. Okay, we need to go for 2D arrays. That's how it is. So now let's say I am creating a new array like this. What 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 okay, so if you see this carefully, the stack function, it takes in only 1D array, and if you pass in a 2D array, it doesn't do anything with the array, right? Except what it does, it just created stacked array of its own, or the array A and B individually was stacked onto something, and that's what got written over here. Okay. Now here on the contrary, if you see the hstack function that I have written at the bottom of the screen at the last line, it took in two 2D arrays to properly stacked. Okay, so that is what is the difference between this normal stacking and this H stack and V stack. Okay, if you want to go for concat function, concat actually differs in two ways. First, one way, actually just only one difference of concat, that is, okay, let me write it. So what 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 let me do it a bit clearly. Give me a few minutes. What print vertical concat vertical stack what 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 okay, let's see the differences. Okay, now what says 0 x is 1. Okay, so for each stack, that is horizontally stacking, right? So what it did, 1 2 3 2 3 4 concatenated in a same row, 4 5 6 5 6 7 concatenated in a same row. Okay, and it return you the desired output that you want to see. So that's how horizontal stack worked. Okay, so this is row wise stacked, but the rows are concatenated together into a new column, right? New row, sorry. So rows are concatenated to a new row, and it outputted a different version of a matrix which is having a different shape. Okay, so if you compare the output of horizontal stacking and vertical concatenation, you will see these two are same thing. Okay, these two are same thing. So that is the basic difference between this concatenation and stacking. So stacking is to add up the elements to the same dimension. So when we are doing a row wise stacking, that is horizontal stacking, we are adding the rows, the element to a row itself. Okay, but instead in concatenation, the rows are added up to the entire matrix. Okay, the rows are added up to the entire matrix. So that is the only difference between this horizontal stacking and vertical and the concatenations. Okay, now for the vertical stack, the same thing happened, right? The columns got merged in, just the columns got increased, and those elements are stacked into the columns. So 2 5 3 6 4 7 have added into the column of the first row itself, which was done in the horizontal concatenation, right? So that's how this concatenation and stacking works and differs. So that means for stacking, the stacking will be along the axis which it is currently working, and for concatenation, they will be concatenated on the same dimension. Okay, so that is the difference between these two. So are these things, these four things clear to everybody, or I need to explain it a bit more? First of all, for stacking doesn't work on 2D arrays, and for H stack, V stack, and horizontal concatenation and vertical concatenation, these are the examples that I have written. So are these things clear? Seeing a mixed response. Okay, let's go over this. So horizontal stacking, right? What it did, it had two arrays to work with. Okay, A and B. Okay, so how A looked like, how B looked like. I will show you. Stack, forget about it, it won't work here. What 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 so this 1 2 3 4 5 6, let me write it down. 1 2 3 4 5 6 2 3 4 5 6 7, these two are the rows, right? So when we are stacking horizontally, the two rows, that is 1 2 3 and 2 3 4 are stacked, okay, on the rows. So 1 2 3 2 3 4 are merged in a single row. 4 5 6 and 5 6 7 are merged again in a single row. Okay, and the resultant output is returned. Okay, so that's how this thing works. Okay, that's how this stacking works. Okay, now for horizontal concatenation, what we have, we are concatenating the rows to the entire matrix. So 2 3 4 5 6 7, these two rows are concatenated to the entire matrix, that is row wise. Okay, so it didn't form a new row, instead it just stacked in the rows at the bottom of the older matrix. Okay, for vertical stacking, it's the same thing but on the column basis. Okay, this is now a single column, this is now a single column, like that. And for vertical concatenation, it is the same thing as horizontal stack, it added those elements in there. Okay, so that is what is about this 4 operations on this array. Okay, so is this clear now? Okay, next is column stack. It is same thing. Let's see it here only. I need to go in the other slides. What 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 what. So the column stack matches with the vertical concat. Okay, so which matches with the horizontal stack. So that is the column stacking. Okay, that is what is about this column stacking. And there, okay, that is how it works. So that is not much used, column stack function. What? So that's how it used. So that is what is a function of this column stack. Okay, so we generally use H stack and V stack a lot, not the other ones. Okay, so if it's clear, we will go into the splitting of arrays. Okay, this is a bit tricky one. So what I will do, okay, so the syntax is, will show you here. The syntax, how it tells is, for the split function is np dot split. What it takes 3 parameters into account. First one will be a array, it can be anything. Next one will be index, this I will explain. The next one is axis. Okay, the array, the first one can be any NumPy array. Okay, it can be any NumPy array. Indices has 2 forms, either integer or a list. If it is an integer, then what it does, it takes into account the array is split from that very index which is mentioned as an integer. But if it is an like section, like an list is passed, then that 1D array will be that array will be splitted from that row. Okay, splitted from that row and column based like that. So it will be coming to an 1D array, the list, it will be then be splitted based on that. So we will see that in a few minutes. Okay, and next one is axis, as you already know, that is having 0 and 1. That is the same thing as you already know, 0 for like a row based, 1 for column based. Okay, so that's how it will work. Now let us go back and work on this A array. Okay, so what A, this will be our A array. Now what we will do, we will split this array. So A, the first, second one I am passing an integer, third one I am giving it a column. So see what happened, I provided 2 as an integer value, right? So the array is split onto two arrays. Okay, if I pass 3, it won't be 3. Why it is not equal? It should be equal, right? Okay, why it is not working? Because we have 2 rows and we are splitting it based on rows, right? So it won't work. So that's why we need to split it on a columnar basis. So that is the idea. Okay, so see here. So we have a 2D array, right? So we are splitting it based on row and we are splitting it to two splits. So the 2 arrays will be coming out. Now we are splitting it based on x is equals 1. So that means a columnar way. So we have 3 columns. So it can be split into three parts, right? So that's what is about the split. Okay, that's what is about the split. Let me print it something here. Now this is the easy and simple part. We will get into the critical part in the next part. The critical thing is coming up for you. Now let's say I am not passing something as integer. Instead, I am passing it as a list. Let's see how the output differs. Okay, so this is how it will differ when you pass this, like when you pass this, pass a list to the integer value. So the array here will be split into 3 parts. Okay, and then those 3 outputs will be given. Okay, so in the list, the first one is the first thing refers to the column. So array will first be split into A:1. Okay, then the array will be split between these two numbers, that is 1:2. Then the array will split for the last number, that is the array will split into the last number, that is 2 colon. Okay, so this 3 thing will be outputted based if it's a list is passed into the indices thing. Okay, so this is what is the idea here. So what this basically does, if you see the array in full, it has 3 elements, right? It is a 2 by 3 array, right? Now I am splitting it from 1 to 2, right? So that means we are splitting into these 3 parts. That's how split works. Okay, so this array refers to from where it is, from which, along which axis it will be splitted, and this is how it will work. Now, so this is what is to hold true for row wise. Now if we go for column wise, you see something different, right? So what is this doing now? Here everything is given for only row, right? But here everything is done for column. Okay, so see, the first output is 1 4. The next one will be done for column. The first one that we have seen was done for rows. Now in the second one, the everything will remain the same. Instead, we will do for columns instead of doing it for rows. Okay, so now if you see carefully, these are the splits that you got in there. Okay, 1 4 2 5 and 3 6. Okay, these are the splits you got from there. So every operation is done like this. So whenever you get an index, you split that array individually into 3 parts like this. Okay, and then you concat the output of these 3 separately. So that's what will return you the exact output of the split function. If you split that on the rows, then it will be a row wise split, and it will return you the values and the 1D arrays based on its rows. And if you split it based on column, that is x is 1, then it will return you some values based on the columns itself, the column separation itself. That is what the concept of a split is.
Our fourth quiz question is, which data structure in Pandas is used for handling labeled data? Option 1 series, option 2 list, option 3 dictionary, option 4 array. So this can be a little tricky. I am hoping for a lot of right answers in the comment. Guys, quickly drop your answers in the comment.
What is the advantage of NumPy over list? Okay, so this NumPy arrays consumes less memory. Next is, this is faster. We will see an example at how faster NumPy arrays can be. And next is more convenient. As you see, in list you didn't had all these methods, right? Sum, min, max, median mode, this concat, h stack, v stack, this all these methods that we have discussed till now. We need to write those on our own. We need to do this on our own, right? So these are the that's why NumPy array is more convenient. And as a data science, and someone was talking about pandas. If you know about pandas already, or if you have read about somewhere, pandas array is only based on NumPy array itself. Okay, it is same thing. Okay, pandas array and NumPy array will go hand in hand. You will see. Okay, so if you understand NumPy array better, it will be easier. It will be cakewalk for the pandas part. Okay, so that is what is about this array part. Okay, that is what is about this NumPy part. Without wasting time, I will go into an example first, then I will come to this one. Okay, example will be somewhere down there. Okay, this one. This is a quick example how it is advantageous based on memory space, and how it is advantageous based on its accessibility time. We are having time near equals 0. Sorry for that. Let me increase it. We have another 0, another 0. Okay. So see, here is a example for memory size. What we are doing, we are defining a list, right? Range function returns a list, right? We all know. So we have taken a list here. We are getting size of 1, that is 1, and we are multiplying with len of L, right? So 1 is an int, so it will be, so what is why 1? Because L will return a range of range from 0 to 1000, right? L will return that. So 1 will be the element and it will be int. So that's why we have written 1 here and we have written len of L. So that means L has 1000 elements and it will take 28 byte for each element to store. From the list basic, you must know this. So that is why it is printing as 28,000. Okay, for that it is printing as 28,000. So for storing 1000 elements in a Python list takes up 28,000 bytes. Okay, whereas for a NumPy array it takes up only 4,000 bytes. Why is that difference? So as you know, a dot size is, what is a dot size? A dot size is the length of the array. A dot item size is size of the array stored in the memory itself. Okay, so size of the array stored in the memory. So that's what it gives us 4,000. So that is coming as 4,000 bytes. So why is that difference? Okay, why is that difference? Why is this huge difference? Now let's go to this PPT. So see, for NumPy array, how we store, we directly store the data into the pointer. So forget about this dimensions, right? Focus into this data. So this is a NumPy array where we have a data head and the data head points to the data directly. Okay, data directly. So as you might have covered in the list basics, how lists are stored in Python is not directly. Lists are stored on some memory location and that memory location is returned to the list element. So that's why that is an mutable one, because and tuple is an immutable one, right? Because in tuple you can change the value because it directly stores the it doesn't have the memory address of it. It is an immutable one. But in list, you will have the memory address stored in it. So whenever you access some element, it is accessing the same memory location only, not the direct value. So again, that memory location will have a value. So for storing memory location, it will consider 2 bytes. And for this, it will 14. So 14 by 2, 28 bytes for a single memory location it will have. Yeah, list will be having 2 steps of data storage. So first one will be a pointer, second one will be a data. Okay, second one will be a data. And no, NumPy is not immutable. NumPy is mutable. We have seen multiple examples, right? NumPy is not immutable. It is not because of this storage that is immutable or mutable. That's what is considered. It is due to some other feature. This is just a language construct. So they have made tuple to be immutable, and tuple doesn't store it like this. Okay, NumPy is not immutable. NumPy is based on list only, so it is totally immutable. But the storage of data is different. It stores the data directly. Okay, but for Python list, it stores the data in a 2 ways. Okay, so 14 by 2, 28 bytes will be taken up for a single memory location. Okay, so that's why that's what you saw in the example also, right? In a programmatic example, you have seen it. So that is how it is beneficial from the memory location. Okay. Now, if you see, we are doing some XYZ operations. That is adding to list. First adding to list and second adding to NumPy arrays. The same thing we are doing. Okay. So here we needed to pass it through a loop, right, for adding. But here we don't need to do that. We can do a clear matrix multiplication by a plus b, and then we are returning the time difference. If you see the time difference here for NumPy for a normal list is 0.005. Okay, but for NumPy arrays it is 0.000999, something like that. So it is too small, because when I was doing it for 10,000 for my machine and configuration, for 1,000 actually, it was not even coming something. It was coming in a zero value first, not a 1,000. And see, even if you see for 1,000 lists, 1,000 values in list and 1 lakh values in NumPy array, still NumPy is somewhat faster than list, right? If I do a 1 lakh in both, you will see the real difference. You will see it is 41% faster than a NumPy array. Okay. Now, if I just reduce a 0, it is coming in the range of 0. Okay. That's how lightning fast NumPy array is, because in NumPy array, the access is direct, right? So that is just going into the location, fetching the data and doing the addition or multiplication or whatever you want to do it. So that is what is being done in NumPy arrays. Okay. That is what is done in NumPy arrays. Okay. So that's how it works. Okay, so that's what is about this NumPy arrays. What?
Just a quick info, guys. Intellipaat offers data analytics course in collaboration with IIT and Pavatak. Through this course, you will master Power BI, data modeling, data mining, and much more from the IIT Madras faculty and industry expert. With this course, we have already helped thousands of professionals in successful career transition. You can check out the testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your careers to new height. So visit the course page link given in the description and take the first step towards the career in the field of data analytics.
All right, my people. So in this class, you guys are aware that I'm going to be teaching you a new library, which is super important. And the name of the library is called Pandas. Now, before we get started with the session, you have to understand a very important thing. Okay. And this is super, super critical. You have to understand how Python and its libraries work, right? So for example, the first thing was NumPy, which is a very important data manipulation tool. It is used for purely applying mathematical concepts, okay? After NumPy, you learn a tool called Pandas because the knowledge of NumPy carry forwards and you can apply that concept in Pandas, right? Right after Pandas, I'm also going to teach you another tool called data visualization tools, okay, for data visualization. So I will be teaching you two libraries. One is called Matplotlib, okay, and the other is called Seaborn. So you see what happens is, via learning NumPy, via learning Pandas, and via learning data visualization tools like Matplotlib and Seaborn, it will prepare you for data pre-processing, okay, and data visualization. This is a very important step in you to move forward in your career for machine learning based algorithms or machine learning, and you want to specifically get started. But in order to do that, you have to have a stepping stone towards data pre-processing and data visualization. So remember, learning NumPy, learning Pandas, learning data visualization, the reason why you're learning all these three tools is because the larger goal is data pre-processing. I hope you kind of got the concept. We want, or you have to be super prepared in the concept of data pre-processing, not to be taken very, very lightly. This is a very, very important concept. Anyways, I welcome you all to yet another session, my people. Today, I am going to be teaching you some very critical concepts in Pandas. Okay, I am going to make you understand how Pandas works. However, realize also one another important factor. Pandas is also a huge, huge ocean. Okay, just like NumPy, Pandas is incredibly large. Pandas is something that I can tell you with 100% guarantee you cannot learn in your life with just, I don't know, without practicing this. Pandas cannot be acquired. The skills in Pandas cannot be acquired. However, the agenda that I have set for this class is very simple. I am going to teach you exactly how certain technologies in Pandas can be learned. Now, the agenda that I have kept for this class is very, very simple. I am going to give you some knowledge on the theory, and we are going to do actually a lot of practical coding. Okay, in this practical part, I have also sort of taken a data set, and we will do data manipulation in together. You and I, we will do data manipulation together. Okay, so why Pandas? Okay, why do we need Pandas? What exactly is Pandas, right? What features does it carry? Why Pandas versus NumPy? What data structures does it have? What data structures does NumPy have? Arrays, right? NumPy's work on a data structure called arrays. Just like that, exactly like how NumPy works on array, what does Pandas work on? We have that as well. We have Panda series objects and data frames. We have merge, join, concat, and other methods in data frame. Do you remember, my people, you have learned something called SQL? Have you ever learned something called SQL in your previous class? Most of you have told me that you have learned SQL. If you did good in SQL, my people, if you really remember SQL well, guess what? Pandas is nothing nothing but a very good knockoff or a copy of what SQL did. Do you remember you used something called group by functionalities in SQL? You had something called pivot table, right? You had something called merge functionality. You had something called joins, inner join, outer join, basically not natural join is inner join, but all those features you did, exactly all those features that you learned in SQL, you will be implementing in Pandas, because Pandas is nothing but an inspiration from SQL. So what if you were good in SQL, anything that you're going to be doing in this particular class is going to be exactly the same. But the way the data is imported is different. Okay. The way data is imported is absolutely different. Anyways, you will see what I'm talking about. Importing data sets, cleaning the data sets, visualizing it, manipulating. We are going to talk about all. But before.
Fifth quiz question is, what is a NumPy array? So option 1, a NumPy array is a multi-dimensional array for numerical data. Option 2, NumPy array is a single dimensional list of strings. Option 3, a graphical representation of data. And option 4, NumPy array is a database management tool. So whichever option you guys feel is most suitable for a NumPy array, kindly drop that option in the chat.
We jump. Let's understand what is Pandas. See, if you're a Python user, or if you're somebody who comes from a Python background, right? Pandas is one of the most used library for both data manipulation and data analysis. Remember, NumPy was a data manipulation tool. NumPy was not a data analysis tool. Yes or no? NumPy was only and only used for manipulation of the data. It was never called to be a data analysis tool. But what is Pandas? Pandas is both data analysis and data manipulation. Are you clear? Pandas is used both, for both. Remember one thing, Python and Pandas are able to integrate itself so faster that whatever you can do in a longer lines in Python, Pandas automatically gives you such functionalities that you don't have to worry about it. Pandas will take care of your load, of your problems, of your responsibilities. You just have to know or remember what methods that Pandas have. And if you are able to remember and recall all the methods, your life will be sorted. Example, let me show you once at a time, okay? Working with large data sets. Let me show you one problem. Have you ever heard of Microsoft Excel? Of course you have, right? What is the limitation of Microsoft Excel? What is one of the biggest limitation of Microsoft Excel? What is the maximum amount of data set a sheet can take? It's up to 1 million, if I'm not wrong, not more than 10 lakhs. And that too, the moment you reach 80,000, your sheet starts getting stuck. If you've not observed it, great. But if you've observed it, great. If you fill up 80% of the sheet, your sheet starts getting a little stuck. What I mean by stuck is, look, even Excel has to work hard in your memory to show you the data, right? Now, the problem with Excel is, right, you have limitations of data, you have a limitations of operations, right? Like operations that you want to do, you have certain limitations. But if you personally ask me, and I am making this claim in front of you, and I'm making this bold claim in front of you, that to be good in Excel is actually a great thing. I'll tell you why. As a data scientist, knowing Excel has only made me a great data scientist. I'll tell you why. Sometimes you don't have the energy to do data analysis in Pandas also. You don't have the energy to load the data set on a Jupyter notebook, call all the libraries, then write the code one line at a time and do analysis one line at a time. Isn't Excel just going to give me an idea and I can do whatever I want with it? If you have a really good skill in Excel, don't you think for a smaller data set, right? For a very small data set or a smaller data set, I can do analysis very quickly. In fact, in 5 to 10 minutes, I will have the answers of my analysis. But in Python, I have to open a Jupyter notebook. I have to load all the libraries. So remember, my people, you should be a really good data scientist and no tools should be your favorite. Oh, no, no, no. Excel is my favorite tool, or Pandas is my favorite tool, or any of that is my favorite tool. That cannot happen. That cannot work. Okay. Learn Excel. This is my personal request and my personal advice to all of you. If you have a smaller data set, work with Excel. If you have a larger to mid-level data set, work with Pandas, okay? Both these tools are going to help you learn, and it will make you very versatile, my people, right? It will make you very, very versatile data scientist. You will not be, how do I say this? You will be very, very open to learning different kind of tools, and you'll also be sort of appreciative of the fact, okay? So remember, working with larger data sets is why we use Pandas. Now, to clean the messy data, analyze and manipulate it according to the needs, Pandas is where you go, right? Pandas is used for data analysis and manipulation. We do data cleaning. Can anybody tell me what is data cleaning plus data analysis and manipulation actually called in technical terms? What would data analysis, data cleaning, it's data pre-processing. This is exactly what you call data pre-processing. You're fixing your data, my people, right? Introduction to Pandas. Remember, Pandas is a simple yet a powerful but open source library which is used in data analysis and manipulation. But the features of Pandas is absolutely open source. What do you mean by open source? Pandas does what? The code file or the code structure or the structure is open source and anybody for everybody to be completely free for use, right? It is very powerful and it is super and ultra flexible. What do you mean by that? It can integrate any language, anything. NumPy can be integrated with Pandas. Pandas can sort of use NumPy. So there are so many awesome stuff that can happen, which is super duper critical. And I personally recommend that once you start coding it, I actually have a practical example for you to have a look at. It's absolutely free and no cost, right? Very, very, very powerful, ultra fast. A super powerful and super amazing thing this particular library is. And after some time, I don't know, after maybe a while, you will start appreciating the fact that Pandas exist. I'm telling you, you guys will love this tool, right? Now, going down. See, Pandas works on something called panel data. That's how the name comes. See, the name comes of Pandas from panel data. So datas, so Pandas. So Pandas name does not come from a cute animal. It comes from a technical term called panel data, which is called Pandas. Have you ever seen a tabular structure like this in SQL also? You call this in SQL as a schema. You have a unique key, right? A unique identifier. You have in unique identification, you also call it. So basically, here is the thing, right? You have something called your foreign keys, your composite keys, right? You have multiple different kind of keys that you have. These keys are used to match one table with another table. If you are able to match based on joins, you can take one key here or another key here, sort of like the primary key concept, and join the table. And if you have multiple tables, you can also have composite keys. You also have like so many different types of concepts, right? So see, this is called as a tabular data. In Pandas or in other old technologies, we used to call this panel data. You guys don't understand one thing, right? This is just a quick fun fact for you, okay? This is sort of like a fun fact. Have you ever seen the very first version of Excel in your life? Have you ever seen or have you ever... No. I'm not talking about Excel. The very first Excel that was launched by Microsoft Excel, I mean, the Microsoft, they used to call this as a spreadsheet. Actually, you guys don't understand that Microsoft comes from something called MS-DOS, okay? Desk Operating System. Desk Operating System, maybe version 2, version 3 had the first version of Excel. And if you look at it, you guys would legit laugh today. Like, you would be like, what is this? It would have 5 columns. And it had 1,000 rows or 2,000 rows, not more than that, because at that time you had to work on floppy disks. and you did not have an options of you just had an option of naming the columns maybe once or twice or something like that, and you could do basic stuff like addition, subtraction, and it was weird, man. It was weird, right? Like I've seen the very first version when the Excel came up and they made it better by better. Of course, Excel today is just I don't know, awesome. But yeah, it was like, it was very good to observe. So in olden times we had things like this, like parallel data. You have very limited number of rows, very limited number of columns. So this is what people used to call panel data. Then they used to call it spreadsheet. Then from spreadsheet it became very famous, and then open source office like LibreOffice came into picture. So many things happened in technology, but yeah, I mean, just to get you know that this is called panel data, right? In Pandas. Okay, by the way, I think we should appreciate this guy called Wes McKinney. He's I think a founder, or I think he works somewhere as a very senior consultant. But this is the guy, the OG of creator of Pandas. So I think we should definitely appreciate this guy. He made Pandas. He open sourced it. He took a lot of people's contributions on Pandas and eventually made it open source. And Pandas is one of the biggest open source libraries, one of the biggest source open libraries that's going on. So I think this is the guy we absolutely should appreciate, the OG guy. Right now, my people, let me tell you a couple of features. But before jumping into features, let me tell you the beauty of NumPy versus Pandas. See, my people, Pandas works is actually and genuinely built for a larger data set, right? So see, Pandas calls itself larger than life. Why am I saying this? Is because Pandas says, look, don't give me smaller and medium level data like 50,000 rows, 10,000 rows, 20,000 rows. Give me, I don't know, give me 5 lakh records, give me 10 lakh records, give me 20 lakh records, give me size which is larger. Heavy data voracious tool this is. When I say voracious, it means it has appetite of consuming and working on a larger size. But NumPy performs better only if the size are larger, but not too larger, right? It's like a small to mid-level. NumPy will do a good job. But you will start seeing that if the dataset size is incredibly larger, Pandas outperforms NumPy. It means Pandas is even faster than NumPy. Pandas series objects is more flexible as you can define your own labeled indexes to index and access elements of an array. Elements in NumPy arrays are accessed by the default integer positions. What it meant is, my people, when you defined arrays in NumPy, suppose you had an array called A, comma B, comma C, comma D, comma E. Was I able to keep a label or an index saying that let's call A as name, this is age, this is something X, this is Y, this is C? Am I able to keep any label on top of the array? Am I allowed to do that? No. By default, every array will be indexed by what position? Via its integer index 0, 1, 2, 3, 4. Are we clear? But in Pandas, what you can do, even if you define one single array, you can define everything has its own label. Are you understanding? The only difference between Pandas and NumPy is everything in Pandas can have its own label, which makes your life super duper easy. And I'll tell you why this particular thing is. You'll understand it in a while. Okay. So are we clear these 2 points? NumPy can only be accessed via its integer position, but in Pandas, you can define your own clear labels. We will see millions of examples in the code file that I'm going to show you. But are we clear until here? Why larger data sets is suitable for Pandas? Any background reason? Yes, there is a background reason. 100%. Have you ever seen me teach a tool yet that is dealing with practical data sets? Have you ever seen me teaching an actual tool, a tool which you can call super practical, that is actually working on data sets like you working on a data, importing data, loading data, uploading data, all of that stuff? Have you seen me do this? No. Okay. I am telling you, Pandas is that particular tool, right? So the background reason for Pandas to work on a larger data set is in the background, this particular Pandas data set is optimized and built only for one operation, and that is data manipulation. Okay, so the specific reason why pandas work really, really well for a larger data set is because it has been optimized. Do you understand the word optimized? It is built in such a way is to handle the operation on data sets. It is built for that one reason. It is built because the way it is written, the way it is coded, the way the whole creators have created that particular library is for only one specific reason. They say everything in life has a reason, right? Car has a reason, it takes you from point A to point B. House has a reason to give you security, right? To feel you, to make you feel safe. Phone, I don't know what phone does. Absolutely, actually, genuinely telling you, I don't know what responsibility does phone have, is to make you, crazy while scrolling Instagram. But everything has a reason. Just like that, Pandas was written in such a way that to make data pre-processing as easy as possible, as quicker as possible. So that's what they've done, and it is written in C, and some wrappers are written in very quick, very faster C wrappers. Is it also to have SQL available in Python? Look, SQL in Python is not like that. Like SQL is itself a standalone tool. Agree or disagree? You don't need this in Python, correct or not? I mean, you already have a SQL table, right? You can query directly from SQL, right? Why do you need Python for it? Are you understanding what I'm trying to say? Pandas is a different tool. SQL is another tool. Like they have nothing connecting them. Just that the way you query your SQL table, you can query your pandas table also, like pandas data structure also. Are we clear until here? Now, my people, just like in NumPy, you had a particular data structure called array, correct? You must also have some data structures that you can follow in pandas. Well, you do. In pandas, for one-dimensional data structure, we call this data structure as series data structure. For two-dimensional data structure, we call this as a data frame data structure. And for three-dimensional data structure, we call this as a panel data. Do you remember, my people, whenever you work on spreadsheet, you can either have only one row, and you can call this as 1, 2, 3, 4, 5, 6, 7. Guess what? Just like how you declared a one-dimensional array in NumPy, you can declare a one-dimensional series object in pandas. We don't call it list, we don't call it array, we call it series data structure. Are you understanding? In pandas, this is called as what? What do you call it? Series data structure. Once again, what do we call this? Series data structure. When you want to take a data like this, like an Excel format, you have multiple columns. Each column has a name of the column. For example, this column name is age, another column name is salary, another column name is loan. You want 3 columns, multiple different rows. This data structure in pandas is called as what? Data frame. Are you understanding? It's called DF, data frame. But sir, what about panel data? Sir, does panel data mean it is 3-dimensional? Yes. But sir, how 3-dimensional? Allow me to explain. My people, can I say that a 3-dimensional data structure is nothing but first you have one 2-dimensional structure and the same structure keeps repeating multiple times? Can I say that this is something that I can say? For example, this is another tabular form. Yes, sir, are you understanding what I'm trying to say? See, this is a column versus row data. Multiple column versus row data can be called as a panel data. Agree or disagree? But you should not think of it like that. I'll give you guys an example. My people, the number of cars sold in 2016, 2016, 2016, 2016, and then 2017, and then 2017. Can I say that I can keep them separated by their year? So 2016 data structure can come here. 2017 data structure can come separately. 2019 data structure can come separately. Are you understanding? Multiple copies exist, but each data has its own year that is following. This is the data for 2016, another data is for 2018, another data is 2019, 2020. Are you understanding what I'm trying to say? It's three-dimensional, not in visualization format, but in reality, in according to certain criteria like age, date, months. I hope you kind of got the concept of what I'm trying to say. It doesn't actually is three-dimensional, but you have to think of it like that. Like you are segregating it based on its principles of age and all of that stuff. It's just like tabs in Excel, man. Absolutely correct. It's just like a tab in Excel, man. Don't you have sheet 1, sheet 2, sheet 3, sheet 4? Have you seen sub sheets in the Excel? You can create multiple sheets. Yeah, man, you can take it like that also. You can create that. Okay, anyways, we'll come to that a little later. Are we clear with the data structures in Pandas? Are we clear with that? Some idea, some basic concepts? Okay, enough theory, man. Enough theory. I think we can jump into the practical aspects of Pandas. And I think I'm also itching forward to making you guys learn Pandas a little bit more hands-on. And I want you guys to learn it a little bit better. So, my people, just like how we import NumPy, okay? How do we import NumPy? Import NumPy as NP. My question to you is not NumPy. We import NumPy as NP. NP is called as an alias. Does everybody know that NP is called alias? Yes or no? I can call np.array like this, right? So I can do np.array, and inside this I can pass something called 1, 2, 3, 4. And if I do, it's an array. But if I call import NumPy as Rudra, R-U-D-R-A, this is also allowed. It's just that R-U-D-R-A, this is also allowed. I can do Rudra.array. And you see, I can work on it. Can you see? I'm able to create an array 1, 2, 3, 4, 5. The problem is everybody in the world has a silent understanding that NumPy will be called NP as an alias. If you write Rudra, what's going to happen to you? You will be found in the middle of the road and all developers are going to do what? I call it kissing the towel. Kissing the towel. What do you mean by that? I'll tell you. See, have you ever seen a wet towel? Okay, so the towel that you use to dry yourself when you are taking a shower or a bath, right? But the moment you wet the towel, it becomes very heavy, correct? The towel becomes very, very heavy. And then when you take that towel and you swing it and you hit somebody, that towel actually feels like it's a rod, right? So what will happen is, if you are working for a company, okay, and if the company, everybody in the company says NumPy is NP, and now you suddenly change the alias and everything in production is breaking just because you changed the alias, well, everybody will help you kiss the towel, right? So don't be that person. Please follow the structure of calling NumPy as NP. Just like how we do that, can I say import pandas? Now, while we import pandas, we can call pandas as PD. This is the basic structure, basic alias that everybody uses. Pandas is always called PD. Are we clear? Very good. This is how we import pandas. Now, I am going to teach you some amazing fun stuff and you guys will understand why this is fun, okay? And slowly and eventually you will start understanding. I told you the first data structure, the very first data structure in pandas is called series. Series data structure. Sir, how do you declare a series data structure? Very simple, my people. PD dot call series. Khatam. And inside this, pass anything. जैसे for example, हम बोलते हैं 100, 100, 200, Rudra. I am done. My date, my whole sort of idea is declared. But the problem is you even have to declare everything as a Python list inside it. Like how you did in NumPy, you can do it. And if I run this, have I created my own structure, my own data? Can you see this? The data is object. Everything got converted into string. You remember how NumPy converted everything into string? You cannot have multiple different data types here. Everything would be a problem. Object is nothing but string data type. Okay, remember, it's a string data type. Anyways, focus on this, right? Did you just write a series data structure in pandas? Is it hard? Absolutely not. We just have to call like pd.array, pd.series and pass inside this, right? For example, 100, 200, Rudra, I was able to answer. And my people, what you can do with it is, do you see automatically you get a value called 0, 1 and 2? Have you seen in Excel that sometimes Excel automatically gives you this 0 value, 1 value, 2 value by default in the left hand side? Let me show you in Google Sheets, okay? Let me do Sheets. Let me show you in this sheets, right? DSA sheet. This data structure sheet, I believe, can help you do well. But can you see this 1, 2, 3, 4, 5? यहाँ से आपको दिख रहा है 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Our row number starts at 1, but by default, Panda starts with what row number? Whatever you do, you cannot delete this. ये जो 0, 1 and 2 you see, right? You cannot delete it. You cannot remove it. It will show up in Pandas. Are we clear? You cannot escape it. There is no escaping. And series can take any data type. Narendra Yadav. Series can take any data type, mix, match, no problem. It can take any data type of any kind, no problem at all. And not all methods are in Pascal cases, but most method in Pandas are going to be following what cases? Pascal case. So Pascal case means in NumPy we called np.array. Do you see the A capital or small? Small. Do you see in Pandas pd.series? Is series ka S capital or small? Capital. So that means most method names in Pandas follows this kind of structure. Okay, you have to be very, very careful. It does mostly carry that kind of thing. But coming back to another topic, suppose I say pd.series, okay, pd.series. Do you remember I just showed you a while ago that if you have a name called Rudra, okay, if you have another name Gopinath, let's say Parminder, okay, and let's say Murchana and Gopinath. These are 4 people. If I run this, do I have automatically assigned label 0 index pe Rudra hai, 1 pe Parminder, 2 pe Murchana, 3 pe Gopinath, yes or no? Do you remember I also told you you can change its label? So if I say index equals to, if I say A, okay, I want to show you something. Hold on, 1 minute. पहले तो मैं आपको ये चीज दिखाता हूँ. 1 minute. B, C, and D. Do you see I changed the 0, 1 and 2 with its own independent label? Did you just see what happened? Example, A को replace कर देंगे with 101. B को replace कर देंगे with 102. C को replace कर देंगे with 103. D को replace कर देंगे with 104. Do you see now I automatically change the label also? Do you see how we change that auto label in that particular thing? Did you get the concept, my people, that whatever data I have defined, I am giving all the data the label or the indexes that I personally choose? Are we clear? I can choose it. Nobody can sort of take it up. The full form of D type is what, my people? The full form of D type is data type. ऑब्जेक्ट का मतलब है सारे के सारे डेटा किस टाइप के स्ट्रक्चर डेटा फॉलो कर रहे हैं. दे आर फॉलोइंग व्हाट डेटा टाइप? स्ट्रिंग डेटा टाइप. आर वी क्लियर? नाउ आर वी क्लियर विद द सीरीज डेटा स्ट्रक्चर? How do we write a very simple series data structure? There is no problem in it. Absolutely, we will be able to write it. Okay. But my people, I told you one thing in the class in the very beginning. Whatever pandas I'm teaching you, of course, in the beginning class, I'm teaching you with the lower data site. But my question to you is, can pandas handle 500, 600 columns and 8 million, 80 million rows? Will it be able to do that easily? Yes, 100%. See, I am showing you 4 people name, 5 people name, 6 people name. भैया ये सब तो ठीक है. But remember one thing, हम लोग एक बहुत ही heavy tool को सीख रहे हैं, right? We are all learning a tool which can handle 700 row size, 800 column size, or 800 column size, 9 million row size, all of this particular thing can be done very, very easily, very, very fast in Pandas. Otherwise, we would have all gone with Excel 100%. So remember, I am showing you some very basic example, but first learn the basics and then learn how it particularly works. It is not exactly like dictionary, like key value pair, but it's kind of somewhere in the middle. And I'll show you an example. Like example, my people, what did I tell you that if you want to create a two-dimensional data structure, is it not called data frame? Hi, Anna. Agree or disagree? It's called data frame. So chalo, एक data बनाते हैं. Let's take a data. Am I taking a dictionary here? Can I say I have taken somebody's name called as Rudra? इसी को copy paste कर लेते हैं, right? Why waste time and energy? Give me 1 second. So let's say I have taken 4 names, okay? And I will take their age also. So let's say, how old is Rudra? Rudra is 29 years old, okay? Parminder, I am only going to make a judgment on you. Don't take me in a wrong way. Parminder looks like Parminder is 30. Okay? Murchana looks like Murchana is 24-year-old kid. Okay, let's make Murchana 16. No, let's make Murchana 12. Okay, 11. Okay. Gopinath looks like Gopinath is 34. Okay, based on what I think. Now, if I want to create a data frame, you have to write a variable data frame is equal to df equals to pd dot data frame and pass what inside? Data inside it. If I print df, do you guys see a table created here? Do you guys see a table created in front of you, my people? The name and age was created and you passed nothing but a dictionary. And because you passed the dictionary, you created your own data here. Okay. Now, I have a small question I want to ask you. My people, imagine you are all working in a professional company. And of course, sorry, all companies are professional. Let me not, I'm so sorry. Not all companies are professional. People who are already working in current organizations, you guys already know this. If you work in a company, are you allowed to alter the table, create the table, delete the table in production? Will you be allowed to do that? I'm asking you all a very simple common sense question. ठीक है? Reality में जीने की कोशिश करते हैं. ठीक है? I'm all going to give you a reality check. If you work for a company as a data scientist, will they give you an opportunity to alter the table, to create the table, to delete the table, to edit the table in production? Will they do it? Absolutely no. If you do this, you will be even jailed. I'm not lying. I'm not lying. I'm not exaggerating. Because a company's data is company's assets, correct? Okay. So first of all, the company itself will make sure that you always work on pre-built tables, correct or not? Pre-built tables is what you will be always working on, correct? There will be a database team or database administration team or data engineering team or DevOps team. Only they will have the rights of changing the table, deleting the table and all of that. Just like that, will you be working on Pandas by creating your own data or data to milega? Matlab data will be given to you. You just have to do analysis. Are you understanding? I am teaching you how to create a table. This is for your knowledge. But in reality of life, you will not be creating data on your own. You will be given a table. You will be given a data, and on that data, you need to start working. Are you understanding, my people? I am teaching you for your knowledge, for your absolute knowledge, but please don't understand or please don't follow that. Oh, now I have to create everything by myself. In reality, this is not how it works. In reality, data will be given to you and you need to just start analyzing. Okay. And my people, the beautiful thing is in this class, I have a data set which I have downloaded from internet and we will be doing manipulation on that data and it will be so much fun. Okay, but first let's understand some basic stuff. So are we clear with data frame? Yes or no? Are we clear with the concept of data frame? हाँ या ना? We are clear. अभी हमको idea मिल गया है. Okay. This another way, this is called type 1. Okay, my people, type 1 of creating a data. Do you know, my people, not many people know this. Everybody online will teach you type 1 only. But guess what? I am not the everybody personality. I will teach you type 2 kind of a data. See, if you want to create a data frame, you are using a data structure called dictionary. Yes or no? To create a data frame, you can use dictionary. But did you know that you can even use Python list? Do you want to have a look at how to create a data frame using a Python list also? Let's have a look at it. Data underscore 2D is equal to, my people, the exact same data I'm going to create it in a list. What was the first name? Rudra, right? Agree? The first name was Rudra. What is the second personality type? Sorry, the second type, 29, age, correct? Agree? What is the next? It is Parminder, okay? Parminder. And what is the next sort of a thing? I think it is 30, right? I come out, I come down, I say, the next is Murchana. Murchana. And Murchana's age is 11-year-old person, right? Murchana comes down. Then we say it is Gopinath, and Gopinath is, we have considered Gopinath to be a 34-year-old person, and this is my array. Is this a two-dimensional array? Agree or disagree? Is this a two-dimensional array? If I want to create a data frame called df underscore new equals to pd.dataframe, inside this I will pass data underscore 2d. But my people, here in the dictionary, I had a column name already defined called name and age. Yes or no? So name and age pop up. But do I have any column name that Rudra, Parminder, Murchana is called name, 29, 30, 11 and 14 is called age? No. Guess what? Write columns equals to, say name, comma age. Did I just create another exact same data structure, but this time using dictionary, this time using Python list? Can you see? I am able to do Rudra, Parminder, Murchana and Gopinath and their age. And now I am also able to create a data frame using this list. Did you observe this? So my people, for your benefit, I'm telling you, you can create a data structure using data dictionary or data list, and you can create any data frame that you want. I have given you both ways. Whichever you want, you can use any one of them. Are we clear? Are we clear with this? Are we clear with this concept? If I print df, do I have Rudra 29, Parminder 30, Murchana 11 and Gopinath 34? हाँ या ना? Agree, disagree? Okay. अब एक बात बताओ, यहाँ पे this is my data frame. I want to add one more person. Okay. I want to add new data. Basically, I want to add new row. So can I take a value called new row? And can I take it in a dictionary, because dictionary is the most easiest way. So suppose I want to add one more person. किसको add करें? Let's add Shamim. ठीक है? Let's add Shamim. I like the name Shamim. Shamim. Wow. Shamim has a very good flow to the name, right? Shamim. Nice. Let's add another person's age, right? So Shamim, I'm going to make you 20. No, because I like your name, I'm going to make you 23. Okay, fine. So this is the new row, Shamim, age 23. I want to add Shamim into the new data frame. So what do we do? df equals to df dot append. Have you seen append in your Python code also? In Python also we have append. कुछ नहीं करना है, न्यू रो लेना है और यहां पे हमें ऐड कर देना है df को. If I run this, क्या प्रॉब्लम हो गया? It says, यार आप ना जब भी कुछ ऐड कर रहे हो, you have to pass something called ignore index equals to true. But क्यों करना है? अच्छा ठीक है, नो प्रॉब्लम. मुझे एरर अवॉइड करना है तो ignore index equals to true लिख दिया मैंने. Okay, I am running this code and I'm getting the output. Okay, so multiple ages got added. अच्छा हाँ, यहाँ पे ना हमें क्या करना होगा ना, इसको comment out करना होगा कि I'll tell you how this works. So let's take this. अच्छा मैंने age वहाँ पे capital age define किया ना, correct. Let me, will have to run this from beginning. हाँ, now correct. See, listen to me very carefully. Do you see this 0, 1, 2, 3, 4 in the side to you, my people? Ek 0, this 1, this 2, this 3, this 4. Okay. See, what happens now, I'll tell you, my people. In pandas, you have to learn one thing and you cannot absolutely forget this, okay? See, when you had a table called Rudra, Parminder, Murchana and Gopinath, it started with 0, 1, 2 and 3, correct? Hi, Anna. When I created Naya data frame called Shamim, Shamim itself will start at what index? Shamim itself will start at 0 index, right? Because every new row created will have its own 0th index, correct? If I add them together, won't Shamim also will start at 0 here? And if I don't do ignore index equals to true, the index will be 0 Rudra, 1 Parminder, 2 Murchana, 3 Gopinath and again 0 Shamim. Agree? But is it okay to have that index? Did everybody understand what I'm trying to teach you? All my folks in the class, are you understanding, my people? Whenever you create a new row, the new row is also going to start at index 0. But is it allowed in Python? Okay, let me, मेरे को ना थोड़ा धीरे धीरे भी समझाना पड़ेगा. Okay, hold on. कभी कभी ना not everybody understands at my pace. एक मिनट. थोड़ा धीरे धीरे समझाते हैं. Okay. Can I say this is the original table? नहीं, ये original नहीं है. इसमें शमीम है. Can I say this is original table? 0th index is Rudra. 1 index is Parminder. 2nd is Murchana and 3rd is Gopinath. Hi Anna, इतना तो समझ में आया सबको? Is everybody able to understand this much? I am asking you to focus. एक मिनट, लाल में निकाल लेता हूँ. I am asking you to focus on this part of the code. This part. 0, 1, 2, 3 index. When I created a new row called Shamim and I made Shamim 23-year-old, when you create a new row, won't Shamim also start at index 0? Because Pandas does not know that this is another table, this is another table. Pandas will treat each table separately. Shamim is also at index 0. If I don't say ignore index, won't if I combine them together, it will become 0 Rudra, 1 Parminder, 2 Murchana, 3 Gopinath and again 0 Shamim. It will add itself in the table, but it will again start, the new row will start at 0. Again, yes or no? Python does not allow that. Pandas does not allow that. Pandas says, if you want to add another person, you need to reset the person's index to 4 so that everything is unique in this particular table. Did you understand why do we use ignore index? Ignore index means when you add the new data, remove its original value 0 and whichever is the last value, give it +1, it will become 4. If I don't write ignore index, what happens? You will get what error? Error. You will not even get 0. You will get error. Did you see how we got error? I'll show you. I'll remove ignore index. Control X. Did you get error? Hi, Anna. Did you get an error? Yes. If I paste it here, ignore index back again with a comma, do I now have any error? See, Shamim got added twice because I ran the code again. If I run it again, Shamim got added thrice. Are we clear until here? Okay. Now my question to you is very, very simple. If you are able to add Shamim to the end, shouldn't you be able to add Shamim to the very last also? Shouldn't you be able to add Shamim to the very beginning? Like for example, after Rudra, after Parminder, I want Shamim to be added at the 2nd index. Yes or no? Shouldn't you be capable of defining Shamim or any other name to any other position that we want? Hi, Anna. We should be able to do that. Agree? In order for me to do that, my people, I need to teach you a method called concat, df.concat. But I am going to come to that a little later because it's a little bit complicated operation. Not too much complicated. Actually, wo kuch bhi nahi hai. But in order for me to teach, right, I will teach you something called concat in a little while. Okay. Before we do that, let's make some basic understanding of things clear, right? Let's do some basic operations. Example. Sir, How do we do indexing in acha, by the way, hold on. How many columns do you have in this data? We are sure there are exactly 2 columns. Agree or disagree? We are sure that exactly how many columns exist in this particular table? Exactly 2 particular columns exist. Yes or no? We have no confusion in this. This 0, 1 and 2 is not to be counted. Please don't count it. Are we clear? Please do not count it. It is not to be counted at all. Are we clear? Okay. Sir, I want to add a new column. Add a new column. Sir, I want to add a new column. How should I be able to do it? For simplicity reasons, I'm teaching you. What is the name of your current data frame? What is the name of your table? The name of your table is called DF, right? Look, you have defined DF equals to DF equals to DF equals to, yes or no? If I say DF of, just write new column. Suppose I will say new underscore column equals to np.nan. Okay, I'm just going to np.nan. And if I run this, and if I print df again, do you see I have created a new column automatically? Did you understand? You have just created a new column by just defining df of whatever new column name you want and passing all the null values inside it, which you can later fill. But now you have created something called as an empty column for yourself. Yeah, now. I hope you got what I'm trying to say. This is how easy it is to create a new column. This is how simple it is for you to create a new column. Are we clear? What is np.nan? np.nan is nothing but give me null or nan values in the entire column. Did we not speak nan extensively in the NumPy class? I told you that 0 is a number, but nan is nothing. You can even pass 0 here if you are confused. Am I passing everything by default 0? Are we clear until here, my people? But what if we want to actually fill value? वो हम आएंगे, उस पे भी आएंगे, उस पे भी हम आएंगे. अगर आपको actual value fill करनी है, तो we can do it like this. df of age plus 10 plus 120 or plus 100. Do you see? I have, oh, of course. See, यहाँ पे आपको एक problem आ गया. Do you see age? हमने यहाँ पे age capital रखना है. Can you see automatically every number is added with 100 by default? आप समझ रहे हो मैं क्या बोल रहा हूँ? You can do such operation. Take all the column age, add 100 to it. So do you see 29 plus 100, 129, 30 plus 100, 130, 11 plus 100, 111? मतलब you can do so many operations. We will come to that a little later. मतलब धीरे धीरे I'll come to that particular value. But I hope you got what I'm trying to say. Creating a new column is very easy. Are we clear until here? Data frame looks like tabular representation of table. Can data frame column hold semi-structured data like XML or JSON? Yes, it can. You can do that. You can also do np.random.randit. Yes, absolutely. करके देखते हैं. क्या करना है यहाँ पे? np.random.randint. Do you think this will work? Do you see what's happening here? See, we are using np.random.randint, but every row is being filled by the random value, correct? This time it is 7. The next random value is 4. Did everybody get filled by 4? आप समझ रहे हो how pandas is working? Each row is given preference and priority. आप समझ रहे हो? It's not taking independent row and filling it with random values. उसके लिए loop लिखना पड़ेगा. You got what I'm trying to say, right? Each value is being filled by the number 4. Is this my data frame called name and age? हाँ या ना? This is my current data frame. Okay. एक काम करें. Can we make this a little bit more bigger and versatile? Okay. What I mean by that is, example, मैं आपको बताता हूँ. Give me 1 second. Okay. In the name and age column, can I add one more thing called employee ID? मतलब the people's employee ID. So Rudra will be 101. ठीक है? And Parminder will be 102. Murchana will be 103. And Gopinath will be 104. So this is name, age, and ID, correct? And this is the data frame. If I run this, Do I now have 3 columns, name, age, and ID? Hi, Anna. Now, if I want to add salary, okay, if I want to add salary, suppose this is my data frame already created. Now I want to add a new column, okay, add a new column, a new column. क्या कर सकते हैं यार? क्या क्या what happens एक नए एम्प्लॉय के लिए क्या क्या होता है? नाम होता है, एज होता है, आईडी होता है. When a new person joins the company, हम क्या क्या लेते हैं उससे? फोन नंबर भी लेते हैं, सैलरी लेते हैं और ईमेल आईडी ले लेते हैं. चलो एक्सपीरियंस ले लेते हैं. नाइस एक्सपीरियंस. ठीक है, एक्सपीरियंस ले लेते हैं. How long is that person experienced? So say Rudra is 9+ years experienced or 9 years experienced. And how experienced is Parminder? Parminder is say 12 years experienced. Murchana is 10 years experienced. Acha, Murchana being 11, how can she be 10 years experienced? Well, she's 10 years experience in being a human being. I know. But Murchana is experienced as a human being since 10 years. Okay? Because in the last 1 year, she was human being also, but and Gopinath is experienced since 8 years. So if I run this and if I print DF again, do you see experience column is added, my people? Another column got added here, yes or no? Another column got added, correct? This is adding a new column, but by default, my column is getting added in the last position, yes or no? Even if I don't want it, my column is being added in the last position. I want my column to be added, okay, to be added to a specific location, specific index, okay, specific index. For example, I want, okay, let's take DF of, can I now take salary, my people? Salary. We will take another column called salary, okay? And how much salary does Rudra make? 1.2, okay? Parminder will make 1.3. Murchana will make 1.1 and Gopinath will make 1.6. Okay, this is a new column. But before I make this column as a new column, you know what you can do? You can take this data, you can add it in new column or a specific column. But if you want it to be added in a specific column or a specific index, you can't write it like this. You can't ऐसे नहीं लिख सकते आप. आपको क्या करना पड़ेगा? You have to use a method called df.insert. In df.insert, आपको pass करना पड़ेगा first which location you want. Index number 1. Okay. What is the name of your column? Salary. Okay, is my column. What is the data? कुछ भी नहीं है. ये copy करना है the whole thing and you paste it here. And if you do this and if you print df again, do you see salary is added at a specific index, index number 1? After 0 came the first index and now salary is added at a specific index. Are you clear? First, I wanted to first clarify all your column related confusion. Is column related thing done? You can add a column automatically by default in the last, or you can add a column using the insert method to any specific index that you wanted. Are we clear? अब हम आते हैं row पे. अभी can we do row operation? Adding row in any index we want and बहुत सारे operation. Can we do it? Okay. See क्या है? I already taught you how to add a row at a last index value. Correct or not? है ना? तो अभी what we'll do is we will use a very important thing called lock and iLock, my people. Okay. So problem ये है कि to add columns, it is very, very easy. But to add row to a specific index, it's a little tricky topic. And in order for you to understand how to add row in a specific topic, you actually have to understand and learn something called lock and iLock in Pandas. Okay, it's a beautiful topic. You will love it, but you have to learn something called lock and iLock. Now, sir, what is lock and iLock? Why do we use it? See, my people, first of all, understand lock is some sort of a location or a locus based method, right? You can think of it like a location sort of a thing. But what does it do? See, lock is used to retrieve, okay, a value like a row, or a column based on a specific indexing. I'll tell you how that particular thing works, okay? Lock is used to retrieve. Ab sir, lock क्यों सीखना है? Because बिना lock के you cannot move forward with anything. For example, see, this is my data frame, correct? df अगर मैं डालता हूँ, this is my data frame. I have 4 people value in it. Yes or no? Agree or disagree? If I say df.lock and if I pass 1, is it not giving me Parminder's information? Can you see yahan pe this is 1, df is 1. How do I zoom it for you guys? Can you see this is 1? At 1, Parminder's salary is 1.3, age is 30, ID is 102, and experience is 12. Is it only and only returning the first row at index number 1? Ha ya na? Is lock helping me to work with the rows? Yes or no? Acha, this is accessing only one row. What if I want to access multiple rows? Okay, for example, I want to access multiple rows. How can I do it? Very simple. df.lock, right? It will help you pass something called maybe 1,3. आप इसको ऐसे करोगे, तो is it helping you take and kind of help you locate from Parminder to Gopinath, access or retrieve, and it tells you based on the index कि आपका ना ये 1th location and 3rd location पे है. So I am helping you sort of retrieve, locate, find, give, whatever you want to call it. I'm able to give you that particular thing. Are you understanding? If I pass 0,3, is it able to give me 0 and 3? Like, are you understanding what I'm trying to say? 0 और 3 मतलब पहले 0 दिया फिर 3 दिया. Did you get what I'm trying to say? You have passed value and it was able to give you a row on a specific value. Agree or disagree? Now, what if you want, but by default, all the values that is popping up, isn't it all the columns it is giving me? It's returning name B, salary B, age B, ID B, experience B. Matlab, the rows are being returned, but in fact, all the columns are also being returned. So tell me one thing, in production, is it not necessary that you want all the columns? You just want name and salary, only name and salary. I don't want age, ID, and experience. Yeah, I only want name and age. I don't want all. So can I not do this? Okay. If I want specific row, okay, specific row and columns. So how do I do this? df.lock, okay, df.lock, take a square bracket like this. I only want the first row, but inside the first row, I only want name. I only want age. Age capital hai kya? Haan, age capital. I only want name. I only want age. If I run this, is it only returning Parminder, but in Parminder only 2 specific things, name and age. It's not returning everything. Did you understand what I'm trying to say? 1 is the index position 1 here. Is this sort of clear? Whatever basics I'm teaching you, first let's focus on that. Okay, are we clear until here? Okay, first of all, when I passed .lock1, it gave me this value. Agree or disagree? Ab my people, use your logic a little bit more extensively. ठीक है, थोड़ा अपना दिमाग दौड़ाता है. If I want to print 4-5 values, won't printing like this take up so much space? If I only print one value, it can give me in detail like this. But if I print multiple rows, won't printing like this take up so much space in the print part? So rather than doing this, if I print it like this, should it not give me exactly like this, which will save a lot of tabular space, negative spacing will be saved, and all the name, salary, age, ID, experience will be shown for multiple table. So did you understand whenever multiple tables are printed, but you get it? Boolean and और is, ये सारी की सारी चीजें SQL में जैसे आप करते हो ना कि select, कैसे समझाऊं मैं आपको, select all from some table, okay, और आप कुछ बोलते हो ना कि if name in, जैसे for example आप अपना लॉजिक लिखोगे ना कि नेम इन एंड ऑल दैट स्टफ, तो आप जैसे ऐसे लिखते हो ना, यू कैन राइट इट इन कोड विथ एंड और इज इन, यू कैन राइट इट, इट्स प्रीटी मच अलाउड. ये सब अलाउड है pandas में. अभी तो आगे जाएंगे सर, विल कम टू दैट. Can I give a new variable to subtable and get it as a separate table? Yes, sir, you can. Suppose new df equals to d of dot ilog 1 name and age, okay? यहाँ पे मैंने इसको ऐसे पास किया, and if I print new df, can you see, sir, name, age, Parminder is taken as a separate data frame? Like this is taken as a separate data frame. Yeah. So, sir, you can absolutely take another variable. In pandas, this becomes one of the most easiest process to do, is to take a separate table and it pretty much gets the whole thing done. Okay. Data d equals to this, df underscore new equals to pd dot data frame, pass inside d and df underscore new. Will you be okay with this? आप समझ रहे हो मैं क्या बोल रहा हूं? देखो, ये सब छोटी मोटी चीजें वी कैन वेरी इजीली मैनिपुलेट. डोंट वरी अबाउट हाउ इट इज प्रिंटिंग. इट कैन ऑलवेज बी चेंज्ड इनटू एनी फॉर्मेट यू वांट. Focus whether the operation happened or not. Okay? Yes, Swapni, absolutely. If you want to work on a result set, then how the output come matters, absolutely. But tell me one thing, just like in Python, when converting integer into a string is not a very hard thing, same thing, converting string or back into integer is not a very hard thing too. It's the logic that makes more sense. If you think the output is not coming in the proper format, you can always pass it in pd.dataframe and get a new data frame. You can even fix the name and age part of it. अभी तो आगे हमको बहुत करना है सर, अभी तो हम बहुत बेसिक वाले ऑपरेशन पे हैं, राइट? बहुत सारी चीजें करेंगे, राइट? Are we clear until here? Good. Perfect. Until here, we kind of got the concept on how this particular thing works. But do you know, my people, in pandas, we also have a feature called ilock. Ab see, ilock is very, very different from lock, and you will see in a second. If I use this, okay, focus on what I'm trying to say. df.ilock, and if I pass 1, is it giving me Parminder the same exact value that a lock gave me? df.lock also gave me Parminder, if you remember. Am I getting the same output? Yes or no? Okay. Yahan pe I have passed something called 0,3. Okay. If I say df.ilock, okay, df.ilock, and I'm passing very simply 1,3 or 1,3 or whatever value it is it also returning the same value 1,3? Integer positions 1,3? But my people, here, while accessing the column name and age, did I give the actual name of the column name and age? Hi or no? Look at this and try to understand what I'm trying to say. My people, if I want to access the name of the column, I am able to access the name of the column via the key name, right? I was able to access the column via the key salary, via the key age, via the key ID, and via the key experience. Yes or no? But do you know that just like how every row is also columned with 0, 1, 2, 3, every column also has an index called 0, 1, 2, 3, and 4. Now tell me one thing, rather than passing the key name, salary, age, ID, and experience, here I want the value of Parminder, but only name and age. Okay. Can I not do this? df dot ilock of what index position you want? I want 1. But which indexes do you want? I want only name and age. So can I pass 0, 2? Just like how I passed name, age, can I pass 0, 2? What answer am I getting? Are you getting that I am also getting name and age only from Parminder? So basically, ilock means you are not allowed to pass the key value, but the indexes, the integer position, the index. Did you get it? What I'm trying to say? Here, I have accessed Parminder, right? If you can see here I have only accessed Parminder, correct? The row Parminder, yes or no? In Parminder, I have only accessed name and age, correct? I have passed from key value number 1, only passed name and age. Correct? Agree or disagree? I have passed the key name and the key age of the column. Agree? But when I use iLock, I can pass the index values of this particular thing. Name is at what index? Name is at which index? यार rocket science नहीं है, थोड़ा ध्यान से सुन लो. Name is at what index? Age is at what index? Rather than passing name comma age, haven't I passed the index, the column index? So can I say that this particular iLock works on integer locations or integer, it locates based on integer values of your columns? I hope you understood what I meant. I think आप SQL में भी ऐसे ही करते हो, right? Like in SQL you do the same thing, right? You got what I'm trying to say? I hope you kind of got the concept of what I'm trying to say. Okay. अच्छा, एक बात बताओ. Haven't you done this in SQL? df.log, okay, df.log. Inside this, I want you to find me df.age for example, any person's age whose person's age is greater than 30. Can I not do this? Only Gopinath is the person whose age is greater than 30. Find the location, df of location. For example, the very first thing you do is whose age is greater than 30. And for that, you do df.log and it gives me that particular value. Hi, Anna. So haven't you seen something like this, my people, in your old code, in your previous code? In our SQL, we do this, and df of age is less than equal to, for example, you do age less than, you say 20. Are you understanding what I'm trying to say? You've had these logical connections, right? Age greater than 30 and my age to be less than 20. All the people I want to print simultaneously. And also you have something called ascending and descending. Basically, rank the people based on the height, rank the people based on their age. I hope you're understanding what I'm trying to say. So each simple step, what I'm trying to do is I'm going to take you to a level of understanding how and what and all we can do. But did you understand the concept of lock and iLock, my people? It's exactly the same. It's just that when it comes to column level access, it's not allowed to give it via key, but you have to pass via the column indexes or their integer values. Are we clear? Okay. The current DF that I have is at what particular index? Name, salary, age, ID, and experience. How many columns do I have? 4. How many values do I have? 4. So is it a 4 cross 4 value? Yes. Okay. So now if I want to add a new row at a specific index, listen to me very carefully. I want to add a new row. Okay. I'm going to take my row directly in a data frame. I want to add a row like this. Okay. Inside this, the name column I want to give, let's take Shamim's example. Okay. Shamim, I want to take Shamim's salary, SALARY. Okay, salary is going to be 1.1. Okay, and Shamim's next kya hai? Age. Shamim's age will be 30 years old. Okay, Shamim's ID is कितना हुआ? हम कौन से position पे डाल रहे हैं? Third. 101, 102, 103. Okay, and Shamim's experience. Give me 1 second. I'm going to copy this. And I am going to paste it here, okay? Shamim's experience will be, I don't know, 7 years old or 9 years old, okay? I am trying to add Shamim after Parminder. Are you understanding? After Rudra, after Parminder, I will add Shamim in the middle. So 101, 102 and Shamim will be 103. Are we clear? So 101 is Rudra, 102 is Parminder and Shamim will become 103 and hence I'm doing it. Can I say new row is my new row? Can you see this is the new row? Oh, hold on, what mistake did I do? Hold on, let's try like this, okay? df, okay, pd dot data frame of new row. It's giving me pd dot data frame में error. It says if using all scalar values, you must pass an index. Scalar value, you must pass an index. यार एक काम करता हूँ मैं. Rather than taking it like this ना, तो फिर मैं ऐसे ले लेता हूँ. एक मिनट रुको. एक मिनट, let me not pass it like this. एक काम करता हूँ, let's take a new row, ठीक है, new underscore row, मैंने new row ले लिया. अब इस पे मैं pd dot data frame में ही पास कर लेता हूँ, right? इसके अंदर let's take a dictionary directly. The name that I had taken, एक मिनट पहले तो ना, let's say if the name is correct. Okay, name is correct. and I'm going to pass in Shamim. I'm going to say Shamim. Shamim मैंने पास किया, ठीक है. ये तो एक सेक्शन हो गया, तो my name is passed, ठीक है. अगर मैं एज पास करूंगा तो नहीं, सैलरी ओके एक मिनट, SALARY सैलरी विल बी पास्ड एज कितना दिया था मैंने, 1.1 दिया होगा, ठीक है. आई एम पासिंग एवरीथिंग एज अ स्केलर वैल्यू वाया एज अ लिस्ट. सैलरी हो गया. फिर आई पास्ड इन एज इज ऑल्सो गुड. आई एम ऑल्सो गोइंग टू पास एज एज लाइक 30-year-old गाय. एंड एज के बाद था ID विल बी 103 because I'm sort of planning to add it in. अच्छा नहीं, इसको भी हम ऐसे ही लेते हैं ताकि it should not give me an error like that. 103 ले लिया हमने. ID के बाद था experience. So let me copy the whole experience and let's paste it here in one single quote, no using double quotes. And I'm passing experience as say 10 years maybe. I hope this works. Yeah, new row. Help me understand it. Yeah, okay, cool. I got it. So what was happening is it was not letting me allow, it was not because it needs to reference the instance itself, because if I was passing it without the array, right, like without the array, it would not have known how to access it or reference it. So that happens. Can I say this is the new row Shamim that I want to add? Yes or no? This is my original DF and this is the value that I want to add. If you want to add a new row at a specific value, you have to use something called df equals to pd.concat. Okay, pd.concat. This is sort of like a method that, okay, but before I do that, I will explain one thing to you. Give me 1 second. Let me sort of copy this. Hold on. Copy and paste. Okay. See, this is my original table, right? This is my original table. Name are 4, columns are 4, correct? In order for you to actually add Shamim in the middle, you have to do this, okay? You first need to decide which index do you want to enter. You want to enter the name at index number 2. So I'm going to cut it, okay? So can I say this is my original table 0, 1, 2, and 3? My people, the first thing, if you want to add a new row, this particular data at particular thing, you need to first tell which index do you want to add. I want to add at index number 2. If you want to add your new row, this particular value at a new row, in the original data, you need to split the data into 2 different tables. So the first table will be split between 0 to 2, right? You will start with 0 to 2. See, you want to add this particular row at index number 2. So first, the original table needs to be split. Wrong. See, the concept is Rudra and Parminder ke baad mein, after Rudra and Parminder, I want to take this new row called Shamim and I want to add them. I want to add Shamim. First of all, the first question you should ask is, I want to insert Shamim, okay, at which index number? Index number 2, correct? I want to add Shamim at index number 2, correct? That's my aim. Shamim has to be added at index number 2. So what I do is, I use a method called pd.concat. Inside pd.concat, I will say that first split the first table, df.ilock. I want you to split all the way till table number 2. All the way till table number 2. This is my first split. The first split data. I want the Rudra till Parminder to be split. Okay. Then you want to add which row? You want to add Mr. New row, right? This is the new row that you want to add. So pass new row inside it. Here, pass something called new row. After new row is passed, what table do you want to add it? Murchana and Gopinath. But Murchana is starting at index number 2, going all the way till end. So can I say inside this df.ilock, where am I starting from? I'm starting from 2 going all the way till end, right? Once you're done with this till the very end, you say dot reset index, and inside this you say drop equals to true. Okay, I'm going to tell you what this particular thing is in a minute. And if I say drop equals to true, and if I run df again, can you see Shamim is added at the second location? See, Shamim is now added at a specific index value. Yes or no? Agree? Shamim is now added. Now let's understand how this happened. Did you understand that df.ilog2 is nothing but Rudra and Parminder as a separate table? From Rudra to Parminder, the entire row, entire column got separate. So this became a separate table. This df.log of 2 to last became from 2 till the last value a separate table. And inside this, to combine the table together, I'm using the method called concat. So are you clear? What I'm doing is I'm separating the table here, separating the table here, taking the new row in between. And because I'm passing them in order, I'm saying that take the first separate table, then after that add new row, after that add the last table and dot reset index. The reason why we do reset index is because Shamim is starting at what position, my people? If I only print Shamim new row, wasn't Shamim starting at 0? Only Shamim starting at 0, but shouldn't I keep 0, 1, 2, 3, 4, 5? My sequence needs to be proper, yes or no? If my sequence needs to be proper, so shouldn't I do reset index? Are you understanding what I'm trying to do with reset index? I will tell you what is this drop equals to 2, not today, a little later. But did you understand why I was teaching you lock and ilock and I was not teaching you how to add a new row? Because you needed to understand the concept of lock and ilock in order to understand how to take a row and add it in a separate or a specific instance or a specific integer value. Are we clear with the insert part here? So tell me one thing, what do you feel about pandas, which whatever I have taught you right now, whatever coding I've taught you right now, what do you feel about it? Do you think it's achievable, doable by you people? Whoever is a really good SQL developer is a great Python pandas developer. This is a known fact. Whoever knows SQL very well will know pandas super well. And did I give you guys an idea about pandas? Yesterday I gave you a link on lead code. You can do 30 exercises of pandas. I gave you a link yesterday, remember? Acha, by the way, if you want to work on Jupyter notebooks and pandas, the best tool on this planet is a website called Kaggle. Have you ever heard about it? Okay, what it does is, let me tell you, suppose if you want to learn pandas, okay, if you want to learn basic pandas, so just say pandas and click on it. You will have univariate plotting with pandas, accessing data with pandas, selecting and filtering with pandas, bivariate plotting with pandas, EDA with pandas. So see pandas basic functions. Example, if you click on this, somebody has written files on how pandas can be done. Like basically what can you do, what can you access, what else can you do, what new analysis can you do. All this is available for free. The reason this website is great is because you guys can access this for absolutely free, and once your knowledge becomes a little good, you can access all these notebooks and make your knowledge from basics to great. Okay, so see, learn pandas with Pokemon. See, somebody has a Pokemon data set, and you can even calculate things like who is my best Pokemon, is the legendary status of the Pokemon true, what is the set index name, right? Drop a specific axis, right? Fill the values within place, which Pokemon has a specific type, fire, type 2 is a dragon, type 2 is a dragon, and type 2 is a fire. All the pivot table format. So it's like, it's fun, man. I mean, it's fun. You can do a lot of stuff with this particular thing. See, he's even plotting who has a median attack style, right? You can even do fire versus water analysis, strongest Pokemon by type. So of course, you know that there is this Pokemon which is a cat kind of Pokemon, which is the strongest Pokemon in the Pokemon universe. But you can even print which Pokemon is the most strongest, and couple of stuff. Mewtwo is one of the strongest Pokemon. So you can do so much stuff, and this is available for free. But don't approach this unless your pandas has become at least better. So before you jump into this, first allow me to take you guys through some basic pandas. I will also show you how to practically solve one data analysis use case using one of the data sets. Then once you feel confident here, go to the other part. Are we clear?
Sixth quiz question is, in pandas, what is a data frame? Option 1, data frame is a two-dimensional label data structure. Option 2, a single column of data. Option 3, a visualization tool. And option 4, a type of database. Again, this question is easy, but the options are very trickier. So look at all the options carefully and drop your answers in the comment.
Just a quick info, guys. Intellipaat offers data analytics course in collaboration with IIT and Powertech. Through this course, you will master Power BI, data modeling, data mining, and much more from the IIT Madras faculty and industry expert. With this course, we have already helped thousands of professionals in successful career transition. You can check out the testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your careers to new height. So visit the course page link given in the description and take the first step towards the career in the field of data analytics.
Just like that, we'll be continuing forward with our journey into pandas today. I am going to explain you the concept of merge and joins in pandas. How do we do merge and joins? Just like you have learned how to do merge and join in SQLs, right? We are going to be doing the same thing in pandas, and we are going to see how similar these are. If you remember, I told you if you guys have done SQL, pandas becomes much more easier. The reason is even the creator of pandas has taken reference and inspiration from SQL based tools and libraries and techniques to make pandas work in real life. Okay. So pandas is sort of inspired from SQL because SQL have been existing since a very long period of time. And so pandas is also kind of inspired from SQL. The only difference is how this works. Pandas works very locally. SQL is sort of a database instance which is made, created, and is uploaded. So now, coming back to that particular topic, right? And we are going to be sort of focusing on understanding how does a merge function work and how does a join function or a method works in this particular example. Okay, and then we are going to sort of talk about how these methods of adding data together works. Okay, so imagine for a very, very simple example. Okay, imagine I'll take an example of let's say Pranav, right? Pranav has a bakery. Okay, now what Pranav does is Pranav has bakery products. Okay, so let's say products are like this. Okay, so pd.data frame, what Pranav does is he's created a table that looks something like this. Okay, he's gonna say product underscore ID. Okay, product ID. So say product ID of this particular thing is 101, 102, 103, 104. Okay, let's take 4 products. Okay, the products that Pranav sells are, say for example, red velvet cake. Okay, so red velvet cake, and the other thing that he sells is brownies, and the other thing that Mr. Pranav sells are strudels, right? strudels, strudels, and pies, right? So these are the 4 products that Mr. Pranav is selling, and each product is sort of costed at say 250 rupees or 350 rupees and 450 rupees and maybe 150 rupees. Example. So see, this is the first instance or the first table type for data for Pranav, where he has product ID, products, and MRP, right? With respect to that, he also has sales data, right? And this looks like pd.data frame. And inside this, we are going to take another dictionary, and he has the same key product ID. And I'm going to take the same key product ID and I'm going to copy it. So I'm going to come to the bottom and we are going to paste it here. So this is the product ID. The second thing that Pranav has are the sales. How many sales has it happened, or how many sales of the product has he done? Say he sold 24 products in the first day, 34 products of the red velvet or brownies, 56 products, and 34 products of other categories. So what Pranav has is Pranav has 2 tables, right? One is bakery products table and the other is sales data table. Are we clear what we've done, my people? We've created 2 tables, very simple 2 tables. In the first table, we have a bakery product table and the other is a sales data table. Now let's look at it very, very clearly. What is the unique ID between the bakery products table and sales table? What is the key? What's your primary key that connects both the tables together? Of course, it is product ID, correct? Now see, in pandas or in specifically pandas, there are very two super important methods. Apart from this, you don't have multiple methods. These are the most important methods. So merge the data. I want to merge these two tables, but I want to merge these tables on product ID, right? The English word is, I want to take table one, I want to merge it on product ID, right? So what would I do? I will say merge data is equal to, the method name is called pd.merge. That's it. Just call pd.merge, and inside this, which tables are you going to pass? I am going to pass bakery products and I am going to pass sales data. My job here is done. But apart from this, you need to mention your primary key. How do you do it? You say on equals to, and in the string part, copy the product ID, copy it and paste it here, right? And make sure that your spacing is correct, your spelling of product ID is correct, and just print merged data. Once you do it, have I merged my product ID and my sales ID correctly? Did I merge my product and my sales 100% and now my tables are merged? All I had to do was mention my key and I'm pretty much sorted to do the combination of tables. Think about it and tell me, suppose this is a table called product ID, products, MRP and sales. My people, didn't I tell you how to create a new column in Pandas? I told you, if you want to create a new column, call the data frame. Is the current data frame merged data, yes or no? So can I say merged data of profit or revenue is equal to, my people, observe one thing carefully. If I multiply by MRP into sales, won't it give me the total profit for revenue for that day? If I multiply the table MRP with sales, make sense? I mean, I just observed it right now. So if I take merged data and of MRP and multiply, so if I just do this multiplication of merged data of, what do I need to multiply it with? Sales, right? So if I copy it and I need to paste sales here, and if I print merged data again, do you see another column has been created called revenue, where it is 6,000, 11,900, 25,200 and 5,100? Yes or no? So I have created another table called revenue. Now what I need to do is take the same table, merged data of revenue dot mean. If I do this, total sales that day is 12,050. Did you understand? No, not mean, dot sum, sorry. Yeah, we need to take the total value. So do you understand? We sold 48,200 worth of, or 48,200 rupees worth of, money that day. Like we have basically sold 48,200 rupees of revenue. So this is the revenue that you made. So you understood what I'm talking about, right? So it's only basic functionalities that you need to understand. What if the product IDs are not matching? Tell me one thing, if the primary key isn't matching, can you even do SQL joins? If the primary key is not matching, can you even do join in SQLs? Just like that, if the product IDs don't match, you cannot do anything. Either remove the problem and then join again. But if the numbers are matching, so see, the thing is, if the products ID are not matching, there is no way you can merge data. I'm just telling you this right now. Like, I'm giving you guys an idea. It cannot happen. If the product IDs and the product IDs of the second tables do not match, there is no way you can multiply or add and merge the tables together. It's not possible. You can do, however, one other thing, but it's logically complicated and let's not talk about it. Okay. So did you understand that for the table that I have joined, I have just taken another column and I was able to calculate the sum for it? Sounds pretty straightforward, unlike SQL, because in SQL, what do? Do you query the table? Yes or no? And my people, tell me one thing. In SQL, have you seen not just inner join, there is also something called outer join. Then there are complicated kind of joins that we have to do. I'm very sure you guys, I don't need to tell you that SQL has not one, but many kind of joins. And the job of Pandas is not to replace SQL, but to replace the complexity that SQL takes. Okay, tell me one thing. Have you ever written a query in SQL? Yes or no? Okay. So when you write a query, don't you mention something called star, which is nothing but all, like select all from a specific table? Yes or no? Have you done this? Okay. Have you ever used something called inner join? Have you, like, was this taught to you how to do an inner join in SQL? Okay. Tell me one thing. Inner join, natural join, outer join, right? There is right join, left join, so many kind of joins. It Okay, so it depends, right? Like from these two tables, do you want the instance of table A or instance of table B? Depends on how you join them, right? That kind of complexity does not exist in pandas. Okay, I'm telling you exactly that same thing. See, I told you one way of merging a table, right? This is the table called bakery products, and the other table was sales product. And so far, I've taught you a method called merge. We also have a method called join, but the join that you have in pandas works very differently from the join that you have in SQL. So don't confuse yourself with that join function of SQL and join function of pandas are same. They have slight difference, and you'll see how. So first of all, okay, you have learned how to do merge, correct? Let me take the exact same table, join bakery products and sales data. Okay, I'm just going to copy it and I'm going to paste it here. Okay, I'm going to take the same data, bakery products and sales data, but instead of, okay, let's do it like this. Okay, this was my original data. Agree? This was my original data, my bakery products and sales data. I had this, yes or no? I did merge using the merge function, where very simply all I had to do was pass the table and on the product ID. So pretty much I was able to merge. But guess what? You can even merge with one other way, which is merge underscore data equals to bakery products, because this is the first table dot in bakery products, which is my primary key. So you have to use something called set index. Inside this, you have to pass something called bakery products. So when you do join in pandas, it works like this: bakery products dot join, just call dot join. Okay. And inside this, you have to pass which table are you merging? With bakery products, what table are you merging? I'm merging sales data. So can I say sales data? But in sales data, dot set index. Set index meaning I am telling this table deliberately that in sales data, my primary key is what ID? Product ID. So if I print merge data here, what answer did you get? So look at the table using merge. In the merge data using the dot merge function, look, using the pd.merge function, I have product ID, products, MRP and sales, and there is a natural indexing, right? 0, 1, 2, 3. But when I did merge, is there a natural indexing showing up? Yep, Rajkumar, you can also do that, but you have to be careful about it. Okay, so can you see product ID shows up, products, MRP and sales shows up, but there is no 0, 1, 2 and 3. Do you see this? Did you see the difference, my people? Let's observe it once again. How did we merge using the dot merge function? What we did is we called pd.merge. I called the bakery products. Observe one thing. When you called the bakery products, what kind of data was already bakery products? What kind of data is it? Isn't it already a data frame instance? Hi, Anna. It is already a data frames. Can you pass a dictionary directly? No. In order to merge two tables, what data structure should they already follow currently? What should they already be? They should already be a data structure called data frame. Is sales data also DF, data frame? Okay, now I'm going to tell you guys some knowledge, okay? In pandas, there is a method called dot merge, there is a method called dot join, and there is a method called dot concat, and I will teach you dot concat also. There are three methods that will do all job that SQL does. Have you ever heard of something called composite key, my people? Was this ever taught to you? See, composite key is a key which is used to again connect two tables. I'm not going to go into that complication or not. Okay. Can you see this on product ID? Can you see this thing called on product ID? Right. See, you can play with these methods so much. I'm telling you an example. See, I'm using pd.merge, right? So .merge pandas. Okay. If you go to the documentation of merge my people, can you see how many parameters I'm left with? Do you have a left table? Do you have a right table? Can you see how equals to inner? Can you see how equals to inner? Your left table and your right table, how do you want to do? Inner join, outer join, natural join, merge join. There's so much stuff, right? Do you want to keep a left index true? Do you want to have a right index? Do you want to sort the table in a specific way? Do you want your indicator to exist? Okay. Do you have any label suffixes that you want to give? So basically what I'm trying to say is I have shown you how to do merge with a very simple idea because I don't want to complicate the example. But all I'm trying to say is the methods called merge, concat, and all of that, these are very heavy lifting, heavy complicated methods that can help you do everything that you were able to do in SQL, you will be able to do in Pandas also. Depends on what is your use case. Okay, for example, here I have added how many tables together? How many tables was I able to merge together? Only 2. Let's say I take another table called reviews data, reviews underscore data. So if I say reviews underscore, okay, let me copy the whole thing. Let me paste it here. Say sales data ke badle, let's say reviews data, okay? REVIEW. And instead of sales, I will say how many review or what review did we get. तो क्या हम बोल सकते हैं कि रेड वेलवेट केक गॉट 4 out of 5 star, brownies got 3 out of 5 stars, strudels got 2 out of 3 stars or 5 stars, and pies got 5 out of 5 stars. So do I now have a data which is not just bakery product sales but also review? अब एक बात बताओ, इसको मुझे join करना. How do we do? Are you understanding what I'm trying to say? How many tables do we have now? How many tables do I have now? 3. अब एक बात बताओ, using this particular thing, if I want to call merge, will I be able to merge more than 2 tables? Yes or no? Do you think we should try this? Okay, let me ask you this. Totally, how many tables, and for all these tables, what is my primary key? In this particular example, what is my primary key? It's my product ID, correct? Okay, in this example, how many tables have we merged together at once? How many tables have we merged together at once? Okay. The problem with this, okay, the problem with Python functions are, if you want to do merge them together, how do you do that? Okay. See, the thing is, you have to be very careful when you do pd.merge. The reason is you can merge only 2 tables at once. The reason why you can only use 2 tables at once is because there is something called as an instance of key, right? For example, from table 1 to table 2, how many can you do together? So if I use merge function, I need to do what? I need to first merge bakery products with sales data, and the output of the table together will be merged with reviews data. Are you understanding what I'm trying to say? Are you getting what I'm trying to say? When you do this, you have to specifically merge first bakery products with sales data. Once this table is merged, then the output table needs to be merged with review data. Are you understanding? Did you get what I'm trying to say? When you do join, you have to take the very similar approach. What do you mean by that? Sir, it's not like I can pass all the tables together and just say on. That's not how it works. See, this is how the functionalities of Pandas is. Okay. If you want to merge everything together, you have sort of like a different library functions. Okay. You can sort of take joins in which you can have multiple things together and you can join it. Like this is pretty much possible in join, but when you do with merge, it's not possible. Okay. In merge, you can only do 2 tables together, but in join, you can take as many as you want. But this sort of code will become sort of highly unreadable. But don't worry. In Pandas, we have a way to navigate that. Okay. These are called extra libraries or extra functionalities, which I'll tell you in the future how do we take care of that. Okay. So I'll help you understand how that particular thing works. But on a basic level, did you understand how to merge table together? using either a merge function, either using a merge or a join. See, here is the beauty of pandas, and you need to be very careful about it. Okay, I'm going to do this together, but see how this is going to turn out. Okay, if I concat them together like this, okay, concat underscore data, okay, I'm doing concatenation, pd.concat, okay, I'm going to do pd.concat, not all caps, small, pd.concat. Look at what's going to happen. Okay, I want to pass bakery products data and I want to merge sales data. And inside this, in the site, I'm just going to keep it empty and I'm going to say concat data. Okay, concat underscore data. Observe what's happening here. First of all, look at the index here, 0, 1, and 2, and 3. And then the table was added once again, and then there is 0, 1, and 2, and 3. Do you see this in the right hand side, this part? 0, 1, 2, and 3. And another table is also starting with 0, 1, 2, and 3. According to the rules of proper serialization, can this happen? According to the rules of proper serializations, should this happen? No. So can I say ignore index equals to true? And if I run this, now is my serialization perfect? Did you understand? Ignore index is a parameter or an argument that lets my serialization be not affected. Did you understand? Okay, I think this is not rocket science, but okay, let's do it once at a time. When I merged two tables together, are my serials in the proper format? 0, 1, 2, 3, 0, 1, 2, 3. Okay, so let's take it like this. Everybody, are you able to remember or are you able to see that your 0, 1, 2, 3 and 0, 1, 2, 3? Let's observe only the serial number and not the product ID, products, MRP or sales. Ignore करो उसको, भूल जाओ, let it go. पहले serial numbers को देखो आप. Look at the serial number first. Are they mismatching? Yes or no? Okay. Do you remember I told you yesterday, whenever you do concatenation, whenever you add, suppose this is the big table, you have to split the table in two if you want to take another row and add it in between, right? You remember I did that yesterday? I told you this yesterday, and I told you in pandas, whenever you create a table, each table will start at 0, correct? This table is also going to start at 0. This table will also start 0. This table will also start at 0. But in serialization, we cannot have everything starting from 0. So when we do ignore index equals to true, right? When we do ignore index equals to true, what happens? My serialization factor is not affected, right? Now it is 0, 1, 2, 3, 4, 5, 6, and 7. My serialization is not affected and it is properly serialized. Yes or no? Agree or disagree? We did that. Okay. On top, when I did pd.concat in the last class, do you see I have done something called .reset index? Did you understand that if it's an argument inside a method, you can write ignore index. But if you are not allowed to pass this as an argument in Python, you can use it as a method called reset index. That is the only difference. I hope you understood what I meant. I'll give an example. Have you done sorting in Python? In Python, there are two ways to do sorting, right? One is to use sort and the other is to do dot sort. Do you remember? Like you can do this? Okay, example. Suppose you have a number called numbers. Numbers equals to this 4, 2, 9, 1, 5, 6. Okay, can I say NUMBERS? Okay, can I say this is an array or a list of numbers? Yes or no? This is a number. Okay, if I do numbers dot sort, okay, and I just print it numbers, did I change my original array into a sorted array? Yes or no, using a method called dot sort? Hi Anna, very, very simple. This is called type 1. This is another way, the sorting number 1, like sorting in one way. If I do the same thing like this, numbers equal to, okay, numbers equal to, okay, 4 comma same exact चीज ले रहा हूं मैं, okay, same exact thing I will take and I will copy paste it here and I will say my sorted array equals to sorted, and inside this I will pass numbers. And if I write my sorted array, do you see? Okay, first of all, did you observe that this is a dot sort is a method? Dot sort is a method and sorted is nothing but a function. I hope you are clear with the concept. Okay, when I'm doing ignore index equals to true, am I not? Okay, so taking you guys through Python, whenever you write in Python something, for example, the name of the method is called, what is the name of the method? pd.concat. pd.concat. Concat is a method. Ha ya na? Agree or disagree? Okay, pd.concat is a method and anything that comes inside the method is called as an argument or a parameter. I hope you know this. In object-oriented programming, I have taught you this. Whenever you pass something inside something, so for example, if you say define sum, and inside this, these are called args or arguments. Okay, so if you want to, or if your methods have the capability of taking an argument, you can pass something called ignore index. So if the ignore index is allowed to be passed with the method, you can do this with ignore index. But if ignore index argument does not exist inside your code and you still want to change the serialization, what will you use? You have to use a method called dot reset index. They both do the same thing. I hope you understood what I meant. If ignore index is not allowed in your method as an argument, you can pass dot reset index. That's it. And drop equals to true means you take all of this from a separate individual instance for it to start with 0 and at the last length -1 value. That's all it means. Did you get the idea what I meant? You have two ways of sorting. You have two ways of resetting the index also. One is if the argument or the method lets you pass ignore index. If it does not let you pass ignore index, you can by default dot reset index and pretty much your life will be sorted. I hope you understood what I was trying to sort of convey here. Are we clear with this concept? Okay. Observe one thing. When we used merge function and join function, did it not arrange the table horizontally, my people? Did you see that when we are merging two tables together in merge and join functions, the table are being merged together in the horizontal direction. But when we do concat, what's happening? How are they being added? Top on top, bottom on top of bottom, right? Did you understand what I'm trying to say? See, suppose there is a table number 1 in Pandas. This is table number 1. This is table number 2. When you use merge function and join functions, these tables are merged together like this. Yes or no? This is table 1 and this is table 2. Agree or disagree? But when you do concat, and remember this and never forget this, the tables are being added top and bottom. They are being stacked. Table 1 and table 2. Did you understand? Did you see what is happening? Observe one thing very carefully. Can you see product ID is repeating itself? 101, 102, 103, 104 and 101, 102, 103, 104. Because in table number 2, products and MRP does not exist. It is being passed as NaN. And because this is passing as sales, this is being passed as NaN. Are you getting what I'm trying to say? Okay, observe what's going to happen. If I pass dot reset index equals to true, look what's going to happen. Dot reset index, and if I pass drop equals to true, observe what's going to happen. Run. Did anything change? Because already ignore index has been added. Are you understanding what I'm trying to say? Did you get the concept that I've already passed ignore index equals to true? Did this make any difference? I'm going to run this again. Run. Any change in this particular thing? No. Are you clear with what I was trying to tell you from the previous example? Okay. So remember one thing. When should you use merge and join and when should you use concat? Concat should only be used when you want to add row by row data or when you want to add tables one after another. This is where concatenation should be used. But in case if you want to merge the tables together like this, which is natural in nature, always use merge and join. And the use case of concat is, did I not show you an example how to merge two tables together like this? We did something called pd.concat. Do you remember? I took a value of new row and you wanted me to specify which row should this new row column be set into. Do you remember we added Shamim? It was Rudra, Parminder, Murchana and Gopinath, but I added Shamim at a second level index. So can I not make this code like this? Insert at. I want to insert at whatever position. So suppose rather than instead of 2, I can say insert at, and I can make this 2 as insert at. And now my code has become so easy that whenever you write whatever index position you will write, my code will put and add anything anywhere in that particular position. Did you understand? I hope you kind of got the concept of this particular thing. How do we take this forward? What do we do? So many amazing and fascinating stuff that we do with it particularly. Okay, so you kind of got an idea about how pandas work, but you know what? Point number 1, my people, okay? Pandas is so large, okay? Is so large. I'll tell you guys an example. My people, do you see towards the left hand side, you have all the functions, methods in pandas? Do you see this all to the left hand side? Pandas dot from dummies, get dummies, concat, merge s of, merge ordered, cut, cross tab, pivot table, pivot, melt. Towards the left hand side, are you able to see all the methods? Okay, I have a small question to ask all of you. एक small question पूछता हूं मैं. My people, एक बात बताओ. When you learned SQL, did you learn recursive also in SQL? How to do recursion in SQL? I'm very sure you have not implemented this. I'm very sure. Yeah, I know it. Did you know in SQL you can also do recursion? Okay. It exists in SQL, but you haven't learned it. You haven't implemented it, correct? Because the chances that you need recursion in your practical career are very, very lower, correct? The chances that you are going to use recursion or the chances that they will ask you recursion in a programming interview are very less because it's a very rare method or a function that you're going to use, right? Just like that, okay? Like how SQL is huge, it is extensive, it is vast. Don't think that you have learned SQL completely. SQL is vast, okay? It's taken me so much time to learn SQL at a very good extent. Pandas is just like that, okay? I have not taught you so many things in pandas, which are, I mean, they are so complicated, and it for sometimes I have no shame in telling you guys that even sometimes I go wrong in the syntax, in the way arguments are passed, because we are all human beings at the end of the day. So this is my advice to all of you. See, I am not a superhuman. You are all not a superhuman. It is okay to accept the fact that we are all humans and we end up making mistakes. There will be errors that will come in your programs. There will be chances that you will forget the name of the method. It happens. Let me tell you one thing. NumPy is another ocean. Pandas is yet another ocean. Your job is to make your interviewer understand that, hey, look, I know what pandas is and I can solve the problem. If you forget the method, please don't shy away from saying that, sir, I've forgotten the name of the method. Can I check the documentation? Don't check internet. Are you understanding what I'm trying to say? You don't go and check the internet. Say, I want to check the documentation. What is documentation? Can I say this is the documentation for pds.merge? This is how you merge two packages. And now you can tell your interviewer, sir, I just need to know what arguments can I pass inside it. And pretty much I will get the idea how to use a merge function. That's it. You don't have to mug up all the methods, because I personally don't remember all the methods. I remember these methods because I have been teaching for a long time. So these are on top of my head. But if you ask me, how do you do, I don't know, resampling, group by, pivot table, yeah, I think I know pivot table well. But I don't know the functions that I've never used, like factorize. I've never used factorize in my life. So how do you use factorize? I don't know. It's okay. But do you know how pandas work? based on that knowledge, based on how you worked on pandas, pretty much you can solve any problem on your own. Okay, so please don't have these superhuman assumptions in your brain that you need to remember all the methods, all the function. This is not a quota factory. This is not a UPSC factory. We are data scientists. We don't need to mug everything up to showcase we are talented. We know how pandas work. All we need to do is just make sure that we know how to code it. Our job is pretty much done. Our job is not to replace knowledge which is already available on internet. I hope you understood the concept. Please do not overwhelm yourself with understanding all the methods, remembering all the methods. I don't, nobody does. In an interview setting, remember all the important methods. My people, look, I have taught you all important methods from lock, ilock, merge, join, concat. Okay, I've taught you how to take a dictionary, convert that into a data frame. I've taught you how to take a list, how to convert that into data frame. Any other method that is left out, I'm going to teach you now using a practical example. But by the end of this session, remember that all major methods and functions that exist in pandas have already been taught. And all you need to do is learn more based on project. Don't just randomly learn a method how to do it. Take some project. I showed you an example of Kaggle. Did I do that or not? Do you remember I showed you a Pokemon example? Once the pandas is done, practice, man. Practice the hell out of it. The more you practice, the more methods you're going to know. Okay. Okay, everything apart. Should we take a practical example and do it on ourselves? A practical data set of sorts, and we will try to analyze how that particular thing works for us. Are you understanding? This way, two things are going to happen. We are going to learn exactly how a data analysis is done using the pandas tool. So it is super duper critical for me, for us particularly. How do you actually implement this in a real life scenario? Are we clear? Should we do it? Okay. So tell me one thing. If I want to take care of this, okay, if I want to sort of do a practical example, let me import all the necessary libraries. So first of all, before pandas, what did I teach you? Before pandas, what did I teach you? Did we learn NumPy before pandas? Okay. So can I import NumPy as NP? Will you have any questions if I do this? Will you have any questions if I import NumPy like this? Okay. Import pandas as PD. Okay. Import pandas as PD. Will you have any questions if I import these two libraries? NumPy and pandas. I'm doing nothing else. Okay. I've imported this and I've imported that. How to load data in pandas. First of all, tell me one thing. Do you all understand what is a CSV file? Do you all understand what is a CSV file? Comma separated value. Okay. In your career, you are going to be using these many methods, but how to load a data is what I'm trying to tell you. How to load a specific data, okay? Take a data frame variable called data equals to pd.read CSV. Okay, how many ways or how many types of data can pandas accept? See, pandas can read your clipboard value, your local clipboard value. It can read CSV. It can even read your Excel file. Can you see? Read _ Excel. Pandas can even read XLXS. You know, right? In Excel, we have an extension .xlxs. So your doc and docx file exist, right? In Excel. So you will have that file, okay? So you can read clipboard files. You can find CSV file. You can find Excel files, okay? So my question is to everybody. Are we ready for a practical example of data analytics? And via this, we get to learn so much more. Can we please do it? Okay, first of all, remember one thing. In a practical scenario or a company, as a data scientist, you only have a read access of the table. I unfortunately cannot show you. But if I could have shown you, how we do it in our company is we use a data warehouse called Snowflake. Have you ever heard of this? Have you ever heard of something called Snowflake? Okay, Snowflake is what we use. Okay, Snowflake is a data warehouse tool. What we do is we go on Snowflake. I have to write a query, SQL query. Snowflake is like SQL, but Snowflake has their own functions like data casting, date casting, and it's complicated, man. I'm not going to go there. but it comes under data engineering more than data science. All we as a data scientist do is very rarely I go on Snowflake, I take a sample data, or I use something called Boto. Have you heard of something called Boto? Have you ever used something called Boto? It's an interface where you can connect your Amazon Web Services in Python using Boto. So, okay, no problem. It's okay. All I'm trying to give you more knowledge is, if you have a Python programming language and you have a services on Amazon, S3 bucket, Lambda services, serverless services, if you want to connect them together, you have Boto, right? So what we do, we first take the data from Boto, we take the sample from Snowflake, we combine them together, and you can sort of work on it. So, I mean, it's complicated part, man. I mean, it's not a very easy thing. You guys are at a very beginner stage, but that's okay. I'm just trying to give you an idea that, look, in industry, so many things exist. You guys just need to focus on the relevant technology, and Pandas is the beginning of it. Anyways, I am going to show you what exactly are the options that you can load. Have you ever heard of Feather file? This is called Apache Feather, FWF, HDF, HTML, JSON, ORC, Parquet. Apache Parquet is a very big data set. Read Pickle, okay, read SPSS, SQL. Can you see? You can even route SQL table directly inside Pandas. Read SQL, SQL query, SQL table, Stata, table, XML, and option. In Pandas, you can read all these options directly. You don't need a package for it, okay? Anyways, what am I going to implement today? I am going to be implementing called read CSV. And inside this, can I teach you guys a trick? Can I teach you guys a small trick? If you don't know the name of your file that you want to import, put double quote, put a dot and a forward slash. What will you do? Data equals to pd.readcsv. Inside the bracket, put a double quote, put a dot and a forward slash, and press tab. Do you see a data called students.csv in my folder? In my folder, it shows that there is already one CSV file called student.csv. And if I just write it, I don't need to remember the name of the file. It will automatically show me. It will autofill that value for me. And if I say data.head of 5, it will run this answer. Okay. Do you see the data load in Pandas in front of you? पहले तो मैं data को पूरा ही load करता हूं. Can you see it's loaded? It is saying that there are 1000 rows and how many columns? 1000 rows and 8 columns. But doesn't it look weird to load the entire data set together? I want to load a portion of it. Remember, whenever you have a larger data set and you want to load a portion of it, how do you do this? Just say data.head of, press 5. It will print the top 5 values of the data. Are you clear? Dot head means it will print the first 5 values of the data. Are you clear? This is the name of the method. If you want to print the last 5 values, you can use data.tail. Okay? Data.tail. And if you do data.tail, and if you pass in, I don't know, 5, see, it's printing the last 5 values. From the last value, it is printing the 5 values. Are we clear? Does that make sense? I want to print middle values. Do you remember I taught you data.lock yesterday? Maybe 1333 to 1677. Are you understanding? Yesterday I taught you lock, right? From lock you can print 133 to 140. Not 1140, but 133, 135. Example. Can you see from 133 to 135 I'm able to print, and I taught you lock yesterday? I'm practically using it for my analysis. Did you understand the concept? So you can load a sample, a portion of the data from either using a data.head method, data.tail method, or data.lock method. Are we clear until here? Does this give us a good idea about what do we do? Okay, so first of all, before jumping, okay, my people, you guys are my students, and my students always follow my thumb rules, my advices. Do you understand what data do we have in front of us? No, forget analysis. No, you are not supposed to jump into analytics yet. Tell me, what is this data about? What is this data about? What are we talking about? What is this particular thing? This is a student data, but what does it have? It has a column called gender. It has a column called race and ethnicity. It has a column called parental level of education. It has lunch. It has test preparation course. It has math score, reading score, and writing score. So first of all, as a data scientist, and I want all of you to think you are already what in my class? Who are all of you? Currently, what are you currently? You are all what? You are all data scientists, and you and I together, we are doing data analysis. So let's write report. Let's write report. Okay, report. What kind of data is this? This data is students' data, right? This data is students' data where, what are we talking about? Where we have data.columns, okay, where we have gender, race, ethnicity, test preparation score, and writing score. Yes or no? This is report point number 1. This is the students' data that we are working on. And in this particular data, what is happening? We have students' data where we have columns like gender, where we have things like race and ethnicity. We have things like parental level of education, lunch, test preparation course, math score, reading score, and writing score, all of that stuff. Okay, so I'm going to keep the report portion very, very separate. Or what we can do is, I'm going to move report to top value. Okay, so what I'm going to do is, okay, I'm going to move report to the top, this is, it's moved to the very top. Okay, and from here I'm doing a practical example. So cell type markdown, and we can say that students analysis, okay, students analysis. And pretty much this is my first report. Okay, so my people, so far what I have done, oh, by the way, if you want to print all the columns of the data, you can use a method called dot columns. Dot columns will give you all the data that exists in that particular table. Okay, just for your understanding. The first task is to understand the data. So can I say that this data is about students who have a specific gender, either they are male or female? Are you sure they are only male or female in this particular example? We'll come to that. Okay, we'll come to that. That what categories do we have? Then we have each student's race and ethnicity. My people, observe, aren't we given group A, group B, group C? Has anybody written Hindu, Sikh, Christian, Muslim, Jain, Parsi? I don't know, anything. The reason is, listen to me very carefully. In your real life company also, you will never get this data. You know why? Because isn't it possible we humans can become biased towards the skin color, towards everything? So in order for us to not make a wrong analysis related to some other religious group or skin color group, they will always give us this value, group A, group B, group C. Now you know nothing. Your analysis will be correct, and later on management will know that group A is nothing but Hindu, group B is nothing but Muslims, group B is Sikhs, and group D is Christians. I hope you got what I'm trying to say. Management is not going to show you the groups, but at the end of the day, they will know the group, so that you don't do biasness in the data. You don't necessarily ruin the results of the data. Okay, it is labeled like that. Anyways, it's for your knowledge. So my people, the first thing as a data analyst or a data scientist you should do, you should always follow this advice, and you will never go wrong. The first thing is you have to pass something called data.info. Okay, what .info does is, it will give me the information about the data. In the data, how many columns are integer values? Can you see there are 3 columns that are integer values? Can you see here? Data type 3. 3 values are integer values. Which columns are these? Math score, reading score, and writing score. What about the other columns? They are all string type. Agree or disagree? All other columns are string type. Okay. So df.info is the first thing. Whenever you get a data set, no matter what happens, you will always implement this. This will give you idea about your data set. Can you see? The indexes are 1000 entries, 0 to 999. It gave you how many total values exist and where the serialization starts from 0. Each column's index and the total data size. This data is 62 KB. Enough information in the very beginning. right after data.info, the most important method that you should implement is called data.describe. Okay, this is a beautiful. Okay, the reason why you call df or data.describe is you are doing something called summary statistics. Okay, statistics. Example, I'll tell you. In the data, we have 3 integer values. Can you see? Math score, reading score, and writing score. Are we clear? So when you do data.describe will only work on number values. It cannot work on string values. So can you see I only got 3 as an output? Math score, reading score, and writing score. Yes or no? Agree? What answer am I getting from this particular data? The average score in mathematics in the entire 1000 people. What is the average score of the students in mathematics in this college? 66%. The average mathematics score is only 66 for all the 1000 students. But what is the average score of reading? Can I say 69%? Did you understand? The average score of writing 68%. So how do you present this analysis? You present this analysis like this. In this particular college or school or whatever this is, people prefer and have the highest score in reading, which is 69%, writing, which is 68%, and mathematics is the least, which is 66%. So can I say this is my analysis I understood? This is point number 2, that reading is number 1, writing is number 2, and math is number 3 in the college or in the university where the data is. Okay. From this data, I can also tell you one thing. From 1000 students, from all the 1000 students, the minimum mark somebody got in math, can you see min is 0? Somebody got an egg in mathematics. In the entire 1000 students, somebody got 0 in mathematics. But what is the minimum somebody got in reading? So there is no 0. Everybody, all 1000 students, the minimum mark somebody got was 17, and the minimum mark somebody got is writing. What is the maximum mark somebody got in the example or in the exam? Somebody got out of out in math, somebody got out of out in reading, and somebody got out of out in writing also. So somebody was able to get an out of out in math or reading or writing. We don't know if out of what was happened or it happened for all the category, reading, writing, and math, but we know independently people have gotten 100 out of 100. So did this give you a summary statistics in the beginning? What is the average value? Who scored the minimum? Who scored the maximum? Did you kind of get the concept? Yes or no, using the descriptive statistics? This you have to implement every time. You cannot escape this. Okay. Now that you understood df.info and df.describe, I want to know about the shape. So can I say data.shape and it will tell me there are 1000 values and 8 columns. Agree or disagree? This will tell me that your data has 1000 columns and 8 values. Are we clear until here? Okay. These 3 methods are the most basic methods that you're supposed to work on. These 3 methods are the most basic methods you are supposed to work on in the very beginning. Are we clear? Okay. Now, my people, the data that we have, right? The data that we have, data dot head of 5 dot head head of 5. Do you see I have gender, race, parents, lunch, test, math, writing, reading, and all of that stuff? In the gender part, we have written something called male and female. Are you sure the category is only male and female? What if in the 9000th column or 900 column there is something called binary or non-binary or transgender? Are you sure that the genders are only male and female? Are we sure that the genders are only male and female? We are not sure. So how to make sure that the number of the categories inside the gender column is only male and female? To do that, you have to use a method called data dot, okay? You have to write it like this, data dot value counts, okay? Dot value counts. But data of what value counts? Data of what vendor or what variable are you looking for? What column are you looking for? Gender. So if I do value counts, it is telling me that 518 are female and 482 are males. So there are only two categories, male and female, guarantee. No other category exists. Are we clear? If there was one transgender also or non-binary, it would have given me the labels right here. So now am I clear? Rather than assuming the number of categories, do I now have clarity that there are guaranteed two categories? One is male, another is female. You can also do this, my people. Data dot gender. You can even call gender like this. See, you can call columns gender using dot method also. You don't need to pass like this only. The problem is, I personally think you should call it like this and not the dot method. Okay, don't do that in professional code. In your actual production code, don't call it using dot method. Always follow this method. Okay, this is my personal advice to you. Years of experience and years of testing code, I'm telling you this is the best. Okay, so if you want to call a specific column, you will do dot value counts. You can also do this, my people, data of gender dot n unique. Okay, if you do this, is it returning the two unique counts that there are two genders? I hope you understood what I meant. N unique will return the number of categories and value counts will return those categories. Both methods are important. So I'm just giving you guys an idea about it. I hope you got it. There is no confusion, no question. Okay, so far. See, you can call either like this or either like this. Data of gender dot value counts or data dot gender dot value counts. Both are allowed. I personally prefer the first one, and you should also prefer the first one. It's my advice to you. I mean, if you want to do this. So did we get the clarity that the gender has only what, my people? Male and female. Can we test it for race and ethnicity also? Yes or no? Can we do this for race and ethnicity? Okay. How many groups are there? Group A, Group B, Group C, Group E, and Group D. How many groups? 5 groups. Out of the 5 groups, can you see from bigger to smaller, it is automatically arranged from bigger to smaller? Automatically, Pandas has taken care of you for this. So which group ethnicity is the highest group? Group C. C group is the highest group in our data. Did we get that clarity? Okay. I'll show you. मैं वो भी आपको दिखाई देता हूँ. Give me 1 second. 1 minute. Import matplotlib. Okay. Import matplotlib dot pyplot as plt. ठीक है? Import cbon as sns. Okay. मेरी बात ध्यान से सुनो. Did I show you that there are two genders, male and female? हाँ या ना? Did I show you there are two genders? sns dot set style. अब मैं आपको set बताता हूँ कैसे करता है. And style equals to dark grid. ठीक है? हम बहुत simple सा style रखते हैं. Dark grid. Okay. This is what I've done. fi comma axs figures and axis. I'll keep it at a very simple. Okay. Plot dot. You know what? मैं सब plot नहीं बनाता हूँ. ठीक. I don't. नहीं बना देते हैं यार. ठीक है. fi comma axs. ठीक है. Is equal to plot dot subplots. Plot dot subplots, because we will be using matplotlib, right? Okay, let me think. Plot dot subplots only. Figure comma axis is plot dot subplots, and inside this I want it to be 1 row 2 columns. So 1 comma 2. So I can pass something like this, right? 1 comma 2. You guys know what I'm trying to do here, right? Figure size. You guys know what I'm trying to do here, right? If I have taught you okay, I have not taught you matplotlib. Okay, don't worry. You guys have not learned this. It's okay. 10 comma 8. Don't worry. I will teach you how this particular thing works. SNS dot, should I do count plot or bar plot? I can teach you about bar plot also. That's not going to be a problem. But let's do count plot then. Let's do count plot. What am I trying to pass? Data gender dot value counts. So probably if I pass in data is equal to data as it is, And before this, I will pass in my data gender dot value counts. I can pass whatever you want, but I can take a variable here and I can say gender. Okay, I have said data is equal to data, x equals to gender, and you can change the color if you want, but you can, I mean, it's not going to make much difference, but ठीक है, axis of I want it in the 0 part. ठीक है, this is my count plot for this gender column, and if I want it to be race comma ethnicity, okay, so I'm going to copy this, I'm going to paste it, and this is going to be axis number 1, right? Okay, थोड़ा बड़ा हो गया. Let me, I'm so sorry, let's make it a little smaller. Let's make it 5 by 8, no, let's make it 6 by 4. Yeah, थोड़ा छोटा हो गया, I understand, but let's say 8 by 4. Okay. Do you see, rather than showing you male versus female and race ethnicity data like this, I have plotted the data for you. Are you understanding what I've done? This is called data visualization. See, race and ethnicity, gender and all of that, am I able to just plot the value for you? I have not shown you a graph. I hope you understood what I meant. When I show beautiful looking graphs, that becomes data visualization. Apart from anything else, this is data analysis. Are we clear until here? This is only data analysis that you're doing. Data visualization is far away. I haven't taught you how to make graphs. ये सब मैं आपको सिखाऊंगा how to do all of that stuff. But did you understand? We are not doing data visualization. Currently, we are at data analysis. Only we are at data analysis. ठीक है? Are we clear until here? Okay. So my people, we calculated for race and ethnicity. Can we also calculate and get the idea for parental level of education? Yes or no? What education does the students' parents carry? Are they educated people, uneducated people, illiterates? What kind of a thing it is? So see, maximum students in the college, their parents have only some college level education. Then some students' parents have associate degree. Very few people in the entire school, their parents are very educated. Did you see? Only 59 people or 59 students out of the entire college, only 59 students out of 1,000 students' parents have master's degree. Rest, some bachelor's degree, high school degree, high school, associate degree, and some college. Does this give you an idea what the parents' level of educations are for the student? See, this is your analysis, my people. This is golden information. यही तो this is what data analysis is. और क्या है data analysis? ये सब चीजें बताना ही data analysis होता है, right? There is not something जो मैं कुछ नया ही some weird thing you're finding it out. This is what you found out, right? Let's take another data and paste it here. What are we missing, my people? Lunch. Lunch is missing, right? So I'm gonna copy this and I'm gonna paste it here. Let me say paste lunch. So lunch mein, how many categories of lunch do we have? How many categories of lunch do we have? 2. Most students get standard lunch, but 355 students, because they come from a separate category, they are either given free lunch or they are given reduced money on lunch. So everybody in the general category will pay 500 rupees for lunch, but people who come from a different background, they have to either be free, the lunch is either free for them or either the price is reduced for them. So did we kind of get an understanding on how this particular thing is applied? Yes or no? So we got the value for lunch, absolutely clear. What is remaining? The last thing that's remaining is test preparation course. I'm going to copy it and I'm going to paste it here. Okay. What this particular thing does is this. In the entire school, okay, do you remember, my people, in our school exams, whenever we had an exam, our school used to have a special class arranged? You can come to the special class. You used to do that. Okay. So do you see that the test preparation course Palapart is none are 642 people who have not completed that yet, and the 358 people have completed that yet. So far, whenever you calculated this particular thing, this entire segment of value counts, test preparation course, so see, come from the top. Here, how many categories exist? 1 or 2? How many categories are there? There are specifically 2 categories. Same thing happens in lunch. Same thing happens in lunch. Yes or no? Okay. What about parental level of education? What about parental level of education? What parental level of education do we have? We have 5 values. What 5 values do we have? What count values do we have? Very simple. Lunch ho gaya, test preparation course ho gaya, race ethnicity ho gaya, gender ho gaya. Is it all giving me the output in the relevant way? Are we all getting this particular thing in a relevant way? So we kind of got the output, we are sorted. Are we clear? You don't want the answer to be 642, 358, but you wanted 358, 42. No problem. Here you have a variable called ascending equals to false. So let's make it true, sorry. Do you see it's, how do I show it to you? Do you see it's reversed? So are we clear with some very basic understanding of how to take an category idea? The first thing in the code that you should always do is never let go of, without understanding how many categories of the data exist, do not continue with your data analysis. Are we clear? Did we follow the thumb rule properly? We first implemented something called data.describe, data.info, and for each column we clearly got which categories of the data are and how many categories they are. Yes or no? So did we describe the data, info the data, all of that stuff that we did? And now what we need to do is basically get into data analysis. So if I do data.head of 5, my people, do you see that we have a math score, reading score, and writing score? So instead of calculating math score again, reading score again, writing score again, क्या मैं math, reading score, writing score को combine नहीं कर सकता into another column called total marks? Rather than reading it independently, can I not create one column जिसको हम बोल सकते हैं total marks? So how do you create a new column in Pandas? Data of, can I say total marks? Total marks equal to, अब total marks मुझे करना है, तो what do I do? Can I not say data of, what am I combining? Which 3 variables are we combining? Math score. So data of math score plus, what are we doing? Plus data of what? अरे ये कहां से आ गया? हाँ, plus data of, what are we doing? Reading score. So remove this and paste it. Plus data of, what are we doing next? Writing score. Can I copy this and paste it here? So my people, if I say data.head of 5, do I have a new column called total marks जहां पे मुझे सारे total marks मिल रहा है? I'm getting all the total marks of everything. हर किसी चीज का total marks मिल रहा है. चलो, I got total marks also. But एक बात बताओ, total marks divided by 300 will give me what? Total marks divided by 300 will give me the average percentage, not average, percentage मिलेगा ना? Average नहीं मिलेगा, percentage मिलेगा, right? क्योंकि by 300 मतलब by total value 300 ही है ना? Out 0 to 100, 0 to 100, 0 to 100. तो अगर if I take data of, okay, I will say data of percentage. Can I create another column called percentage? Can I do this? Can I do this? Okay. Inside this, if I take data of total marks, ठीक है, मैंने data of total mark ले लिया. I need to divide this by how much? I need to divide this by how much? 300. अब इसको हमने 300 की तरह ले लिया. अब what do I do here by 300? If I do this and if I print data dot head, what will it give me? Will it not give me the value such as the percentage? But एक बात बताओ, this is in fraction, हाँ या ना? इसको अगर मैं multiply करूंगा with 100, will it not give me a proper answer? हाँ या ना? So do you see I'm getting 72? But the problem is, do you see the trailing numbers 0.666667, 0.8333333? I don't want that nonsense of trailing numbers or you know, least significant values like that. So my people, if I use a method called dot round, and if I pass just 2, do you see my answer is fixed? Dot round 2, and now I have a column with gender, race, parent, level of education, lunch, test preparation, math, reading, writing, total marks, and percentage. So did I make my data better or better enhanced so that now whatever analysis I want to do in the later stages, my life is sorted? Hi, Anna. Are we clear that my life is going to be sorted? Now my data is clean. My data has gender, race, parents, lunch, and all that nonsense that I need for the data. Now, the most important thing after you fix the data is, my people, I told you, won't your data have null values sometimes? Sometimes your data has null values also. My people, don't you sometimes have null data, NaN data, that the ones that are like nonsense, like rows are missing, columns are missing, you have empty values, and then you are kind of irritated and acknowledging the problem and you want to fix it? In order to do that, in Pandas, we can test whether the data is empty or not. To do this, always implement this method, okay? Data dot is null or is NA, you can pass it dot sum. And I'll tell you what this particular thing does, don't worry. Am I getting for all the columns the answer is 0? Am I getting the answer for everything as 0? Hi, Anna. What does this tell me? What is this thing telling me? It is telling me that in your entire data set, no column or no row is empty. Everything is 0, means everything is filled properly. Are you understanding? Did you understand what I'm trying to say? This is trying to tell me that this particular data, okay, is completely filled and completely useful. You have nothing to worry about. You have no data that is completely empty. But sir, how does this particular thing work? Can we have a look at it? Absolutely. Have I taught you how to take a data in Pandas? Suppose if you want to take an example data to test something, have I taught you how to do that? How do you take sort of like an example data set on your own? I think I have taught you this example. How do you do this? So can I say that test underscore data equals to pd.data frame? Yes or no? Hi, Anna. Okay. Inside this, have I not taught you that you can take dictionary type data? Have I not taught you that you can take a dictionary type data? Okay. Let's say you have a column called name. You have a column called name, and inside name, I'm passing an array. So the first name I will take is Murchana. Okay? Murchana. And the next name is none. None means Python mein what? In programming or in Python or in data analysis, it means nothing exists there. It's not 0. 0 means a number exists. None means nothing exists. And can I take another name? Let's take Harshita. Harshita. So have I taken Murchana, none, Harshita? Yes? Okay. Can I say the age is, Murchana is 24 years old, and can I pass none, none? Yes or no? Can I pass? Yeah, none is NaN. None is NaN. Yeah, NaN is just a computer representation of null. Nothing exists there. ठीक है? कुछ नहीं है वहाँ पे ऐसा. So let's take one more column. Name I have taken, age I have taken. I can take phone number. I can take, I don't know, city ले लेते हैं. Which city you live in? ठीक है? So let's say Murchana lives in Bhopal. Okay, Bhopal, and none lives in Indore, by the way, beautiful city, and say none. Okay. This is my test data, which is some null values. Hi, Anna. This data has some null values. Hi, Anna. Is data may some null values exist, correct? How do you test this exist? So can I say test data dot is NA? If I return dot is NA, wherever the data is empty, is it returning false or true? Wherever the data is empty, what Boolean value it is returning, true or false? It is returning true, right? See, Murchana ke baad none exists, right? So wherever the values are empty, isn't it returning true value there? So I want to calculate how many true values are there. Dot true, how many in the name, how many true values are there? If I do dot sum, will it not calculate that in name, one true value exists, in age 2, and in city 1, basically telling me that in name, there is one section which is null, and in age, there is one section called null, and in city, there is another section called null. Hi, Anna. Until here, are you clear? This is showing me how did you get what? What are you doing here? What are you doing here? Isn't this your original data, my people? Test data. So test data is my original data, correct? There is null value here, none value here. Agree or disagree? Okay. Look what I'm going to do. Test data dot drop NA. If I call this method and run this, anything and any column with null values, are they deleted automatically from original data? And I am left with only and only the rows that are only and only left with all particular values. So can you see I am able to do this? Did you understand what I meant? All the NaN values, null values, all of these are gone, and I'm only left with the table and the values which are only specific. So the name of the method is called drop NA. If you want to remove the null values from the data, this is just an example I wanted to show you. Are you clear? There is so much more we will learn, but I hope in the beginning you get the idea. Now, remember, in case if you really want to take null value or none value, do you remember I told you in NumPy you have something called np.nan? Never make the mistake of writing none here, right? See, I have made one small mistake, not a mistake actually. Rather than calling it none, call it np.nan. So np.nan, okay, I'll show you an example. np.nan, np.nan, okay. Let me copy this, copy it, paste it here, and paste it here, okay. Run this, and actually take it out and run this. Do you see everything is properly filled with nan, not a number? But if I still do dot sum, it is telling me empty values exist. So don't take none, take np.nan. It is genuinely a true representation of nothing exists in Python. Are you understanding what I'm trying to say? If you don't know how to take a null value or a nan value, take it like this, np.nan. It's a true representation. Are we clear? With all the none values represented with np.nan, computer understand nan's value much more clearly than none values. I hope you got the concept of what I was trying to tell you, right? Okay, anyways, this example was just to show you how we did isNA.sum. Are we clear with isNA? I hope you got the concept. Okay, yeah. So this is how a representation is done. Anyways. Is this my original data, my people? Yes or no? Gender, race, ethnicity, parents' level of education, and all of that stuff. Have I validated whether people have actually, have I validated that writing score, reading score, total marks and percentage, everything is correct? There is no problem. Are we clear until here? Okay. My first question and my answer is, are men good at mathematics or women good at mathematics? Are gender men good at reading or women good at reading? Are men good at writing, women good at writing? If I want to do this, can I not segregate my original data into males and females? Are you understanding what I'm trying to say? For example, let the segregation begin. Okay, think about it. My people, I want to separate all the males separately, females separately. If I want to keep all the males separately, can I create a data frame called male, only and only male? And from the data variable, the data of gender, what gender do I want? If I want specifically male, can I say gender is equal to male? Because the gender column here has male written like this, my people. Can you see? MALE, all small. Correct? Gender is in the data gender, there is a variable called male, category called male. So can I say that all the males, if I want to keep it separately, data of gender equals to male, the reason you write an extra data outside is because you want to again convert it into data frame. Okay. So for example, I will show you an example. Okay. Let me comment this out. If I say data of gender equals to male, if I run this code, okay, look at this. Is it returning the output not in a table format? The output is not in a table format, correct? It's like a series object, like a Pandas series object. Yes or no? If I do data of gender equals to male, it's a series object, right? But if I put another bracket in the beginning, in the end, and I put the data or the data frame outside, now is it a table? But look, all the gender is male. Did you get what I'm trying to say? That is why I have written data of data outside. I hope you kind of got the concept. All the males, I have kept it separately here. But can I also take another column or another data frame called female? I can copy paste the same code here and paste it. But my people, instead of saying equal to female, can I also not say not equal to male, which is nothing but female only? To separate all the females, I can write two code, right? Either I can say equal to female, or I can say not equal to male. If I run this, do I now have two separate data frames, one male and another female? I have split my data into two. One category will have all the males and other category will have all the females. Does that make sense? Okay. So now that I have split the data into gender, male and female, let's do this. Print. Oh, by the way, I'm going to teach you something amazing now. This is string formatting. I love teaching you guys Python. Let's do this. Have you ever seen F string? If I say var equals to, okay, var equals to math score. Okay, print f of colon var, but here I will use a tilde, not tilde, equal to up sign 30, or let's say 70. Do you see what happened, my people? Does anybody understand what's happening in the code? I wanted my math score to be middle aligned, but I wanted it to look neat. So in order for me to be middle aligning it, inside the F string, wherever you have a var, put a colon, whichever symbol you want, you put double equal to. So see, I have put equal to. Can you see this? Put upper sign, equal sign. This equal sign means, or the upper sign, the upper hat means I want the math score variable to be exactly middle aligned. So can you see my math score is middle aligned and rest equal to is in the side in the proper number. Left is also correct and right is also correct. The numbers are proper. You can do this in Python, by the way. I'm just wanted to show you. Are we clear? Any confusion in this code? Any confusion in this code? I hope this is cool, right? Something you can do with F strings. Some concepts I've been aiming to teach. Okay. I want to know which category performs good, male or female. So can I say print of F double quotes of, my people, I want to categorize whether males are good in math or females are good in math. So can I say male colon and I can put a flower bracket. Can I say this is a placeholder? Can I say this is a placeholder? Okay. Where are all the males created in a data frame called male? Agree? In males, what do I need to check for? Math score, right? In males, I need to check for math score, correct? In order to calculate mean, can I call the method called dot mean the average? Hi, Anna. Am I not calculating the dot mean, which is basically that particular value? If I copy paste the whole thing and paste it in the bottom and called it female, and instead of this, I can say female dot mean. Do you see that the average score in mathematics in men are 68% and the average score for female is 63? What analysis can you say? Men on an average perform better in mathematics than females. Males are performing better in mathematics in my data than females. Can you see 68.628381 goes on? The numbers are trailing numbers. Can I not do colon dot 4f or 3f? If I do this, I got the output correct. Do you know this, right? I think you know this so far. You can do it like this also. In F string, you can do it like this. Dot colon dot 3f is going to give you 3 float point values from the dot. Like round functions, this can be implemented within the F string itself. You can do this in this particular thing itself. You can do group by also But in group by there is one small problem. The problem will be जब आप group by करोगे, right? आपको group by with respect to क्या किसके साथ करना पड़ेगा, right? जैसे for example, group by index gender and with respect to reading score. तो आप group by करोगे तो भी आपको ऐसा आंसर मिल जाएगा. आप अगर group by करोगे gender, race and with math score तब भी आपको आंसर मिल जाएगा. So आप अगर group by करोगे that is also a good approach. If you do it separately as a data frame, that's also a good approach. मतलब दोनों ही approach viable है, कर सकते हो आप, no problem. Both of them is fine. आप दोनों ही approach कर सकते हो, क्योंकि group by में क्या होगा? Gender will have both male and female, and you are grouping by with respect to math score. तो आप उसको कर सकते हो, ये pretty much possible है, no issues. वो भी अपने कर लेते हैं अभी, एक example दिखा देता हूँ मैं. Did you understand how did we get math score so far? How did we calculate the average value of math score so far? With math score, what else are we remaining with apart from math score? Can I say reading score is also remaining? So can I say apart from math score, I can say reading score? Yes or no? What do I need to change here apart from math score? Reading score, and change this particular thing to reading score, right? Control Z, oops, but Control Z. Reading score. If I run this, on an average, who performs better in reading, men or women, males or females? Who is good in math? Men are good in math. Males are good in math. Who's good in reading? Females are good in reading. Okay, let's copy the same thing and paste it here. And instead of reading, what do we have? We have writing, right? So writing. So all I need to do is change the reading score with writing score, and come over here and change the reading score to writing score. So my people, on an average, who performs good in writing? Again, female for the win. Females perform better in reading and writing, and men perform better in mathematics. Are we clear under this so far? Okay. Did we get the idea did we get the concept where we kind of were able to get sort of like an average value for all the people? What happened, how it happened, all that nonsense, all we were able to get all that stuff. Okay. Suppose you have a variable called Rudra Sharma. Okay. You have a variable called Rudra Sharma and you want to print f of var, this as a var, okay, colon, if I say left side, okay, of, I don't know, okay, let's say equal to left and I don't know, 10, I guess. Let's see. Oh, sorry. This comes like this, right? Dot this. What am I doing? Give me 1 second. Is it a dot or equal to or? Oh, sorry. This is a tilde sign. Yeah, this is an upper sign. Hold on. Give me 1 second. Equal to and upper sign, which is this. Okay. Have I taken the correct var? Give me 1 second. Equal to var and the number is 10. Wait. 30? Yeah, of course. Makes sense. So what's happening here is, do you see this symbol called equal to? This symbol called equal to? After where I have taken a colon. Okay. Equal to means to the left hand side of the string and to the right hand side of the string. What is the name of this? Give us. It's called Rudra Sharma and you have mentioned it in the variable called var. So var you have passed here. So this means Rudra Sharma. You want Rudra Sharma to be in the middle. So if you want something to be in the middle, you have placed this this thing called tilde. Can you see? Tilde. Okay. If you make this tilde as lesser sign, can you see Rudra Sharma is towards the left hand corner and all the dot colon is going to the right hand side? If you want your name to be left aligned, it's going to the left. If you want your name to be right aligned, it's going to the right. But if you want your name to be middle aligned, you can pass this. And Rudra Sharma is in the middle aligned. And this number is how many lines do you want? Can you see how many lines I have? Initially it was 30, now it is 40. I hope you got what I'm trying to say. This code helps you format things well. This is just another trick. Okay. Whenever you say 40 also, yeah, I mean, this is not exactly going to be 40, by the way. I mean, see, if I say 41, see, 41, it needs to make sure that the left portion and the right portion looks neat, right? Equal. Are you understanding what I'm trying to say? You can pass anything. Apart from this equal, you can pass dot, you can pass dash, you can pass, I don't know, A, R. I hope you understood what I meant. Like you can pass any variable with this particular thing and anything can matter. I mean, anything can work out. So this is just that particular string and that's what you're trying to do. Okay. I hope you kind of got the concept so far. Now, can we continue with the analysis, please? So now that you've calculated the reading score, writing score, and all of that stuff, my people, don't you want to know the top scores in mathematics that everyone in the school got? So for example, out of 1000 students, okay, out of 1000 students that we have, how many people got 96%? 96 out of 100? How many people got 40 out of 100? How many people got 36 out of 100, 45 out of 100? 80 out of 100. So basically what I want to know is I want to identify the top scores that people have gotten, right? So that particular way, I want to identify what the top score have been like. So if I say data of math scores, okay, math particular score dot value counts, the one that I taught you a while ago, see what it returns. 36 people got 65 marks. Okay, dot head of 10. Okay, 65 marks were given to 36 people. So the highest amount of pattern, that 65 were given, okay, then 62, then 69, then 59, then 61, then 73. Then so these are the numbers that we have given. And then on the right hand side, you see all the patterns that you have. Did you understand what value counts did? 65 marks were given to 36 people. And the number and the patterns are being printed here. So the top 10 values in repeated patterns, okay, top math scores, not ROP, top math scores in repeated patterns are printed here, okay. These are the top values of maths which have been given. 36 people have been given 65 marks and pretty much goes on and on and on and on. So these are the top 10 values that you have. But now I want to understand how many people got 100 out of 100 in math. Only and only math I am talking about. So if I want to calculate in SQL, how do you do? Can you not write data of math score, not like this, math score equal to 100? This is what you do. I want all the values of the people who got math score equal to 100. But what problem I told you this does? This does not return data frame, correct? If you do this, it will return a series object. It will not return a data frame. So outside of this, can I write data also? So now am I getting all the people who have scored in 100 or 100 in math? You got what I'm trying to say? When all the people whose math score equal to 100 and I put data outside, which is nothing the data frame, did I get all the people who got math score 100 out of 100? Haan ya na? Did you understand what I'm trying to say? Abhi, we've not added math score and reading score and writing score, but am I saying all students who scored 100 out of 100 in math? Can I say it like this? All the people who scored 100 or 100 in math. Now, I want to calculate how many people these are. Like, kitne logon ne ye kiya hai? Like, how many people got out in math? So, can I take the same code? I can say math score, all and all, just the math score. Hold on, give me 1 second. Copy this, paste it here. Math score dot count. How many people got out in math? 7. Because what I'm doing here is, for all this table, see, when I say data of data math score equals to 100, from all the math score, I am only taking which variable? math score column and I'm counting the length of that column. So see, I have passed something called math score and I'm saying in the math score column, count the number of values. How much did it return? Value count won't work. Value count won't work because value count is to calculate segregation of counts, right? Count will tell you the length of that particular value. I hope you understood the difference between value counts and counts. Example, if I take this and do dot value counts, okay, आपको मैं बोलता हूं यहां पे dot value, give me 1 second, dot count, okay, copy this and paste it here, okay, dot value counts, and if I return it, do you see what's happening here? It's returning for all the columns. For column A, gender, ethnicity, parents' level of education, and all of that. If you take math score here, okay, yahan pe, if you take math score, and if I run this, is it returning 107? It's returning 100, right? 100 marks for 7 people. But it's returning name, data type, all of these data. It's returning extra variables which you don't need. You just need one number 7. I hope you understood what I meant. You don't need extra information. You don't need all of that stuff. You just need one value count, 7, right? Like I hope what you meant. When you do dot count, C-O-U-N-T count and run it, is it not returning 7, which is what you want? In the value counts, you will have to remove a lot of unnecessary value, and in the count, you just take the number directly. So that's why I'm saying all the people, if you want to count, okay, instead of calculating value counts, if you just want a number directly, which is an integer or a float type, use a count variable, okay? Can we use dot count instead of again entering math.score? If you do count without doing math.score, here is what's going to happen. Is it going to return count for all columns because you are not telling which column you want count for? I hope you understood. See, because when you do data of data math score equals to 100, it is calculating all the people who got 100, but it is returning the entire data frame also. The entire column, including writing score, reading score, total marks, race, ethnicity, gender. But you are only interested in one particular column, right? Which is math score. That's why outside this, I am telling via its index that only and only I am interested in a specific column called math score. And inside math score, give me that particular count. So I hope you understood what I meant. Instead of returning 7 every time, it will return specifically for math because my analysis is for math. I hope you got what I'm trying to say. Okay, my question to you is, if I want to calculate who got out in reading, how do you do this? Same thing, right? Copy the entire table, paste it, just remove math with reading and we are pretty much done. Yes or no? Reading score, hi or no? And this will return all the data frame for the people who got out in reading. I hope you understood what I meant. So this is how you query a table. Unlike SQL, अच्छा मैं आपको एक example बताता हूँ. Example, ठीक है? ये हमारे पास data है. Can I query something complicated, sir? Rather than 100, less than 50. Less than 50. Can I do this? Did you get all the people whose scores are less than 50? And you can count also. Like यहाँ पे mathscore.count लगा दूंगा. So I can calculate how many people got less than 1500 in mathematics. Out of 1000 people, 90 people got less than 100. Less than मतलब less than 50, 90 लोगों ने calculate किया है. Are you understanding what I'm trying to say here? You can do so much more. There is no end to this particular thing.
Just a quick info, guys. Intellipaat offers data analytics course in collaboration with IIT and Pandas. Through this course, you will master Power BI, data modeling, data mining, and much more from the IIT Madras faculty and industry expert. With this course, we have already helped thousands of professionals in successful career transition. You can check out the testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your careers to a new height. So visit the course page link given in the description and take the first step towards the career in the field of data analytics.
I am going. Now let's say I want to understand who scored 100 in reading, writing, and math. So which genius has scored out in math. Now we know that our data is saved in a variable called the data frame called data. Agree or disagree? And if I do data dot head of 2, it's going to return the top 2 values of my data frame. Correct? Now my people, listen. I am going to talk to you in technical terms. So I am not going to talk in terms of stuff like this and that. Okay. Now my data frame, my entire table, can I say that my table is named as data, and all information related to the table is in data? Can I make this statement that all the table information is now in the variable called data? Agree? So I want to calculate who scored out in math. So basically, in the data frame data, for the variable math score or for the column math score, who scored out in 100? Correct or not? This is my first statement. This is my first query statement. Hi, Anna. This is my first query statement, right? Who scored? Okay, in the table name data, under math score column, who scored 100? And bracket close, under the data frame data, in the example of reading score, who scored in out in reading? Agree or disagree? This is equation number 2 or line number 2. I am matching both 100 scores in math and 100 scores in reading. What do I need to do? At the rate and I need to close this bracket, actually copy paste the whole thing and change the reading to, what do I need to change the reading to? What would I change the reading to? Writing score. Are you understanding? But my people, if I run this, right, it returns everything is a series object. To convert this into data frame once again, don't I need to write the data frame outside once again? Like this, data. And if I do this, I have an example of 3 people, 2 female and 1 male, who got out in math, reading and writing. Did you understand? It is very, very simple. I'm not going to spend much time explaining what this is. We scored out in math and out in reading and out in writing, and we put a bracket and we put the data frame outside again because we want data not in a series object format. We want it in a table object format. Remember this and never, ever, ever forget this particular thing. Are we clear? I'm going to show you some more complicated examples and you will see what's happening. My people, have you ever seen something called as pivot functions or group by functions? Have you ever had an opportunity? Okay. Do you know what is a group by function? Okay. Do you all understand what is a group by function in your SQL? Okay. If you know group by function, can I do this? Bad math score. So can I say that for bad math score, okay, for my bad math score, my data for math score, okay, for my data of math score, which is less than 50, but I will encapsulate this because this will return me a series object and I will pass the data outside. So can I say that bad math score is another table that I have created for all the people whose scores in mathematics are less than 50? Can I say that this is another data frame that I created? Whose scores, all the students whose scores are terrible in mathematics, right? So bad math score dot group by, I want to understand for people whose mathematics scores are worst, how did their parents perform? Are their parents from good degree, bad degree? Are they from a good level of background? So when I do bad math score dot group by, can I not pass their parental level of education? Yes or no? I can take the parental level of education, I can copy it and I can paste it here. Parental level of education, and I want math score to pop up here, right? So for example, I'm going to take math score, copy it, paste it here, right? Math score dot count here. I'm going to do dot count. I want to count the total values dot sort values. Okay. I want to do sort values. I want the answers sort underscore values. and I want it in ascending equals to false. Okay. Ascending, ASCENDING, ascending equals to false. If I run this, do you see that 36 of the students who have terrible exam scores lesser than 50, their parents' education is they only have done high school. And 6 people who did bad in math, their degree or their parents' degree was master's degree. So did you understand that I am able to connect the math score with respect to their parents' level of education? I'm able to group it by. I'm very sure you must have seen this functionality in SQL. I am able to group by the scores of mathematics with respect to their parents' level of education. So what analysis do you get out of this? People whose parents have done master's degree, they tend to perform better in mathematics, but whose parents have done only high school degree, their kids don't tend to perform greater in mathematics. Can I say that this is the analysis that we can do? My people, tell me one thing. Depending on the data that we have, how many different opportunities exist? Are you understanding what I'm trying to say? Are you understanding that there are so many opportunities of so many group by functions that you can do that can make your life super easy? Yes or no? Agree or disagree? And as a data analyst, what do you need to get clarity on? What is the first thing you need to give clarity on? The clarity should be first on the data, right? On the data itself. If you have clarity with the data, anything can be done. Agree or disagree? If you have clarity with respect to data and the methods you know, can you not just do whatever you want? Okay, I'll give you another example. Have you ever heard of something called pivot tables, my people? Do you have any idea about what pivot tables does? Okay, can I show you how pivot tables are performed? Because the example is very, very practical, it will go inside your brain in a much more nicer way. When I show you to you, you will kind of get a better clarity. Can we do it? Can I show you how pivot table performs in pandas? Okay. Pivot underscore table is equal to pivot underscore table equals to data dot pivot table. That's it. You have to call this method called pivot table. Done. अब इसके अंदर you have to pass what values do you want to pivot. So I will say values equal to, I want to pivot math score. Okay, SCORE math score. I also want to pivot reading score. Okay, I'm going to copy this. I'm going to paste it here. And I also want to pivot writing score. So math score, reading score, and writing score. So I'm going to take writing score here. I'm going to paste it right here. So all the values of my reading score, math score, writing scores are done. But my index with which I want to segregate it is based on the gender. Okay. I will segregate based on gender, and I can take race and ethnicity also. Okay. I can take either race and ethnicity. I'm going to paste it, and I'm going to paste it here. And yeah, pretty much I'm done. I'll come outside. The aggregate function that I want to keep is only and only mean of those values. If I run this, if I run my pivot table, right? And if I do this, do you see I have pivoted that which gender, and in that gender, which ethnicity is better at math, reading, and writing? Did you get what I'm trying to say? Here, you are combining the results and you're checking with respect to each other. See, here, we were printing everything one at a time. But whenever you have functions like group by and pivot, what am I doing, my people? So first of all, the output that I wanted for everything, isn't it going to show up in a value called values? I want math score to be reading. I want the answers for math, reading, and writing. So math, reading, and writing is here. But I want my index value to be based on gender and based on ethnicity. So did you see what I did? For which gender, for example, male or female, which group ethnicity performs on an average better average math score? So haven't I taken mean, which is an average math score? Did you understand what I did? Now I have the results combined for gender. What relationship does gender have with race? And gender and race together, are they good in math, reading, and writing? And I can do so much more with these guys. For example, I will take the same exact code and I'm going to paste it here. And rather than taking math value, reading value, writing value, can I take and remove all and make you understand in a much more nicer way? Don't we have total marks, people? Overall marks, both reading, writing, and all of that. See, I'm taking another pivot table where I want my output to be with respect to total marks. Okay, so Control Z, just give me total marks output. Okay, the index column that I'm going to do is I'm going to still keep gender and race and ethnicity. I can do it, no problem. But rather than mean, I can call sum. And if I run this, do you see what output did I get? For gender female, depending on the ethnicity, the top performers are group D, or sorry, group C. In female genders, group C ends up performing really well. And in male gender, which group is performing better? Group C. So can I say that for both male and female, group C is the most successful ethnicity group in among all the other group? Did you understand that group C, for both gender, male and female, they are doing good? So you can represent it like this. For example, Sikh faith students, both males and females are better in education. See, this is the claim I'm making currently. Female in group C, let's say group C is of Sikh background, right? For example, Punjabis. So it's like Sikh faith people or Sikh faith students are able to perform better in both male and female categories. Not just this, my people. I'm going to copy this. I'm going to show you one more example. You can not just take sum, but you can take combination of mean and sum also. So I can take an array in the aggregate function, take both a combination of mean and sum. And if you run it, do you see I'm getting the mean total marks and sum total marks? So I'm getting both the average values and the total values. So are you understanding what I'm trying to say, my folks? That you have limitless opportunities with respect to the data that is given to you, and you can do as many things you can. The only thing that you need to do is take a data set like the way I took it, right? Of course, I was teaching you as a beginner level, but there are so many things that you can do. I can give you an example of, see, have you ever heard of something called UCI machine learning repository, my people? Have you ever heard of a tool or a link or a website called UCI Machine Learning Repository? Okay. My people, this is a place where you can get unlimited data sets. See, do you see this data set that I uploaded called students data set? This data set called students data set that I've uploaded here, where we did a lot of analysis. I have taken this data set from this website called UCI Machine Learning Repository. This place is a place where you get millions of data. For example, I'll show you, okay? Let's look at the adult data set. Okay, look at this. We have a data variable called age, working class, feature called education, education number, marital status, occupation, relationship, race, and sex. These are the data set that is given to me. Can I not download this data set? Like, see, I clicked on download. Let's do it like this. Give me 1 second. Let's come to the bottom. Hold on. Give me 1 second. Pip install UCI machine learning repo. This is going to install the library. And what is said? Okay. From UCI machine learning this, I need to import this, is it? From UCI adult equals to fetch UCI repo ID2. Okay, give me 1 second. Copy this. Paste. Run. My people, see, without even downloading the data, I am able to sort of fetch the data from UCI repo. So see, I'm able to fetch the data, right? So rather than printing this, right, I'm going to print adult. I'm going to run this, right? Data is in what type? Give me 1 second. The type of the data that I have is, I'm assuming JSON, but okay. Oh, this is fetching again and again, right? So let's not do that. This is dictionary. This is UCI machine learning repo.dictionary. How do I convert this into a CSV? Let me just check. Okay, no problem. Let's download. I need to check it. This is a new feature they must have added. I've already told you about this website called Kaggle, right? I've already sort of explained you the concept of Kaggle, right? All you have to do is just type pandas here, right? You will have millions of repositories here, millions of files here with pandas. I think I showed you an example of these Pokemon example. If I'm, yeah, right here. See, learn pandas with Pokemon. Have a look at this, my people. I'm going to show you this code for a while. Do you see we loaded the data called pd.readcsv input file.pokemon.csv, and here df.head n equals to 10, which is nothing but passing the value 10, and all 10 values are popping up. Yes or no? Okay, here, have a look at this example. For all the columns that they have, for all the columns, this person is replacing all the special characters. So for example, in our data, okay, do we have race/ethnicity, parental level of education? There is no special character, right? No $, hyphen, underscore, dash. There is no special character, right? So we did not need to do replace. Here in his columns, there are special characters. So he's replacing them. Once he does that, can see what he's trying to do is come here. Yeah. See, he is trying to print all the columns, all the shape. He's trying to fill all the empty values. He's doing location of it. He's trying to calculate for which type, which category the data is. So much stuff can be done depending on the type of data that we have. We can print all the n unique values inside it, all the category values. You can do all the sum values. See, this is called describe, which we've already done, all the summary statistic value. And these are all the proper visualization plots. But the point I'm trying to make is, once you start practicing pandas, okay, first of all, did you feel it different from SQL? Did you see that pandas is slightly different from SQL? You can do everything that you were able to do in SQL, but the syntax that you follow is much more easier and simple. Agree or disagree? Were you able to understand the concept that the focus is pretty much the same, but the only difference that you have from that to here is just that the syntax is very Pythonic in nature. Unlike in SQL, where you write from star select star from from a particular table name, and then you have all these things. That's where it comes difference, right? That's where you have the difference with pretty much all that stuff, right? Exactly. That's exactly how it's going to be done. So if you are able to clarify or give yourself that clarity, pretty much we will be sorted. Are we clear until here? Where we use round brackets and where we use square brackets, there is no way to explain. This will come with respect to a little bit of experience, but my personal recommendation is wherever you're confused, right? Like for example, group by. Suppose I did group by functionality, and while doing group by functionality, I showed you that there came a bracket. All you have to do is pandas.groupby. Just go to the repository directly or go to the code, and you'll be able to see that your data frame.groupby has to start with a bracket functionality. So I'll explain why this is confusing to you. Give me 1 second. Suppose in Python, have you ever made EMI calculators, my people, in Python? I mean, have you ever done this? Okay. Do you remember the formula for EMI calculator? EMI formula? This is the formula, my people, right? Do you remember? This is the principal loan amount into rate of interest into number of periods, which is the monthly interest rate, which is also called repo rate, right? And then you have a monthly installment. If you want to do that calculation, right, in Python, if I ask you to do that calculation, won't you very peacefully be able to use a combination of this list and this example, this bracket and this bracket? For example, okay, define calculate underscore EMI. Okay, when you want to calculate EMI, what will you pass inside this? Can I say the principal amount? Annual, I don't know what this is called. I think interest rate. I think this is called interest rate. Huh? This is called the annual interest rate. The tenure. How long do you want to take the loan? The tenure years. Correct or not? Because tenure comes in here, right? The tenure, the number of periods. How long do you want to take the loan? What is the first thing you do? You convert the monthly interest rate, okay, the annual interest rate into monthly, right? you take the annual interest rate, you convert that into monthly interest rate. अब आपको monthly interest rate calculate करना है, तो क्या मैं बोलूं monthly equals to annual interest rate divided by, what do you need to do? Divided by 12, right? अब इसको मुझे परसेंटेज में कन्वर्ट करना है, तो क्या मैं इसको मल्टीप्लाई बाय 100 बोल सकता हूं? अब इतना मैंने कर लिया. Okay, if I come down, tenure, okay, the tenure months that you, are you understanding what I'm trying to say, my people? See, brackets will come when you have a complicated calculation. See, for example, देखो यहाँ पे ना, बहुत ध्यान से देखिए यहाँ पे, I wanted to calculate the people who scored out in math and data equals to reading score 100 and data equals to writing score 100. So remember one thing, there is only one ground rule in Python. What is that one ground rule? If you have a method, data frame dot method, how will it start? It will always start with a bracket like this. But inside this, if you want to do a complicated calculation, give itself independent brackets. Like for example, this divided by this, right? So I can do A into B divided by B into C. This is how you're supposed to keep your, your code clean. Okay. So what you need to do, my dear, is the more you start working on the code, right, the more idea you will start getting on how exactly this particular thing works. I hope you got the idea, you got the concept. Are we clear? Right? Just exactly like SQL, but what you need to do is, whenever you're doing a complicated mathematical calculation, like for example, I think we can take a longer formula like Sridhar's method, right? Like you can say A into B divided by C. So you should not take it like this. You should take a bracket to A into B divided by C and take this as a variable called X equals to this. Okay. Suppose X equals to this, A into B divided by C, and another variable called Y is equal to A double score A to the power of 2 divided by B to the power of 2 divided by C. And this is X divided by Y. So see, you should take the segregation of functions like this, and only then you will be able to understand things well. Okay. I hope you understood the concept that I'm trying to tell you. With this, the clarity that you will attain or have is going to be different. And that is exactly what I've done in Pandas also. Wherever there was a method, there comes an open bracket called argument brackets, which is what I'm trying to do. Right? So if I correlate this with example with Python, I think you kind of got the concept. Just requires a little bit of practice, and I think this will be sorted. You'll understand what I'm talking about. Cool. Have I used group by here? Hi, Anna. Have I used group by here? Yes or no? Yes. I am trying to print group by for math score for only parents level of education. Hi, Anna. Agree or disagree? Look at this entire code. Okay. Beginning से end तक मैंने highlight कर दिया है. कौन से वाले code पे focus करना है? In this example that I have given you, can I add, apart from parental level of education, can I also add, I don't know, can I also add lunch? My first question to you is you will understand what I'm talking about. I have taken for all the people, okay, first of all, bad math score is a data frame. Agree, disagree? The bad math score is a data frame for all the students whose math score has come lesser than 50. Yes or no? Okay, that you understood. I am trying to calculate for all the people who scored terrible in mathematics. I want you to tell me how many of such people, dot count, how many of such people's parental level of education was what, right? I'm trying to map that. I'm trying to aggregate. I'm trying to add the information of math plus the parents' level of education together, right? And I'm getting the output. I'm trying to judge the output. Hi, Anna. So my people here, rather than taking only parental level of education, can I take parental level of education plus I can take lunch? Also, I can do this. And if I run this for high school people whose lunch were free, 24 people were there, whose math scores are worse. High school people whose lunch were free, 24 people were such. So did you understand what I did? I grouped high school, some degree, associate degree with lunch. And what is the count of those such particular people? Agree or disagree? So did you understand the concept of group by? Group by is letting me calculate what is the math score with respect to parents' level of education and lunch. Agree or disagree? So, okay, coming back to the example. Sir, what is group by in technical terms? Can I say group by is a method, okay, is a method that you use to split the data. To split the data in groups. And predominantly group by is used to help in understanding the count part of it. Most probably, group by functions are always used to help me understand the count, total number, something which can be aggregated, summed, yes or no, min, max, count, only that. But when it comes to pivot tables, what does pivot table tell us? Pivot table tell us, okay, pivot tables, what does pivot tables help us with? Pivot tables help us with looking at all data all at once. Like group by, pivot table is also an aggregate function. Yes or no? Group pivot tables are also aggregate function. But the difference between pivot table and aggregate functions isn't pivot table letting me look at everything at once, but there is no count, but there is min, max, sum, mean, all of that stuff. So pivot table is only for observing, but group by functions are always used for analysis. More hardcore analysis, you will always use group by methods. But whenever you just want to read the dimension or the flow of the data, you go with pivot tables. I hope you are understanding. See, if you did not understand the concept in SQL, me teaching you this now will be very hard. But try to grasp what I'm trying to say. Pivot tables are only used to observe multi-dimensional data at once. They have no advantage. They are used in nothing, nowhere, just to observe. But can I say group by data, for example, the number called 24, 24, 18, 15 will help me in the further analysis? Here I am observing that, group by is doing good, that's it. But here the number 24 actually makes sense in my further analysis. That is the difference between group by and pivot tables. Are we clear until here? Did you guys get the concept of it so far? Until here, are we clear so far? Are we clear until here? Okay, very, very good. So my people, tell me this. I'm going to ask you this question once again. The data set that I have given you and the functions that I have given you, will you try couple of more analysis from your end? Try doing weird stuff from your end to get more ideas, more knowledge? I have already given this file. I will give you this file. But now in today's class, we will focus on one of the most important concepts as a data analyst or a data scientist. And that thing is called data visualization. And we need to make sure that we learn all kind of data visualization tools. And in this class, we will be learning a tool called Matplotlib and we will be learning called Seaborn. Anybody in my class who had heard about this tool in the beginning? If you had not learned it, which is pretty much fine, not a problem. But the most important thing that you will learn in this class is, my people, whenever we paint, I'm not sure how many of you paint, but before we paint, is the first step buying a canvas? Yes or no? The first step in painting a paint is buying a canvas. This is my step number 1. The step number 2 is buying paints and brush. Agree or disagree? Once you buy paint and brush and you paint it, the third thing you do is sign the paint. Agree or disagree? See, I told you, if you are a painter, the first thing that you do is get the canvas. The second thing that we do is, sir, we get the paint and the brush. And the third thing that we do is sign our painting. Do you know what? Here, In data visualization, you would paint first, but without having the canvas, किस पे paint करोगे? हवा में paint करोगे? अगर आपके पास canvas ही नहीं है तो कहाँ paint करोगे? ठीक है, पेंट और ब्रश के साथ पेंटिंग कर दी ऐसा समझ लो, ठीक है? पेंट और ब्रश के साथ ही पेंटिंग हो गई, सेकंड स्टेप में समझ लो उसको, ठीक है? ज्यादा कंफ्यूजन नहीं होता है. In data visualization, the logic applies the same. Same logic applies. एक बात बताओ, for any data visualization tool to perform, don't we need data, which is step number 1? बिना data के there is no visualization. Just like without canvas there is no paint, without data there is no visualization, yes or no? So can I write it like this, my people? Step number 1. If you want to do data visualization in the future, make sure these 3 steps are always taken care of. What are these steps? Get the data. Step number 1. What is step number 2? Step number 2. What is step number 2? Make or decide your plot. Decide your plot. Step number 3. Okay, step number 3. BEAUTEFY, beautify. Okay, अब मैं आपको समझाता हूं ये कैसे काम करता है. How does this work? Okay, my people, can I say import matplotlib.pyplot as PLT? This is how you import matplotlib. Any confusion? According to the ground rule of always having data visualization, can I say get the data is step number 1? So get the data is step number 1. So if I say x equals to maybe 1, 2, 3, 4, 5, y equals to, I will say 10, 12, 13, 14, whatever, 15, 17, example. Can I say this is my data of x-axis versus y-axis? Do I need to teach you that in building a graph, you have x-axis and y-axis and z-axis? Do I need to teach you this, or do you already know that whenever you have to make a graph, you have an x-axis and a y-axis? Did I do the step 1 correctly? Did I do the step 1 correctly? Next thing is decide your plot. Okay. Step number 2 is decide your plot. See, I want to do a line chart. I want to make a line plot. So what I'm going to do, I'm going to say PLT, which is an alias name, dot plot. That's it. Pass x comma y. Done. Is my data taken and the decision of my plot taken? Step number 2 also done. The last thing is called beautification. BEAUTIFICAON. Beautification का मतलब है every plot in the world, will it not have a title? What is the name? The title of the plot. The title of the plot. What is the value of x-axis? What is the value of y-axis? So can I say this? Plot dot x label is what is the label in the x-axis? Let's say weeks. Okay. Plot dot plt dot y label on the y-axis. I will say profit in months. MON, profits in month. MONTHS, months. Plot dot title, and I'm going to give this title as a demo plot. And if I run this, did you just create the first chart of your career following the same concept? Did you get what I did? I'm gonna decrease the concept here of the code. I took the x-axis data and the y-axis data. I decided to make a simple line plot. Doing plot.plot is a line plot, and I gave it a title. I gave the value of x-axis as weeks. I gave the y-axis of profit in month. Are we clear that this is how the plotting is going to be done in your entire career? I have given you a blueprint for writing data visualization plots for your entire career. You follow this guideline, you never will go wrong. Agree? And is this code understood? Is this code understood by everybody? I have made a very simple plot so far. Any questions? I have made a plot. Any questions so far? Okay. Does this plot look good to you? If you look at it, do you call this as a very beautiful looking graph? No, right? You wouldn't call this plot as a beautiful looking graph, right? There is so much more to work on. Agree? There is so much more to work on, correct? We need to plot grids, legends, colors, plots, line style, line width, alphas, color schemas, all of that. We haven't added any of this. But for a beginner level understanding, are the 3 steps clear? Getting the canvas, deciding the canvas, signing the canvas, or getting the brush, painting it, then signing it. Same way, get the data, decide on what plot you want to do, get all the beautification, title, X label, Y label, and all of that stuff. Can I show you another example? But this time we will make our plot look very, very pretty, very, very nice. A data scientist, a data analyst level plot. Can we do it? Can I import matplotlib once again, my people? Acha, I'm going to zoom into this code. Will that be fine? Import matplotlib.pyplot as PLT. Any questions so far? All I have done is just imported matplotlib.pyplot as PLT. That's all I did, right? All this is doing is pretty much loading the matplotlib library and the sub-module called pyplot as a PLT. This is how you're going to be doing in your entire, how do I say this, in your entire career, okay, for matplotlib. Are we clear until here? Okay. I am importing it again so that my code looks neat. I don't need to import it, but I do it so that the code looks good. That's it. I hope you understood what I meant. I'm importing it again, not because I need it, but because the code will look neat. That's it. That's our only intention. Okay. The first step is to get the data. Yes or no? 6, 7. I have taken the value of X is this and the value of Y as 10, 12, 13, 15, 12, 17, and 18 or 8. 1, 2, 3, 4, 5, 6, and 7. Okay. Okay. What if we can insert value directly into the pot? You can do that. You can do that, but plots are not dynamically created. They need data first. Okay. All the data. There is no real-time plotting in matplotlib. Okay. Clearly, like, or really real-time plotting does not exist. You have to refresh the frame rate of the plots. We'll come to that. Okay. So, ask good question, by the way. But you can pass the data dynamically if you want, but you have to sort of rerun the cell once again. आपको ना वो cell वापस run करना पड़ेगा. I'll tell you how. So is this 7 value? 1, 2, 3, 4, 5, 6, 7. 7 value. Okay. Have I taken the data? Yes or no? The step 1 part of it, the data that is given to me, I have taken. Correct or not? Okay. But to make my plot look even neat, my people, when we do painting on canvas all will have size, right? I can buy a very big canvas. I can buy a very small canvas. I can make a very big plot. I can make a very small plot. Yes or no? So shouldn't we decide how big the plot should be? Shouldn't we have the control how big my graph should print? Yes or no? If you want to decide, DECIDE, decide the size of your plot. If you want to decide the size of your plot, okay, you have to do it like this. Figure equals to, I'm not talking about axis. I'm talking about axis will come when I'm doing subplots. I'm talking about the dimension of the plot. So example, plot.figure, okay, plot.figure, and inside this figure size is equal to 10 by 8. Do you see, my people? I have created a 1000 pixel by 800 pixel dimension data, like the graph. It's not showing it to you yet, but I have told matplotlib that whenever you print a graph for me, please don't let it be 1000 by 800 dimension. Are you understanding what I did here? I have decided what dimension my plot will be. After this, after I have decided what plot I need to do, should I create a basic line chart or a line plot? If I want to do a basic line plot, plot.plot. Inside this, I'm going to pass X, Y. Simple. Is my plot ready? Now to do beautification, can I copy the same thing from the top that I did here and copy and paste it here? And beautification, if I come and I paste it here and done. Do you see the plot is 10 by 8? So I'm going to make it 6 by 3. Do you see my plot size has decreased? It was initially giving me a larger plot, and now I made my plot look smaller. I shrunk it. We have reduced the dimension of the plot. In Excel also, we can do this with drag and drop. But here, did you see we made the plot smaller and more comparatively better than this plot here, which was giving in square dimensions, but I've taken it in a rectangular dimension the way I want it? Yes or no? Agree or disagree? Okay. Now let's make it beautiful. Okay. Now let's make it a little bit neater, one step at a time. The first thing that you need to make your graph good look with is the line itself. Do you see the line, the blue color line that is going up and down and then up and down and then up and down? Okay. If I want to make this line bigger, if I want to extend that line, where are we plotting the data? Which part of the code is plotting my data? Isn't it plot.plot, which is responsible for plotting my X and Y? This line plot.plot is responsible for plotting my data, right? X and Y together, it is making a line equation. Agree or disagree? Here, if I pass a variable called line width, LINEWIDTH, line width equals to 2. Do you see my line became larger or more fatter? The width of the line increased. If I make it line width equals to 4, did I make my line a little bit more darker or more fatter, more widthier? Okay. I'm going to keep it at 2 or 1.5 just to make sure that okay, let's keep it at 2. Okay. So did you understand that I made my line thicker? I can control that. Okay. After I have controlled the line, you can change the style of the line. So this is called line style equals to, if I take double quote and put a colon, did I convert my line into dotted lines? If I don't want dotted lines, I say dash dash. Is now my line dashed lines? You understood what I'm saying, right? You first control the width of the line. And my people, there is no restriction. You can first control the line style, then control the line width. The sequence and the order does not matter. First line width only has to come, then line style only has to come. In Matplotlib, order does not matter. If I run this, it will still give me the output. I hope you understood. Any order you give, the output will come, does not matter. So first, did we print the line style and line width? Any questions so far? Okay. Sir, I don't like the color of the line. So can I say color is equal to R? Did I convert R ka matlab red? You can also write red, by the way. I changed the line color as red. Did I change the color of my line to red? Hi, Anna. Okay. यहाँ पे red का LIGHTGREEN light green. Did you see I changed the color to light green? Can I teach you one more magic in Matplotlib? Okay. Do you know what is a hex code? Have you ever heard of something called hex code, color hex codes? Yeah. Suppose you like a color called, I don't know. Let's take a nice looking color, something yellowish, something. Yeah, let's take this color, right? Looks neat. Copy the hex code, come to the code, and in the light green part, paste it. Do you see that the line plots with the same hex code that you just selected? So you don't need to remember the name of the colors. You can even copy paste the hex code. It will do exactly the task. Now that my hex code is done, my people, can you see this line? The line, the green color line, you can even make it lighter or darker. How? There is a value called alpha. Alpha means make the color brighter or lighter. If I make an alpha of 0.2, did I make my line very, very bleak, very, very light? And the maximum value alpha can have is 1. Is this the maximum brightness alpha will give me? That's it. You cannot do 10. यहाँ पे 10 नहीं कर सकते, error आएगा. You cannot do 10 here. It will give you error. Alpha value can be between 0 to 1. But if I say 0.2, did I make my line chart very, very lighter? So did you understand? You can even control the the opacity of the color. The opacity of the color. Okay. So let's make alpha equals to 1. Any question in the alpha part? Now, my people, do you see these data points are all marked? Okay. We have marked the data points. So suppose if you put a data called marker, marker equals to O, all the data points are now plotted, whichever my points are x comma y, which is 1 comma 10, 2 comma 13, 3 comma 15, 4 comma 12, 5 comma 17, 6 comma, whatever it is, you can plot it. So did you understand this? You can play with the plot itself. Whenever we take a variable called fig and we do plot.figure, this fig is automatically referenced. You don't have to call it. It is referenced at the print time. Matlab, whenever you are making the print happen, that's when it is referenced. So you don't need to specifically use figure dot something. It is referenced via runtime. So I hope you got what I'm trying to say. We don't have to do it ever. Matlab, in Matplotlib, whenever we change the size of the canvas, we never need to reference image called fig. This is referenced at runtime. Okay. So we don't need to do that. But when we do subplots, then we need to reference it. But I'll tell you how to do that. Let's go one step at a time. Okay. I'll tell you how to reference that. When we decide the size of the canvas, no need to reference it. But when we do subplots, then we need to reference it. We'll come to that in a second. Okay. Are we clear with this plot so far? We made a lot of changes in my particular code. No change, no confusion so far. Okay. I'm going to write one more part called grid. Have you ever heard of something called grid? Example, plot.grid, and I'm passing something called true. क्या मेरे ग्राफ के पीछे एक ग्रिड बन गया? क्या मेरे ग्राफ के पीछे एक ग्रिड बना? Yes or no? This code looks neater. The graph started to look a little neater, right? Yes or no? Okay. But do you see which color is my grid? My grid is of what color? Is it gray, grayish, black? Sort of like that. If I take the color is equal to this, observe carefully. If I take the color equals to the grid, in the beside of the grid, I will go to hex color again, actually go back, and let's make our grid color yellow. Okay, just for fun, my people, just for fun. I don't mean by any way to write a code like this, but if I run this, is my grid now converted to a different color? So are we able to see the color change in the grid? In the background, it was first black and now it is yellow. Acha. If I want to make the line style of the grid not proper lines, but I want the line style to be like this, did I now make my grid dotted? Initially, it was a straight line, but did I now make my point? So are you not using the same arguments again and again in the other? Same arguments are being used in different methods. That's it. I am able to plot the grid now, and in the grid, I was able to make a dotted line. In the dotted line, can I not also pass alpha into 0.4? So did you see my grid become a little more lighter in the background? This is all Matplotlib is. Yehi game hai, bas. That's it. See, should you focus on beautification of the code first, or should you plot the basic code? You can do beautify later. Always code first, plot first. Get the idea about the code first. Beautification is at the very end. When you have even the time, beautification can happen then. But first thing is plotting the data. As a data scientist, you need good looking, understandable graphs. So first thing you need to do is plot it and not beautify it. Are we clear? Over the period of some time, over certain experience, you will realize that you have now started to plot and beautify at the same time. So somebody who is a senior person will be able to write what line style they want, what line width they want, what will look good on the data, because they have done so many graphs in their life. So after some time, there will come a time where you are doing beautification and writing the code at the same time. But as a beginner, I would ask you to take these things separately. That's why I first plotted the data and now I'm beautifying it. Are you clear? I hope you understood what I meant by this. Did you understand the concept of grid? Yes or no? Can I assume you understood what this plot.grid did? from all the way to matplotlib, the whole thing, from line number 1 to getting the data, to deciding what figure size you want of the plot, to creating a basic line plot, changing things inside it, writing the beautification part of X label, Y label, title, and all of that, and doing the plot.grid. Are we clear until here? This part is clear. Nobody's having any questions in this, right? In the entire data, everything I understood. But there is one thing that is missing. What is that one thing? Sir, the data that you have done, for every point, can I still get the output that this is 1, 10, this is 2, 13, this is 3, 15, like that? You want annotations on the plot. Agree or disagree? These are called annotations. I want my data points to be annotated. Sir, I want this particular, the reason I want annotations is because for every data point, I need to understand what was my x-axis, what was my y-axis, right? This is what pretty much people want. So after I'm done with my plot.grid, I will annotate it, okay? In matplotlib, there is a beautiful annotation method, but it does not work directly. The reason it cannot work directly is how many data point of x's and y's do we have here? The value of x and value of y, 8 points. Do we have considerably 8 data points in our value? Yes or no? Correct or not? Okay. So for I, in range of length of x, so can I say this is the place where my loop is running the number of times, exactly the number of times where I have data? If I have 8 data points, my loop will run 8 times. No confusion here. If my value of x is 8, it will run 8 times. When I say for I in range of length of x, am I looping via its index or looping via its value? I'm looping via index, right? Because for I in range of length of x. So this is via index, right? Okay. You have to call a method called plot.annotate. Okay. You have to use f double string. F of double string. Inside this, put a small bracket. Okay. Inside the small bracket, put a placeholder. In the placeholder, don't you want it x of I variables, all the values of x of I to be run? All the values of x, suppose 1, 2, 3, 4, 5. Whenever you're doing the looping, I want the x of I value to show up, that is 1 to pop up. So did you understand the concept of this placeholder? Now that you've done it for x, don't you need to do it for y? Y of I. So I want both the values of x of I and y of I. After this particular thing in the double quote or single quote, you come out of the bracket. What you need to pass inside this? The value of x of I, comma, the value of y of I. So did you understand? I'm taking the value of x of I, I'm taking the value of y of I, and I'm passing it inside this. After this, you have to pass something. Okay, ab na yahan pe aapko thoda, I'll try to tell you how this particular thing works. When you annotate, you need to tell how do you want it to be offset. Offset ka matlab hai, I'll tell you. Whenever, okay, pehle to isko na 1 minute run karta hai. Is the data annotated now? 3, 15, 4, 13, 10, 15, whatever the values that we wanted. But is it overlapping with my data? Is it overlapping on my graph itself? किसी किसी के लाइन के ऊपर से जा रहा है, नीचे से जा रहा है. तो right, जैसे 2, 13, it is crossing over the point, right? So I need to fix that overlapping, yes or no? I hope you understood. तो हमको offset करना पड़ता है. Do you now understand the meaning of offset? Offset meaning write the plot in such a way that it will not have any overlapping effect, any overlaying effect. I hope, how do I? So if there is a line going, if there is a line happening, or if there is a line on a graph and you don't want the point to be exactly on top of it, when you say offset, do you not say that I'm basically trying to make sure that the print statements or the way it is written is signed kind of like offsetted from a specific point? Okay. In order to do that, you have to pass something called as a, what was it called? Give me 1 second, my people. Give me 1 second. Plot.annotate. Give me 1 second. I don't know what it is called. It's a text chords. It's called text chords. Correct. What do we call this? Text chords. text quads equal to, I think there is something called offset text quads kya tha? Go 1 second, guys. Because I need to remember. Offset points. Yes, it's called offset points. Copy it, paste it here. Offset points. Please tell me if it works. Oh yeah, right. Do you see the points move away from bottom to the top? Right? It's not going to fix the overlapping problem completely. Let me tell you this very frankly, but it's going to move the point a little bleaker, matlab to the side and all of that stuff. You can do much more, my people. I'll show you. Dekho. You can also do, what was the thing called as the, yeah, I think this is the function. I think this is the max we can do. XY text equal to none. Yeah, I don't need any text on XY. ठीक है. This is fine. I don't need any other value. So see, I offsetted the value to a slight overlapping, but it does not completely solve the problem of overlapping. Okay. So this is what you can do to annotate the data. But did you understand this point of annotation? Annotation, no matter which plot you do, you have to loop through it. No escaping. अगर annotation करना है, तो loop करना पड़ेगा. No escaping that. Okay, now, are we clear with this code on how to make this graph happen? Does anybody have any more confusion in this code? If not, can I proceed forward with some more fascinating stuff? Can we do some nice looking graphs? Can we make some more graphs? Okay. I'm sorry, I forgot to tell you one thing before I wanted to start this entire thing again, okay? Okay, figure size, no problem. Do you see this code is equal to, this line of code where figure equals to plot.figure and figure size equals to 6/3. If I make this 1/2, look what happens to my graph, okay? Look what happens to the graph. Did it become 1/2, 100/200? Did you understand? Figure size is used to make the dimension of the data. For example, if I make it 100/200, look what happens. Wait, let it load. It's going to take some time. Did you make a graph that looks such huge graph? Do you see? Do you see? The graph has become so large. 100,000 or, 110,000 divided by 20,000 it became. So see, this is nothing but the dimension of the graph. So 6/4, right? So this is the data. 6 is going to be your 6 times 100 becomes your pixel length for your your width of the graph, and 4 becomes the length of the graph. I hope you understood what is this. It's the length by breadth, like breadth by length. Are we clear? Yeah. Okay. Now, my people, I have a small question I want to ask you. Have you ever heard about something called subplots? Have you ever heard of a concept called subplot? Never heard of it. Okay. Have you ever seen a graph right next to each other? Two graphs next to next? Or two graphs bottom to each other? These both graphs are representing knowledge about the same topic or maybe different topics, but they are next to each other. These are called subplots. What do we call this? Subplots. Now, I'm going to teach you how to make a subplot, because a person in our question asked a very good interview. Sir, we don't reference figure. We don't reference, okay. What he meant by that is, my people, is there a variable called FIG? Is there a variable called FIG in my code? Yes or no? If I change this FIG to Rudra, should it run the code or not? If I run this, did it still run the code? That means whatever variable I give here, it does not matter, right? Whatever variable I give, it does not matter. Whatever figure size I give, that runs. But I am not using this figure anywhere. Have I used this figure dot anywhere in the code? Have I used the concept of figure dot anywhere in the code? You don't need to reference it. The reason is Matplotlib wants you to write this code. But in Python, are you just allowed to write this code without any variable? Does Python allow this? Without giving it a static variable naming, Does Python allow you to do it? It is not possible. So in order for this to happen, we need to give it a dummy variable name. Do you know in Python you can also give dummy variables? Do you know this? No name variables. How do you do it? Do you know? It's called underscore. Am I able to run the output? I'll show you. Underscore equals to 5. Did it give me any error? Underscore plus underscore plus 1. What is the output? My people, what is the answer to this? Underscore plus 1. What is the output? 11. Because the value of underscore is 5, na? 5 plus 5 is 10 plus 1, 11. Yes or no? Did you get it? You change the variable. Now, if I print only underscore, what is the output of underscore? It is 11. It's 5 because you gave 5. Did you understand what I'm trying to say? See, in Python, if you don't want a variable to be named, you can pass it like this. For I in, okay, I'll show you. You guys have no list comprehensions. Do you guys know list comprehension? So for example, val equals to I for I in range of 10. What will be the value of val? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, correct? Agree or disagree? If I change this I into underscore, did it give me any answer or did it change something? Control X, Control V, tell, okay, and I'm gonna change it. If I take for I in underscore in range of, is it giving me the same output again? For I in range of 0, 1, 2, 3, 4. If I change this to underscore, it says not defined. So you cannot define underscore wherever you want. Okay. Underscore, okay, first of all, this is the right syntax. Underscore can only be defined under conditions where you have no logic happening inside it. So this is an underscore. Is my code still running? Hi, Anna. Any questions, any confusions? Even if you don't write it in any other variable, you can do this in Python. Just wanted to let you know, but I'm going to change it to figure, okay? Control Z, FIG. Okay, no problem. Should we do subplots? Should we learn a little bit more about subplots? Let's do that. Subplots. Now, listen to me very carefully, and then you will start understanding things well. My people, suppose if I have a plot like this, plot number 1, plot number 2, and plot number 3. My people, how many rows and how many columns do I have in this? How many rows? Only one row, correct? Row number 1 is this, yes or no? But how many column? Column number 1, column number 2, and column number 3. So if I want a plot like this, I need to pass 1, 3, yes or no? If I want a plot looking like this, I have to pass 1, 3. But if I have a plot that looks like this, how many rows are there? 2 rows. How many column? So do I need to pass 2, 1 is able to explain the code that look, I want one bottom, another, yes or no? And I can control the length and the width using the figure size, the one that I told you. So I can control how long I can make the graph, yes or no? Okay. So tell me, for any data visualization code, is the first thing the import statement? So import matplotlib. Import matplotlib. Now you don't have to import it again. I am doing it so that the code looks beautiful. You don't have to do it. .pyplot as PLT. Yes or no? Is this something that I can assume is correct? This is the first import statement of my code. Any questions? For simplicity reasons, I'm also going to import NumPy and I'll tell you why. NumPy is NP. So have I imported NumPy also? Matplotlib and NumPy? Okay. How many months do we have in a year? 12. Number of months is equal to 12. Is it okay if I write this? Is it okay if I say number of months in a year is 12? Revenue of a company, the revenue of a company is np.random. In NumPy, we have a method called randint. What it does is, between some number to some number, it generates a random number. So between 12,000 rupees or to 25,000 rupees, I'm generating a random number. But how many random numbers do I want to generate? I want exactly number of months. So if I print revenue, did it generate 12 random numbers in my array? Was I able to generate 20 random numbers in my array? Yes or no? Are we clear until here? I'm able to generate 12. So can I take the same code, copy it and paste it, and instead of taking revenue, we can take sales, we can take expenses equals to np.random.in, and rather than taking this, I will take between 5,000 to 19,000. Okay? Can I say that I have two arrays of size 12, revenue and expenses already made? I have no problem. My data I generated on my own. So can I say this is the data that the code will be dependent on? Is this clear? Okay. The next thing that you need to do is define the size of your plot. Yes or no? How long you want the plot? How big you want the plot? What kind of plots do you want? So here you need to decide on the size of the plot, on size of plots, on SIZE, size of plots. But whenever you're doing subplotting, you have to write a code like this: figure comma, take a bracket, AX1 comma AX2, and I will tell you what this is. Just give me 1 second, I will be able to explain. Equals to plot dot, I want to do subplots. So you have to call subplots. You cannot escape. Because you want to do subplots, you have to call subplots. Now we want the plot to be 2, 1. So I'm going to pass 2, 1, comma. Inside this, you can pass figure size. Okay, you can pass FIG, SIZE, figure size equal to, in a bracket, say 6, 5 or 10, 8 or whatever. 10, 8 le lo aap. No problem. 10, 8. So see, my people, I am creating two subplot. One plot is like this and the other plot is like this. But in order to put the data in this plot, don't I need to name the plot? To tell Python that this is plot number 1 and this is plot number 2. Hi, Anna. This plot will be called AX1 and this plot will be called AX2. Did you now understand why have I taken AX1 and AX2? Because I want Python to know that, look, AX1 means I want my data to be plotted in the first plot, and AX2 means I want my data to be plotted in the second plot. Are you understanding what I'm trying to say? When you do subplots, you need to pass the names of those plots also. I have passed the name as AX1 and AX2. You can pass whatever you want, but the names have to be passed. Are you understanding? Until here, we are clear, right? The reason why I have passed AX1 and AX2 is because I want to name the plot, because Python don't know which plot do you want. So can I say that my data is done, my size of the plots is done. Now I will plot the plot number 1. Okay, so plot number 1. My people, what is the name of plot number 1? AX1 dot. Now you will not call plot dot. See, in the above code, haven't we called plot dot grid, plot dot title, plot dot y label, plot dot x label, plot dot plot? You can't do this in subplot. In subplot, you have to call the name of the subplot and call the method plot. So can I say I want to plot revenue? I want to plot revenue. I can make the code look better. Like for example, marker, marker, marker equals to O, line style equals to something. So for example, line style equals to, let's keep dash line style, line width is equal to 1.5. I'm going to keep it at that. Alpha, I'm going to keep it at 1. I will not change anything with the alpha. I will definitely change the color, and color, let's make it a nice looking color. So let's take a bright color, like a dark color that will look good, right? So give me 1 second. Let's take a maroon. This maroon looks good. Copy it and paste it here, right? So I've taken a very dark color, right? Here you can pass label. So label equals to revenue plot, revenue data. Okay. I'll explain what this label is. Now that I've plotted the data, my people, AX1, Don't AX1 needs its own X label and Y label? Agree or disagree? Doesn't my first plot need its own X label and Y label? For subplots, you need to call AX1 dot control Z. X control V. So I want AX1 dot. Now, if you want to call X label, you can't call X label directly. In subplots, you have to pass something called set underscore X label. Okay. So give me 1 second. Set underscore, give me 1 second, control X, run, paste, set underscore X label. So when you do dot set X label, what do you want to say? So let's say these are the number of months. And what was Y? AX1 dot set underscore Y label, YALEBEL label, revenue in months. Revenue in months. We can say X label, Y label. You can even set independent plots its own title. AX1 dot set underscore TITLE title, and I will say revenue demo, revenue graph. Plot, set X label, set Y label, set title. We are pretty much done here. But do you remember in every code we did grid? In every plot, we created grid. Same way, AX1 dot grid. That's all you have to pass. And inside this, you can pass something like true. And if you want to change its line style, it's alpha. So suppose line style is equal to colon like this. And here you have to pass something called AX1.legend, which I'm not going to teach you now. It will take some time. This is plot number 1 done. If I run this, can you see my first plot is done? But my second plot, because I have not written anything, it does not show. Let's make it 8 ke badle, let's make it 5. Do you understand what's happening here, my people? I have only called axis number 1. So only axis number 1 plot is being shown. Correct or not? Axis number 2 is not written so far, so it is not being shown. So can I copy paste the same thing, whole code, and I put it in the bottom and say plot number 2? And instead of AX1, I need to change everything to AX2. Yes or no? But change revenue ke badle, this is expense. And this is expense graph. And I change the revenue to expenses. And now I need to change the color. So let's also take a beautiful looking color for this. Let's take red ke saath kya jata hai? Let's take turquoise. Ye le lete hain. This sort of looks good. Copy and change this color to this. I hate this copy paste thing. Copy and paste. Yeah. Do you see, my people? I have now plotted a revenue graph and an expense graph. Hi, Anna. Okay. But do you see one problem in the graph? Yahan pe the expense graph and month is being overlapped with the year, right? 6 expense, it's being overlapped. So yahan pe isko expense data bol dete hain, theek hai? Expense data. See, in matplotlib, in subplots, if you want to fix that, all you have to do is plot.titleLayout. You have to call something called plot.titleLayout, and it's a callable function. Now, is it fixed, my people? Is anything overlapping? Are all the titles proper, number proper, set proper, distance proper between each other? You're understanding what I'm trying to say? Everything is proper. My people, have a look what I'm trying to do, okay? In this code above, see, the previous code I'm telling you, this line must be telling me some information, right? This line must be giving me some information, right? You can pass label here directly. Label is equal to, this is profit graph, profit line. So see, here I have written called label equals to profit line. In the code, if I do plot.legend, look what happens. Do you see this line is representing what information just popped up here? Profit line. This line is representing what in the data, whatever label you give in your plot, that exact same code comes here in the top. Are you understanding? That exact part of the code came up. Hi, Anna. You can change this. For example, plot.legend location equals to upper left. Did my upper left, upper right ले लेता है. Did I change my from upper left to upper right, bottom left, bottom right? You're understanding what I'm trying to say. You can even change the legend's location. So if you put location equals to best, matplotlib will decide the best location and it will automatically put it. You don't have to worry about it. Just say location equals to best. That's it, done. Are we clear? Did this become clear? So in my code, can I also put ax1.legend in my code, legend? And I make this a callable function because legend is a callable function. ax1.legend, right? If I make it callable, I copy the whole thing and I paste it here. Does it not tell me that revenue data kya hai? And here, yahan pe maine label diya hai expense data. Oh, this is ax2.legend. Do you see that I'm getting the best location? Wherever the data is not overlapping, it is telling me. I hope you got what I'm trying to say, my people. You can do much more with it. I mean, because somebody had asked me for subplot, did you not reference AX1 and AX2, but you still don't reference figure? Did you understand what I'm trying to say? Here, figure and AX1, AX2, you are not referencing figure, but you only reference the plot AX1 and AX2. That's all you reference. So, did you kind of get the concept what I'm trying to say? You are not referencing the variables f figure itself, but you are only referencing the number. This is xticks. You can change this also. I'll show you how to do that also. Here, matplotlib automatically decided that to make the graph beautiful looking, I will only give a difference of 2 numbers at a time. I hope you understood. There are 12 data points here. It's not like it's jumped anything. This is called xticks. Okay. मैं इसको भी समझाता हूँ आपको. Allow me 1 second. इसको xticks, yticks बोलता है. We'll come to that. I'm going to change this line dash for this to colon so that you guys are able to distinguish between them. Did you understand how to make subplots? Did you know how to reference names of the plot? Axis 1 dot something, axis 2 dot something, figure size हमने यहाँ पे डाल दिया है, figure size of 10,5. So is it not very logical that matplotlib is very, very simple, my people? It's not a very complicated technology or tool. I mean, with a little bit of practice with pandas, won't you be able to make beautiful looking, better looking graphs only using matplotlib? Okay, let me ask you one question. AX1 and AX2. In this part of the code, am I referencing? Okay, in this, just the highlighted part of the code, what am I referencing? What is my actual reference point? What am I doing here? This code does what? In AX1, what are you plotting? What are you referencing here? What is your main goal here? Your aim is to plot data on graph number 1, correct? Am I assuming that your understanding is correct? That you are referencing the first plot by the name AX1 and you're passing something called revenue here to pass the data. And the same thing will happen with AX2, right? The same exact thing will happen to AX2. Nothing will change. Agree or disagree? Are we clear with this particular part? Okay. Now, what else do I need to teach you in this part? Okay. Do you see the title here? Revenue graph. Do you see the title in the code? Where have I written the title? Which line decides the title? Or which line decides the title? AX1 dot, which line decides the title? Set title. Inside the set title, if I come in the side, if I come as an argument and change the font, I think size equals to, I don't know if the variable is correct. Yeah. Did I make the title? बहुत ही बड़ा हो गया यार. Did I make the title bold? Bold मतलब बड़ा. Did I make it larger? Did I make the title of my graph larger? I want the revenue graph to be of color, suppose COLOR. 1 minute. Color is मेरे को तो red ही पता है यार, red. Did I make the title graph red? If I copy paste the whole thing in the set label, and if I paste exact same thing in your X label, did you see the X label is also changed? Sorry, Y label is also changed. Okay, but I hope you understood what I'm trying to say. Everything is changeable, everything is customizable. Matlab, the aim of this lecture is, look, anything can change. All you have to remember is where to change it. That's it. You're pretty much done. Anything and everything is customizable. In Matplotlib, you can make a graph that looks like incredibly funny, incredibly good looking, incredibly cute looking. It's up to you. Are we clear until here? Did you guys learn something of importance today in my class? Did you learn of something importance today? I taught you 3 rules of data visualization that I personally follow. When I manage a team of my own, I always ask them to follow these rules. पहले data दिखाओ, दूसरा plot दिखाओ, तीसरा मुझे बताओ beautification कैसे करना है. That's it. Are we clear?
Just a quick info, guys. Intellipaat offers data analytics course in collaboration with IIT and Pavatak. Through this course, you will master Power BI, data modeling, data mining, and much more from the IIT Madras faculty and industry expert. With this course, we have already helped thousands of professionals in successful career transition. You can check out the testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your careers to a new height. So visit the course page link given in the description and take the first step towards the career in the field of data analytics.
So anyways, we started with NumPy. We went ahead with Pandas. We are currently at data visualization. I taught you an example called Matplotlib, and I will of course sort of take you guys through Seaborn. What I want you guys to remember, and I also wanted to tell you this since a long time. Look, this is how Matplotlib looks like for all of you. Okay, I want to give you guys an idea. See, Matplotlib, okay, sort of looks like this. I want to show you documentation of it, in case if you want to work on Matplotlib in the future, right? Sir, how is this going to work, and what kind of different things are we going to have? So, for example, if you have Matplotlib, okay, there is a small function. For example, if you see here, plot types, right? So you can see plot of x comma y, which is a line plot, scatter plot, bar plot, stem plot, stair plot, stack plot, fill between, right, which is called as an area plot, right? Histograms for statistical distributions. Then you have gridded data. Gridded data is basically used to monitor density based plots, right? Irregular gridded plots also monitor the density without the directions. You have volumetric plots, right? So many different kind of plots, and these are not just done. I'm going to show you. See, if you have pairwise plots, statistical plots, gridded plots, and see you have IM show, p color mesh, barbs, quivers, stream plot, and if I go down, you have this, and then you have 3D volumetric plots. So see, there are so many methods in Matplotlib, and these are not the ones, okay? There are so many to be covered. The point that I'm trying to make is, okay, practically speaking, the only best way to learn things like Matplotlib, okay, Matplotlib, or specifically a library called Seaborn, is by actually doing practice, right? Because all the methods that are used, or all the graphs that are covered in data visualization cannot be covered, right? This is simply humanly not possible. So the solution for that is, as many plots you can do practically through multiple kinds of data in your career, you should do it. This is only this one topic, okay, where you have so much to cover and so little that can be taught in a certain segment of time. So this is to be implemented on as many kind of data, as many plots you do, that will become better. Now, the second library that I'm going to tell you, Seaborn, okay, Seaborn, right? The difference between this library Matplot and the difference between Seaborn is Matplotlib is a very old yet a very studied and a very sturdy library, right? Apart from this, you have another library called Seaborn. Now, Seaborn is different from Matplotlib. The reason is Seaborn is a very rich library in manipulation or changes. So, for example, compared to Matplotlib, the amount of graphs that we have on Seaborn library is incredibly large. What do I mean by large is what you can achieve with Seaborn, certain things are not achievable with Matplotlib also, because Matplotlib can only do some basic kind of graph plotting. I'll give an example. My people, tell me one thing. Have you ever heard of something called as a bar plot? You have heard of something called line plot. Agree or disagree? Very nice. Okay. You must have heard of something called pie chart. Okay. I'm not sure if you've heard of this, but area plot or area chart. Okay. We have also something called violin plot. People who do stocks and shares, they have heard of something called candle chart or candle plot. Right. So the concept I'm trying to tell you is these are all the basic kind of plots that you must have done in your data visualization, correct? For example, let me ask you a very simple question. In what conditions do you plot a bar plot? What do why do you use bar plot to represent what? Can I say frequency? For example, how many males and how many females? To represent frequency of a category, don't we implement bar plot? Why do we implement a line plot? A line plot is implemented to show trend of a data, right? Line can go up and line can go down. Can I say there is an upward trend in the data and there is a downward trend in the data? So basically, to represent some kind of a trend analytics, we always use a line plot. Why do we use pie chart? To show distribution, right? For example, if you have a pie, 21% goes there, 27% goes there, and 45% goes here. Example. So our 100% ratio, to represent the distribution of something, we represent the pie chart, right? We sort of kind of show about a pie chart. Sir, what about area plot? Area plot is used for competitor analysis. Let me show you. Have you ever seen a plot like this? Area plot. So have a look at this. Do you see this particular plot in front of you? Is this visible for you? So if you see between 2001, 2002, 2003, 2004, between multiple years, can you do comparative analysis? Comparative analysis meaning, can I check all the data at once and see which is working well? Which year was the best for the company in terms of growth, and also for January, February, March? Compare this example. You have something called compact disk. Nowadays, you guys don't know, but in our era, we have worked on CDs. If you guys know, I'm sure you guys have also sort of worked on an era where you had a Walkman and you had a CD, and then you used to burn the CD, and there were a couple of CDs which you could reburn. Reburning means you can upload a song here and then you can share it with your friends, and they have to have a cassette player. They would put the CD in and they would work, right? So this graph shows which particular type of streaming technology was very largely used. So in 1973, there was something called 8-track, right? Then came vinyl. Vinyl was this black color thing which ran, a song. Then you had cassette player coming in. Then there was compact disc. Then there was other kind of technology. Then there was downloading data on internet. And then there was streaming. So do you see, out of all the technology, which technology was abused or used a lot? Which technology clearly you see had a long or the largest growth among all the technology? Can I say CDs? Among all the data, which technology had the highest utilization in year? Can I also say compact disc? Between 1988 to 2013 to 2017, compact disc stayed. Do you understand what I mean by area graph to do comparative analysis? Are you understanding what I'm trying to say? For example, okay, let's take an example. Sir, how do we do an area plot in specifically Matplotlib? And sir, can all of this be done using, using all these basic graphs, the ones that you have written? Can we do that in Seaborn? The answer is yes. As long as the graphs are very, very basic, and these are basic plots like bar plot, line plot, pie chart, area plot, violin plot, candle chart, right? Not specifically candle chart, but all the 4 plots, all the above plots, it's very much easily possible to be done in Matplotlib. But sir, what about Seaborn? Seaborn can do complicated graphs. I'll come to that topic, but let's address that. So sir, for example, if I want to implement an area plot, okay, now that you have intrigued my interest and piqued my interest. So can I say import matplotlib? Okay, so for example, matplotlib.pyplot as plt. I have already told you that pyplot is what, my people? What is this technically called as pyplot? Pyplot is technically called as what? Is called as a submodule. What do you call this dot pyplot as? Submodule. What do you call this plt as? What is plt technically called as? It's called as an alias. Have you not studied an alias? You call the table as something in SQL, your table as main table, like this. Have you not written like this in your SQL? You have some query in the beginning, something from something query table as main table. You have done this in your SQL, right? Same exact thing. Now, let's take one example. For an area plot to work, or have a look at this idea of area plot, the y-axis can vary, right? But the x-axis is constantly, what do you say? It remains constant, correct? Only y changes because multiple graphs has to come, right? Your x-axis is same, but the y's are multiple. So let's say 1, 2, 3, 4, 5. Okay. Let's say x ke badle, I'm saying weeks or weeks. Okay. I'll say 6, 7, 8, 9, 10. Example. This is the data for weeks. Let's say I have a company called company number 1 is equal to, I'm doing an analysis of 2 different competitor companies and I want to measure the profit that they have made. So say 10 CR, okay, and the other company made 12 CR, right? 15 crores per profit, 16 crores in that week, 18, and then let's say 16, let's say 17, and let's say 18 or 19, right? So do we have 10 values? 1, 2, 3, 4, 5, 6, 7, 8. I need 2 more. Let's say 15 and let's say 17, right? So this is company number 1. Let's say company number 2 is going to be very, very simple. So let's say they did not make much. They said 9, they made 12, they made 16, and let's say 15, 14, or whatever it is, 12, 9, right? 14 and 15. How many have we done? 1, 2, 3, 4, 5, 6, 7, 8, 9, and then let's add one more to say 15, right? So I hope this is done. Let's quickly validate. Length of comp 2 is how much? Give me 10. Change this to comp 1. Also change it to comp 1. Also 10. Okay. So I have taken weeks data and comps data. I told you in Matplotlib, you have to start with creating a canvas. This part is nothing but the creation of your data, right? This is where your data lies in. But once the data pops in, I told you the second thing you need to look at is the size of your canvas, okay? Is the size of your canvas. So now size of my canvas could be plot.figure. If I just do plot.figure, not figure text, figure, right? Plot.figure. And inside this figure, I pass in another parameter called figure size equals to, now I can give it 9, 4 or 9, 5, whatever it is, right? This is me defining my figure. The next plot is called actually plotting. So what you need to do in order to create an area plot is just call a method called fill between, right? So you have something called fill between. First, pass in the weeks data because this is my x-axis and company 1. The one company that you're doing competitor analysis on, you have to pass that, right? And now you can do multiple optimizations here. Like for example, color. What kind of color do you want in a graph? Let's do one thing. Let's go to hex code online, okay? And let's click on this, right? Not this, hex color code online. Okay, let's say we are here, right? I want to choose a very mild color. So I'm going to go in the bottom and maybe choose like a very mild bluish tint color. So I'm going to sort of pick this, okay? Something lighter. So I'm going to pick this. I'm going to copy this. I'm going to come here. I'm going to put a hashtag and paste it here, right? And the label I want to give this particular thing is, let's say company number 1 ka hum naam de dete hain. This is Google, right? This is for a company called Google. Okay, this is plot number 1. And if I run this, okay, no answer. It gave me an error. What was the error? It says, let's look at the error. It says, let's come to the bottom. Yeah, got an, oh, we gave the spelling wrong. Label, right? We always make this mistake. I end up making a mistake. So see, I have a graph created, sort of like a one which covers the entire area of the chart. Okay, sort of like an area of the chart. But this is only graph number one that we have covered. We don't have graph number two, which we have done so far. So how do we do it? Very simple. You just copy paste the same thing. Okay, you paste it in the bottom line, but instead of company one, mention company two, and this time select another color, sort of like a darker color, so that you can sort of mask it. So I'm just gonna copy it. I'm just gonna come here. I'm going to change this particular thing and I'm gonna paste it. So now if I run this, so I have two graphs now. I have graph number one, which is company number one. I have graph number two, which is company number two. But again, my plots are not done. The reason is I have done no beautification, no labeling. So plot.x label. So first of all, on your X part, what data have you mentioned? So sir, this is weeks data, right? Or months data or year data. Plot dot, you have also something called Y label. Inside Y label, can I say comparative amount? So we can say amount in CR, crores, right? If you come down, you say plot dot title. In this particular chart of title, I'm just going to say area plot demo, for example, area plot demo, right? If you come to the bottom, you have plot dot legend. Inside this legend, you can say companies or competitor or companies analysis, example, comparative analysis, right? Comparative analysis, right? You come here and then you say you're done. Because you've also mentioned labels, just say plot.grid. Inside this, pass the value true and just say plot.legend, right? Once you're done with this, you run it, you get your legends, you get your grid, and you get the answer. If you want to make this particular graph overlapping, all you have to do is just pass the value of alpha to 0.5 and come here and pass alpha equals to 0.5. And if you see this, I can see through the graphs, right? Like these graphs have become sort of transparent on each other. So see, now I can do comparative analysis between two companies. That company number one is Google and the other company is called Microsoft, right? So see, you have Microsoft. So if you see this, I have a company data called the blue color company is Google and the yellow color or the red color company is called Microsoft, right? So you see, we have blue color data representing here. We have, red color, red graphs representing here. We have a plot. We have put the grid. If you want your grid to be very, very mild, pass the alpha on the grid to be 0.2. So you see your grid has become very, very lighter. So it is as per what we had learned in the last class that the only thing in Matplotlib that matters what you actually work on is something called dot fill between. And for people who are asking me what is legend, I think that's a very good question you're asking me. See, when you ran this particular data, right, this particular idea that you ran without this, the whole thing, right? Give me 1 second. I'm also going to remove what is the label. Okay, so this must be a junk value, but okay, we have to ignore this. So my people, legend is something, when I plot this graph, this table on the right hand side is not telling me this blue color graph is doing what and this red color graph is representing what. So when you do plot.legend and run it, whatever label you have given here, right? Google and label Microsoft, this particular thing runs and it shows up here. That is what is called legend, my people, right? In the data, in the graph, you need to, at the end of the day, represent what are you learning, right? What exactly is this graph representing? So in order to do that, you need to put something called plot.legend. Are we clear? This is what's called legend, okay? And remember one thing, in legend, you can pass the location. Location equal to, how do you pass? Location equals to best. If you say location equals to best, it will always show up wherever you have no restrictions on a graph, right? It will not overlap anything. But if you say upper left, where is the graph? Where is the legend popping up now? Where is the whole thing popping up? Are you understanding what I'm trying to say? You can also put it in the bottom right, bottom left, top right, top left. There's also middle, by the way. So many things, so many things. The idea here is not for the legend, but to show you guys an idea about how this particular thing works. So can I say that Matplotlib plots very basic kind of graph? I'll also show you an example of one more plot. Allow me to do that example. My people, have you ever heard of something called bar plots? Have you ever heard of concepts of bar plots? tell me one thing. We have learned something called bar plots, and these are super important while working on specifically talking about bar plots, right? Matplotlib is kind of basic, right? And this is super, super important, right? Now, why do we do this? Why do we have this example, right? For bar plots, bar plots can do a lot of changes for you. For example, what do I mean by that? Example, let's take one simple example. Let's say you have month data. Okay, month, month data. So can I say, my people, months are categories like January. I can have another month called February. I can have another month called March, right? I'll take another month called April, APR, okay, April. So I have a data called month. Here for bar plot, to run bar plot, I'm taking my x-axis data called month data, or I'm just going to simply write data, D-A-T-A, data, right? I have month data. After month, let's say if this data is for a bakeries company, so I will say the number of or the amounts of cake sold. So I will say by the end of January, I was able to sell 140, pieces of cake, to 200 pieces of cake, 400 pieces of cake, 430 pieces of cake. Example, four different values, right? This is my month data and my cake sold data, right? If I want to plot just a simple bar plot, right, in Matplotlib, just call plot.bar and your job is done. I'm just going to pass month. I'm just going to pass cakes sold. I'm just going to pass something called what color do I have. So for example, COLOR, okay, COLOR. I'm just going to make it sky blue. Okay, I'm going to say sky blue. If this color exists, I'm not sure. We'll see. Then we have all the beautification part of it, all the labeling part of it. So all that stuff that you have done in your other classes, same other stuff. For example, plot.bar, okay, sorry, plot.x label. Inside this x label, what am I passing? In the x, I'm going to say this is the month data, right? Plot.y label, I'm just going to say the amount of cakes sold. So this is sort of like, cakes sold example in the y-axis. And in the title part of it, I will just say that this is an example or a demo of how do you do demo of how to work on bar plot, right? BRAPLOT, bar plot, and just do, okay, I think pretty much I'm going to run this. So see, you can see a graph which is constantly increasing and you have sort of like a bar plot. In this, you can implement the strategy of figure size also. So I'm going to copy this. I'm going to paste it here. And what I'm going to do, implement figure size. So can I make it 4:2? Make it very, very small. Did I make my plot incredibly small now? 400 by 200 pixel dimension size, which we usually implement in all of that stuff. So, sir, can you also pass a label? Let's say you have a label called label equals to Google. Example, I'm going to come here and I'm going to paste it here. Example, label equals to Google. I will take plot.legend, plot.grid. I'm going to come here and I'm going to paste the same exact code and I'm going to run this. What did it do to your graph? Do you have a label, a grid in the background, and a legend? Did you understand? For this particular bar graph, the one that we have implemented, see, okay, in the entire code that you see, which part is the bar graph? Can I say this part of the plot is bar graph? Yes, yes or no? In this particular part, in this particular bar plot, what did we do? The only thing that we have done is taken care of this, right? Now, my people, right? Murchana was asking me, sir, can I change the width? You can change the width like this, 0.8, right? Run this. What did you do with your, okay, so let's first of all make it better. Let's make it 8:4. Is this graph bigger, larger? Can I say if I make this width 0.2, what did you do with your plot's width? Did you understand what I'm trying to say? You can control the width. The highest amount of width a graph will have is how much? The highest amount of width a graph can have is how much? 1. The lowest amount a graph can have is how much? So do you have any plot here? We don't have any plots. Agree? Sir, if I don't mention width by default, what happens? Do you see this? Width equals to default. So even if you don't mention width, do you get like a proper orientation, proper value of the data correctly? Yes or no? Agree or disagree? So my people, this is how you plotted a data, like sort of like a width, right? You can also put the width as a variable also. So for example, right, if you say w equals to 5, okay, w equals to 5 or whatever your value is 5. So you can say width equals to w. And if you run this, can you see I am having 5? Okay, so of course 0.5. If I run this, can you see my width is passed as a dynamic variable inside the argument itself? Did you understand what I'm trying to say? If you take this as a variable which is defined by the user, you can even pass this as a dynamic argument inside it. So all that is possible. But my people, tell me one thing. Have you always seen a bar plot that looks like this only? Have you always seen a bar plot just like this? Have you never seen a bar graph which is vertically horizontal like this? Agree or disagree? So bar plots are of multiple different categories, right? This is not the only bar plot which are capable of doing, right? What, okay, this is vertical or is this horizontal? What kind of bar graph is this? Can I say this is like a vertical graph? So suppose, sir, if I want to have a horizontal, okay, let's first of all get you guys a clarity. My people, whenever you get the data from your actual database where you want to draw your data, okay, think you are in a company, you're actually working. Do you know that you have two kind of databases? One is called SQL database and others called NoSQL databases or document databases, where sometimes the data comes in JSON format. Do you know what that is? Do you know what I'm talking about? So, okay, what I mean is, in SQL databases, isn't data in columns and rows format, column number A, column number B, column number C, and then pretty much from that column, you plot column number A in the x-axis, column number B in the y-axis, and you might get a bar graph. Are you understanding what I'm trying to say? You have to query a database like this. But do you know that there are databases like MongoDB, where databases are not actually a table value, but a JSON value? How many of you know what is JSON? How many of you know what is JSON in the class? What is JSON? JSON looks like this, okay? JSON data example. Do you see this particular example in front of your screen, my people? Can you see this? Orders. Orders is nothing but order number, date, tracking number, customer ID, customer, who was the customer. So can I say that each record of the customer or each idea or data table of a customer doesn't come in tabular format? This comes in a very structured, very highly structured key value pair like dictionary in our data. Agree? This particular schema in SQL is very, very sturdy, right, my people? So for example, in a SQL data, you properly have column number A, column number B, column number C, column number D. But in JSON, you don't have a schema as such, but you have like a key value pair. See, order number can come before date, date can come before order number. The order does not matter. So suppose, sir, if your data is not proper from JSONic format, the way I'm showing it to you, sir, it's exactly in a JSON format. So for example, let's take data in a different way. I have shown you how to work with data which is of a list type. Sir, by default, my data is of type dictionary. So for example, rather than passing like this, I have a data called Apple, okay? Apple has been sold 200 times in a month, okay? This is data point number one. Say mangoes, I'm going to come here and I'm going to say mangoes, MANGOES. Say mangoes have been sold like 300 times this particular month, okay? I'm going to come and I'm going to say that cherry has been sold how many days? Say 450 units of cherries I have sold, and oranges or orange, ORANG, orange has been sold 600 units of oranges have been sold so far. Now, if I print type of this particular data, what data type is this? This is dictionary data type, right? If you observe JSON, do you also see that this is nothing but dictionary? In Python, we call this dictionary. In JSON, it's called JSON. Yes. So if I come to my data, what have you learned in basic Python? How to get the values of your key and how to get the values of your value? How do we do this? So can I segregate it that name of the fruit or fruit itself can be said like this? Okay. Can I say data dot keys and put a bracket here? And if I run this and print fruit, what is it returning to me? Is it returning apple, mangoes, cherries, and oranges separately? Ha ya na? I have taken all the keys separately, so it's giving me all the keys separately, right? If I take the same exact thing, the value or the unit or amount underscore sold, the amount of SOLD, not sold, right, is going to be data dot. Can somebody tell me what should be the method here in dictionary if I want to get all the value? Values, very nice. And if I run this and print amount sold, is it not giving me everything like this? Dictionary values is 200, 300, 450, and 600. The problem here is my data in proper list format? Yes or no? Is my data in a proper list format or still improper list format? No, it is not in list format. Do you see this thing called dictionary values popping up in the beginning? In Python, what do we call this data type as? What do we call this data type as in Python? Don't we call this tuple? Having a data like this, isn't it called tuple? So tell me one thing, within a tuple, there is a list. To convert this into proper list, can I write the keyword list in the beginning? And I can write the keyword list in the beginning and encapsulate the whole data. Now, if I run it, is everything in a proper amount sold and fruit is in a proper dictionary, proper list format? Agree or disagree? So from a dictionary based data where I was able to extract the key separately, the value separately, what did I do? I gave myself an understanding that if I want to work with the dictionary data, at the end of the day, I will have to convert it into list. But initially, if the data comes in sort of like a dictionary format or a JSONic format, I will first take the data, convert that into a list. What do you do next, my people? Don't you do plot your size, your canvas? So if I come here and paste the sizing of the canvas, I have been doing this in my past example of the same way. The next thing that I need to do is actually run the bar plot. But this time, I'm not going to run a bar plot directly. I'm going to put an H here. Do you see in the previous example, this was just a simple bar plot. But in my new example, what extra keyword have I added? What extra keyword did I add? I have added H. H, what is the full form of H? Horizontal. Can I say horizontal? So now, let me take the whole thing, come here, remove width, right? Instead of month, let's call it fruit. Let's call it fruits sold, okay, units sold. UNITS, units sold, demo on how to work bar horizontal plots. If I run this, does your plot appear horizontally now? Are you understanding what I'm trying to say? Right? So this time we implemented a bar plot with different kind of data. And I also showed you how to basically take a different kind of plot and implement it. Just like this, right? The concept of matplotlib is so simple that you can plot any kind of plots that you want, horizontal, vertical. In fact, I want to teach you one more kind of plot. Hold on. My people, have you seen that there is a plot like this? Have I taught you how to do a line chart, my people? A line plot? Plot number 1 called line plot? Yes or no? Have I also taught you how to do a bar plot? How to make a bar plot that looks like this? Have you not seen, my people, that imagine my people, this plot, okay, is like a photo. If I pick this photo and if I place it on this particular plot, what do we call this placing of one plot on another plot? Don't we call this overlapping? Like overlapping on one photo, I'm keeping another photo, right? I showed you how to do subplot. One plot on the top, one plot in the bottom, or one plot like this, one plot in the side. Or you can make 4 different plots that look like this, correct or not? We call this as a subplot. But what will happen, sir, if I take one plot and on top of this plot, I want to represent another plot? I'll give you guys an example, okay? I'll give you guys an example. So my people, currently right now, just a while ago, I showed you how to work on something called bar plot, okay? So let's take that particular example. So can I say import matplotlib? This is only for making your code looks good, okay? This is not needed to call again and again, right? I hope you understood that in every cell, you don't have to call the library again and again. Once you have written library once, you don't need to import it again and again. The cell will keep remembering it. I hope you know this, right? So say, I will import NumPy as NP, okay? I'm going to use the concept of NumPy as NP. Now, my people, let's first define the data. Ab aap kya karoge? You will say categories, right? So categories of my data is going to be very, very simple. Can I say, I'll take the same example, Apple. So basically, I'm just going to say Apple, right? I'm going to say orange. I'm going to say cherry or mango, okay, MANGO, mango, and I'm going to say LITCHI, lychee, LITECHI, lychee, and let's take one more fruit, GUAVA, guava, example. So these are the categories of the fruits that I want to that particularly take, right? I want to pass something called bar data. For bar particular data, I would say that the amount is sold is say 15, some random value 30, 22, 18 and 25, example, right? And on top of it, I want to represent a line data also to represent the trend on the bar chart. So for example, 10, 20, 15, or maybe 12 or maybe 18, right? So this is my bar data. This is the line data. Now, in case if you want to create a subplot, right? Remember one thing, my people. Have I taught you how to create a subplot in one of the previous examples where we had a line equation in a graph like this and a line equation? This was represented as AX1 and this was represented as AX2. Do you remember we did that? Do you remember we did this AX1 and AX2 and then we worked on AX1, meaning it will work on graph number 1 and AX2 will work on graph number 2. Exactly like that. You cannot run overlapping plots without creating an axis. So can I say figure comma AX1, since I only need one graph, I don't need multiple subplot. I want to take one plot and overlap another plot on top of it. I'm only going to take one. AX1 is equal to plot.subplots. Okay, plot.subplots, and I'm not even going to pass figure size equal to whatever you want. You can give here if you want. Figure size equals to whatever you want here. You can pass in. I'm not passing, right? AX1 dot on the value of AX1. What am I doing? I'm plotting a bar plot. So what do you mean? I'm taking categories. I'm passing in the bar data, and I'm going to pass in things like color equals to, let's give it a very mild color. Okay. So let's come to a very mildish, greenish, lightish color. And I'm going to sort of copy this and I'm going to paste it here. So I'm going to come here. I'm going to paste the color, put a hashtag in between. Otherwise it won't know this is a hex code. And let's say alpha equals to 0.5. I'm assuming already the color is very, very light, right? The label I'm going to say is bar data. Okay, bar data. So this is done with my bar data. Now what I'm going to do, my people, is I'm going to write a small statement called AX2 equals to, now that I have not defined it, I'm just going to say AX1 dot twinx. I'm going to call a method called twinx and I'm going to put a bracket here. And now in the bottom, I'm going to say AX2 dot plot. Simple writing dot plot. Is it not a line equation, my people? I'll show you an example. Categories, comma, line data, right? Color equals to, let's give it a simple red. Okay. Let's say marker, not markdown. Marker equals to O. Okay, I want the data to be marked. Alpha, let's make it very, very simple. Let's say 0.7, 0.6. I'm assuming in that line. Label equals to label, LABEL, not LEBAL. Label equals to line data. So line data. And if I run it, hopefully, did I get it right? I got it right. Okay. Do you see there was once a line plot and then another time a bar plot? And I'm able to put a line plot on top of a bar plot. Did you see what's happening here, my people? Like, I hope you kind of got an understanding. So this bar plot is also representing the trend analytics in the data. Yes or no? You understood what I meant? See, how did we do this? See, usually when we do subplots, don't we take two axes in a data? Hi, Anna. Agree or disagree? Whenever we usually do a subplot, you remember in last class, I told you, you have to take a data like this, AX1, comma, AX2, like this. We passed it like this and we did plot dot subplots. And then I took 1, 2 like this. For example, I'm just going to show you. Okay. I'm just going to run this and run it. So do you see 1, 2, right? 1, 2, I gave it multiple value like this. And here I also passed in something called figure size. I'm just going to hold on. Give me 1 second. Figure size kahan likha hai maine? Ha, figure size equals to this. I'm going to copy this. I'm going to come here and I'm going to paste it. So figure size equal to not 8, 4, but say 2, 2 example. So do you see 2, 2 data popping up here, like one here, another here, right? It's become smaller and I was able to sort of make a data. But this is not what we do in our actual plot when you want to overlap it. You don't have to pass figure size. If you want to, you can. You don't have to pass any data inside it. All you have to do is, do you see what I've done here is, first I plotted the bar plot using the AX1 axis. So it plotted the bar graph very simple. Because I wanted to overlap it, what method did I use? What method did I use? The method name is called twinx. Remember, my people, if you want to plot a third plot, like if you want to overlap the third plot, what do you need to do? You need to copy this, you need to paste it in the bottom, called AX3 equals to AX2.twinx, and this is how the whole thing continues. I hope you understood what I meant. This is how you continue forward, continue forward, continue forward. And as many subplots that you want, you kind of get those subplots to be easily plotted on your data. Are we clear? Did you get it? And not just this, my people, that is not the only thing that you're good at, right? For example, when you do machine learning in the future, have you ever heard of something called scatter plots, my people? Your entire machine learning and data science journey will be used in making this plot like 100 times a day. I'm not even kidding. I myself, whenever I see or show a data to my management, most of my plots are scatter plots. Sir, what do we do about scatter plot, my people? You must have understood one thing for now. My aim in this class is not to make you how to learn a plot. My aim is to make you understand everything in Matplotlib is nothing but syntax, correct or not? Okay, let me ask you guys one question. I'm going to ask you guys one question. Like NumPy and Pandas, data visualization is more method oriented, right? If your memory is sharp, if from all the people who have joined this particular class today, if your memory is sharp and you're able to remember syntax, and if your memory is not sharp, you're not able to remember the syntax, the only difference is people who remember the syntax will have a small advantage. People who don't remember the syntax won't have a higher advantage. Why? Because you are just capable of remembering what method was called to plot what graph. Agree or disagree? Can I say that an intelligent person knows Matplotlib? Okay. We of course say an intelligent person knows machine learning, but because to learn machine learning, you have to learn core math. But for Matplotlib, mugging up will do. Agree? If you mug up all the methods, anybody can do Matplotlib. There is no great work somebody can do in Matplotlib. I hope you understand what I'm trying to say. Example. Okay, example. I'll give you guys an example. Suppose I'm generating a data x equals to np.random, okay, np.random .rand, okay, rand integer values. Say I want to generate 50 data points. I'm just going to copy this. I'm going to sort of paste it here. I'm going to call this my y variable. So this is the data that I generated. I want to have a figure size of my data. What I'm going to do, same exact code I'm going to copy paste, my people. You don't have to work hard towards this. So this is also done. I want to do scatter plot. My people, bar plot was called dot bar. Line plot was called dot plot. What do you think scatter plot will be called as in English in Matplotlib? What should, okay, don't even look at Google. Tell me, dot scatter. That's it. Dot scatter and you're done. That's it. Pass in the value of x comma y, okay? In your scatter plot, pass in the comma of x comma y. Sir, what can I do? You can pass something called marker values. Marker values will become O. Suppose I said O is my marker. Okay, the color that I want to represent is say red. Okay, very simply put. The alpha that I want to pass is 0.6. Haven't I used this logic of color, marker, alpha in the examples in the top also? Maybe hundreds of times I have given the same exact thing everywhere. Okay, for labeling, haven't I done the same thing, my people? Copy paste the same label. In fact, copy paste the whole thing and paste it here in the bottom and say x-axis is x-axis, y-axis is y-axis, and this is a demo of what kind of plot? This is a demo of scatter plot. So say scatter plot. And if I run this, do I have a scatter plot right in front of me, my people? Do I have a scatter plot right in front of me that you guys can see? Okay, sir, what kind of things that can you do here? If you want to come here and if you want to do edge color is equal to blue. If you run this, initially I had all red points. Do I have an edge color data point where I have made the points darker? Are you understanding what I'm trying to say? So that is it, my people, right? Like it's, so point that I'm trying to make here is, it's not a very complicated thing to do Matplotlib. The only thing that you need in Matplotlib is, what do you need to know? What is the most important thing that you need to know? You need to know how you particularly implement it. Sir, what do you mean by marker? Okay. In this example, when the data point is plotted, do you see this red color circle, my friend? Shubhodeep? Do you see this red color dot that's sort of connecting two lines together? Okay. Make this marker from this to capital D diamond. Did I change it to a diamond shape? Did I make it into a diamond shape? Correct? I hope you understood what I meant. If you make this into an X, do you see now my marker is an X? If I change this marker into P, it's not going to work out. But do you see a pentagon here? Like it's not very visible, so I never use P. Like I hope you got it, right? So marker is a way to put up a point. Just like that, to represent my scatter plots, can I say that marker is going to be from O, I represent it from X, so it will give me all X. But the edge color blue does not work here because there is no way to put blue here. And if I want to change the X axis, say to D, so this will all become diamond. Remember one thing, my people, right? I was able to show you how to annotate the data using a method called plot.annotate. Do you remember we used to do that? Where I showed you, if you run this particular data, you will be able to annotate your data. Like for example, if it was a line plot, we were able to see what this point represents, what this point represents, what this point represents. Okay. Just asking you guys on a very common sense perspective. If you plot a scatter plot, should you plot what x comma y axis of each point is? Scatter plot is not never to be plotted like that. Just giving you an idea. Can you do it? Yes. Should you do it? No. Reason is scatter plot is used to represent density and the distribution. And only if you plot a graph like this, will you need what kind of graph data point I had x comma y here, x comma y here, x comma y here. Okay. So point is we can do it. Should you do it? No, it makes no sense. Okay. I'm just letting you know that you can annotate it. You can definitely work on it, but it's not going to work out. This, my people, is how easy a matplotlib is. All you need to do is just remember the name of the methods. And my people, I have done one thing for you. I have done one great thing for you. And that great thing is in the presentation, when we created the content for you, okay, my idea was, since I have been in the industry for 10 plus years, I have given hundreds of interviews myself, and I've taken hundreds of interviews myself. I have kind of curated that 90% guaranteed asked methods. Like what methods are they going to ask? What methods are important in Matplotlib? And I've consolidated in the PPT in the PPT that I've created. Okay. So what I'm going to do is I'm going to share the PPT with you towards the end of the class. What you can do is all the methods and all the plots that I've mentioned in Matplotlib, just need to implement it and keep it in your mind. And remember one thing, I don't want to scare you, but I want to give you a reality truth, okay? There are differences between good companies and bad companies. I'll give you guys an example. In really good companies, when you give interview, right, almost 95% of the companies are like this. Let's say you are in an interview, the interviewer tells you, make a bar plot for the data, okay? You don't remember the syntax. Dot was the, dot what I used to call to run a bar plot. Suppose you forgot. Usually it is dot bar, but you forgot. Sir, will I be allowed to go back and check Google or internet? Can I ask the interviewer, sir, can we check it? See, 95% of the time, the answer is yes. Okay, because you are not cheating. You're simply not remembering the method to plot the data. Okay, I have opened up so many times documentation in front of you, right? Sometimes when I get an error, my people, haven't I gotten stuck? Sometimes I got errors in my programs. Sometimes I didn't know the full form or the meaning of the syntax. Did I not go and check the syntax? Right? In the last class that we took, when I was teaching you or taking you guys through Matplotlib, right? When I was doing annotation, do you remember in the plot.annotate, I did not remember what the argument's spelling was? I did not know it. We went through the internet, we checked it again. See, 95% of the time, this is allowed. Okay. And if it's a good company and a good people or a good interviewer, he or she is going to be like, no, pretty much do whatever you want. But 5% of the extreme cases, my people, okay, sometimes the interviewer himself assumes that you must know everything. When sometimes you get idiots interviewer like these, then you might have a problem. But 95% of the situation, not just in Matplotlib, my people, in fact, in machine learning, if I talk myself personally, I will always allow you to go back and check your syntaxes, formula, and all of that. I will never assume that you must remember everything, because the whole world has a technology called Google right here, right? If you have a technology called Google, why should you waste time in learning something which is easily found on the internet in a one-click search? You should learn technology or techniques where how to implement the graph, where to implement the graph. So remember, not to worry, just make sure that you learn Matplotlib as your best, implement how many ever methods you can, and your life will become sorted. Are you clear so far? Are you clear so far? Do you guys want a break? Okay, can I show you one last graph in Matplotlib, and then we can take a break, and then we can jump in Seaborn? Can I do it one last graph, please? Also a very important graph. Sir, could you please explain when to use scatter plot, bar plot, area plot once again? I'll do that at the end, Meda, okay? Can I also show you one other plot as a data scientist? This plot is your life. Have you ever heard of something called histogram? Have you ever heard of something called histogram? Remember, my people, as a data scientist, as a machine learning engineer, if you don't know how to plot a histogram, if you're a doctor, if you don't know how to give somebody an injection, that's the kind of thing, right? Import NumPy as NP, import Matplotlib as something. Can I say data is equal to, for now, I'm going to take a random normal distribution data. So can I say rand n, normal distribution data, and I'm taking 10,000 data points. Okay. I will say plot. According to your common sense and your knowledge of Matplotlib so far, everything has been in English. So what will this be called as? Dot method will be called as? What should this dot method be called as? Short. Hist. That's it. Just hist. Nothing else. Pass your data. Okay. Pass the color. COLOR is equal to color is equal to, I'm just going to say sky blue. Okay. Sky blue. BLUE blue. And pass. अच्छा ठीक है, पहले इतना ही करो आप. ओके, प्लॉट डॉट हिस्ट. अब हम क्या करेंगे यहाँ पे? कैन आई गिव इट अ फिगर साइज सर? 100%. व्हाई कांट यू गिव अ फिगर साइज हियर? सो आफ्टर द डेटा गिव द फिगर साइज. सर व्हाट आफ्टर द फिगर साइज सर? कैन आई गिव अ लेबल? 100% यू कैन गिव अ लेबल. आई एम गोना कम हियर, आई एम गोना गिव अ लेबल. अब यहाँ पे क्या होता है? यू कैन गिव व्हाटएवर यू वांट. ओके, आई एम जस्ट गोना रन इट. डू आई हैव अ हिस्टोग्राम हियर of my data? But there is a small problem. Does this histogram have a very wider, very longer looking bins? So sir, what can I do here? You can come here to the histogram data and pass another variable or an argument called bins. Okay, remember, if you keep a bins equals to 40, do you see that my histogram plots have become sort of like very, the width became smaller, and now I'm able to see the normal distribution data well. But sir, what if I want to do this? Edge color, the one that you have mentioned here, equals to blue. Sir, can I also implement it in the histogram? 100%. Copy paste. So can I say properly my histogram, each bar, each line, I'm able to represent it well? If I want to give it not blue, if I want to give it red, do you see I'm representing all my data in reddish format? Yes or no? Did you understand what I'm trying to say? Super duper important. See, what is this bin, sir? Look at this particular thing, okay? Can I say that this is the width of my histogram plot? The distance between this red color line and this next red color line, can I say this width is smaller? Okay. If I make the width or the bins equal to 400, what happened to my line? Did it become smaller? So higher the bin size, smaller is the line distance. Agree? Agree or disagree? Higher is the bin number, smaller is the size. Smaller is the bin number, higher is the distance. Did you understand? So bins is nothing but it's like a bucket. You want to distribute or represent your data in how many bins, how many buckets, how many sizes. That is what bins is. I'm going to keep it at 40, which is a simple enough understanding on things. The higher you go, the more resolution you are adding. Simple. That's it. That's what bins mean. Are we clear? It's the number of bins or buckets or bars with which you represent your normal distribution. That's pretty much the answer of it. So my people, let's change the approach a little bit. Okay. What do I mean by that? Right. I'm going to show you how do you work on Seaborn, but slightly differently. Okay. I'm going to show you all the ways of making beautiful looking graph, nice looking graph, but slightly differently. Sir, what do I mean by that? See, first of all, how do you work with Seaborn? So, sir, how does Seaborn work and how do I import it? How do we sort of work on it? Very, very simple, right? So what do? You say import Seaborn, okay, Seaborn as SNS. And remember one thing, just like you don't import NumPy as num, num. You never make the mistake of calling NumPy as num or nump or whatever like this. There is a standard practice of calling NumPy as np. Seaborn is also going to be called SNS. Never ever forget this. But let's change the approach a little bit. Sir, what do we do? Do one thing. In Seaborn, because it is such a bigger library comparative to Matplotlib, and it is much more complex. Matlab, the plots that you can make in Seaborn are much more complex than Matplotlib. They give you a way to generate your own data also, to give you own data. For example, data frame equals to, okay, also let me import NumPy. Oh, sorry, Pandas. Import Pandas as PD, okay? So these are the libraries I've imported. Suppose df equals to sns dot, there is a method called load dataset, okay? Let's take tips dataset, okay? Yahan pe, I'm taking a dataset called tips. And if I say df dot head of 5, do you see the data? What was the total bill? Okay, so this data represents, okay, what is the total bill that has happened in the restaurant, or how much is the total bill in a restaurant? What percentage of tip did the person get? What was the person's sex, female or male? Was the person smoker? What was the day of the restaurant? What day did the people come and have their food? Was it the dinner time, breakfast time, lunch time? And how many people came and ate in the restaurant? So what was the table size? Basically, if you know, in the hotel, in the restaurant, there are tables for 2, table for 3, table for 4, table for family, right? Multiple different table size. So this is the size of the people, right? Here, let's do one thing, right? df dot rename. Let's rename a column, okay? So columns equal to, let's rename this particular column, that the column is called sex, and change this to another column called, let's make it gender. Okay, let's make it gender and say in place equals to true, right? If I do this and if I run it, and if I say df dot head of maybe 2, did I change the column name? Initially it was sex and I've changed this to gender. Agree or disagree? Agree? Okay. Now let's understand, sir, what can what can Seaborn do so different that I am going to be using Seaborn for a longer period of time, or the reason I want to use Seaborn is much more important. Example, I'll give you guys an example, okay? So my people, my first question to you is very simple question, okay? I'll show you guys an example. Who particularly, sir, what is the meaning of in place equals to true? See, in place equals to true means if I don't give in place equals to true, what happens is, okay, I'll show you an example. Rather than showing it, rather than showing it to you like this, I can show it to you like this. Run. Okay. So do you see here we had something called gender? Okay, let me change this to df. Huh? Do you see that I changed df dot rename columns equals to this, but again when I call df dot head, it changed itself back. So see here, df is equal to sns dot load. Here my data set was loaded and I was able to get total bill, tip, sex, smoker, date, time and size again. I did rename df dot rename. I did not do df equals to df dot rename, right? Like I did not do this, and this is also not allowed. I did this df dot rename. So when I ran this particular line of code in line number 65, I was able to change the sex back into gender. But the minute I put df.head, did it replace back, change itself back? Did it change the name itself back into what was originally given? I hope you understood. Yeah. So dear, what we do know, to retain that change, we write something called in place equals to true. So kya hota hai? When we say in place equals to true, we override the method and now no longer the whole thing changes. It will be based on what we passed. All right. Does that help? Did you get the idea? Yeah. Okay. Good. Okay. Now listen to me very carefully. My people, what is the size of the data? Can I say df.shape will give me the size of the data? There are 244 rows and how many columns? Yeah. Okay. My people, look at this, okay? SNS dot bar plot, X equals to gender, Y equals to total bill, okay? Kya total bill hai na? Total bill hai. Give me 1 second. I'm going to show you guys an example, okay? This is just a demo example. Don't take it too seriously, okay? Data equals to DF, okay? Between men and women, who ended up spending more money? Who spent on an average more money in the restaurant? Men or women? Male? Okay. Do you see this black color line here? This black color line? This is the median value. You did not ask for it, but Seaborn automatically gave you. Okay. I'm not going to actually start Seaborn like this. I'm just showing you an example how it works. But let's not start like that. Let's start in a very simpler way. Okay. So first of all, okay, get one understanding clear. One understanding very clear. Matplotlib will be used. When will you use Matplotlib in your career professionally, and when will you use Seaborn professionally? Okay. When should you use which? If I have any basic plotting that I need to do, what will you use? If you have independent plots, bar plot, line plot, histogram plot, area plot, which one will you prefer? Not prefer. Which one will you use? Matplotlib. Whenever you have complex plots, the one that I'm going to teach you like in the next 1 hour, what kind of plotting library will you prefer? What kind of library will you prefer? Seaborn. I will show you an example. Okay, I'll show you an example. The first kind of plots that Seaborns are good at are called distribution plots. Distribution plots. Okay, distribution plots. Sir, what do you mean by distribution plots? Example. Distribution plot is also called histogram plots. Example, SNS dot dist plot. Instead of calling histogram, we call it dist plot. And I want the distribution of the data of total bill. Is the total bill normally distributed or not? How is my data distributed, my people? Is it normal or not normal? This is skewed, right? This data is not normal distributed. This is left skewed data, correct? Agree? Sir, I want to plot a line on top of it. Okay. Just pass KDE equals to true. Equals to TRUE. I'll show you what is going to happen now. When I put KDE equals to true, do you see a line popping up here, which is showing the data representation in a curve format also on top of the data? Did you understand what it did here? Did you learn something called bins in the histograms? What bins did we take? 40, right? In the last. Can I say that bins are automatically plotted here? Now look at the example of Matplotlib's Matplotlib's data plot.histogram. And I'm going to copy this particular thing, okay? I'm going to copy this and I'm going to paste it here. What difference do you see from this to this? Okay, so first of all, the bottom one is Matplotlib and the top one is Seaborn. I think this idea is clear. Huh? Okay, so tell me one thing. My question to you is, what difference do you see? What difference do you see? What difference do you see? Example. My data is passed like this, DF of total bill, and my data was passed here data. Yes, agree? Line by line, let's look at it. See, you will understand how this works, okay? Example, copy and paste. Okay, give me 1 second. Is this visible to you? This particular code line is visible. Is it visible to you? It is visible, right? Okay, very nice. So tell me, the method names are different. The method names are different. Dist plot is used for Seaborn and .hist is called for Matplotlib. So clearly point number 1, the name of the methods in Matplotlib versus your Seaborn are different. It's a proven fact, correct? This is a proven fact. Okay. This is how you pass the data. So inside the argument of the method, you have to pass the data as the first point, right? Here I am passing data directly. Here I am passing one single column, correct or not? In the entire data set of total bill, tips, gender, smoker, day, time, size, I am passing one column. But can I pass it? Yes, I can. So point number 2, independent columns can be passed also. Agree or disagree? Agree or disagree? I am passing the number of bins in Matplotlib and I'm passing the number of bins in Seaborn. So that means bins and bins are common in both Matplotlib and Seaborn. Agree? I am passing another thing called edge color equals to red, right? you can pass an exact same code, right, my people? Give me 1 second. Edge color equals to red. I'm going to copy this. I'm going to paste it here. Okay. I hope the spelling is correct. Yeah. Give me 1 second. I don't need KDE for it. I'm just going to run it without the KDE. Okay. Oh, yeah. I think, give me 1 second. Seaborn may, right? Did I pass in something like this? Oh, okay. I think I need to pass in a separate axis first, right? So do you see the edge color changing from this to this? I'll tell you what is the reason for it, okay? Because I have not given distribution value here. But essentially, edge color can also be passed from the original value to the new value, okay? So I'm just going to plot.hist, change kar deta hu main. I'll tell you what's happening here. Give me 1 second. I'm going to cut it, okay? And I'm going to paste it here separately, okay? And I'm going to run this. And I'm going to take edge color equals to EDGER. Give me 1 second. Edge color equals to red. Copy this, paste it here. Don't give me any problems. Okay. Let me also put a KDE equals to true here. Okay. Am I able to get an edge color red here? The same that we got from Matplotlib? The same exact idea? Whatever value of Matplotlib I was able to get, or in Matplotlib I was able to pass edge color red, I am also able to pass edge color the same way in particularly distplot also, right? Sir, what is this KDE, which was not available in Matplotlib, but it is available in distplot? See, my people, do you know in statistics there is a concept called inferential statistics? No problem, it's okay. In statistics, there is a concept called inferential statistics. In inferential statistics, there's a function called probability density function, right? What this does is, okay, whenever you have a data and the data needs to be converted into a distribution of a data, like distributional form, that is taken care by KDE, kernel density estimate. It's a mathematical formula that takes the data of ranges, like for example, 1, 4, 8, 9, 10, and it will create a range like this, 1, 4, 5, 9, 10. So did you understand what I'm trying to say? It will take a continuous variable data and it will make that into a continuous plot. That is a scientific, it's actually a concept in statistics called KDE, kernel density estimate. So in order for whenever you want to specifically have sort of like a, how do I say this? Like a line to represent the distribution of the data, what do you use? The kernel density estimate method. It's a parameter. Sir, what is the use of it? I'll tell you. Can I say this is the exact code that I have used for plotting a histogram in my Matplotlib Seaborn? I'm going to copy it. Rather than passing any other type of data, what can I pass? Do you know? So for example, this is distplot, correct or not, my people? sns.distplot in the top that I have written. Instead of distplot, you can pass something called KDE plot. Okay, I'm going to comment the top one and I'm going to move the bottom one. Okay. So do you see, I don't need KDE equals to true. Okay, edge color equals to nahi hota hai isme. So I'm just gonna copy the whole thing and I'm gonna move it. I don't even have bins. I'm gonna paste it. Do you see, I just get the line, the one that I'm getting on top. Jo hum is pe kar pa rahe the. The one that I was getting on top, I'm getting the same exact thing in the bottom. The line that you see here, the blue line. Same thing, if I just remove the dist plot and put KDE plot, am I only getting the distribution of the data? Hi, Anna. So tell me one thing, did you work hard in creating the logic for KDE, kernel density estimate, or it was automatically given to you? So this is more like an advanced process. I hope you understood what I meant. Did you get what I'm trying to say? Okay. So, sir, should you use Seaborn to plot basic plots like bar plot, pie chart and all of that stuff? The answer strictly is no. Am I making sense? Your job is not at all going to be plotting basic plots in Seaborn because it is not built to be made on top of Seaborn. Did you understand? Seaborn is going to be used only and only if you are going to plot multiple different kind of complicated plot. Example, another plot I'm going to teach you is something called joint plot. This is also going to make your life super easy. Example, SNS dot joint plot. I'm going to pass X equals to total bill. Now, my see, people, you will understand what I mean by example complicated plot. Okay, give me 1 second. This is my data frame. Yeah, why am I calling data frame again and again? Give me 1 second. df dot columns, right? I'm going to call columns. So let's say total bill. I'm going to copy it. I'm going to paste it here. I'm going to say y axis variable. Let's say it is tip. Okay, I'm going to copy this. I'm going to paste tip here. And I'm going to say data equals to df. And the data that I'm passing is df. And the kind of plot I want is a regression plot. Okay, I'm going to run this. Give me 1 second. I'll tell you how this particular thing works. Can I say this is just a one single line of code? Can I say this is one single line of code and it generated kind of complicated graph for me? First of all, observe this, right? This is a very simple graph, correct? A very simple graph, right? Here, first of all, sir, in Matplotlib, I'm so sorry, I'm going to tell you this. Sir, was I able to control the size of the canvas like this? Plot.figure, figure size is equal to 8,4. Yeah, because you have come to a very complicated library, you just need to pass something called height. Height equals to say 8 or say 5. Here you can also pass something called aspect. Have you ever heard of something called aspect ratio? 4,4 of aspect in this. I'm going to say 1.5 and run this. Okay. What did I do? Where did I go wrong? Did I ASPECT? I hope I did not do anything wrong. Oh, give me 1 second, my people. Is there an aspect ratio in joint plot? Give me 1 second. Dot joint plot. Okay. Is there an aspect ratio? I think there should be. Oh, it's just ratio, is it? Okay. I think, okay. All right. So ratio equals to, give me 1 second. RATIO. Ratio equals to, what value have they given? They have given 5. I will also give 5. Let's see if 5 works. Okay. So sorry. I thought that it is aspect. Okay, fine. Did I make my size of the graph become smaller? Like, aap dekh pa rahe ho na what I'm trying to say. If I change this to 5, it's changing its size differently. Yes or no? Are you understanding what I'm trying to say here? Sir, what is joint plot? Okay, I'm going to take a photo of this particular plot and I'm going to teach you how this particular thing works. Okay, give me 1 second. I'm going to show you an example of this particular plot and show you how to read it. Okay, my people, first of all, on top of it, what value is mentioned here? This particular blue graph that you see is nothing but a total bill. Okay, this is the distribution of total bill. Total bill paid by the user. And to the left hand side, I have something called tip data. How many people have tipped? Sir, what can you deduce from this graph and why is this graph important? Have a look from the data, my people. From the data of all the people, most people in the entire 288 people, did they on an average pay between $10 and only $20? Between $10 and $30 is the most amount of people who have paid the money. Did you understand? From 300 people in our data set, between $10 and $30 is being maximum paid. The total bill in the restaurant on an average is something else, but most people pay between $10 and $30. That's why the distribution is high here. Which is the highest amount of tip people give? Between $1 and between $4, $4.50. This is the maximum amount of tip people give, which is here, and this is the maximum amount of bill. Did you understand this from the data? That what is the average consumption or average value of money people spend in the hotel or the restaurant? Did you get that? Okay. With respect to bill and the tip, okay, including tip and bill together, okay, give me 1 second, let me erase this. Including both the tip and the bill, most people are falling in which category? Which category is the more distribution found? Can I say this is the most distribution and more overlapping is found here? Agree? It means most people who spend low amount of money also give low amount of tip. This is where my majority of the data is lying. Did you understand? Because I'm comparing total bill with the tip, it's giving me how many information together? bill with respect to tip. Agree or disagree? If you want to calculate total bill paid by, how many people say smoker or non-smoker, okay? Example. If I run this particular example, did it give me an output here or did it give me an error? The error is because my people smoker is continuous value or categorical value. Tell me this. Smoker, is it a categorical value or continuous value? It's a categorical value. Can you compare a continuous value with a categorical value like that? You can't. It's not straight away possible, right? Sir, can I do it with size? For example, rather than passing categorical variable called smoker, can I pass in size, SIZE? My people, did you get the idea? Size, the number of people who came into the restaurant. So first of all, which number of people are very frequent in the restaurant? Which among one person stepping into the restaurant, two people stepping in the restaurant, 3, 4, 5, and 6, which is highly probable? 2 and 3, correct? And also 4. So 2, 3, and 4 are the highest amount of people that enter and get a table. So either people take a 2 table, or they take 3 table, or they take 4 table. Are you understanding? Did you get the concept of what this particular thing represents? Joint plot meaning it will join the total bill and the tip for you, and it is going to give you the data combined. It is giving you both the information in one plot. It's giving the total bills distribution here, the tip information here, both total and tip together here in the middle. Did you get it? You did not ask the joint plot to do this for you, but it did that automatically. Did you understand what I meant? Did you kind of get the idea? That in machine learning or in data science, sir, what is the importance of all of this? Okay, for example, did you ask Seaborn to plot both total tip and the total bill and tip together? No, it created that for you. If I had to write this code on matplotlib, should not I have done 3 subplots? One subplot for total bill, one subplot for tip, and other scatter plot for the data. I had to write 3 different subplots. Do you understand what I'm trying to say? In matplotlib, you would have written a subplot to represent the normal distribution of total bill, normal distribution of KD plot, or a normal distribution of a tip POA, and then you had to do sort of a scatter plot. But in this particular part, you just have to call one single method and it will take care of all of this for you. And my people, let me also give you one idea. See, Seaborn is such an old library that they now have created all the plots that are needed by data scientists. It's not like they've created plots like joint plot and you don't know where to use it and how to implement it. Every plot, every method that Seaborn has created, they all have been proven to be useful. They all have been proven to be very successful in a practical setting. So whatever method that you're going to eventually learn in the future classes from me, they are all super critical and super important. But did you get the concept of joint plot yet? Did you get the idea of how joint plot works? Okay, sir, I want to plot a very simple, very elegant, very nice looking bar plot. Okay, sir, I want to do bar plot and my aim is only to plot bar plot. I know you have asked me not to particularly plot bar plot in Seaborn, but my heart goes out to learning bar plot. So first, let's understand one thing. Tell me this. If I want to plot this kind of bar plot, okay? Suppose if I want to do, what did I write in the beginning? I think I compared 2 things, right? Gender and data. Okay. So I'm just going to copy this and I'm going to paste it. Okay. I'm going to sort of paste this. I'm going to uncomment this. Can I say I have a bar plot? I will also change the HEIGHT height equals to 4. Okay. Why are you not giving me height? Did I get the spelling right? Give me 1 second. HEIGHT equals to 5. Let me also take a ratio of 5. Give me 1 second. And let me paste it here. Don't tell me you don't have a height. Access.bar got multiple value for arguments. Okay, give me 1 second. SNS.bar plot. Okay, SNS.bar plot. Bar plot. Give me 1 second. Go here, go to the bar plot. How do I change your height? I change your height by changing estimator fill value. Okay. height is not mentioned here. Okay, give me 1 second. Is there a ratio here? No ratio, right? So if I scroll down, okay, chalo, theek hai, isko, so sir, let's do it with matplotlib only. Agar if this is not showing up, give me 1 second. Where is it? Figure dots. Where did I do? Figure dot size. Copy it. 1 second. Please tell me this will. Yeah, I think this should work. But no. Wait. Hold on. 2,4. Did that work? No. Okay. 4,2. That worked. Okay. So okay. I'll have to kind of give you guys this advice also. Okay. Plot.figure figure size equals to 4 is which part of the library? Which part of the library? Is it from matplotlib background? sns.barplot is which part of the library? Did the matplotlib sizing or resizing the canvas work on the Seaborn bar graph or any kind of graph for that matter of fact? In fact, dekho, if I take this plot.figure figure size equals to 2 and remove the height from here, okay? I'm going to just come here and put this. I'm going to remove the height and ratio, okay? Control X. And I'm going to paste it outside. Paste. Did I change this also? 4 by 2. Okay, let me say 2 by 2. Okay. Yahan pe, did it change anything? Did it change anything yahan pe in 2 by 2? It made no difference, right? Koi difference nahi hua yahan pe. But only by taking height and ratio was I able to make a change here, right? Like for example, if I change this height here, 5 equals to ratio equals to 5. See, so remember, you have to remember one thing. In Seaborn, there are 2 ways you can resize, okay? 2 ways you can resize a library or a graph. Either the graph will have an argument called height or ratio. If you don't have it, you will definitely have something called matplotlib's method called plot.figure figure size equals to this, and with this you will be able to resize it. Okay, only 2 methods exist. Either you will have an argument called height and ratio. If not, you will have to use it using the matplotlib. So that must mean matplotlib is very easily integrated in Seaborn. Are we clear? Matplotlib and Seaborn are very easily integratable between each other. Are we clear so far? Did you get the idea so far? Okay. Now let me take 2 questions. One question from Shubhadeep Saha is, sir, what is this scatter plot? This scatter plot is the data between total bill and between tip. Did you get it? To plot a scatter plot, don't you need an X, Y? This is my total bill, this is my tip, and then X, Y is this scatter plot, this scatter plot, this scatter plot. Did you understand what I'm trying to say? On my X-axis, what have I taken in my data? What is my X-axis data in X-axis? Total bill. What is my Y-axis data? Tip. Both are continuous. So can I not say X has a range, Y has a range, and this is my scatter plot? I hope this gives you an idea. Okay. Now Raj Kumar is asking me, is KD a display of standard deviation and variance? The answer is no. Okay. Can you see this kernel density estimation plot? Tell me one thing. What is standard deviation, sir? Standard deviation is nothing but the dispersion of data from its mean. Is there any dispersion value that you see here? Okay. What do I mean by that? Whenever you draw a distributional data like this, standard deviation is written like this. This is called as a mu, population mean. Standard deviation could be written like this. Population standard deviation, sigma. Okay, sorry, population standard deviation sigma, population variance sigma square. So is there any point, a line that is plotted in between or anything that is representing standard deviation or variance here? No, right? So nor is it a sample variance or standard deviation. This only represents distribution, sir. KDE is in no way representing standard deviation or variance in any shape, form, or in any way. I hope this is clear. No representation of standard deviation or variance. It's just distribution. That's it. That's it. Whenever you want a data distribution like this, you have to have a value, sir. So for example, for your population standard deviation, it should be sigma square. This is your population variance. Sigma is your population standard deviation. This is your sample variance. This is your sample standard deviation. And this is your population mean. And this is your sample mean. Unless you see these keywords pop up in a graph, it's not representing it in your graph. So no, you do not have it as a part of a data. Okay, I hope you're clear. Anyways, coming back to the point, did I make a bar plot here in front of you? Right in front of you. So tell me one thing, from this plot, do you see that in a bar plot, which gender is paying the highest bill? See, x-axis is gender, y-axis is total bill. Which particular gender is spending the highest amount of money? Tell me. Is it male? Is it the male that's spending the highest amount of money? Okay, listen to this very, very carefully. Sir, what else can we do to make our life much more easier? Listen to this. Have you ever heard of something called count plot? Look at this, okay? Count plot. I am passing x equals to gender, okay? Only and only gender, passing data equals to df, and I'm going to say palette equals to, I'm going to say set1. My people automatically, did I write the spelling of palette correct? Was it, oh my God, there is no get method run. Okay. My people, when I did count plot, yeah, I saw that. When I did count plot, how many number of males and how many number of females? Is it giving me the count automatically? Setting up the y-axis on its own, x-axis on its own, giving me the values automatically? Did it give me the color combination automatically? I did not choose it. If I make the set 1 to set 2, did the color change? I'm not sure if there is a set 3, but let me try. I'm not sure. Oh, there is a set 3 also. Set 4 भी होगा क्या? नहीं, I think set 4 नहीं होगा. हाँ, ठीक है, yeah. Set 1, example. Do you see what's happened? I think there is also color palette called cool warm. I'm not sure. Cool warm. Yeah, correct. Right there. Cool warm. So do you see what's happening here? The combination of colors, you don't have to take the headache or risk. They have come up with certain palette. You just have to write the palette, and these will be good looking to the eye. It's decided by the people themselves. All you have to do is just pass the method, pass the palette, and it'll automatically take care of color combination for you, plotting the bar plot for you. So can I say in the bar plot, I was able to compare the total bill with respect to the gender, but here I was only able to take gender. If I take smoker, okay, how many smoker enter into the restaurant? In the restaurants, are majority of the people smokers or non-smokers? In the restaurant, majority of the people, are they smokers or are they non-smokers? Okay. What other variables do we have? Example, day. Which part of the day do the people enter? Okay. So if I just enter day, okay, in the restaurant, which category the day the restaurant ends up making a higher volume of people? Is it Saturday, Sunday, Thursday, or Friday? So can I say that the top 2 busiest days in the entire restaurant industry is Saturday and Sunday? Did you get what I'm trying to say? Did you get what I'm trying to say? And if I pass instead of this gender and total bill, instead of this gender, if I pass a day, okay, not good day, what answer did we get? My people, highest amount of bill, which day generates? The highest amount of bill is generated by which day? Isn't Sunday the highest amount of generation of the bill? Hi, Anna. And on an overall average, who spends the highest amount of money? It's the males. Did you get what I'm trying to say? Did you understand what I meant by saying that this is how you actually get an understanding on the data? I hope you kind of got the concept. So tell me one thing. Apart from Matplotlib and Seaborn, the effort it took for us to do calculation of multiple variables together in lesser lines of code was with Matplotlib or this? With which value you had to take lesser amount of effort to get the highest amount of value? What was that? I'll also show you guys an example. Look, I'll show you guys one more example. Here, apart from bar plot and count plot, this is such an important method called cat plot. Okay, I'll show you guys an example. It's called cat plot. Okay, categorical plot. My people, for which day for which particular day the highest bill was generated? So total bill, TOTAL underscore, I think bill, I think मैंने correct ही दिया है, and data equals to DF. Kind equals to bar plot. Okay, तो categorical plot में bar plot, and I will say palette equals to set1. ठीक है, example मैं लेता हूँ. यहाँ पे क्या गलत कर दिया भाई मैंने? Bat. Okay, it's bar plot. Okay, my people, For total bill, which amount of people have come the highest on Sunday? I think we can say that successfully Sunday generates the highest amount of bill. If I change this to tip, which day generates the highest amount of tip? अब ये हमको क्यों ऐसा आ रहा है? Look at it. In this data, if I did tip versus total bill, and यहाँ पे, okay, look at this, okay. If I do tip versus total bill, am I getting the same answer but in a different kind of plots? Hi, Anna. So what did I do here? Is it not generating for all the tips that has been given versus the total bill? It's not giving me a good idea. So instead of why having total bill, can I change this with day? Did you see I made the horizontal to vertical to horizontal automatically? I did not give any method, just change X and Y and it gave me the answer directly. What do I mean by that is, if I had made X day and Y tip, what is it, horizontal or vertical now? Is it vertical or horizontal? Can I say this is vertical? Agree or disagree? Rather than doing this, if I just pass tip here and day here, did I have to pass anything extra and it automatically made my tip as my x-axis and my this as a y-axis horizontal? Did I use any extra special method here? Or just I am playing with the data directly? Did you understand what I mean by that? What I meant by this? Did you guys get the idea, the concept? I'm actually trying to give you guys the concept that Seaborn is all about playing with the data, right? So I'll give you guys an example. Day and tip example. Suppose if this is the day, this is the tip. This is my particular code that is running. Okay. Is this vertical or horizontal according to you? And what information is this code giving you? What information is this graph giving me? Is this graph giving me information about which day generates the highest amount of tip? Which day generates the highest amount of tip for the people? Which day is generating the maximum amount of tip for these people? Can I say this is being generated by, I don't know, certain kind of people, like for example, I don't know that. Okay, I'll give you guys an example also. You remember, my people, we imported a data set called the students data set. I'll stick to this data only. My people, tell me this. I have a small question I want to ask you. And this is super simple that I want to, the super simple question I'm asking you, okay? Tell me this, okay? In this particular data, how many variables are being mapped? How many variables am I mapping? Am I mapping 2 variables? And what kind of plot am I giving? I'm giving bar. If I change this to count, what will happen to my data? Did it give me an answer? Either X or Y must be none or kind count. So can I do count here? Can I do any count kind of variable here? Just like I want to do it. यहाँ पे मुझे error आया. Can somebody explain why this is happening? Why did I not get kind equals to count here? Why was I not able to do kind equals to count here? What could have gone wrong? Okay, so if I do kind equals to bar, I have no problem. I'm able to run the output absolutely correctly. X is day, Y is tip. One of them is categorical. Which is categorical? Between day and tip, which is categorical? Can I say day is categorical? So whenever you have categorical versus continuous data, categorical can be the bucket, right? Bucket number A, bucket number B, bucket number C, bucket number D, and the x-axis will be the amount of that particular range or magnitude, correct? Understand what I'm trying to say? You understood what I'm trying to say? This is your x-axis, this is your y-axis. So if I want to have like a categorical plot, either both needs to be what? So suppose day and smoker. Okay, if I do this, यहाँ पे error आना चाहिए, नहीं आना चाहिए. दोनों categorical है. आ गया error. Neither X nor Y appears to be what? In what format it is? Numeric में से दोनों भी नहीं है, correct or not? Smoker भी नहीं है, day भी नहीं है. Okay, I'll explain it to you. Example, आपको ये data दिख रहा है? ये total bill. Okay, ये total bill is what kind of variable? Continuous or discrete? It's a continuous value. What about tip? What about sex? Gender? Okay, what about smoker? What about Sunday? What about day? Suppose ये day वाला part. Okay, so tell me one thing. अब इसमें से मुझे अगर लेने हैं 2 categorical variables. Example, okay. Suppose मैंने 2 categorical ले लिए. I have 2 categorical variables. What relationship will you establish between that? Okay. So what do I mean by that is example. Say मेरे पास data है, right? Plot dot SNS dot count plot. What does count plot do, my people? What does a count plot do? What does a count plot do? Count plot क्या करेगा? Like here, if I say smoker के बदले मैं ले लेता हूँ tip, okay, and if I run bar, मुझे आंसर मिल गया, ठीक है? This is my count plot, the one that I taught you right now. X equals to this particular thing called smoker. So I'm going to say X equals to smoker, ठीक है? मैंने ले लिया smoker. यहाँ पे if you want to plot two variables together, you have to take a value or a parameter called hue. Let me say the hue is gender, ठीक है? And data equals to df. If I plot this, do you see what's happening here? Between smokers, how many are male and female? Did you understand? देखिए मैंने मेरा मेन क्राइटेरिया इज स्मोकर, बट विद इन स्मोकर्स yes and no में how many are males and females? Did you understand what I'm trying to say? Did you understand how this particular thing works? Did you understand this data? Are you able to understand what's happening? See, my main criteria was I want people to be recognized as smoker, but between smoker I want to understand कि कितने उसमें से males और females थे. Hue is nothing but to consider both the variables at once. Hue is that variable or that parameter. Okay, I'll give you guys another example. Give me 1 second. Give me 1 second. I'll give you guys an example. df dot head of 2. Okay, so my people, if I ask you a question that which under dinner time, who is the highest eater, males or females? How will you find this out? So between dinner time, so can I call this as time? X-axis equals to time, hue gender. So lunch and dinner में सबसे ज़्यादा कौन आते हैं dinner में? Dinner में who is the highest proportion of the gender that comes in? अब gender के बदले if I not say smoker, तो हम ये बोल सकते हैं ना कि dinner time पे और lunch time पे सबसे ज़्यादा smokers आते हैं, non-smokers आते हैं. तो what data am I getting? सबसे ज़्यादा smoker कब आते हैं? What did you understand? Did you get what I'm trying to say? To plot two categorical variables, to plot two distinguished categorical variables together, you have to use another parameter called hue. और hue के बदले आप ले सकते हो. जैसे for example, अगर मैं यहाँ पे size लिख दूँ, SIZE, what's gonna happen? Lunch time और dinner time पे सबसे ज़्यादा seating कहाँ होती है? In lunch time and dinner time, सबसे ज़्यादा seating कहाँ available है? Who appears in the highest amount of seating? 2, 3 and 4. Make sense? Did that make sense? कि for lunch and for dinner, the maximum number of people who come are this. अब अच्छा यहाँ पे अगर मैं size के बदले by गलती से tip ले लूँ, what's gonna happen to my data? Is it going on, but it still give me the distribution? आप समझ रहे हो मैं क्या बोल रहा हूँ? I'll show you an example. Okay, total bill. एक मिनट. Total TOTAL underscore bill. ठीक है? If I run this, total underscore bill, and यहाँ पे मैं दे दूंगा time, और नहीं मैं दे देता हूँ smoker. ठीक है? SMOKER. Smoker. What happened here? Is it telling me that the blue lines are smokers and the other lines are non-smokers? So is it giving us any valuable information through this graph? No. Which value is categorical? Which value is continuous value? If I pass the hue is equal to tip, example, क्या हुआ हमारे डेटा का? Is it running? हो क्या रहा है? For each value of total bill, it is going through all the values of tip. This just became O of n square operation. Okay, इसको हमें करना नहीं है. Okay, we are not supposed to add to continuous variables because it's going to give us all nonsensical value. You can compare at max gender, which is basically one categorical variable. Another categorical variable is which part of the day. Okay, control copy, control paste. And then if you want to combine two categorical variables together, you can do that very easily with either count plot, pair plot, and all of that, just by taking hue equals to day. Remember, just like I have taught you what is alpha, what is line width, the hue is also a very important parameter that is repeated all across the part. Are we clear with the concept of what I wanted to teach you, my people? The concept, the idea? Did you get it? Sir, instead of using exact data points, can we plot the graph with the combination of data points? Example, column heads A into B. Yes, absolutely, 100%. If you have a column A and column B, you can take df of A into df of B, and you can give it some variable called C, right? So you can say C equals to this, and you can do SNS dot pair plot or count plot, and you can pass C directly like this. Data equals to C, right? Like df of C, and you can pass it like this. You can pass it like this. Like you can make another column called C, like df of C like this. Df of C column is this, and you can pass a specific column for the data. So surely this is pretty much possible. You can do this. You can change and manipulate and do whatever you want, and you can aram se do it. My question to all of you is, did you understand why did you learn data visualization, or why are you learning data visualization? Because whenever you do data science and data analytics, the report that you want to generate to your manager, will every plot that you have created will be shown to your manager or your boss? In the data analytics, that everything we did, will you show all the plot that you did for analysis for your manager? No, my people. You will make the okay. So first of all, the reason why you are doing this is because from the entire data, maybe only 4 plots are making sense. You did them in Matplotlib, but they are not very presentable. Agree? They are not very easy to present, not easy to show. So what you do, you convert the Matplotlib graphs, complicated graphs, you do it in Seaborn, you copy paste the image, or you save the image as a JPEG file, and you paste that image in your PPT and you present it in your data. Are we clear? Are we clear? Did you get what I'm trying to say? So example के लिए बताता हूँ. So for example, ये graph जो है, this is the graph, correct? This is the graph that you have. I want to save this in my folder. What do you do? TLT dot save figure. Say give some idea. Gender versus day. Gender versus day. Here in the bracket, say format equals to which format do you want? So say format equals to JPEG, PDF, whatever you want. I will say JPEG. Run this code. What happens? In my folder, wherever this particular code is saved, wherever I have saved this code, there I will have my data already saved, or my code already saved. Did you get it? This is clear to you, or you guys got the concept? Your image is gonna be saved in your folder. Done, all set. अब उस image को आप copy paste करो, save करो, however you want to work on it. It's your job, your responsibility, but pretty much it will be handled for you. Are we clear? Are we clear with it so far? Are you guys clear so far? Okay. So my people, my answer or my question to you is only one thing. Will you practice Seaborn, Matplotlib with multiple different kinds of data to get clarity on which plot to use in which condition, to increase and gather your knowledge? What I was able to do in this class was to give you guys an idea that, look, Matplotlib to plot a graph has a certain pattern to it. First, get the data. Second, create the figure size. Third, plot the data. Fourth, save the figure and put label and beautification. In Seaborn, you don't have such easier plots. Only when you have complicated and complex plots, you have already defined methods, which you should already know, remember, mug, revise, by heart, whatever you want to do, you do. But it should be simple enough for you to understand. We've already discussed this, yes or no? Agree or disagree? I hope you understood what I meant. So in that sense, you have to be very, very careful. You have to be very, very smart with respect to how do you do this. And the more you practice, the more you get clarity on it. And also allow me to ask a question. Have you not done statistics? Acha, by the way, in your curriculum, do you have statistics in the future? In the current curriculum, the way you are going, do you have inferential statistics and descriptive statistics in your class? Look, if you are becoming data scientist or data analyst, I am very sure it must be in your curriculum. I cannot believe that you guys are doing data science or data analyst course and they are not teaching descriptive. I don't think this is possible. So I believe in the future courses, you will have something called descriptive statistics and inferential statistics. ये दोनों तो सीखना ही पड़ेगा. Without this तो I mean नहीं होगा.
Just a quick info, guys. Intellipaat offers data analytics course in collaboration with IIT and Powertech. Through this course, you will master Power BI, data modeling, data mining, and much more from the IIT Madras faculty and industry expert. With this course, we have already helped thousands of professionals in successful career transition. You can check out the testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your careers to a new height. So visit the course page link given in the description and take the first step towards the career in the field of data analytics.
Our sixth quiz question is, what is the main purpose of inferential statistics? So in order to answer this question, you guys should know what is inferential statistics. Let's look at the options. Option 1 is to make predictions or inferences about a population from a sample. Option 2, to organize and summarize data. Option 3, to create data visualizations. And option 4 is to store data securely. So kindly drop your answers in the comment.
Good morning, everyone, for having me on the class. Okay. All right. So, as you guys are aware that we are going to be having a session on inferential statistics today, right? So the class that I'm going to be taking you guys through today is going to be on inferential statistics. I have a couple of things prepared for you, planned for all of you guys, right? So before we get started with our session on inferential statistics, let me very quickly take you guys through the agenda that I'm going to be taking you guys through. Basically, in the lecture series of inferential statistics, what is it that exactly you're going to be studying? What and why is this specifically important for your career as a data scientist or a data analyst? Okay, both your careers will be mended well if you know the concept of inferential statistics. So in the agenda of the class today, my people, we are going to be learning about what exactly is inferential statistics. Okay, then I'm going to take you guys through an example of confidence interval. What exactly is confidence interval? Why is this important? What is hypothesis testing? Why is it a crucial topic in inferential statistics? What errors happen or occur in hypothesis testing? There are only two kinds of errors. One is called type 1 or alpha error, type 2 or beta errors. We'll talk about that. From topic number 5 to topic number 8 is the most important topic, which is super critical and super crucial for you to learn. It's called t-test, f-test, z-test, chi-square and ANOVA. So the agenda for this class is going to be very simple. Okay. I'm going to be taking you guys through some examples. I'm also going to be taking you guys through certain understanding of what exactly is, inferential statistics. As a data scientist, or as somebody who comes or wants to go into the field of artificial intelligence or machine learning or data analytics or any kind of data analysis, okay, why is inferential statistics such a crucial topic? And also, inferential statistics is one topic I believe that every engineer should know. The reason is because it is such an important topic. It deals with a lot of concepts related to a large, data. So now that you've understood the agenda for the topic that we are going to follow, right? We will start today's session with learning what exactly is inferential, okay? Inferential statistics, okay? Stats. So before we get started with inferential statistics, isn't it good or isn't it better that if I take you guys through some previous examples of statistics, maybe a quick revision of statistics of sorts? Before we jump into inferential statistics directly, can we revise certain topics of previous statistics? Example, my people, in your 10th standard, you must have studied something called measure of central tendency, right? Number 1 was called mean. Number 2 was called median. And the third was called mode. Have you studied this in your 10th standard or your 12th standard or your school time? You must have heard of something called measure of central tendency. We call this mean, median, and mode. What do you mean by mean, sir? Mean is nothing but if you have a given number called 1, 4, 3, 9. Example, What do? 1 plus 4 plus 3 plus 9 divided by 4. This answer would be your mean value, your average value. Correct? If you think from the perspective of mathematics, this may not look very fascinating. But if you look from the perspective of data visualization, it will look like this. Have you heard of something called number line, my people? A number line? A line where numbers are represented. Like, for example, 1, 2, 3, 4, 5, 6, 7, 8, and 9, right? So if you say number 1, right? So line number 1 is here, number 4 is here, number 3 is here, and number 9 is here. When you say you want to draw a mean, you are saying that you are taking a number that passes in between something that is the mean of all the numbers, correct? The average value of all the numbers. Does that make sense? Did this make sense? You are calculating the mean called x bar, which is a mean of all the numbers. So what would be 9 plus 4 plus 3 plus 1, 4, 5, 6, 7, 8, 17 by 4, right? What is 17 by 4, my people? What is the answer for 17 by 4? Quickly, somebody calculate. 4.25, right? So you will have something here. 4.25. So do you see that your x bar is the middle value of the entire cross section? Do you see this? It's like a middle value of the entire cross section, 1, 3, 4, and 9. This is what you call as mean value. But what do you mean by median value, my people? Suppose if you have 1, 2, 3, 4, 5. What is the median value of all of this? 3 is the median value, right? The number that goes on exactly in the middle. Correct? A number that's exactly in the middle of all these numbers. That is called as a median value. And what is a mode value? For example, if you have 1, 2, 2, 3. If a number repeats itself again and again, then the mode is 2. I'm very sure you must have learned about the topic of mean, median, and mode. Absolutely okay. What about, have you studied of something called variance, my people? Have you studied of something called variance? Very good. In statistics, okay, my folks, remember, I'm asking and I'm telling all of you who are in the class, remember, my people, in statistics, for one topic like variance, there are 2 different formulas. One formula will be for something called population, and the other formula will be for sample. Are we clear? Variance, standard deviation, and all these topics, all these clear ideas, okay? Variance is my doubt. I asked before also variance 1 here. Okay, sure, Raj. I'll explain you what is variance in a nicer way. Okay, don't worry. Remember one thing. Point number 1 for you to remember. Inferential. In statistics, variance or standard deviation, any topic, any formulation will have 2 formulas. Either population, either sample. Okay, I'm only going to show you sample. I'm going to delete this. And I'm going to tell you guys, my people, what if I make you visualize variance? Like how we visualized, right? Mean, right? We'll also try to visualize what exactly is variance. I'll give you guys an idea, and I think from this you will be able to understand. My people, whenever you have a number called -4 and you have a number called 4, what is the mean value of this number? -4 and 4. What's the mean? 0. -6 and +6. What's the mean? 0. -8 and +8. Is it still 0? Observe one thing. Mean is not able to tell how far the number is from 0, correct? This number is larger than this number, correct? The distance between, give me 1 second. The distance between this line from 0 to 4 and between 0 to 6, which is the larger distance? The distance from mean. We will consider this 0 as a mean. Which distance is larger? 0 to 4 is larger, 0 to 6 is larger, or 0 to 8 is larger? Which is the largest among all 3? 0 to 8 is the largest, then this is second largest, and this is the smallest. Agree? This is the sense. But when we calculate using mean, median, and mode, do we get that information? Does mean, median, and mode has this information, or can it include this information? No. For such numbers, mean, median, and mode will fail. To answer or to solve that problem, we have a concept called variance. My people, remember this. Variance is used to calculate the spread of the data. What do we use it to calculate? The spread of the data. Example, suppose you have a variance formula, which is this, right? So variance equals to each data point minus its mean, the whole square, divided by sample size minus 1. X of I is nothing but each individual data point. Okay? Data point. POINT. What is X bar? Mean of the data, or sample mean of the data. And what is N? N is the sample size. Okay, N is sample size. Sir, what do you mean by that? Suppose if you have a number called 1, 4, 3. So to solve or to calculate the variance or the spread within the data, you take 1 minus, my people, what is 1 plus 4 plus 3 divided by 3? Quickly tell me. 4, 5, 6, 7, 8. What is 8 divided by 3? Or we can take a simple number, right? Like, or plus 2 by 4. So this would be 10 by 4, right? What is 10 by 4? 5 by 2. 2.5, right? So you will have 2.5, something like this. So 1 minus 2.5, the whole square, plus, sorry, there has to be a summation here, plus 2 minus 2.5, the whole square, plus 4 minus 2.5, the whole square, plus 3 minus 2.5, the whole square, whole divided by the number of sample size as 4. There are 4 data points. So 4 minus 1 is 3. If you calculate this, you will get a number which will represent the spread within the data. How far off the data spread is. So my question to all of you is, 1, 2, 4, and 3 isn't very highly spread data. But what about 1, 8, 19, and 100? Can I say that the spread within the data is higher and the spread within the data is not that high? Does that make sense? So the variance value will be higher or larger for this value versus than this value. Are you clear? Is everybody clear? Variance is a statistical formula that is used to calculate the spread. How far apart are the numbers kept? The variance between 1, 2, 3, 4 will be a lower number, and a variance between 1, 10, 20, and 30 will be a larger number. So higher the spread, larger the variance. Are we clear in this? Did you kind of get the concept, my people? And don't worry, this is just me introducing the concept of variance. Your concept of variance is about to become much more clearer. You will get much better idea about what exactly is variance and where do we use it. Anyways, my people, after variance, a lot of you must have also heard about a topic called standard deviation. Haven't we calculated standard deviation in our schools when they used to teach us statistics, and we absolutely had no idea? We were struggling with calculating its formula. You remember? The variance, right? The variance formula is very, very simple. Summation of each data point minus its mean, the whole square, divided by n minus 1. Just put a square root. Or standard deviation is nothing but square root of variance. Can I call that these two are the formulas? Can I say this is the formula? Either you can take the formula of variance, or standard deviation is nothing but square root of variance. Okay, my people, I'm about to teach you something that will make your mind shift change. Okay, that will change your mind shift a little bit. In our younger generation or in our younger days, have you all used to share movies with your friends, with each other, but you used to compress your movies? When Netflix wasn't available, we used to download movies from internet, and we used to share movies with our friends, right? Like for example, if there is a a Ninja Turtle movie, or maybe if there is some other movie, we used to compress the movie and we used to share, right? So a 1.5 GB movie would become maybe 800 MB, and we would put this in a CD or a pen drive, and we used to share it with our friends. Have you done this situation where you used to take a large movie, compress it, and share it with your friends? A lot, right? Yeah, that's nice. This is, I'm talking about people who have not seen Netflix, like people like us. We have not seen Netflix. We've seen Doordarshan. That was our life. So coming from that era, right? We have used compression algorithms to take games, movies, and all of that stuff, and we've compressed it. My question to you is very, very simple, and try and understand what I'm trying to teach you here. If the variance of a number is 100, the standard deviation will be 10, because variance is not, standard deviation is nothing but square root. Okay, suppose if the variance of a number is I don't know, 16. Okay, will the standard deviation be 4? Okay, my people, can I say that standard deviation is nothing but a compression of variance without losing the information? Example, you had a data point called 100 and a data number called 16. I just compressed and made it into a smaller number with retaining the information. Meaning, between 100 and 16, which is a bigger number? Between 100 and 16, which is a bigger number? 100. When I compressed both the numbers, still between 10 and 4, which is a bigger number? 10. So did I lose any information? Did any information get lost? No. Was I able to bring a bigger number down into a smaller number? Are you understanding what I'm trying to teach you here? That standard deviation is also a statistical concept that tells you what the spread of the data. Okay, the reason why we apply square root to it is a little complicated to explain, but for now, in your brain visually, do you understand what's happening? Variance is going to be a larger number because I'm taking a summation of all of the number, plus we are also doing the square of the number, isn't it? Aren't we doing each number whole square plus second number whole square plus third number whole square plus fourth number whole square divided by n minus 1? So the number is going to be larger, right? Whenever you calculate variance, to deal with it mathematically, don't you want the number to be a little smaller so that it is manageable? Does that make sense? So standard deviation is a square root of variance. It's nothing but a spread number which is just shortened or made compressed. That's it. Remember, standard deviation is represented by the term sigma, and variance is represented by the term s square, like this. I hope this is clear. Can we proceed forward? If I have your standard variance, standard deviation, I'm so sorry, standard deviation, yeah, that happens, my people, not my fault. I just woke up and I did not get the coffee, so that may be the reason for it. Could be. Do you see something called in population variance? Okay, मैं आपको एक image निकाल के दिखाता हूँ. I'll show you an image and I will tell you guys the difference. Okay, this is important because this might come in your interview someday in the future. So I want you guys to be prepared for it. I'll just take an image like this. Okay, give me 1 second. Copy image and paste. Control Z and let me show it to you. 1 minute. Give me 1 second. Let me expand this a little bit. Oh yeah, that's right. My people, listen to me very carefully. You're about to understand certain things in deeper understanding. My question is, in population variance, you divide it by not small n, capital N, okay? The total sample size. And in sample, you divide by n minus 1. The first question is, you have to learn that when you calculate population variance, you have to divide it by the capital N. And when you calculate the sample variance, you have to calculate n minus 1. First of all, the formula for population versus the formula for sample is different. I hope everybody understood this. We have clarity for variance, standard deviation, and such different topics. The formula is different for sample and population. Are we clear? Number 2, sir, why do we do this? Why are we subtracting n minus 1 from sample, and why are we only dividing n? What is the reason? The reason is this n-1 is called Bessel correction. What do we call this term, my people? I want you to be aware of this. Okay, I know it's a deeper concept, but I want you to be aware of this. Subtracting a number, subtracting by n-1 in the sample, always in most formulas in statistics is called Bessel correction. The reason why we do this is because we fix the bias in the problem. Wrong. We fix the biasness in the data. Wrong. So just know that this is called Bessel correction. And if I have some time in the future, you let me know. I will teach you what exactly is Bessel correction also. You guys will understand why n-1 very clearly. Okay. Wrong. In the future, if we have some time, then I'll definitely take this up also. Okay. If we have 5-10 minutes extra remaining in our class, then I will teach you what is Bessel correction properly, because this is a little deeper concept. Anyways, are we clear, my people? Subtracting sample by n-1 is due to a concept called Bessel correction in statistics, and this n-1 is called degree of freedom. We'll talk about it a little later. Okay, anyways, no problem. Is everything clear until here to everyone, all my students, everybody? Yes? Can we proceed forward with inferential statistics in a beautiful way, in a nice way, so that all of us understand things really well? Perfect. Okay. In order for me to teach you inferential statistics in a much more nicer way, I want you to understand one topic. I am very sure you guys have studied about something called population and sample, correct or not? You all have studied what exactly is a population, what exactly is a sample, correct? You guys have studied this. I don't need to teach you this. You guys have studied. Just to revise myself or revise the concept to everybody, can I take this concept but in a different format, in a different way? Example, you study in a university and the university has 25,000 plus students. You study in a university. In that university are 25,000 plus students. So the university is a population or sample? Is the university a population or sample? It's a population, correct? It's a population. All these people are population. Okay. The problem statement is you want to ask students, are you happy? Are you happy with your education? This is the question you want to ask everybody in the university. You want to take a survey from all the students in the university saying that, are you happy with your studies? That's it. This is the survey you want to conduct, right? Is it possible for you to reach out all the 25,000 plus students? Would it be possible for you to go to every 25,000 plus student and ask them, hey, are you happy? Are you happy? Are you happy? Are you happy? It's not possible. So from a population, from a 25,000 plus students, we take a sample, correct? We take a smaller sample of maybe 100 students. Agree? We take a sample of 100 students. Agree or disagree? And what we do is we ask these 100 students the question, are you happy? In the 100 students, if the answer is 70% people say I am happy and 30% people say we are not happy, this is the answer or the output you got from the entire survey. This was the answer that you got from the survey. My people, listen to me very carefully. You had a population. You wanted to take a survey. That survey you could not take directly. So what you did, you took a sample. From the sample of 100 students, you got some answer. 70% people say I am happy. 30% people say I'm not happy. The answer that you got on the sample, does it even make sense, or does it apply to the entire population also? Does the answer 70% happy and 30% people say not happy, will this be validated, or will this be also the answer of your population? Yes or no? The study of this is called inferential statistics. Are you clear with the basic definition of inferential statistics? Did you get like the basic idea of what inferential statistics is? When you take let me tell you certain things practically. When you take a sample from a population, do you only take one sample? think logically. I want you to think from the most basic sense. My people, when you take a sample from a population, don't you take a sample which is not biased? I'll give you guys an example. Imagine you are working in a country where 90% of the people love coffee. If you are in a country where 90% of the people drink coffee, they don't drink tea. You want to calculate the survey, or you want to calculate the people who are, you want to calculate how many people enjoy tea. Your survey is how many of you enjoy tea. If you take a random group of the people, won't by default you will have more coffee drinkers, but you need both coffee and tea drinkers on a balance. You want a 50-50 split so that the data is not biased, because everybody will say they will hate coffee, they will hate tea. Agree or disagree? Does that make sense? If in a population everybody prefers one thing over more, shouldn't you now give more focus to tea drinking people? You have to bias your sample a little bit. Does that make sense? So my first question to all of you, okay, let me ask you this. If I am a tea company, what company? I'm a what company? What am I a company? I'm a tea company. I'm a chai company. Okay, good. Very nice. Remember, I'm a chai company. Okay. I want to calculate what flavor of tea do people enjoy. Do they want a very strong tea, mild tea, or very mild tea? Flavor. I'm talking about the flavor. If I take the population of all the coffee drinking people and I will put it in the tea drinking people, won't my result be wrong? Because they anyways don't like the tea. And in the entire population of the country, 90% drink coffee. Isn't my data going to be biased by default, because the most people that will come in the sample also will be by default biased towards coffee, so they will give wrong answers. So in order for me to really understand tea, I should then selectively take people who are more tea drinkers and lesser coffee drinkers. My sample has to now change, correct? My sample now cannot be random people who I can pick. Rather than I have to first ask them, okay, remember one thing. In statistics, the most important topic for statisticians was also a theory called sampling. What do we call this? What do you mean by sampling? How to select a sample from a population is also another field of statistics. Selecting a sample from a population is yet another field called sampling. Sir, what other kind of samplings do we have? So many. Random sampling, purposive sampling, selective sampling, need bias sampling. So many different kind of sampling exist. But my question is very simple. When you take a sample from a population and takes and conduct some survey, and on that on that sample you get some answer, does this answer apply to the population also or not? To check this, the concept that we need in statistics is called inferential statistics. Did you guys get it? The answer that you get on your sample, does that answer apply on the population also? Is the population also saying the same thing? To validate that, we need to study something called inferential statistics. This definition of inferential statistics is going to become much more clearer to you once we take the class. This is the best definition that you will get it. In order for you to understand inferential statistics even better, I have something that I want to teach you guys, and this is super critical for you to be learned. Okay, give me 1 second. Is it at 100%? 100%. Okay. Now that you guys have decided to study data science and you guys wanted to make your life deliberately hard, and you wanted to make your life good and hard both at the same time, right? Allow me to introduce a concept. Okay, so do we as a data scientist will do survey? How do we get sample data? Oh, very nice, Harshita. Very good. I would like to copy this question if I may. This is a very good question, very practical question, by the way. I like it. Is this visible to all of you? Yeah. Question is very simple. As a data scientist, do we do the survey or do we get the sample data? In your practical career as a data scientist that I have spent in my life, data will always be, first of all, given to you. Understood, my people? As a data scientist in your career, no matter which company you will work in, the data will be given to you. Once the data is given to you, as a data scientist, the survey that you conduct is not the survey that I taught you. Okay, the survey that you will conduct is, I'll give you guys an example. Suppose you work in a finance company and you got a data like this: age, salary, okay, age, salary, years of experience, and all of this. Okay, you got a data like this. What is the age of the guy who wants a loan? What is the salary of the person who wants the loan? And how many years of experience does it come with? Example, this is the data. You can do inferential statistics on either age column, age salary column, or age salary and years of experience column. So the survey that you are conducting is not going to people and conducting their survey and getting an answer. The survey you conduct is within the data itself. I hope you got the clarity I'm trying to give you. Your survey is not a survey that you go out and collect the answers and then you get it. The data is given to you and you have to conduct the survey within the data for the columns that is given to you. You don't go outside and do any kind of survey. That's not our job. It's a job of market research companies, not our job. Whenever a data is given to you by the company, whatever data is given to you, you need to do testing within that data frame itself. There is no going outside. Okay, good. Anyways, coming back to the main topic, how do we select data? That depends on your company to company, job to job, profile to profile. It's a very open-ended question. Selecting data depends on so many things. Depends on what are you trying to solve. If you're trying to solve the average age for people to get a loan, then age. If you're trying to do two-way ANOVA, then you have to do age and salary. If you're trying to do two-way ANOVA with interaction effect, all the three columns, we'll learn about it a little bit more. Okay, maybe you'll try to get an idea then. Okay, my people, have you ever heard of a concept called normal distribution? Has anybody in my class ever heard about the term called normal distribution? This is also called as a bell curve. This is also called as Gaussian distribution. Have you ever had a chance or opportunity to hear about this thing called normal distribution or bell curve or Gaussian distribution? It looks like this. Okay, my people, it looks like this. Okay, I have not so since I'm an artist of a very high caliber, my drawings are not imperfect. They are just like that. Okay, so they look like this. This is how a normal distribution looks like. Okay, this is what a normal distribution will look like. So the thing is, sir, what is normal distribution? And I absolutely have no idea about normal distribution. Okay, can I assume in my entire class nobody knows what normal distribution is? Is there anybody in my class who has never heard about normal distribution? Is there anybody in my class who has never heard about normal distribution? Anyone? You guys have learned about normal distribution? Okay, I'm going to ask you one question. Did you completely understand normal distribution? 1 sigma, 2 sigma, 3 sigma, all of that stuff. You guys were taught this concept? Mean one? No, that I'm not saying mean one, standard deviation 0. I'm saying that were you taught that in a normal distribution, you will have a center value where mean is equal to median equals to mode. Then one direction in the right will be 1 standard deviation. One direction will be 2 standard deviation. This will be 1 standard deviation to the left, 2 standard deviation to the right. Okay, so we will have to make our knowledge of normal distribution a large. Okay, my question to all of you is one thing. Okay, imagine, my people, imagine all of you will go to your village. And in your village, you will have some school, correct? All of you, when you go to your village, you will all have schools, right? Some government schools, some private schools, right? Maybe nowadays villages are no longer looking like villages, but you will have a school. Suppose in your village, you have 100 students. How many students? 100 students. If you make them stand according to their height, HEIGHT, if you make all the students stand according to their height, so won't the tallest of the tall people come in the beginning? These many people are tall, then most people are of average height, and then only few people will be small in height. Can I say if you make them stand according to the height, This is how the data will look like in histogram formation. Tall people, most of them average, then short. Can I say that this is how your data of histogram will look like? If you make everybody stand based on their height, this is how it will look like. Okay. Did you observe one pattern? Did you all observe one pattern? When you rank all the students based on the height, very few people will be very tall. Very few people will be very short. But majority of the people will always be average. Very few people will be very tall. Very few people will be very short. Majority of the people are of average height. So my people, my question to you is, my actual answer to you is, imagine you have a plastic sheet. What sheet? What sheet? A plastic sheet that is taken or that is held very very firmly by the two end. My people, listen to me very carefully. Imagine a plastic sheet, something that cannot break, is taken care or is held together by two people at the very end. If I drop rock is stone. If I drop stone into this, will this sheet take up a form like this? Will it take up a form like this? If I drop rocks on the sheet of paper, will it take up a form like this where rocks are all full here, getting filled or full here? Does that make sense? So that must mean the reason why normal distribution looks like it is a normal distribution is because normal distribution is a density curve. What curve? What kind of curve is normal distribution, my people? Normal distribution is what kind of curve? It's a density curve. What curve? Once again, I want all of you to tell me the answer once again. Density curve. Why do we call it density curve? Very simple. Listen to me very carefully, okay? I'm going to shorten this graph. Give me 1 second. Reduce this dimension, put it in the left. Okay. Listen to me very carefully. And I want you to never forget this concept, because if you know the concept that I just taught you now, you guys will become the pro at normal distribution. Listen to me very carefully. Sir, first of all, you taught me what is called normal distribution. You taught me what is called density curve. Sir, what do you mean by density curve? Whenever you plot a normal distribution graph in your life, you have the spread of the normal distribution, which is represented by x-axis, and you have the heap or the height of the normal distribution. If I decide to increase the height of my normal distribution somehow, what will happen to your distance? It will become, if you increase the height, somehow if you take this and if you make the height bigger, your normal distribution will become peakier, but the distance between the points will become shorter. And if you press it from the top, it will become smaller in peak, but higher in spread. Did that make sense? You can never increase the peak and also increase the dimension. That cannot happen. If you decide to increase its peak, your spread will decrease. If you decrease the spread, your peak will increase, right? If you increase the spread, your peak will decrease. Both the things are inverse to each other. They can't happen together. That's why it's called density, because in density, everything is just one particular 100% number. You can't change it. Are you clear? And I'll come to what is on X and Y axis. Give me 1 second. I'll come to what is X and Y, but are you clear with this concept? What is, you cannot change the dimension on it. Are we clear on this so far? Okay. Now let's understand it in more advance, in more details. A standard deviation is called standard deviation because on the x-axis, it's the concept of standard deviation. The standard deviation sigma that you calculated comes in the bottom, in the bottom of it. Give me 1 second. I'll show you guys in a much better example. Standard bell curve. Okay, bell curve. Oh yeah. This is the best one. Okay. Copy and paste. I'm going to expand the image a little bit. Give me 1 second. Ron. My people, do you see in the middle a value called mean? The center line that passes the central distribution or the normal distribution, exactly it will cut the normal distribution in half. This is called your mu or your mean. In normal distribution, your mean should be equals to your median should be equal to your mode. When your mean, median and mode all are very same numbers, you will get the center value called mu. Are we clear? If you want to plot a distribution of a data, you should get your mean equals to median equals to mode, and that's exactly where you will have a center line of your distribution. Depending on your data, if you calculate one sigma or one standard deviation, this much distance in one axis is called one standard deviation. Are we clear? Your mu plus one standard deviation will be this much distance, and your mean minus one standard deviation will be this much distance. Are we clear? This is not made up by me. This is a rule. If you have to plot a normal distribution, this is how you have to plot it. This is exactly how you do it. You can just simply call it one standard deviation. Okay, you can just simply call this one standard deviation, two standard deviation, and three standard deviation. To the left, you call it one standard deviation, two standard deviation, and three standard deviation. Are you clear, my people? On the x-axis, you plot one standard deviation, then take 2 times of that 2 standard deviation, then 3 standard deviation. Both of this on the right hand side and also to the left hand side, and your data will start looking like this. It'll grow up, grow down. Sir, what does this mean? What is the meaning of this? It means, my people, just now we took the example of height of the people, right? Of the 100 students, of all the 100 students. Agree or disagree? 100 students were taken for according to their height. Make sense? A while ago, in the example of the data, only few people will have a very tall height, only few people will have a very short height. Just like that, in our normal distribution data, do you see this tail, my people? In the left hand side, a small thing that is getting ended here, like it's becoming shorter and shorter and shorter, and it's becoming shorter and shorter and shorter. This thing is called as a tail. It means that very few people are either very short, either few people are very, very tall. But majority of the people are what, my people? Average height. This is what the graph is representing. Did you understand? Did you get it? The tail of your normal distribution always represents what? Extreme cases. To the left hand side, extremely short people, because we are in the negative direction. To the extreme right, we are very tall people, because this is a positive direction. Most people are average. My question to you all is, if you take height, you will get this normal distribution graph. What about if you take wealth distribution in the world? Will your answer not be same, my people? If you take the wealth distribution in the world, very few people are super duper rich. Very few people are very, very poor, but almost most people are average. Does that make sense? Either somebody will be very poor, either somebody will be very, very poor, or somebody will be very, very rich, but most of us are average. What about weight, my people? If you take random 100 people's weight in the market, or from people in the group, somebody will be very, very fat or very, very obese. Somebody will be very, very thin, or somebody will be thin, but most people are of average weight. Agree or disagree? When statisticians figured out this, they saw that almost all the data in the world follows what distribution? All the data in the world follows normal distribution. This normal distribution is not going to leave your life. I'll tell you why. You all are working people. Is somebody in my class a working person? Somebody who are already working in a company, any other company? My people, have you ever heard that there are something called job appraisal? Do you know that every year you have a job appraisal? Job appraisal meaning your manager, suppose I'm a manager, right? Like I manage a team of 33 people, correct? I directly manage a team of 33 people. So I have to give these 33 people a rank between 1 to 5. 1 being the lowest, 2 being the lowest, 3 is okay, 4 and 5 being good worker. Matlab this guy has done an exceptionally great job. For 33 people, my people, is it possible that all 33 people did great in my company, in my team? Is it possible that all 33 people did the absolute best? Or can I say all 33 did the worst? No. In the job appraisal also, won't my team follow a normal distribution? Somebody did exceptionally great, but the number of people who did exceptionally great will be very lower. Somebody who did exceptionally terrible, the number will be lower, but most people will be average. Does that make sense? If you don't know this, every company in the world will try to fit you, all the employees, in a normal distribution. When you get your appraisals, they also fit you in a normal distribution. Most of you will get an average score of 3, believe it or not, and a hike of maybe 10% of your salary. But somebody who did exceptionally well, maybe the person will get a higher bonus or a appraisal. But remember, normal distribution will never leave your life. In fact, your salary increment is also dependent on this topic. So learn this well. Okay? Are we clear with the concept so far, my people? Did you guys understand the concept of normal distribution? Would you now be willing to calculate normal distribution very, very quicker without going through the headache much? Or have you ever felt while learning something new that sometimes it's getting a little overwhelming? Have you ever felt like that? It's becoming too much to learn within that span of time. Have you felt like that in any of the classes? Yeah, it does. Okay. Happens. I can understand. Well, everyone, how do I say this to you? You guys will be learning machine learning. In the future classes, in some of the classes that you will be taking some of the classes on machine learning, the algorithms that will be taught to you, I'm not going to say that they are hard. Okay, my people, I'm not going to say they are hard. But for somebody who's listening to the topic for the very first time, it may sound very weird, right? Why are we doing this? Eventually, it will make sense. But in the very beginning, it might appear a little weird or it might appear a little hard. That is the challenge you will have to navigate. Okay, you'll be like, why are we doing this? What is the reason for it? And then eventually you'll understand, oh, okay, this is why we are doing it. So machine learning might become a little weird for you, not hard for a fact, but yeah, it might be a little weird for you that you're learning something in a very different way. So that could be one of the things, but I think that you guys will be able to overcome that. It shouldn't be a problem. Anyways, SQL is the most important skill that you have in an organization. I don't want to give you guys the hint or the advice, but I'm going to tell you guys one thing, that people get fired sometimes because as a data scientist, their SQL skills are not up to the mark. I have seen this happen to a lot of people, lot of new students. The reason is when they are expected to extract the data from the data warehouse, but they are still not able to get the data from the data warehouse writing a very simplistic query. They are not able to clean a certain kind of data, not able to do casting in the SQL query. The companies don't prefer such kind of people because they don't care about machine learning at the end, but you are not even able to do data extraction properly. That is a big no for certain companies, right? So especially in startups, right? Like if you aim or if you want to join startups and mid-tier companies, make sure that your SQL is not great. It will take some time for you to reach there, but if you call yourself 8 out of 10 in SQL, you guys are doing good. So please practice SQL. It's a very important skill. Without this, I'm telling you, no surviving in the industry. It's very, very hard. Okay. So just letting you guys know that it's super critical for you to learn SQL. Very important skill. Anyways, we have completed what is a normal distribution. I spoke to you guys about what is this normal distribution looks like and all of that stuff. Right? We spoke about it. We also spoke about, what exactly is sampling, what exactly is population. By the way, I also need to tell you one other thing, one other small topic. Population, if your population is 25,000 plus, and if you take a sample of maybe 100 or 1,000 or 5,000, these are all called samples. But if you take a sample which is very close to your population, for example, 23,000, okay? From your population of 25,000, you took a sample size of 23,000. The name of this is called census. Are you clear? Population, sample, census. Are we clear? You will have to learn this eventually later in your life. whenever you take a sample which is very close to the population number, that number or the name of that particular sample is not sample anymore, it is called census. Are we clear? I hope all of you are okay with my pace. Is my speed okay, my people? Quick feedback time. Are you okay with the speed, with the content, with the, how do I say this, with my communication? Are you guys okay with it? Do you want me to reduce the speed a little bit, increase it, or is the one that I'm continuing is fine? Is the one that I'm an increase would be good? Okay, that's fine. Okay. Now, coming back to the topic of normal distribution, right? We discussed, we have discussed about what is normal distribution and all of that stuff. Right now, I would love to take you guys through some definitions. Okay, it's very, very important. Okay, that the class is also following normal distribution, right? Anyways, that's good. Okay. Let me copy the definition of inferential statistics from the PPT and paste it here, and we will expand on this. My people, is this the definition from the PPT that we have taken? It says that descriptive statistics describes the data. Inferential statistics is used to draw conclusions. How do I make this larger? Give me 1 second, my people. How do I make this? Oh yeah, right here. 11 को हम कर देते हैं 26. Yeah, that's right. Perfect. My people, this is the definition that is given to us in the presentation. Okay. Is this visible now for all of you? I'm also going to make this a little bold. Descriptive statistics describes the data, right? I'm not going to talk about descriptive statistics. You guys have already studied this. I'm talking about inferential statistics. Inferential statistics is used to draw conclusion. The keyword here is conclusion. Please listen carefully. About the population based on statistical finding on sample analysis. What this text is trying to say that is inferential statistics is used to draw conclusion. So the first word is called conclusion, right? So conclusion, basically an answer. You want a conclusion on what, my people? What do you want a conclusion on? You want a conclusion on your population. But the conclusion will be given to you of the population based on what? What will you use to draw a conclusion on your population? Using a sample. Using a sample, asking this sample some question and making sure that this sample's answer also apply on the population. To validate this, we have a theory called inferential statistics. Are we clear? The PPT says the same exact thing that we had discussed a while ago. Sir, is there any theory or method to know how much sample or how many samples are sufficient to represent the universe? Yes, it's called increment. Okay, increment is not a theory. It's a concept in statistics called incremental learning. What it does is when you have a sample of 25,000 plus students, you take a sample of 100,000, 5,000, 17,000 and all of that, and you start plotting the data. If any sample gives you same answer repeatedly for sample size, you stop there. So that becomes your incremental learning. Have a knowledge like that, but it's a little complicated topic. But you can do that. You can take multiple sample sizes also. You can also optimize for it. We have a theory like that in mathematics. We have that. Okay. Are we clear with the definition of inferential statistics, my people? I hope the definition is clear. Inferential statistics is nothing. You have a conclusion that you want to have on your population, but to make the conclusion on your population, you need a sample. So to applying statistics on your sample, you get an answer on your population. Okay. This point will become very, very clear now in a while. In just a second, it will become very, very clear. Are we clear in this so far? My people, in statistics, you will be hearing two things very commonly, and I do not want you to forget it. Okay. One is called population parameter. Population parameter and sample statistic. Sample statistic. Remember, my people, whenever you calculate any population's mean, it's called population mean. If you calculate any population standard deviation, it's called population standard deviation. And if you take a population and calculate its variance, it's called population variance. Population mean, population variance, and population standard deviation together, or any one or any two, is called as what? Is called as what in statistics? It's called as population parameter. What do we call this? Population mean, population standard deviation, population mode, population median, all of these, when you calculate on a population, what do we call this? Population parameter. But when you calculate and when you take a sample and when you calculate its mean, its standard deviation, its variance, its mode, its median, all of these are called as what, my people? Sample statistic. Are you clear? In the entire PPT that I'm going to be taking you forward, they have not mentioned population mean or population standard deviation or population variance. They have not mentioned it. They have all mentioned it by the name population parameter and sample statistic. I am telling you right now that remember, any population, any calculation is called as population parameter, and you do the same thing on sample. It's called as sample statistic. Are we clear so far? Now, my people, you guys have understood the definition of inferential statistics. Inferential statistics is a field where you take a data, you have a population, you take a small sample. Does this sample's answer make sense for the entire population? For example, when you took a survey of are you happy in your education, you had a university of 25,000 plus students. But when you took a sample of 100, 70% people said that they are happy in the course and 30% people said we are not happy in the course. Does this mean from 25,000 plus students, 70% of the students are genuinely happy and 30% students are not happy? Because the answer that you got on your sample, does it even make sense on the population? Will the same logic apply on the population or not? To validate this, we use inferential statistics, right? That is what the definition of inferential statistics is. To continue or to learn inferential statistics, there is a concept called confidence interval. Okay, there is a concept called confidence interval. Sir, what do you mean by confidence interval? First of all, I'm going to write down the formula for confidence interval and everything will make sense. See, confidence interval CI, confidence interval is equal to X bar, which is your mean value, plus or minus Z score into S divided by root of N. Now remember, this Z value is Z score. Okay, I'll tell you guys what this particular thing is. Okay, this is the formula of confidence interval, X bar plus or minus Z into S divided by root of N. But you will be like, sir, I don't understand. I don't know what you're trying to say. What is S? What is X bar? I am not clear. Don't worry, I'll explain it to you. My people, what is X bar? X bar is nothing but the sample mean. The sample that you have taken, its mean will be sample mean. Sir, what is this Z value? See, this Z value is called as a Z score, and I will help you understand what is Z score. Okay, I'll tell you how to teach it little later. What is S? What should be your S? S is the standard deviation or your sample standard deviation. For the sample that you have, your standard deviation is called as an S, and your N is the sample size. Okay, is your sample size. So confidence interval is calculated as X bar plus or minus Z into S divided by root of N. Very nice. This is the formula for confidence interval. But sir, what exactly is confidence interval? What do you mean by confidence interval? I don't understand. I have no idea about what is confidence interval. Okay. If I show you one example, you will understand the definition, the reason why confidence interval is important, and everything will be made clear to you. Can we do it? Can we take one example and everything will become crystal clear in your head? Yeah? Okay. Listen to me very carefully, because the topic that you're going to learn now is super duper critical. Okay, very, very critical. Then I'm going to talk about range estimates and point estimates. Okay, very, very simple. So I'm going to take an example. Okay, I'm going to write down an example. Give me 1 second. Oh, right there. Oh, nice. This is awesome. Insert home 28. Okay, I'm going to make it 28. A random sample of, I hope this is visible. 55 males were taken and their protein consumption and their average protein, okay, protein consumption and their average AVERAGE. Let me expand this a little bit. Give me 1 second. expand this a little bit. This much is fine. Okay. A random sample of 55 males were taken and their average protein consumption for a day, we can say that is an average protein consumption in a day is for an average male is about 122 grams. वो तो ज़्यादा हो गया. I know it's too much, but I'm just going to take some 122 grams. Okay. A random sample of 55 males were taken and their average protein consumption was 122 grams. Okay, was 122 grams of protein. Okay, 122 grams of protein, 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 with a standard deviation of maybe we can say 12 grams, 13 grams, maybe up to 14 grams. We can say this is the standard deviations of 14 grams, right? A random sample of 55 males were taken and their average, let's say, grams of protein, protein consumption was 122 grams of protein with a standard deviation of 14% gram. Calculate population average with 95% confidence interval. With 95% confidence interval. The 95% confidence interval. Okay, ठीक है. My people, this is the question that has been asked to me by some statistician. Okay. Do you remember the definition I told you a while ago for one of the examples of, how do I say this? So one of the examples on inferential statistics, that whenever you have a sample, you make a judgment on your population. You remember we did this example of inferential statistical definition. You will have a sample and based on the sample, you will make a judgment on the population. So let's take the data from whatever is given to us. My people, what and all is given to us? Can I say that the sample mean X bar is given to me? X bar is given to me that on an average 55 people, the average protein consumption per day is 122 grams. 122 gram of protein is what they consume every day. How many number of people have been taken in the survey? 55 people have been taken for the survey. What else is there? What is the standard deviation of the data? How many grams? 14 grams of the standard deviation. And what is the confidence interval, my people? The confidence interval is 95%. Okay. So keep this number as it is. I'll make you understand what is 95% in a while. Okay. Just for simplicity reasons, the Z value for 95% confidence interval is 1.96. Now, I want you to please remember one thing. Okay. How to calculate Z value is a little complicated topic. So I will be teaching you how to calculate the concept of Z score, how to do that in a test called Z test. In our PPT, here we have a test called Z test. I will be teaching you how to calculate the Z value directly from a manual task there in that topic. But for now, to get the answers faster, I want you to please assume this is actually the correct answer, that for Z value of 95%, the answer is 1.96. The formula for confidence interval is X bar plus or minus Z score into S divided by root of N. This was the formula that I had. If I apply this formula, I need to split the formula into two parts. Okay. First of all, I need to make this formula, split it into two parts. Why two parts? One formula will have X bar plus Z into S divided by root of N, and the other part will have X bar minus Z into S divided by root of N. It will be plus and minus, so I need to split it. For simplicity reasons, whichever is the plus sign, we call this as upper bound. UB. Okay, I'm going to write the full form so that you can refer my notes later. The full form for this UB is called upper bound. Okay, UPPER BOUND bound, and this is called as a lower bound, BOUND. So now LB lower bound equals to X bar minus Z into S divided by root of N, meaning what is X bar? 122 minus 1.96 into what is S? S is 14 divided by root of 55. And this is your lower bound formula. What is your upper bound formula? X bar plus Z into S divided by root of N. So X bar is what? 122 plus 1.96 into 14 divided by root of 55. Can somebody calculate the answer for this, please? I don't, because the numbers is The numbers I've taken is on the top of my head. Can somebody calculate the answer for this? What is 122 minus 1.96 into 14 divided by root of 55 and 122 plus 1.96 into 14 divided by root of 5? Upper bound is equal to 125.70 and lower bound is equal to 118.29. Okay. The lower bound is this much and upper bound is this much. Correct or not, my people? This is the answer that we got, yes or no? It means that, listen to me carefully, listen to me very carefully. You took a sample for 55 people and the average protein consumption is 122 grams. The answer that you got from the formula of confidence interval means, listen to me very carefully and tell me, my people, myself, I am a protein company. Okay, I make protein for all the gym or the health freaks in India. Is it possible for me to reach out to all the people in India? Is it possible for me to reach out to every single person on India or in India who consumes protein? No, right? So if my question is, what is the average protein consumption of the population, not the sample? The question that the protein company is asking is the average consumption of protein for the population. That is my question. But can I actually take all the population in India? I can't. So what did I do? I took a sample of how many people, my people? How many people sample did I take? 55 people sample I took, correct? The answer that I got from the sample is the average protein consumption is in India is between 118.29 grams to 125.70 grams. This range is the answer that I got from the confidence interval, and the confidence that I have that the population will consume any protein between 118 grams and between 125 grams. How much percent confident I am in my answer? 95%. Because what is the confidence interval that you took? What is the confidence interval that you took? You are 95% sure, confident that if you take a population, somehow if you are able to calculate the population of all the protein eaters in India, the population's mean, your population of all the protein consumption people in India and the mean of the people, the mean average consumption of protein is guaranteed to be between 119 grams and 118 grams. Did you understand? Did you understand the topic, my people? Did you understand the concept? Confidence interval will help you calculate a range. Some number between X range and Y range, a number between X and Y, okay, a number between X and Y, and the population's parameter is guaranteed to be between that, inside it. It means that the population of all the Indians protein eaters is guaranteed to be between 118 grams and 125 grams. We cannot tell accurately exactly how much it will be because that is not possible. But we can tell you between what range it will lie and how much percent confident I am that whatever range I have calculated, I'm very, very sure. Did you understand, my people? My people, remember one thing. Remember one thing. Sir, if I take a confidence interval of 95%, why can't we take a confidence interval of 95%? Who gives us the confidence value of 95%? Okay. First of all, question number 1. Confidence interval range or the value. Okay. The value of confidence interval. The value of confidence interval is always assumed. Are we clear, my people? In the data science industry and the statistics industry, everybody will be taking a confidence interval of 95%. This is a standard rule. My people, higher the confidence level, higher is the chance that my population calculations are correct. If my confidence interval number is higher, then the range I have calculated and my assumption that my population parameter calculations are correct. So higher calculations are always preferred. So if this statement is true, then it can go 95%, to 99%. This is the standard rate of calculating confidence interval in the interviews, in data science, in drugs calculations, in statistical tests. All these tests in the world, you always have a confidence interval of 95% to 99%. This is the rule, a standard practice that everybody follows. It can go beyond 95 up to 99. If you go 100%, then the range will be equal to population. Confidence interval is determined by the confidence level of how the data is collected. Okay, allow me to explain. Everything will make sense. Whenever you are doing any statistical test, will you calculate confidence interval, or before doing the experiment, you need to decide on what confidence I will accept the answer? Please tell me which statement is correct. Do you calculate confidence interval, or do you assume a confidence interval and then you will accept your answer if the confidence interval makes sense? First of all, let's get this clarity. Whenever you do an experimentation, okay, any statistical test, okay, I'll give you guys an example with which everything will make sense. Okay, imagine you are testing for a drug called Dolo. My people, Dolo is used to reduce the temperature of the body. Agree? If you guys are sick, if you guys have fever, if you take Dolo, it will reduce your temperature. This is called as Dolo is a medicine that will reduce the temperature. Okay. I want to test the effectiveness of the drug. Is this drug really effective? Does this really help people? So can I not split the 100 people group into two groups? 50 people group and 50 people group. 50 people I will give some sweet medication and 50 people I will give Dolo, and I will test whether Dolo is really effective or not, or is it people's brain that is telling them no, because I ate a medicine I feel good. It's called placebo. If you don't know, this is how it is done. Before I even do an experimentation to test one thing or not, don't I need to say that I will calculate the population parameter at 95% confidence interval only? So 95% confidence interval is not calculated. It is always assumed. Are we clear? Is this point first of all clear? That 95% is assumed. It is assumed on the basis of one thing. How accurate do you want the answer? If you want the answers to be 99% accurate, my question to you all is very simple. My people, suppose this is my entire population. Do you agree? This is my entire population. Do you agree? This line is my entire population. Suppose at 95% confidence interval, I might get a range like this, correct? This is the range. This is the lower bound. Sorry, this is the upper bound and this is the lower bound. Agree? This is the range I got for 95% accurate. For me to be 99% sure, won't this range go beyond? Won't this range expand a little bit more to be 99% confident? Understand or not? If I do 100%, won't the entire population's range become my total range? If you want higher confidence, your judgment number should also be high, right? Does that make sense? Okay, listen to me very carefully, okay? I'll give you guys an example. My people, I have a population of all the people's height in the world, okay? All the people's height in the world, the average height of the population of all Indian men, okay? Let's say Indian men, all the Indian men. Can I say, my people, all Indian men's average height is about 172 centimeter, 5 feet 8 inches? Wrong. The average height of Indians. This is the population, all the Indians in the world I have taken. Can I say all the Indians in the world, the average height of all the Indians in the world is 172 centimeter, 5.8. When I took a sample of Indian men, just a small sample of Indian men, I got a range between 182 centimeter to 165 centimeter. This range I got between 95% confidence interval. Tell me, is my population mean within this data? Wrong. Is my population mean within this data? It is, right? My population mean of 172 is between the range of 95%. But if I have calculated for 99%, won't my number increase the range a little bit more? Now I will be between 190 centimeter and 142 centimeter. Wrong. To be more confident, you have to make more judgment. The ranges will be much bigger. Does that make sense? so that the confidence you have that you are right will also increase with it. Did you understand? So the selection of confidence interval is on the basis of how big a range are you okay taking in your answer. Does that make sense? How much range are you willing to take? Do you want a higher range or do you want a smaller range? It depends on your question, on your test, on the statistician. So confidence interval is always taken by the experimenter before doing the exam or before conducting the exam. I can even tell you one thing right now. If confidence interval is not given to you in any question, which value of confidence interval will you by default assume in any interview questions from today? 95%. That's it. 95% is the industry standard. Only and only if you are doing medical related data, then 99% confidence interval, because they want the accuracy to be higher. But for all other purposes, including data science, data analytics, what is the confidence interval everybody assumes? 95%. So first of all, are we clear with the concept of 95% assumption? Are we clear with the assumption of 95%? In the formula of z-score, have I taken the value of z is equal to 1.96? Lot of you had a questions on z statistics. So I'm telling you this. I have taken the value of z is equal to 1.96. Do you all see? I am highlighting it right now, right here. Can you see this is highlighted here? 1.96. Sir, how did you take it? Did I teach you how I took it, my people? Did I tell you why and how I took 1.96? Okay. Did I tell you the reason behind it? I did. If you don't know, let me repeat it myself. To calculate the z value of 1.96, I will have to teach you z-test. So did I make a request to all of you in the beginning of the class that can you please allow me to take an assumption that the z value is 1.96 for this particular example? And when I'm going to be teaching you z-test, I will make it very, very clear why the z value is 1.96 for 95% confidence interval. Can I make this request to all of you that rather than jumping so many topics and getting you guys confused unnecessarily, let's do connect the dots. Let's go one step at a time. And when I promise you, when I teach you z-test, I will come back to this question and I will tell you, now does it make sense? And you guys will be like, okay, sir, now it makes sense. How did you calculate 1.96? So this is a request to all of you. Can I skip teaching you what is 1.96 using the z table? Because it's not very, very easy. I will show you how it is calculated also. Give me 1 second. Very simple answer I'll tell you, okay? Just very quickly I'll tell you so that you guys are sort of sure that don't worry, it will be taken care for you, okay? Right, give me 1 second. Okay, my people, do you see this number called 1.9 here? Can you see this number 1.9 here? This 1.9, I'm highlighting it here. Can you see this? I'm going to highlight it a little bit more. Can you see this 1.9 number here? 1.9. And can you see this number called 0.06? If you combine the numbers together, okay, do you find a number called 0.9750?
Wrong.
Okay. 0.9750, right? I will help you how to calculate this. You will get an answer called 0.6 and 1.9. Okay. This number is 97.50%, but the tail is towards called, okay, so you will see in Z table, we calculate two tail. One is the entire table to the right, one is entire table to the left, okay? So I'll tell you how exactly 9750 will come in Z test, don't worry, but we'll be able to calculate 9750 percentage पे पूरा answer, which is 1.96, and you'll get the answer called 1.96, so don't worry. Okay, so I'm going to skip this topic for now. I'm going to teach you guys this in the z-test part of it. When I'm going to be teaching you z-test, then you guys will be able to learn this well. Are we clear? Is everyone clear? I hope the concept is sort of clear between all of you, that the z value of 1.96 will be taught to you then. Okay. Do you want me to repeat the question and the solution once again? Yes. Only Raj is saying yes. Do you want me to repeat it? Okay. This is the question that is given to me by the protein company. Let's say Pushpa Protein. Okay. The name of my company is called Pushpa Protein. I want to know what is the average consumptions of protein in India. How much average protein do people consume in India so that I can make a packaging bottle and sell it to people per month basis, 30 day basis. I can give them so that on an average, they can consume 1 scoop every day and 30 days the packet will be over. I want to make that product. So what I did, I conducted a survey with how many people, how many males did I conduct the survey with? 55 males. Now look, I had no idea. I had no way. I did not want to discriminate against men or women. So I'm going to take males and females, but just for example, okay? So I have taken 55 males and the average protein consumption was monitored. So first of all, I took 55 people. I monitored what is the average protein consumption of these people. It is assumed to be, not assumed, it is calculated to be 122 grams. So 55 people consumed 122 grams. My people, do you see this thing called standard deviation equals to 14 grams? Standard deviation equals to 14 grams. Do you see this term called standard deviation equals to 14 grams? Yes or no? It means that in the data, in the entire data, it was observed that 122 plus 14 grams is how much, my people? What is 122 plus 14? Oh yeah, grams. Sorry. 136. What is 122 minus 14? 108. The data in the entire 55 people, somebody had consumed up to 136 gram, somebody had consumed as low as 108 gram. Collectively for 55 people, the average came up to be 122. That is what standard deviation means. I hope you're clear. The max values were also found to be 136 grams. The lower values were found to be 108 grams, but the average came up to be 122. I hope you are clear. That is what standard deviation of 14 means. Did you understand? Did you get it? The range was given to you, and between this range, the average came up to be 122 grams. We have to calculate the confidence interval. We have to calculate a range of population parameter with 95% confidence interval. This confidence interval is always assumed or it is always taken. So first of all, in this particular step, I have written down the data clearly, correct? This is X, which is the sample mean. Sample mean is 122 gram. The sample size is 55 grams. The standard deviation is 14 grams. The confidence interval is 95%. And the Z-score for 95% confidence interval is 1.96. In this step, I have taken nothing but I have taken the data from the question. Any confusion here? Any confusion in this part? This right here is the formula for confidence interval, correct? Confidence interval is equal to X bar plus or minus Z into S divided by root of N. This formula had to be split between the lower bound formula and upper bound formula. Make sense? This is the lower bound formula and this is the upper bound formula. Any confusion so far? Took the sample mean X bar is 122 minus the Z-score value is 1.96. The standard deviation is 14 and the sample size is root of 55. I got the lower bound formula called lower bound equals to 118.29 grams. And when I implemented it for upper bound, I calculated same 122 plus 1.96 into 14 divided by root of 55. I got an upper bound of 155 grams. What this particular answer means, or what this particular thing is saying is, if I take a population of all the Indian protein consumptions men from a sample, I am making a guess that the average protein consumption of Indian people or all the Indian men must be between 118 grams of protein to 125 grams of protein. I am sure that the population of all the Indian men who consume protein, I am sure that the average value, the real value, the actual true value of population mean lies somewhere between 118 grams and between 125 grams. This is what this confidence interval formula has given me the output of. And how confident I am of my answer? I am 95% confident of my answer. Did that make sense? We are done with the classes for today because we are done.
Just a quick info, guys. Intellipaat offers data analytics course in collaboration with IIT and Pandas. Through this course, you will master Power BI, data modeling, data mining, and much more from the IIT Madras faculty and industry expert. With this course, we have already helped thousands of professionals in successful career transition. You can check out the testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your careers to a new height. So visit the course page link given in the description and take the first step towards the career in the field of data analytics.
Our next quiz question is: what is the first step in the statistical analysis for a purchase case study? So let's look at the options. Our option 1 is data collection, option 2 is hypothesis testing, option 3 is visualization of data, and option 4 is creating a report. Want to see a lot of answers in the chat?
An important topic. You remember from the sequence that we had started learning inferential statistics, we learned so many more stuff, right? Like going through the agenda of what PPT we followed. First, we understood what exactly is inferential statistics, right? Inferential statistics is a way where you take a sample because that's the only data you have available. You don't have population available to you, or it's given to you. So sample whenever it's given to you, when you want to do judgment or make a judgment on your population from where the sample comes from, inferential statistics allows you to do a lot of other stuff. The first thing that you did when you work on your population, so coming back to the most simplistic of the definitions, right? When you are given a sample, okay, of anything, you want to make certain judgment on your population data. So what do? You will always be given something called as a sample. You will make a judgment on your population, right? The first thing where sample was given to you and you made a judgment on your data was confidence interval, right? Confidence interval is x bar plus or minus z into s divided by root of n. Then after this, you pretty much understood what is hypothesis testing. We were learning something called hypothesis testing errors, right? In yesterday's class, I was taking you guys through this particular example where we have 4 situations, 4 different scene of where the things could go wrong or where the things could go right. What do I mean by that? In scenario number 1, in situation number 1, what happened? We had a doctor, we had a patient. The patient in reality, in actual truth, had cancer. And the doctor also diagnosed that, yes, you have cancer. Okay, this is a good thing the doctor did because somebody was positive about something and the doctor's diagnosis was also, guess what, you're positive, right? What happened in the other scenario? The guy does not have a cancer and the prediction that the doctor gave or the diagnosis the doctor gave is, don't worry, you don't have cancer, right? Which is a good thing the model did. In other situation, the patient did not have cancer. Right here, the patient does not have cancer, but the doctor says, misdiagnose him as you have cancer. Wrong situation. Something which is false, somebody saying it is true. Not good. In the other reverse situation, something is true, you predict it as false. Somebody has cancer and your diagnosis is, don't worry, you do not have cancer. That's not a good thing. Where was I heading with this definition? I was heading to a very important topic. What is that topic? The topic was, whenever we have hypothesis testing questions. So for example, in hypothesis testing, we have 2 kind of questions which we ask. One is called null hypothesis and the other is called alternate hypothesis. Did we learn this in yesterday's class? That in inferential statistics or any statistical test, you have null hypothesis and alternate hypothesis. Very good. Now, whatever I'm about to teach you now, please listen to me very carefully. My people, whenever you have a condition or 2 condition, null hypothesis or alternate hypothesis, we don't say in inferential statistics something is true or something is false. We don't say that. Instead, we say, do we accept it or do we reject it? Okay, this is the more technical way, the more professional and the correct way of saying the hypothesis. So I'll give you guys an example. According to the most simplistic of the understanding, my people, if I accept the null hypothesis, doesn't it make the null hypothesis automatically rejected? Because there are 2 other conditions. Does that make sense? If I accept the null hypothesis, by default, the null hypothesis will be rejected, right? And if I reject the null hypothesis, automatically the alternate hypothesis will be accepted. Make sense? Because they are reverse conditions of each other. So if I just work, accept or reject only null hypothesis, I don't even touch alternate, won't this give me the answer for alternate is true or null is true, or alternate is rejected or null is rejected? Does that make sense? I only and only accept or reject, never null. You either accept null hypothesis or you reject null hypothesis. The other condition is automatically taken care by itself. I'll give you an example. So what do you do? In one test, you said, I accept the null hypothesis. Automatically, what happened to your alternate hypothesis, my people? If you accept the null hypothesis, the alternate hypothesis stands rejected. Let's write it down. If you accept the null hypothesis, then your alternate hypothesis stands rejected. If you reject alternate null hypothesis, if you reject null hypothesis, your alternate stands accepted. They are opposite of each other. So you only and only accept or reject which condition? Only and only null. Does it make sense? You only and only work with null. You do not touch the alternate hypothesis. This is the rule. Are we clear? This is the rule. This is the condition based on which everything is dependent on. Are we clear so far, everybody? Very good. So based on this logic, whenever in reality, okay, give me and listen to this very carefully, okay? Type 1 and type 2 errors. Listen to this very carefully. Yeah, this is a good thing. Okay, I'm going to copy this and I'm going to paste this. Is this visible to all of you? Is this image visible to all? Very good. Listen to me very carefully. In reality, null hypothesis is true. In reality, null hypothesis is true. You rejected the null hypothesis. Did you do a good job? In reality, a null hypothesis was supposed to be true. You rejected it. Can I call this the type 1 error? In reality, null hypothesis was supposed to be false and you rejected it. Is that a good thing you did? So when null hypothesis is false, my people, this might not make sense to you immediately. Whatever I'm teaching you right now, the true, false, the null rejected, the accepted rejected. Of course, this is a little complicated to understand in the beginning, but I want all of you to make a little effort to understand this, right? Because this concept is very new for all of you. This may not make sense so much now, but I promise you, once I take you guys through inferential statistics in the examples in some of my further classes, this will make a lot of sense. Just try to make some effort to learn what I'm trying to teach you. I told you null hypothesis is accepted and rejected. In the entire thing, isn't null hypothesis is either true or false? In reality, okay, null hypothesis is either true, null hypothesis is either false. That means null hypothesis in reality was true, null hypothesis in reality was false. But what you did in your test, when you ran your test, when reality null hypothesis was supposed to be true, you rejected the null hypothesis. You did a reverse case. Here, you actually have reached something called type 1 error. Not a good condition. You don't actually have to worry about these two conditions. Ignore. You only worry about this. When null hypothesis was true, you rejected it. You did a type 1 kind of error. When null hypothesis was false, right? When the null hypothesis in reality is supposed to be false, but what you did with it, you not rejected, meaning you accepted it. Okay. The not rejected is nothing but accepted. Okay. People write it as not rejected, but it's rejected. So it's accepted. So when you accept it, but it's supposed to be false, it's called type 2 error. It's called false negative error and false positive error. It's just like the confusion matrix that I showed you. This will just take a little time for you to understand. But once you understand this is very much logical. Pretty logical to how confusion matrix is. This is a confusion matrix and this is sort of like a tabular format. This is not a proper confusion matrix, but you understand the idea. Did you get what I'm trying to say? Did you understand what I'm trying to aim at? So my question to all of you is, just because inferential statistics is able to take a sample and make a judgment on the population, is it 100% perfect or accurate? Just because inferential statistics is able to take a sample and make a judgment on the population, is it not possible that sometimes you can get a type 1 or type 2 error in your examples? That means your answers are not correct. They may have some incorrectness in themselves, or the answers could be wrong by themselves. Is there a possibility of that? The answer is yes. Is it clear? Inferential statistics is just to give you guys a certain estimate, either point or range. Did you guys get the concept of the type 1 and type 2 error? They are not perfect. There could be errors in the program, and that can happen. It is very much possible. It's possible that there are type 1 errors or type 2 errors in the program. Are we clear so far? Now, my people, as you've understood very important and super complicated stuff, let's understand what inferential stats tests are and how do we implement it. Okay, there are tests called t-test, or there is a test called t-test. Let me write it like this. In inferential statistics, there are a couple of tests that are more important that you will be using in your career for a very long period of time. And the way I'm going to teach you these tests now, I want you to write the code in the exact same way. I want you to write down manually also in the same way possible. But the way I am going to teach it to you is going to be slightly different. I'll tell you how. My people, in your interview, assume you have a data scientist interview or a data analyst interview. Say you are going for an interview. Because the way technology has developed so well this time, nobody will be asking you to solve a t-test problem mathematically. Nobody, no interviewer is going to give you a sheet of paper and they will give you a problem statement and expect you to write the whole mathematics behind the t-test and do it. What is that you will be expected to do? Understand the problem and code the problem. Basically, write a program. This will take not more than 2 minutes to 3 minutes. Agree or disagree? But solving it mathematically may take 15 minutes to 20 minutes, depending on how good is your calculation speed. But my belief is, okay, if you ask me, my personal belief is, I'm very sure that you don't have to learn. So my personal belief is, at least once in your life, you should solve at least one problem mathematically. The reason is, you will clearly understand what exactly is happening behind my code, or within the code, under the hood. What is it that's really working, so that you can understand the foundational and basic knowledge very, very well. To really understand what this test is doing, solving it mathematically will make a lot of difference. So how I will take this class forward is, how many tests there are in inferential statistic? There is a test called t-test. There is a test called z-test. There is a test called f-test. There is a test called ANOVA, or analysis of variance. And there is a test called chi-square. What I'm thinking is, for all of you, for each test, I will teach you both mathematical and the code, mathematical way and a code, mathematical way and a code, mathematics, code and code. This way, you will be able to understand the clear factor of how these tests are working, how do the internal mechanisms work. So you will be able to solve any given problem in your career for any of this test, both in paper and also with code. Let me also tell you one other thing. Writing and teaching you a mathematical part of it is not a part of your syllabus, but like I said, foundations are everything in life. This is how I'm going to proceed. So now that you have understood so many important concepts, you guys should be aware that how many tests are there in inferential statistics. There are so many, my people, okay? So many tests exist, but the most important ones are the test called t-test, there's a test called z-test, there's a test called f-test, there's a test called ANOVA, and there is a test called chi-square, okay? I am going to teach you right now a test called a t-test. Okay, a test called t-test. Sir, what is t-test? It's inferential statistics. Why does it have a weird name? Why does it have an alphabetical name called t-test, z-test, f-test, p-test, x-test, y-test? Why does it have a weird name? Okay, first of all, my people, t-test actually comes with the full form of t-test. Actually, some fascinating uh, you know uh, facts for all of you. T-test's full form is called students t-test. Okay, students t-test. This is created by a very important and a very intelligent statistician called Robert Fisher, or Fisher, you can just call him Fisher. Okay, Fisher was working in a company where he was not allowed to give his name or name the company. So he created the test, or he wrote the research paper under the name students t-test, right? The reason he created this test was he was walking down a field one day where he saw two different paddy fields. Do you understand what is paddy? You know what is paddy, right? Paddy is a grain. We eat it. It's rice. Yeah. Mr. Fisher wanted to understand, can we identify the yield of the field? You understand what is yield, right? So if you have 1 acre of land and if you put tomatoes in it, how much will you be able to produce? So for example, if you are able to sow maybe 100 kg or 1000 kg of potatoes, not all the potatoes you will be able to produce, or you will have a yield of it. Some get destroyed in, I don't know, some get destroyed by the animals, all of that stuff. So Mr. Fisher wanted to understand, can I identify or predict or estimate a yield of both the fields of similar patterns? And can I say that the yields are same or equal or unequal? So this is one of the reasons why students t-test was written. Okay. But what exactly is students t-test? I'll tell you. My people, have you heard of the concept called population? Have you heard of the concept called population? The definition that I'm giving you right now is going to improve over a period of time. So the definition that I'm giving you is basic. So I'll talk to you like this. If you talk to, okay, if a pilot, a airline pilot talks to a 5-year-old kid, a 20-year-old kid, a 30-year-old man, and a 40-year-old gentleman, the definition of what he does will change, right? So a pilot will tell a 5-year-old kid, I fly in the air. Then a pilot will tell a 20-year-old kid that I fly an aeroplane which is highly aerodynamic in nature, which has engines such that I am able to fly at maybe 10,000 feet of altitude. Example. Your definition will change according to the people's level of understanding, correct? So the understanding and the definition of t-test that I'm going to give you now and the one that you will have it by the end of t-test will be slightly different. Okay, so try and take it like that. If you have a population, I take 2 samples. How many samples, my people? Sample number 1 and sample number 2. From one population, I've taken 2 samples. Are we clear? When you take 2 different samples from same population, you calculate the mean. What do you mean? Mean. MEAN, or average. You take the average of S1 and you take the average of S2. T-test is a test in inferential statistics that is used to compare. What does it do? What does it do, my people? What is inferential statistical test called t-test used for? T-test is a test that is used to compare the means between 2 groups. Example. I'll give you guys an example. The average protein consumption in India, according to the population, is about 122 to 130 grams. Example. If I take a sample of the population and it turns out to be 118 grams, example, and the sample 2 turns out to be, 127 grams. I am going to compare the sample one's mean, which is 118 grams and 127 grams, to compare the means between 2 groups or 2 samples that come from same population. When you do such test, that test is called t-test. Did you understand? Did we get the very basic definition of what a t-test does? T-test does nothing different. Nothing different. T-test is a test to compare the mean between two groups. When you compare two groups, you compare the mean between them. When you have such test, that's called t-test. Very basic definition. Did everybody understand? It will become further clear when I take you guys through some more examples. But are we clear in the beginning? Very good. There are some rules if you want to apply t-test. What did I say, my people? There are some rules if you want to apply t-test. Rule number 1, the sample size, whenever you want to implement a t-test, you cannot take a sample greater than 30. So that means the sample size whenever you have to run a t-test should be less than or equal to 30. Did it become clear? If you are 1.4 billion people in this planet called Bharatiya Indians, we are 1.4 billion population. But if I want to do t-test, the maximum sample size that I can take is how much, my people, everybody? What is the total sample size? How much can I maximum take my sample? Even if your population is 1.4 billion, 20 billion, 30 billion, 80 billion, 1 trillion, 1 quadrillion, 1 zillion, whatever, goes on and on and on. The sample size can only be up to 30. Does that make sense? Less than or equal to 30. This is a rule if you want to do t-test. I'll tell you why do we have to do this. There is always a why behind everything. Sir, why only 30? There must be a reason. I'll tell you later. But did you understand the first rule? T-test is a test that is used to compare what between two groups? Means between two groups. Are we clear? So these two things are important. T-test is used to compare the averages of one sample with another sample, and the second thing it can only have a sample size less than or equal to 30. 31, you cannot use t-test. T-test can't be used for a sample size even for 31. Can't use it. Sir, t-test is not very simple as it appears, not in the complexity. Okay, what is 30? Sample size. Imagine you manufacture 40,000 chips packet per day. You manufacture 40,000 chips packet per day. If you want to take a sample, random sample from the batch that you manufactured that day, what is the maximum sample you can take? How many chips packet will you take from the 40,000 chips packet you manufactured? If you want to run t-test, how many sample of packets can you take max? So 30 is nothing but sample size. T-test is actually of multiple different type. Type number 1 is called one sample t-test. T-test has multiple tests within itself. The first test in t-test is called one sample t-test. What do we call this? One sample t-test. The second type of t-test is called independent sample t-test. And the third type of test is called paired t-test. So basically, there are 3 types of t-test, not just t-test. There are 3 different types of t-test. Sir, what are these types of t-test? I'll make you guys understand this very, very well. Let's first take what is one sample t-test, okay? One sample t-test. My people, imagine you guys run a chocolate factory or a chips factory, okay? Just like how Mr. Prasad has a chips factory. Let's say you are owning a chips factory. Chips are potato chips or tortillas or any other chip factory. Imagine of that sorts, whatever you like. Imagine company manufacture 40,000 chips per day. How many day? How many chips per day? 40,000 chips per day. 40,000 is the manufacturing capacity of Mr. Prasad. Okay, that's the manufacturing capacity. Mr. Prasad has kept a standard. What standard? Mr. Prasad says each packet, individual packet of my chip will have 10 grams of 10 grams worth of chips. Each packet, each individual chips packet I will manufacture will have 10 grams worth of chips inside it, plus the weight of the plastic cover. But assume that entire packet weight should be 10 grams. Example, assume it. Okay. Did Mr. Prasad set up a standard for the company saying that each packet needs to follow this guideline very, very strictly? Agree or disagree? So tell me one thing. Did Mr. Prasad not do one thing by default, by mistake, or by deliberation, that from a big population, one of the sample is by default 10. The average is set at 10. No matter what happens, one of the sample becomes 10, and the other sample could be the sample you want. Maybe 30 packets of chips randomly taken from 40,000, or 25 random chips packet, or 40 random chips packet. Whenever you have such a standard to maintain and you do that kind of test, that test is called one sample t-test. Are we clear? Did you understand what is one sample t-test? One sample t-test is called one sample because from the population, how many samples, which sample was drawn from the actual data from the population? Only one, right? You randomly took 25 packets from 40,000 packets. Agree or disagree? But the other sample is by default set at 10 gram because that standard is set by my dear Prasad. Did that make sense? In one sample t-test, one of the sample called sample 1 is nothing but the standard a company sets. And the other sample is the number of samples you take from the original 40,000. Did that make sense to everybody? One sample t-test is a test to always maintain the standard in a company. I'm going to ask you guys a question. Won't this be the most important test in FMCG companies? Where every manufactured food item or billable item will be compared against a standard. Whichever company is packaging company, manufacturing company, can they use t-test, one sample t-test to do comparison analysis? When somebody has a standard, like a standard of 80 grams per chocolate bar or 10 grams per chocolate, your standard becomes one of the sample 1, and the other becomes how many samples you want to take from the original batch, 40,000. From 40,000 chips packet, I will decide to take random 25 packets and I will measure the average. Logically speaking, everybody listen to me. Logically speaking, every chip packet, suppose you have taken 25 chips packet, shouldn't it have a sample? All the samples average should be 10 grams only by default. I'm asking you all a simple question. Logically speaking, I'm asking you guys a very simple question, okay? Try and understand what I'm trying to tell you. If I have taken randomly 25 packets of chips from 40,000 batch, this entire big batch, shouldn't each gram or each potato chip should be 10 gram, 10 gram, 10 gram? If I take the average also, shouldn't it give me 10 only at the end of the day? Mathematically speaking, shouldn't it? Raj sir, please wait for a little minute. I'll give you an access to the mic. Raj sir, please wait for a little while. I'll give you an access. I've taken your question, but let's take a little while, okay? How does hypothesis testing fit into it? So, Asha, we haven't gone to that stage yet. I'm making you understand the concept first. Then I'm going to show you how hypothesis test fit into it, okay? Yeah, so we'll go through that example. Don't worry. Let's not rush through concepts. Let's understand them. And then I'm going to tell you practically how this entire thing is implemented, okay? Okay, so let's take an example. We'll take an example to solve the problem also. But first, understand what the topic is. My question to all of you is, rather than taking 25 random packets, I have taken 4 random packets, okay? I have taken 4 random packets out of 40,000. 40,000 was manufactured per day. In a day, it was manufactured 40,000. From that, I have taken 4. 4 packets I have taken. That means each packet will be 10 gram, 10 gram, 10 gram, 10 gram. Make sense? So average of this will be 10 plus 10 plus 10 plus 10 divided by 4. Logically speaking, can I not write it like this? 10 into 4 divided by 4. 4 cancels. The average is still 10. Makes sense? Now tell me one thing. In one of the examples, I have taken one of the samples. One of the samples by default, I have taken how much grams? Or how many grams have I taken by default? The mean of this sample is by default taken how many? Yeah. If you take the mean of sample number 2, this also should give you 10, right? And you can compare 10 against 10 and say everything is good. The manufacturing went well. But if the 4 packets average comes up to 9.8 grams, where is the other 0.2 gram? Won't this give me an idea that there is a problem in the manufacturing? Some packets are now being produced less. The manufacturing isn't going well. So when I compare the original standard value with the new samples average, won't this give me an idea that there looks like somewhere the manufacturing there is a problem? The weights are not properly distributed, or 10 grams of wafers are not being put into every packet. This comparison will give me that idea, yes or no. Such test, when you run with hypothesis testing, is called one sample t-test. Are we clear? That one sample t-test is a very good example of manufacturing. Whenever you compare it against a standard, you call this as a one sample t-test. Are we clear? Does this make sense to everybody? Is this easier to understand? You compare the sample against a standard, it becomes one sample t-test. Can I proceed forward next? Did you all get the one sample t-test? So after one sample t-test, there is another kind of test called independent sample t-test. Independent sample t-test, okay? Independent sample t-test. Now listen to me very carefully. This is also a very beautiful test and you will understand this very nicely, okay? So in independent sample t-test, do you remember, my people, I gave you guys an idea a while ago that we have an independent population, and from that population you take two samples, sample number 1 and sample number 2. But in one sample t-test, one of the samples that we take already has a standard set, that each sample is by default 30 grams, 40 grams, 80 grams, whatever it is. In independent sample t-test, your population is not one, it's two different populations. Population number 1 and then population number 2. Both these populations are independent of each other. From each independent population, you take its independent sample called sample number 1, you take an independent sample called sample number 2, and when you compare the mean or the average number between these samples, this kind of test is called independent sample t-test. I'll give you guys an example. My people, can I say India? Okay. Can I say Indian students and American students? If I want to calculate, are Indians more intelligent in mathematics or American more intelligent in mathematics? Indian students and American students are independent of each other. They have no relationship with each other apart from being a student. They are completely independent populations. Indian students and American students are independent populations, culturally different. In all other ways, they are independent of each other. Agree or disagree? So have I taken two different populations, independent students, Indian students and American students? So many millions of students. From Indian students, can I select a random group of 30 people? 30 Indian students. From all the Indian students in India, can I take 30 random group of Indian students? Can I take a 30 random group of 30 American students? Yes or no? And I can give both these students a common test called SAT, math stat. Make sense? I can give both the students, both 30 Indian students and 30 American students, a common test. And whichever student's average is higher, or we can compare the averages, right? Like for example, out of 100 marks exam on mathematics, Indian students got on an average 78% and American students got 68%. Will I be able to compare the means of two samples? Did that make sense to all of you, my people? Whenever you talk about independent sample t-test, the rule that there will be one population and two different samples does not apply anymore. In independent sample t-test, your population should be independent. When you take the sample from the population, they will also be independent. And when you compare the means between these two samples, such kind of tests are called independent sample t-test. This is much more easier to understand, and don't worry, I will teach you much more. My people, can I give you one more example of independent sample t-test? One more. I don't like to do this because I believe we are all Indians. Okay? But because culturally, right, North and South India are different, right? Like I live in South India, right? I live in Bangalore. I love the culture here, but I'm originally from North, right? I'm a Punjabi by culture, but I live in South. So if I want to ask one simple question, statistically, are North Indians, do North Indians eat more sweet food or South Indians eat more sweet food? Or are North Indians are North Indians okay with spicy food or South Indian okay with spicy food? Which culture is comfortable with much more spicier food? So to calculate the spice level, we have something called Scoville unit. Can I not take North India as a separate population and South India as a separate population? Take a random group of 30 people, make them eat very spicy food, mild spicy food, not a spicy food, and take a reading and compare the average? Did that make sense? Did that make sense? I'll give you one more example. Are students in Mumbai smarter than students in Bangalore? Are students in Mumbai smarter than students in Bangalore? Isn't this also independent population, my people? They may be students, but they are independent, right? It depends on the question I ask. Make sense? If I was asking the question internationally, then India and America make sense. But if I was asking a question with respect to states, then states are also different. Make sense? Yeah. Picking up two different set of samples from categorically two independent populations. They have to be categorically different. Absolutely correct, Chandrakant. Are we clear, my people? Such kind of tests are called independent sample t-test because the population are independent, sample will be independent, the answer will be independent. Make sense? All of you? Did you understand the concept of independent sample t-test? Yes or no? Very good. Can I proceed forward with something called paired t-test? Can I proceed forward with something called paired t-test? If you guys have given me the example, okay. The population needs to be same in both cases. The population needs to be same. Are you talking about the number or are you talking about the independence of the population? Coffee and tea example cannot work here because they are dependent. No. All of you need to understand one thing. My entire statistics is dependent on the way I ask the question. Will you agree?
Wrong.
The way the question is asked, my entire statistics depends on that. Make sense? Okay. When we take spice test, we will use 30 spicy, 30 mild, 30 less spicy. We will take only 30 people. The category we defined, the label could be many, not 30. The number of people we will take 30. But mild, not mild, mild, we can take a survey like this. If it's mild, call it 0. Not mild, 1. Very spicy, 2. We can take a label like this. Okay, we can take a label like this and count the labels later, like 4 zeros, 3 2s, and 1 1s. We can take a label like that, and then we can do an averaging later. But point being, statistics depends very much on the way a question is asked. Okay, when we wanted to compare Indian students with American students, we know that this population is also different, this population is also different. Correct? Agree or disagree, everybody? But when I want to compare Indian students also, now you can't ask the question that which students are smarter, Indian or American. Now you will have to change your question. Looking at state-wise understanding, which state is important? Mumbai is smarter or Bangalore is smarter? Aren't these also independent according to the definition of the question? Does that make sense? Do you understand? Within Bangalore, listen to me very carefully. Within Bangalore, school A is performing good or school B is performing good. Isn't this also independent population? Because school A is different, school B is different, but both of them are in Bangalore. Rural, urban, whatever you see, statistics completely depends on the way you formulate the question. But the point is, they have to be independent of each other. They cannot be dependent on each other. I'll give you guys an example of dependence also. I'll give you guys an example. If I take all male students of an example, okay, let me ask you a question. If I take all the male students in class A and male students in class B, do you call this independent population or dependent population? Only and only male. They are still independent, correct? School A, male students, school B, male students. They are still independent, correct? Because they have no relationship with each other. Make sense? Does that make sense? Did you guys get the idea? Taking male separately, female separately has nothing to do with statistics. The question is simple. If the students in group A are also visible in group B or are also duplicated in group B, will they remain independent or dependent? If there is any duplication in group A and group B, will you call this independent or dependent? Example, somebody in group A plays guitar and somebody in group B plays sitar also. But a student called student A plays both guitar and sitar and is both visible in group A and group B. Will you truly have independence or there are certain dependencies? There are some complications like duplicacy. There are certain dependencies like sitar is dependent on guitar, example. They are both musical instruments like that. So dependency and independency depends on the way you ask the question in statistics. But when you take the concept that two populations are independent of each other, there is no relation between them. There is not one variable that causes this change and this change. If they are not dependent on each other, then it is truly called to be independent. And that's the kind of test you can run on one sample t-test. Are we clear? Are we clear? Did that make sense? Good. In machine learning, have you ever heard of a concept called correlation? Have you ever heard of a concept called correlation? Let me give you an example. If the price of the sugar goes high, if the price of the sugar go high, will the price of the coffee also increase in India? If the price of the sugar goes high today, will all the coffee owners increase the price? I'll give you one more example. If the price of the fuel goes high, will Zomato, Swiggy, Cab, all these people also increase the fare? So are these events independent of each other or dependent in each other? One event is causing a change in another event. Are they dependent of each other? Very good. Will the price of coffee increase the price of my laptop? Are these independent of each other? Are these independent of each other? Okay. When you take a group called group A and when you take a group called group B, are they independent or dependent? Depends on the question is being asked to us. Make sense? What context are you asking? Are you asking about coffee? Are you asking about laptop? That's why I told you independence and dependence depends on the question you ask. Okay. So did you understand the concept of independent sample t-test, my people? Independent sample t-test is a t-test that can be applied if the two populations are independent of each other. There is no relationship between them. You take a sample and you compare the means. Did we learn something important right now? Have you ever seen an ad on your TV where somebody will come on the TV and says that I was 100 kgs and I was very, very sad. I was not feeling very confident in my life, but suddenly there is a magical pill that I ate and now I'm suddenly 60 kgs and my life is so good. I have so many new friends and all of that stuff, right? You know the example you've seen. Have you seen this before and after? Have you seen those stupid ads on the internet that makes you fair apparently? I believe every skin color people are amazing, but have you seen those ads in the past where a guy was like, I was feeling very, very dark, but then I applied this, and suddenly I'm fairer than the sun, right? All these nonsense ads you must have seen. What do you see in this ad? Before and after, correct? Before and after, correct? We had I was before I was so heavy, I was not a very tall person, but after taking this medication I suddenly became very, very tall. I'm able to reach the sky and touch the Indigo Airlines and directly sit inside the airline. Before and after ads, you have seen this thing, right? Paired t test is exactly that. Not kidding, I'll tell you. Imagine you take a random group of 4 people. Can I say this is a valid t-test? Yes or no? Does it follow the rule of t-test? I have taken a group of 4 people, a sample of 4 people. Is this a valid t-test? Yes or no? Very good. My people, paired t-test is used to run on before and after scenario. Example. Suppose there are 4 people I have taken, okay? 4 people. All these 4 people are diabetic. Okay, all these 4 people are diabetic. Okay, you understand diabetes, right? People who have sugar, high blood sugar in their blood. People who are diabetic need an external insulin in their body. I hope everybody knows this. Okay, imagine there are 4 people and they are all diabetic, and there is this new drug in the market that reduces your diabetes level, okay, your sugar level in your body. So can I say I can measure my blood level, my blood sugar level before taking the tablet, and I can measure after taking the tablet. And if I compare the means before and after, I will be able to get to know the validity or the validation of the drug. Does that make sense? I'll take a very bad example. Don't fall into the trap of taking pills for reducing your weight. Okay. I absolutely am against it. You should never do it. Go work out. Don't be lazy. Imagine there is a pill called diet pill. Okay. Suppose person number 1 was 100 kg before taking the diet pill, and now he's suddenly 90 kg. He lost 10 kg. Somebody was 80 kg, lost 70 kg, became 70 kg. Somebody was 65 kg, became 50 kg. Okay. Somebody was 71 kg, became 65 kgs. Whenever you have a test, when you want to compare the before and after effect of anything, That kind of test is called paired t-test. The reason why it is called paired t-test is because for the same person number one, how many times do we measure his recording in a test? To do paired t-test for the same person, how many times do we take his recording, or how many times do we take his data? Twice. In a pair, we take the data before and after. Such kind of test is called paired t-test. Are we clear? Did that make sense, my people? The reason why this is called paired t-test, paired t-test is a test in one sample t-test that is used to compare something before something and after something. Paired t-test is used to measure the efficiency of something. I'll give you guys another example. I'll give you guys one more example. Have you learned something called abacus? Have you heard of something called abacus? Have you seen students on internet? Okay, I'm not sure. Okay, let me tell you. Have you seen students on the internet doing this and then calculating like a very big number? 45 into 645 plus 246 plus 195 minus 122. They do all of that stuff, right? And then there is this thing called abacus where you move your beads. I'll show you what is abacus. I'll show you. Have you seen this this bead thing? Yeah, this is abacus. That is, I think there is a name for it. I don't know what it's called, Kumon or something. I'm not sure. There are multiple ways you can make your mathematics stronger. Imagine a student, or imagine if scientists want to know, okay, if scientists want to know whether you have actually improved after learning abacus in mathematics. So can we not take 4 students who were very, very bad in mathematics? Before we take the score, the average score they used to get in the test, after teaching them abacus, we will take. So can't we prove the effectiveness of abacus, that abacus is really good? Before they were scoring very bad and now they are scoring very good. Do you understand? Whenever you want to check the effectiveness of something, you do one sample you do paired t-test. Are we clear? Got the concept? Okay. Did you understand the difference in one sample t-test, independent sample t-test, and paired t-test? Are we clear? Can we take a mathematical exercise, people? The finally we come to mathematics of t-test. Can we take it up? Let's solve it. Perfect, my people. So now that you guys have learned what exactly is one sample t-test, the time of understanding how does t-test work has finally come. We are going to learn how to implement it. We are going to learn how to actually write it down, mathematically solve it, and then I'm going to make you solve it and make you understand all of this really, really well. Okay. Now, let's write down the first version of our question. I'm going to give you guys an example. Give me 1 second. Where is the text? Oh, text is here, right? So I will have to write down a text. Let's reduce the dimension of this to maybe 20, 36. 36 is fine. Is this visible to everyone? If I write a text like this, hello, it's pretty much visible. The average salary of the average salary of blue collar, let's not say blue collar, kind of discriminatory. The average salary of men in 2019 was $100. Okay, I'm just taking a random example. The average salary of men in the average salary of hotel chefs was $100 in 2019. However, considering a sample of Control Z, considering a sample of, let's take a sample size less than 30. We can take exactly 30 participants. It was found that the average salary is $140. $140 with standard deviation of $14, $15. I think we can take an average standard deviation, a very small standard deviation. So maybe $20. Yeah, we'll take a deviation of $20. The average salary of a hotel chef back in 2019 was $100. However, considering a sample of 30 participants, it was found that the average salary for 30 participants, for these 30 participants were $100, $140 with a standard deviation of $20. Okay. Now let's ask the question: Has the salary increased in increased in the last 2019, 21, 2, 3. Okay. 19, 20, 1, 2, 3, maybe 5 years. In the last 5 years, has the salary increased in the last 5 years? This is the question number 1, or this is the only question. Question is, has the salary increased in the last 5 years? Not increased. Let's not say increased. Let's say changed. Has the salary changed in the last 5 years? Okay. Solve the problem with 95% confidence interval. Okay. Confidence interval. Okay. I'm going to expand this a little bit so that you guys are able to see this. I'm going to also make this a little bold. Is this visible to all of you? Is all of this visible to you? Is this question visible to you? The question is very simple. Back in 2019, chefs were able to make how much salary? $100 on an average. Okay? It's a lower number, but just for understanding. $100 they were able to make $100 in 2019. But in the 2023 or in 2024, they took how many group of random people? 30 group of random people. When we took a random group of 30 people and we calculated their average salary, the average salary was how much dollars? $140 with a standard deviation of $20, right? We need to calculate, has the salary changed in the last 5 years or not? Has the salary changed? We are not asking has it increased or decreased. We are asking did it change or no, right? This is the question. We will solve this problem using one sample, using t-test, right? So this problem will be solved using t-test. Now, in order to solve the problem using t-test, the first step you need to do is write down the data. Correct or not? The average salary of a chef is $100 back in 2019. Is this survey conducted? Is this research conducted already? Is this the truth? It's conducted. So can I say that the population mean, my population mean mu, my standard against which I will be comparing all my data is $100. Can I say this? This $100 has become my standard. So this problem just became a one sample t-test problem because my problem is already set. I have a standard of $100. Agree or disagree? My population mean is $100. What is my sample mean? What is my sample mean X bar? What is my sample mean? What is the sample's money that we calculated? $140. $140 is the sample's money. What is the sample size? How many people have we taken for the study? 30. What is my confidence interval in the entire thing? 95%. What is my standard deviation? It is $20. Right? I hope I've taken 20. Yeah. Is this the data that is taken in the question? Yes or no? Is this the data that is given to me in the question? Agree or disagree? I am teaching you how to solve a t-test using mathematics. Okay, mathematically, I'm teaching you how to run t-test. This is important. The first step is step number 1. Step number 1 is to write hypothesis first. Before you even solve a problem in t-test, aren't you supposed to write the hypothesis first? Agree or disagree? I told you this in the beginning of the class. You do not continue inferential statistics before you write a hypothesis. So my people, my null hypothesis and my alternate hypothesis. What can I say? My null hypothesis is that I still believe the old research is correct, that the average salary of my population, the entire population in 2023 also is how many dollars? $100. The sample mean is still going to be my, not sample mean, the population mean will still be $100 because my people, we may have taken 30 participants, but we are making a guess on the population, right? We are making a judgment on the population, right? Using the sample, we will make a judgment on the population. Correct or not? Agree or disagree? We will make a judgment on the population, right? Using the sample, we make a judgment on the population. So using a sample of 30 people, you say that the population mean in 2023 is still $100. But the alternate hypothesis is that the population mean is no longer $100. Did you understand? This is your null and alternate hypothesis. Simple as that. My question to all of you is very, very simple. Isn't it possible that the salary could also have decreased or also could have increased? Both the situations could have happened. Salaries could have decreased also, salary could have increased also. Now we have taken a group of 30 participants. How sure are you if I don't take other 30 participants, it will be less than $100? Are you sure that no, it will always be greater than 100? Are you sure? No, right? We are not sure. So don't we need to check for less than $100 also and greater than $100 also? Does that make sense, my people? Does it logically make sense to validate both the cases? Has it increased? Has it decreased? If it is increased, can I call the salary has changed logically? Logically speaking, if it is changed, I can call it changed, right? If it is greater, I can call it changed. But if it is equal, it is not changed. Agree? We wrote hypothesis as step number 1. Step number 1 was writing hypothesis, right? Step number 2. In step number 2, you write something called significance value. Significance value is called as alpha. What do we call significance value as, my people? Significance value will be called as alpha. In significance value, we'll take alpha. Sir, in alternate, can we not take 140? Why not equal to 100? So, do you remember I told you that $140 is not our question. Our question is, has the population remained the same or has it not remained the same? So if it is up to $100, we say that that is the null hypothesis, that we prove that null is still 100. We say it is not equal to 100 because in this condition, $140 is clearly greater than 100. But are you sure when you are testing for the entire population, are you sure that some people have not gotten less than 100 also? So we don't check for $140. We see, because the question is, has the salary changed or increased? Has the salary changed? Correct? Not increased. If it was increased, then we would have mentioned in the alternate hypothesis greater than 100. Correct? If the question was, has the salary increased from the $100? If the question is increased, then I would have said the alternate hypothesis is mu is greater than 100. Okay? Fine. I hope you understood now. I hope it is clear now. Step number 2 is called significance value called alpha. My people, significance value is called alpha. Okay? Significance value. To calculate significance value, you take 100% minus confidence interval. 100% minus, what is the confidence interval, my people? In the given question that we have, 95%. So automatically my alpha became how many percent or what percent? Did this make sense to you? Did you understand this part of the code? Significance value. If I look at it from a normal distribution perspective, this is my normal distribution. The entire graph, the whole normal distribution graph, can I consider this is the 100% of the graph? The entire graph can be considered 100%. My significance value alpha, my significance level alpha means it is totally how many percent, my people? 5%. Correct or not? It is 5%. This is totally 5%. Okay. Calculating for both lesser than 100 and greater than 100, in technical terms, we call this how many tailed test? This is called two-tailed t-test. Understand? When you calculate for both lesser than 100 and greater than 100 in the condition of this is called two-tailed t-test. My people, my alpha is how much percent currently? What's the total percentage of my alpha? 5. If I do two-tailed t-test, I will divide my alpha in two different tails, one in the left tail, other in the right tail. So how much percentage will be my left tail? 2.5%. And how much will be in the left tail? 2.5%. Together my left tail and my right tail will be 5%. But because we are doing two tail, my significance level should be divided in two different parts. Are we clear? For people who don't know what is tail, I want you to just let it be right now like this, okay? Don't worry about it. You will understand this in a while. Whenever you calculate alpha, listen to me very carefully. Whenever you are calculating alpha and you are doing two-tailed t-test, your alpha will be divided in how many parts? Two different parts. In inferential statistics and in any statistics, you only do either one tail test or two tail test. There is no 8-tail test, because in a normal distribution, how many tail do you have? Maximum tails? How many maximum tails do you have in a normal distribution? Only two. So the maximum you can do is only two tail test. Okay? Understand this. Either you can do one tail test or two tail test. Because this is a clear example of two tail test, your alpha is divided, one in the right tail, other in the left tail. If you do one tail test, you either do one tail to the right or one tail to the left. Any of this condition is okay. When you do one tail test, you need to specify, is it a right tail or left tail, and your job is done. How do you know when we do which tail? With over a certain experience, you will get it. Let me solve couple of more problems with which you will understand when to do one tail, when to do two tail. Okay? Because this is a very first example. I will not be able to show you many versatile examples with which you will understand, is it one tail or two tail. So allow me to complete this example, and then maybe when I take a next example, I'll take it one tail. You calculated you calculated the hypothesis in first step, or you made your hypothesis in step 1. In step 2, you created significance value. In step number 3, you calculate something called degree or degrees of freedom. My people, the formula of degrees of freedom is very, very simple. DF, degree of freedom, is equal to sample size minus 1. What is your sample size? 30 people minus 1. So what is the degree of freedom that you're supposed to have? What is your degree of freedom? 29. You calculated degree of freedom also. Step number 4, decision boundary. Decision boundary. Sir, what do you mean by decision boundary? Very simple. Very, very simple. Is this my normally distribution data, or is my normally distributed data for all the 30 people that I have taken? All the 30 chefs that I have taken in 2023, this is the normally distribution data of them. I told you one thing, when you plot confidence interval, don't you plot a upper bound and a lower bound, my people? Do you plot an upper bound and a lower bound whenever you're doing a calculation like that? Yes or no? If this is my normal distribution and I want my answer to be 95% confident, don't I need to plot a lower bound here and an upper bound here? I need to calculate the lower bound for the data. Yes or no? I need to calculate my lower bound value and my upper bound value, correct? I need to calculate this. Very good. Okay. To calculate the lower bound value and upper bound value for 95% confidence interval, you have to go to which table? You have to go to which table, my people? You have to go to tea table. Which table? Tea table. Okay, not the drinking tea. That is a different kind of tea. This is a different kind of tea. Let me take it again. Give me 1 second.
Wrong.
The first question I'm asking is, are you doing a one-tail test or a two-tail test? Please tell that. Are you doing a one-tail test or a two-tail test? Are we not doing two-tail test? So which column will you select? Which row will you select? The bottom row. T table is different from Z table. It's completely different. T table and Z table we are doing two-tail test. So I have written two-tail here. My people, your two-tail combined together, one tail plus one tail, together two-tail combined, how many percentage do you get? Where is 5%? 0.05. Agree? 5% in fraction form is 0.05. For people you don't know, your 5% can be written 5 divided by 100. So you will get 0.05. That's why we got 0.05. In the bottom of the columns, in the left part, do you see this thing called degree of freedom here? Degree of freedom here, the one where I'm circling. Yeah. What is the degree of freedom? What is my degree of freedom? 29. Is 29 here, my people? Yes. If I scroll down, down, down and go down, right? And if I scroll through the column, do I reach a number called 2.045? Do I reach up a number called 2.045? According to the T table, okay, I'm going to zoom this a little bit more. 100. According to the T table, we got a value from the T table, correct? Are you all listening to me? Whenever you calculate a value from the table, be it T table, Z table, F table, any table, whenever you calculate the value from a table, the name for that number is called critical value. What do we call this? What do we call this number? Critical value. Because you are doing t-test and you are calculating the value from the table, this is called t-critical. I'm going to call this number as what, people? I'm going to call this number as t-critical. Okay. So the t-critical value that I calculated from the table is how much, my people? 2.045. Because normal distribution is a symmetrical graph, your upper bound will be plus 2.045 and your negative will be minus 2.045. Did you understand? Your upper bound value became plus 2.045 and your lower bound value became negative 2.045. Did you understand? Whenever you calculate a value from the table, give me 1 second. I'm going to show you guys a magic. Listen to me. Whenever you calculate a value from the table, that value is called as critical value. I've written it in your code file. Every time you go for a table, every time you go to the table, you calculate the value, it becomes critical value. We calculated something called t-test, hence the value is called t-critical. Because you are calculating the confidence interval, the interval within which the population's parameter will lie, and because the normal distribution is what kind of curve? It's a symmetrical curve. Agree or disagree? Whatever is on the right, just put a negative sign, will come to the left. Did that make sense? Whatever you have a number here, because it is symmetrical, you just fold it. This will become a positive number, this will be a negative number, and this is your confidence interval range. Are we clear? Did everybody learn how to look at the table value? Did you guys learn how to read the table value? Did you all learn how to read the table value? Here is the decision boundary. The last and the most important step is calculating T statistic. Listen to me very carefully. My people, just because I'm calculating T critical value, doesn't it mean I have not implemented t-test yet? Because there is no formula that I've implemented. Sir, one silly question. If t-test can have max 30 sample, then why table have value? Not silly. Very good question. Listen to me very carefully and try to understand this. I told you that a t-test can have a maximum of 30 sample. Whenever you use a t-test, your sample size cannot be more than 30. But do you see here, you are allowed to calculate for a sample size up to 40, 60, 80, 100, 1000, meaning your original data must be 1001. So you did -1, so you got 1000. But meaning you had taken a data which was 1000. Does that make sense? You will not hate me if I give you this answer, okay? In t-test, you are allowed to take a sample size greater than 30 also. But you are only allowed to do that in special conditions. Are you clear? I will teach you the special conditions. I will teach you what these special conditions are. But remember, under special conditions, you are allowed to take sample size more than 30. Are we clear? Only when the special condition occurs. If the special condition does not occur, sample size cannot be more than 30. Are we clear? Are we clear? It's like this. I'll give you guys an example. My people, if you have, how do I say this? Imagine your friend has bought the most expensive supercar and he or she is your best friend and your friend is not around and the key is with you. You understand what I'm trying to say? That is a special condition. Right? Because if you ask your friend, he or she will not let you drive the car. But because there are special conditions, you will be able to drive the car or you will drive the car. You understand what I'm trying to say? There are some special condition when your friend is not around, and in that special condition, you have the key of the car also with you. So you understand what I'm trying to say, right? Both the conditions are very, very special. It does not happen very often, but you are lucky that this condition exists, right? So just like that, if a t-test has to be implemented, okay, you have to have a special condition. Only then you are allowed to take a sample size greater than 30. Are we clear? Okay. So coming to T statistic.
Wrong.
My people, this is a very important step and I want you to write this down. T is equal to, I am teaching you the formula. Sir, how
Wrong.
did you find out 2.045? See, this is the T table, correct? This is my T table. Because I am doing a two-tailed test, I'm doing two-tailed test. In two-tailed test, both the tail combined are 5%. See, my alpha value is 5%, correct? My alpha is 5, and because I'm doing two-tail, hence I'm going to only select 5, okay? I'm going to select 5%, okay? This is my 5%. Here, the degree of freedom that I calculated was 29. Okay, the sample size minus 1 is 29. So you will see I have taken 29 here also. So what I did is, when you go down on this column, go down, scroll, and if you take this column, row, you get a number called 2.045. Now, Jaggesh, you have to be very careful. The number will be positive, but because you know in a normal distribution, the data is symmetric. So what will you do? 2.045 on the right tail part and minus 2.045 on the left tail part. That's how I got 2.045. I hope you're clear. I hope the concept became clear. This is how I calculated 2.045. But it character is showing. Okay, here it is. This is the table right here. Right here. This is the table. Yes, sir. This is the T. This is called T table. This is not called a chart. This is called T table. If you just type on internet, just type T table. Just type T table. Any first link you click on it, it will open. Okay. Okay. Are you clear now? After this class, you will never see this table again. I will tell you with 100% confidence. Can I go back to T statistic? How to do T statistic? Whatever I'm writing right now is the formula for T. Okay, to calculate T test, this is the formula. T underscore statistic is equal to x bar minus mu divided by S divided by root of n. Sir, what is this? This is the formula based on what T test is built. This is the formula of T test. T test formula. This is the T test formula. Based on this is what we are going to be doing T test. Okay. Whenever you implement a formula or any formula, that number or that variable should be called as statistic. Are we clear? Whenever we calculate the value from the table, we call it T critical. When you do that using the formula, you should call it statistic, T statistic. Okay. Now, if I calculate T statistic formula, what is the value of X bar, my people? $140 minus $100 divided by standard deviation is 20 divided by root of 30. If you solve this thing, which I will have to solve in a code, but I don't know. What is the same formula for all T test type? No. For one sample T test, the formula is different. I would have actually taught you after this class, but yeah, it's different for different it's different. For one sample T test, this is the formula. Is 10.95 the answer for this? So the T statistic formula is how much, my people? 10.95. This is the T statistic answer. Okay? Okay. This 10.95, my people, this 10.95, does it come on this number line of this normal distribution? Can I say 10.95 comes somewhere here? If my number starts minus 2.045, minus 1, 0, 1, 2, 3, 4, in the number line like this, does my value 10.95 come somewhere outside the boundary? Can I say that the number is coming outside the boundary of upper bound and beyond this range of this boundary called upper bound? Whenever a number comes outside the boundary, we call this number as a rejection region. Actually, we call the region as rejection region, and a number that comes within the boundary is called as acceptance region. If the number was 1.16, is 1.16 between minus 2.045 and plus 2.045, yes or no? Then the answer would have been accepted. But the number that we got is 10.95. Because it is outside the boundary, we do what with our null hypothesis? We reject our null hypothesis. Because the number of t statistic value is outside the boundary, we call this reject null hypothesis, meaning statistically proven that what is the null hypothesis, my people? That the salary of people is $100. This is proven to be rejected. What is the true condition? The condition is that the salary or the boundary is no longer 100, that the salary of people is no longer 100. No longer 100 because it does not fall in the range of LB and UB, no longer 100. Let me repeat the whole thing. The salary is no longer $100 or it has changed from $100. We are not calculating whether has it increased or decreased, correct or not? We are not telling with statistical significance that the salary has definitely increased. We say it is changed. It's no longer 100. Could be greater, could be lesser. Did everybody understand what I'm trying to say? Can I please write a... Okay, here's what we will do. My people, listen to me very carefully. I taught you an example mathematically. Can I teach you the code of it? And then I will teach you the whole mathematics once again and code once again to show you guys the difference. What will happen is the same exact problem statement. I know I have done the mathematics of it and I know not everybody got it 100%. I get it. But can I write a code for this? And then I'm going to come and teach you the math part once again. And I'm very sure you guys will understand what I'm trying to say. Okay. I want to show you guys some amazing stuff. So what I'm going to do now is let's take a code part of it. What is the time right now? 8:51. I will not have enough time. Okay. Let me write it for. Okay, let's not rush into things. Let me finish the code. My people, will you wait for 2 extra minutes if I write down the code? It's not a very complicated code. Like if you really ask me, it's not a very complicated code. It's very, very simple. It's just that I will be able to make you guys understand things much more detailed so that by the time next week happens, you guys don't miss out on this and you will have at least something to practice. Cool? Okay. If you want to implement stats, import scipy.stats, okay, from scipy.stats. What test are you doing, my people? What test are you doing? T. So import T. That's it. From scipy.stats, import T. Import NumPy as NP. Simple, done. I've imported 2 important libraries. Now, my people, let's take down the data. Okay, let's take the data. DATA, data. DATA, data. The data says, what is my population mean, my people? What is the population mean? Isn't it $140? What is my sample mean? Isn't it $100? Oh, sorry, 140 is sample and population is 100, correct? Yeah, I think I must have reversed it. Yeah, is this correct? Okay, good. What is the sample size? Sample size is equal to 30 people. And hold on, I will also copy this question so that you guys don't worry about it. Give me 1 second. Copy this, go to the bottom and paste it. So this is the question for which this is the answer, okay? So that you guys are able to practice it well. The standard deviation is $20 and the confidence interval is 95%. So we'll take significance value alpha directly. Alpha is equal to 0.05, okay? Is this my data, yes or no? Okay. In the entire example that I showed you, do you remember the t-statistics formula? The t-statistics formula is sample mean minus population mean divided by standard deviation divided by root of sample size. This is the formula. Let's write down t-statistic formula, t-stat, okay? T_stat equals to population mean, sample mean minus population mean divided by, so you can divide it by standard deviation divided by, standard deviation. Let's take a bracket so that we don't miss out on this. Let's take a bracket here. Divided by NP dot square root of sample size n. So if I print F double quotes of T statistic is what? T statistics. So my people, what answer did we get in our example, in our code example, in our math example? What was the value of T stat that we got? What is the answer that we got? 10.95. If I run this, what answer did we get? 10.95. Did we get the answer 10.95? I can even control this 0.3f, 0.2f. Okay, yeah, 10.95. Now do I have the answer? Is this the t-statistic value? Yes or no? Once we calculated t-statistics value, did we also calculate the degree of freedom? The degrees of freedom is equal to sample size n minus 1. And if I print degrees of freedom, f double quotes of degrees of freedom, colon bracket degrees of freedom. What is the degree of freedom, my people? N minus 1. What do we need to calculate? T critical value, T critical value, correct or not? The one that we took from the table, the one that we just took from the table, the critical value. So T underscore critical is equal to, remember this and never forget this. Remember this and never forget this. Whenever you want to calculate the value of the table, T table, Z table, F table, whatever table value you want to do, the name of the method will be .ppf. The full form of .ppf is called percent point function. What do we call this? It's called percent point function. Whenever you want to calculate the value of the table without looking at the table, you have to do t.ppf. This is the value. To calculate critical value, here is what you have to do. 1 minus alpha divided by 2, comma, degrees of freedom. I'll tell you why do we need to do this, okay? Print critical value, T critical. I'm going to copy this. I'm going to F double quote, paste this here, this T critical value. Did I get the answer called 2.045? Yes or no? Is this the T critical value that I had? 2.045? This is upper bound or lower bound? Which bound is this? Is this upper bound or lower bound? If I want to calculate lower bound, remove this 1 minus. Yes, Shubhadeep, I'll come to the code. Remove this 1 minus, you will get minus 2.045. Point number 1. If you want to calculate T critical, F critical, Z critical, any table value, what is the name of the method? P.ppf or PPF. Are we clear? In inferential statistics, you will be dealing with 3 functions in your lifetime. The first function is called PPF function. What do we call this function as? Percent point function. The second function you will deal with is called SF, survival function. One is PPF, the other is called SF. Can we plot graph with label for this? Don't need it. It's an unnecessary stuff. Then the third function is called CDF, percent point function, survival function, cumulative distribution function or density function. This is the third function. To calculate the value of your table value or critical value, the only method in the entire code that will help you calculate the critical value in the entire statistics is PPF function. If you want to calculate P value, you calculate it either using SF or CDF. Are we clear? This distribution function and survival function is used to calculate something called P value, which I will teach you after some classes. But remember, are we using something called PPF function here? Okay. My people, are we doing one-tail test or two-tail test? Are we doing one-tail test or two-tail test? So shouldn't alpha be divided by 2? Should not alpha be divided by 2? So to calculate critical value, did you not pass in the table how many tail are you doing, one tail or two tail? Did you not pass this information to C in the table? First you checked whether it is one tail or two tail. So shouldn't we pass alpha by 2 because we are saying it is two tail? And also we checked for degrees of freedom in the bottom. So have I not passed degrees of freedom here? When I passed both the tail information and degree of freedom, won't it give me the table value? Yes? No? Maybe? Not maybe? Got it? Not got it? You guys need to give me that idea. Did we get it so far until this part of the code? Did you understand? Did you understand this part of it? Very good. What is the value of alpha? 0.05. Alpha divided by 2 is 0.025. That is exactly what we have passed. 1 minus alpha divided by 2 will give you plus, which is 2.045. This is the upper bound. And if you remove 1 minus, this is minus 2.045, which is the lower bound. Are we clear until here? Where is T defined? From scipy.stats import T. So T is my alias. 0.05 by 2 and degree of freedom. How do we have to multiply? What do we have to multiply? You don't have to do anything. This is a method. You don't have to do anything, sir. The way I'm teaching you is, or the way you are supposed to learn this is, you are not supposed to do anything. You have a function. You are just supposed to pass whether are you doing one tail test or two tail test. Okay, I'm going to ask you a question. If this was a one tail test and not a two tail test, should I have done alpha by 2? Should I have done alpha by 2? No. For one tail test, isn't my answer coming up to 1.699? Makes sense. If for some reason I was doing a one tail test, just pass alpha directly. But if you're doing two tail test, you have to do alpha by 2. I've already told you the theory behind this. Does that make sense? Does this make sense? Is this the drive that I have shared with you, my people? Is this the drive that I had shared with you? Agree? Okay, hold on. I'm going to upload the code file for you first of all. This is keep both the files. Give me 1 second. I'm going to upload the file so that I don't forget anything. Degrees of freedom. Okay. What seems to be the problem here? Degrees of freedom. Okay. Okay. Yeah. 0.05. So yeah, I hope you guys are able to see the code file also on the drive. Please confirm if you guys are able to see the code file on the drive. How this is used in corporate. Sir, पहले ही question में corporate का सीख रहे हो. We'll come to that. Hold on. Notes PDF here, please. You guys want to learn so many things so fast. It is amazing. I like it. I really love the fact that you guys want to learn so many things faster. But patiently, we will learn it. Don't worry. I will teach you where do we use this in corporate, how as a data scientist this is important for you, why will you need to learn all of this. So don't worry. We'll teach you everything. Okay, step by step. We'll go step by step. Can someone share the drive link here? Can someone please share the drive link to Murchana Sarma? Very important student. Give me 1 second. I will have to cover this. I hope I have covered all the parts. Yeah, all the parts I've covered. Left, right, left, bottom. But here also it's not 0.05, dear. This 0.05 is telling you that this is a two-tailed combined 0.05. But the values that are mentioned in the bottom are for 0.025. So don't think of it like this. Think of it like this. One tail and two tail combined are 0.05, right? But logically speaking, if two tail combination is 0.05, then it must mean that if I'm passing alpha by 2, it's written 0.05 here because this is just a label, but the values in the table are also 0.025. It's by default 0.025, but because it will be hard to write like that, they have given one combined label. If my confidence interval was 90%, example, okay, both my tails combined is 10% alpha, correct? But each tail is 5%. So you have to pass each tail here, not combined 10%. Each tail 5%. That's it. And you'll get the answer here. It was raised by mistake. Koi baat nahi, Siddhant. No issues. Chalo, take care.
Our ninth quiz question is, what does data cleaning involve? So option 1, removing or correcting errors in data. Option 2 is adding more data to the data set. Option 3 is visualizing the data. Option 4 is analyzing data patterns. So drop down your answers in the comment, guys.
Just a quick info, guys. Intellipaat offers data analytics course in collaboration with IIT and Pandas. Through this course, you will master Power BI, data modeling, data mining, and much more from the IIT Madras faculty and industry expert. With this course, we have already helped thousands of professionals in successful career transition. You can check out the testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your careers to a new height. So visit the course page link given in the description and take the first step towards the career in the field of data analytics.
And everyone, good morning. You do remember that whenever we read the value from the table, that value is called critical value. Do you all agree with this statement? Do you all agree with this statement that whenever you look at a value from a specific table, it becomes a T critical value or a critical value? In the example problem that I am solving right now, we calculated both the T statistic value and the critical value. It's not very old now, my people. It is very, very important to tell you the beauty of inferential statistics and how you can take advantage of all of this. Let me tell you how. In the manual problem that you solved or the mathematical example problem that we've solved together, to calculate whether we reject the null hypothesis or accept the null hypothesis, which two values are important for me to decide, do I need to accept the hypothesis or reject the hypothesis? It is T critical value, which is called T critical value, and underscore T statistic. Based on T critical value and T statistics value, we decide whether we accept the null hypothesis or reject the null hypothesis. But guess what? Whenever you start to code the solution up, or whenever you're doing programming of the solution, or whenever from now on in the future, whenever you're going to actually code the solution up, you don't use T critical and T statistic. You use a value called P value, and you use something called alpha. I have already told you what is alpha. Alpha is also called significance level or significance value, right? Significance level or significance value. We've calculated this using the confidence interval. Remember, if the confidence interval is equal to 95%, your alpha is equal to 100% minus 95%, which is 5%. So in the coding solution, you don't use T critical or T statistic. This is only used when you solve a manual problem. But there is a better way to get an answer, and that is P value and alpha. The guarantee is whatever answer you will get in the manual answer, the same exact answer you will get in the coding solution also. And then, my people, in this class, I will tell you what exactly this P value is. What is this big mystery around P value? Why is this important? And remember, my people, as data scientists, P value is a very critical information or a topic. This is important. No problem. Perfect. So, my people, I have told you the distinction between solving a problem manually and solving a problem code-wise. What do you know? When you solve a problem mathematically, you will be using something called T critical and T statistic. But whenever you will solve the problem in the code level or with code, you will not use T critical or T statistic. You will use P value and alpha. Now, let's just test it out, sir. What did we do? Okay. First of all, did we calculate the T statistics value? Yes or no? Here, agree or disagree? Have we calculated it? Agree, yes or no? We have calculated it. Do we have the value of alpha? We have the value of alpha. Do we have the value of degree of freedom? We have it. We also have T critical. But do we need T critical and T statistics in the coding example based on what I just taught you guys right now? No. In the programming exercise, you don't need T statistics and T critical. So what do we need, sir? What is that we need? We need to calculate something called P value. Now, everybody, do you remember I told you that whenever you calculate the T critical value, the name of the method is called .ppf. It's called percent point function. Do you remember in the last class I had discussed this? Whenever you calculate any statistical test in the world, if you want to calculate its critical value, you have to use percent point functions. Let's not forget it. Let's never forget it. Okay. So the way to calculate P value, my people, and what exactly is P value? I'll tell you, don't worry. We are not going to skip on that topic. It's an important topic and I will teach you this. But in case if you want to calculate P value, you have a function. Actually, there are two ways to calculate this, but I'm going to teach you using the .cdf method. So what you do is you take 2 multiplied by, take a parenthesis bracket, 1 minus t.cdf. Whenever you have to calculate P value, the name of the method is going to be CDF, cumulative distribution function. Okay. T1 minus t.cdf, and you close the bracket, and inside this bracket you're supposed to pass 2 information. One of the information is actually the T statistics value that you have calculated. So I'm going to uncomment it out. Before you pass this, you pass something called abs. If you don't know what abs is, it's a mathematical function to convert anything negative into positive. It's called absolute value. If you take a negative 4, abs will convert that into positive 4. If you take abs of 4, the answer will still be 4. So any negative number will be converted into positive number. So when you have to calculate P value, actually there are ways to calculate P value, but 2 multiplied by 1 minus t.cdf abs of, you pass the T statistics value here, which is the T stat value. Once you've passed the T stat value, you come here and you pass the degrees of freedom. Now, if I go ahead and copy this particular thing, and if I go ahead and also paste this here, okay, let me just copy P value here, paste it here, and also take up the degrees of freedom from here and paste it up here. Do we have the P value printed, my people? 8.02 into 10 to the power of minus 12, yes or no? Do we have p-value printed? Yes, we have p-value printed. Now, the line of code that I'm going to write right now will remain the same in all the tests. Okay, this line of code is universal. What do I mean by universal? Any statistical test you want to do in your life, including data science, machine learning, inferential statistics, or statistics in general, this will remain same. If your alpha, alpha, is less than p-value, or your p-value, let's always take it like this. If your p-value, right, is less than alpha, okay, you get an answer called, you print directly without any hesitation, we reject the null hypothesis. Okay, else you come down in the else condition, you go ahead and you print something called accept or fail to reject. Okay, so accept, or the best way or the technical way is fail to reject, fail to reject null hypothesis. What answer did we get in class when we solved the problem manually, my people? We got the answer as reject null hypothesis. Do you remember? What is the answer here? What print statement are we getting? Reject null hypothesis. We got the same exact answer that we did manually. Now, I know you guys have a lot of questions, and don't worry, I will figure it out for them. The biggest question that is going on in your brain is, what is this new thing called p-value? Isn't it? Aren't you a little curious what is this p-value and how is it able to replace t statistics and t critical? Is there anybody in this class who's thinking in that term? What is this p-value and how is it doing this magic of converting everything back into, and it's giving us the right answer? Okay, it's not like the answers are not correct. The way it is handling, the way it is working, it is giving us the right answer. But how exactly it is doing it? Now let's try to understand this. Now, my people, remember one thing, p-value is a very, very important topic, so you cannot miss this. My people, I'm going to explain it to you in a more easier sense. Okay, so try and have a focus on this. Let's say, for example, I take a population of, okay, I'm going to take a population of, I'm just going to draw a circle, sorry, not a circle, a rectangle, a population of all Indian policemen, okay, all Indian policemen. My people, if I take a population of all Indian policemen, I'm assuming I'm counting lakhs and lakhs of police force available in India, right? If I assume that these are, or this is the population of all Indian policemen, right? They must have some minimum height